Loiseleur Deslongchamps, 45, has argued that if our cereal plants have been greatly modified by cultivation, the weeds which habitually grow mingled with them would have been equally modified. But this argument shows how completely the principle of selection has been overlooked, that such weeds have not varied, or at least do not vary now in any extreme degree, is the opinion of Mr. H. Roman 100 Watson and Professor Asa Gray, as they inform me, but who will pretend to say that they do not vary as much as the individual plants of the same subvariety of wheat? We have already seen that pure varieties of wheat cultivated in the same field offer many slight variations, which can be selected and separately propagated, and that occasionally more strongly pronounced variations appear which, as Mr. Shuref has proved, are well worthy of extensive cultivation. Not until equal attention be paid to the variability and selection of weeds can the argument from their constancy under unintentional culture be of any value. In accordance with the principles of selection, we can understand how it is that in the several cultivated varieties of wheat, the organs of vegetation differ so little, for if a plant with peculiar leaves appeared, it would be neglected. Unless the grains of corn were at the same time superior in quality or size, the selection of seed corn was strongly recommended 46 in ancient times by Columella and Celsus, and as Virgil says, "I've seen the largest seeds, though viewed with care, degenerate unless industrious hand did yearly cull the largest." But whether in ancient times selection was methodically pursued, we may well doubt, when we hear how laborious the work has been found by Lacouder and Hallett. Although the principle of selection is so important, yet the little which man has effected by incessant efforts 47 during thousands of years, in rendering the plants more productive, or the grains more nutritious than they were in the time of the old Egyptians, would seem to speak strongly against its efficacy. But we must not forget that at each successive period the state of agriculture and the quantity of manure supplied to the land will have determined the maximum degree of productiveness, for it would be impossible to cultivate a highly productive variety unless the land contained a sufficient supply of the necessary chemical elements. We now know that man was sufficiently civilized to cultivate the ground at an immensely remote period, so that wheat might have been improved long ago up to that standard of excellence, which was possible under the then existing state of agriculture. One small class of facts supports this view of the slow and gradual improvement of our cereals in the most ancient lake habitations of Switzerland. When men employed only flint tools, the most extensively cultivated wheat was a peculiar kind, with remarkably small ears and grains 48, whilst the grains of the modern forms are in section from 7 to 8 millimeters in length. The larger grains from the lake habitations are 6, seldom 7, and the smaller ones only 4. The ear is thus much narrower, and the spikelets stand out more horizontally than in our present forms. So again, with barley, the most ancient and most extensively cultivated kind had small ears, and the grains were smaller, shorter, and nearer to each other than in that now grown without the husk. They were 212 lines long and scarcely 112 broad, whilst those now grown have a length of 3 lines, and almost the same in breadth, 49. These small-grain varieties of wheat and barley are believed by here to be the parent forms of certain existing allied varieties, which have supplanted their early progenitors. Here gives an interesting account of the first appearance and final disappearance of the several plants, which were cultivated in greater or less abundance in Switzerland during former successive periods, and which generally differed more or less from our existing varieties. The peculiar small-eared and small-grained wheat, already alluded to, was the commonest kind during the Stone period. It lasted down to the Helvetico-Roman age and then became extinct. A second kind was rare at first, but afterwards became more frequent. A third, the Egyptian wheat T. turgidum, does not agree exactly with any existing variety, and was rare during the Stone period. A fourth kind T. dicoccum differs from all known varieties of this form. A fifth kind T. monococcum is known to have existed during the Stone period only by the presence of a single ear. A sixth kind, the common T. spelta, was not introduced into Switzerland until the Bronze Age of barley. Besides the short-eared and small-grained kind, 2 others were cultivated, one of which was very scarce, and resembled our present common H. distichum. During the Bronze Age, rye and oats were introduced, the oat grains being somewhat smaller than those produced by our existing varieties. The poppy was largely cultivated during the Stone period, probably for its oil, but the variety which then existed is not now known. A peculiar pea with small seeds lasted from the Stone to the Bronze Age, and then became extinct, whilst a peculiar bean likewise having small seeds came in at the Bronze period, and lasted to the time of the Romans. These details sound like the descriptions given by paleontologists of the first appearance, the increasing rarity, and final extinction, or modification of fossil species, embedded in the successive stages of a geological formation. Finally, everyone must judge for himself whether it is more probable that the several forms of wheat, barley, rye, and oats are descended from between 10 and 15 species, most of which are now either unknown or extinct, or whether they are descended from between 4 and 8 species, which may have either closely resembled our present cultivated forms, or have been so widely different as to escape identification. In this latter case, we must conclude that man cultivated the cereals at an enormously remote period, and that he formerly practiced some degree of selection, which in itself is not improbable. We may perhaps further believe that when wheat was first cultivated, the ears and grains increased quickly in size in the same manner, as the roots of the wild carrot and parsnip are known to increase quickly in bulk under cultivation. Maize or Indian corn. Maize botanists are nearly unanimous that all the cultivated kinds belong to the same species. It is undoubtedly 50 of American origin, and was grown by the Aborigines throughout the continent from New England to Chile. Its cultivation must have been extremely ancient, for T. 51 describes two kinds now extinct or not known in Peru, which were taken from tombs apparently prior to the dynasty of the Incas. But there is even stronger evidence of antiquity, for I found on the coast of Peru 52 heads of maize together, with 18 species of recent seashell, embedded in a beach which had been upraised at least 85 feet above the level of the sea. In accordance with this ancient cultivation, numerous American varieties have arisen. The aboriginal form has not as yet been discovered in the wild state, a peculiar kind 53, in which the grains, instead of being naked, are concealed by husks. As much as 11 lines in length has been stated, but on insufficient evidence to grow wild in Brazil, it is certain that the aboriginal form would have had its grains thus protected. 54. But the seeds of the Brazilian variety produce, as I hear from Professor Asagre, and as is stated in 2 published accounts, either common or husked maize, and it is not credible that a wild species when first cultivated should vary so quickly, and in so great a degree. Maize has varied in an extraordinary and conspicuous manner. Metzger 55, who paid particular attention to the cultivation of this plant, makes 12 races unter it, with numerous subvarieties of the latter. Some are tolerably constant, others quite inconstant. The different races vary in height from 15-18 feet to only 16-18 inches. As in a dwarf variety described by Bonafus, the whole ear is variable in shape, being long and narrow or short, and thick or branched. The ear in one variety is more than 4 times as long as in a dwarf kind. The seeds are arranged in the ear in from 6 to even 20 rows, or are placed irregularly. The seeds are color red, white, pale yellow, orange, red, violet, or elegantly streaked with black. 56, and in the same ear there are sometimes seeds of 2 colors in a small collection. I found that a single grain of one variety nearly equaled in weight 7 grains of another variety. The shape of the seed varies greatly, being very flat, or nearly globular, or oval, broader than long or longer than broad, without any point, or produced into a sharp tooth, and this tooth is sometimes recurved. One variety, the rugosa of Bonafus, and which is extensively cultivated in the United States as sweet corn, has its seeds curiously wrinkled, giving to the whole ear singular appearance. Another variety, the Simosa of Bonn, carries its ears so crowded together that it is called maize a bouquet. The seeds of some varieties contain much glucose, instead of starch. Male flowers sometimes appear amongst the female flowers, and Mr. J. Scott has lately observed the rarer case of female flowers on a true male panicle, and likewise hermaphrodite flowers. 57. Azara describes 58, a variety in Paraguay, the grains of which are very tender, and he states that several varieties are fitted for being cooked in various ways. The varieties also differ greatly in precocity, and have different powers of resisting dryness and the action of violent wind. 59. Some of the foregoing differences would certainly be considered of specific value with plants in a state of nature. LeConte restates that the grains of all the varieties which he cultivated ultimately assumed a yellow color, but Bonafus 60 found that most of those which he sowed for 10 consecutive years kept true to their proper tints, and he adds that in the valleys of the Pyrenees and on the plains of Piedmont, a white maize has been cultivated for more than a century, and has undergone no change. The tall kinds grown in southern latitudes, and therefore exposed to great heat, require from 6 to 7 months to ripen their seed, whereas the dwarf kinds grown in northern and colder climates require only from 3 to 4 months. 61 Peter Kalm 62, who particularly attended to this plant, says that in the United States, in proceeding from south to north, the plants steadily diminish in bulk. Seeds brought from Lat 37 in Virginia and sown in Lat 43-44 in New England produce plants, which will not ripen their seed, or ripen them with the utmost difficulty. So it is with seed carried from New England to Lat 45-47 in Canada. By taking great care at first, the southern kinds, after some years, culture ripen their seed perfectly in their northern homes, so that this is an analogous case with that of the conversion of summer into winter wheat. And conversely, when tall and dwarf maize are planted together, the dwarf kinds are in full flower before the others have produced a single flower. And in Pennsylvania, they ripen their seeds 6 weeks earlier than the tall maize. Metzger also mentions a European maize which ripens its seed 4 weeks earlier than another European kind. With these facts so plainly showing inherited acclimatization, we may readily believe Kalm, who states that in North America, maize and some other plants have gradually been cultivated further and further northward. All writers agree that to keep the varieties of maize pure, they must be planted separately, so that they shall not cross. The effects of the climate of Europe on the American varieties is highly remarkable. Metzger obtained seed from various parts of America and cultivated several kinds in Germany. I will give an abstract of the changes observed. 63 in one case, namely, with a tall kind Breitkorniger Maize Z altissima, brought from the warmer parts of America during the first year, the plants were 12 feet high, and a few seeds were perfected. The lower seeds in the ear kept true to their proper form, but the upper seeds became slightly changed in the second generation. The plants were from 9 to 10 feet in height, and ripened their seed better. The depression on the outer side of the seed had almost disappeared, and the original beautiful white color had become duskier. Some of the seeds had even become yellow, and in their now rounded form, they approached common European maize in the third generation. Nearly all resemblance to the original and very distinct American parent form was lost in the sixth generation. This maize perfectly resembled a European variety described as the second subvariety of the fifth race. When Metzger published his book, this variety was still cultivated near Heidelberg and could be distinguished from the common kind only by a somewhat more vigorous growth. Analogous results were obtained by the cultivation of another American race, the white-tooth corn. The tooth nearly disappeared even in the second generation, a third race. The chicken corn did not undergo so great a change, but the seeds became less polished and pellucid in the above cases. The seeds were carried from a warm to a colder climate. But Fritz Muller informs me that a dwarf variety with small rounded seeds, Papagayen maize introduced from Germany into Brazil, produces plants as tall with seeds as flat as those of the kind commonly cultivated there. These facts afford the most remarkable instance known to me of the direct and prompt action of climate on a plant. It might have been expected that the tallness of the stem, the period of vegetation, and the ripening of the seed would have been thus affected, but it is a much more surprising fact that the seeds should have undergone so rapid and great a change, as however flowers with their product, the seed, are formed by the metamorphosis of the stem, and leaves. Any modification in these latter organs would be apt to extend through correlation to the organs of fructification. Cabbage Brassica oleracea. Everyone knows how greatly the various kinds of cabbage differ in appearance in the island of Jersey, from the effects of particular culture and of climate. A stalk has grown to the height of 16 feet, and had its spring shoots at the top occupied by a magpie's nest. The woody stems are not unfrequently from 10 to 12 feet in height, and are there used as rafters. 64, and as walking sticks. We are thus reminded that in certain countries plants belonging to the generally herbaceous order of the crucifer are developed into trees. Everyone can appreciate the difference between green or red cabbages, with great single heads, Brussels sprouts with numerous little heads, broccolis, and cauliflowers with the greater number of their flowers in an aborted condition, incapable of producing seed and borne in a dense corymb, instead of an open panicle savoys, with their blistered and wrinkled leaves and borkles and kyles, which come nearest to the wild parent form. There are also various frizzled and laciniated kinds, some of such beautiful colors that Vilmorin in his catalogue of 1851 enumerates 10 varieties which are valued solely for ornament. Some kinds are less commonly known, such as the Portuguese couve tronchuda, with the ribs of its leaves greatly thickened, and the kohlrabi or chauxraves, with their stems enlarged into great turnip-like masses above the ground, and the recently formed new race, 65 of the chauxraves, already including 9 subvarieties, in which the enlarged part lies beneath the ground like a turnip. Although we see such great differences in the shape, size, color arrangement, and manner of growth of the leaves and stem, and of the flower stems in the broccoli and cauliflower, it is remarkable that the flowers themselves, the seed pods and seeds, present extremely slight differences, or none at all. 66. I compared the flowers of all the principal kinds. Those of the couve tronchuda are white, and rather smaller than in common cabbages. Those of the Portsmouth broccoli have narrower sepals and smaller, less elongated petals, and in no other cabbage could any difference be detected with respect to the seed pods. In the purple kohlrabi alone do they differ, being a little longer and narrower than usual. I made a collection of the seeds of 28 different kinds, and most of them were undistinguishable. When there was any difference, it was excessively slight. Thus the seeds of various broccolis and cauliflowers, when seen in mass, are a little redder. Those of the early green Ulm Savoy are rather smaller, and those of the Breda Kyle slightly larger than usual, but not larger than the seeds of the wild cabbage from the coast of Wales. What a contrast in the amount of difference is presented if, on the one hand, we compare the leaves and stems of the various kinds of cabbage with their flowers, pods, and seeds, and, on the other hand, the corresponding parts in the varieties of maize and wheat. The explanation is obvious. The seeds alone are valued in our cereals, and their variations have been selected, whereas the seeds, seed pods, and flowers have been utterly neglected in the cabbage, whilst many useful variations in their leaves and stems have been noticed and preserved from an extremely remote period, for cabbages were cultivated by the old Celts. 67. It would be useless to give a classified description, 68, of the numerous races, subraces, and varieties of the cabbage, but it may be mentioned that Dr. Lindley has lately proposed 69, a system founded on the state of development of the terminal and lateral leaf buds. Thus Roman 1, all the leaf buds active and open, as in the wild cabbage, Kyle, etc. Roman 2, all the leaf buds active, but forming heads, as in Brussels sprouts, etc. Roman 3, terminal leaf bud, alone active, forming a head, as in common cabbages, savoys, etc. Roman 4, terminal leaf bud, alone active and open, with most of the flowers abortive and succulent, as in the cauliflower and broccoli. Roman 5, all the leaf buds active and open, with most of the flowers abortive and succulent, as in the sprouting broccoli. This latter variety is a new one, and bears the same relation to common broccoli as Brussels sprouts due to common cabbages. It suddenly appeared in a bed of common broccoli, and was found faithfully to transmit its newly acquired and remarkable characters. The principal kinds of cabbage existed at least as early as the 16th century 70, so that numerous modifications of structure have been inherited for a long period. This fact is the more remarkable as great care must be taken to prevent the crossing of the different kinds. To give proof of this, I raised 233 seedlings from cabbages of different kinds, which had purposely been planted near each other, and of the seedlings, no less than 155 were plainly deteriorated and mongrelized, nor were the remaining 78 all perfectly true. It may be doubted whether many permanent varieties have been formed by intentional or accidental crosses, for such crossed plants are found to be very inconstant. One kind, however, called cottager's Kyle, has lately been produced by crossing common Kyle and Brussels sprouts recrossed with purple broccoli. 71, and is said to be true, but plants raised by me were not nearly so constant in character as any common kind of cabbage. Although most of the kinds keep true if carefully preserved from crossing, yet the seedbeds must be yearly examined, and a few seedlings are generally found false. But even in this case, the force of inheritance is shown, for as Metzger has remarked 72, when speaking of Brussels sprouts, the variations generally keep to their unter art or main race, but in order that any kind may be truly propagated, there must be no great change in the conditions of life. Thus cabbages will not form heads in hot countries, and the same thing has been observed with an English variety grown during an extremely warm and damp autumn near Paris. 73. Extremely poor soil also affects the characters of certain varieties. Most authors believe that all the races are descended from the wild cabbage, found on the western shores of Europe. But Alf de Candolle, 74, forcibly argues on historical and other grounds that it is more probable that two or three closely allied forms, generally ranked as distinct species, still living in the Mediterranean region, are the parents now all commingled together of the various cultivated kinds in the same manner. As we have often seen with domesticated animals, the supposed multiple origin of the cabbage throws no light on the characteristic differences between the cultivated forms. If our cabbages are the descendants of 3 or 4 distinct species, every trace of any sterility which may originally have existed between them is now lost, for none of the varieties can be kept distinct without scrupulous care to prevent intercrossing. The other cultivated forms of the genus Brassica are descended, according to the view adopted by Godwin and Metzger, 75, from 2 species B. napus and rapa, but according to other botanists from 3 species, whilst others again strongly suspect that all these forms, both wild and cultivated, ought to be ranked as a single species. Brassica napus has given rise to 2 large groups, namely Swedish turnips, believed to be of hybrid origin 76, and causes the seeds of which yield oil. Brassica rapa of Koch has also given rise to 2 races, namely common turnips and the oil-giving rape. The evidence is unusually clear that these latter plants, though so different in external appearance, belong to the same species, for the turnip has been observed by Koch and Godwin to lose its thick roots in uncultivated soil, and when rape and turnips are sown together they cross to such a degree that scarcely a single plant comes true. 77 Metzger, by culture, converted the biennial or winter rape into the annual or summer rape varieties, which have been thought by some authors to be specifically distinct. 78. In the production of large fleshy turnip-like stems, we have a case of analogous variation in 3 forms, which are generally considered as distinct species. But scarcely any modification seems so easily acquired as a succulent enlargement of the stem or root that is a store of nutriment laid up for the plant's own future use. We see this in our radishes, beet, and in the less generally known turnip-rooted celery, and in the finocchio or Italian variety of the common fennel. Mr. Buckman has lately proved by his interesting experiments how quickly the roots of the wild parsnip can be enlarged, as Vilmorin formerly proved in the case of the carrot. 79. This latter plant in its cultivated state differs in scarcely any character from the wild English carrot, except in general luxuriance, and in the size and quality of its roots. But 10 varieties differing in the color, shape, and quality of the root are cultivated in England, and come true by seed. 80 Hence with the carrot, as in so many other cases, for instance with the numerous varieties and subvarieties of the radish, that part of the plant which is valued by man falsely appears alone to have varied. The truth is that variations in this part alone have been selected, and the seedlings inheriting a tendency to vary in the same way, analogous modifications have been again and again selected, until at last a great amount of change has been effected. With respect to the radish Roman 1000 Carriere, by sowing the seed of the wild Raphanus raffinistrum in rich soil, and by continued selection during several generations, raised many varieties closely like the cultivated radish R. sativus in their roots, as well as the wonderful Chinese variety R. caudatus. See Journal d'Agriculture Pratique, Tom I 1869 p. 159. Also a separate S. Origine des plants, Domestiques 1869. Raphanus. Raffinistrum and sativus have often been ranked as distinct species, and owing to differences in their fruit, even as distinct genera. But Professor Hoffmann Bott Zeitung, 1872 p. 482, has now shown that these differences, remarkable as they are, graduate away the fruit of R. caudatus, being intermediate, by cultivating R. raffinistrum during several generations. Ibid 1873 p. 9. Professor Hoffmann also obtained plants bearing fruits like those of R. sativus. P. pisum sativum. Most botanists look at the garden pea as specifically distinct from the field pea P. arvens. The latter exists in a wild state in southern Europe, but the aboriginal parent of the garden pea has been found by one collector alone, as he states in the Crimea 81. Andrew Knight crossed, as I am informed by the Rev. A. Fitch, the field pea with a well-known garden variety, the Prussian pea, and the cross seems to have been perfectly fertile. Dr. Field has recently studied 82 the genus with care, and after having cultivated about 50 varieties, concludes that certainly they all belong to the same species. It is an interesting fact, already alluded to, that according to O. here 83, the peas found in the lake habitations of Switzerland of the Stone and Bronze Ages belong to an extinct variety with exceedingly small seeds allied to P. arvens or the field pea. The varieties of the common garden pea are numerous and differ considerably from one another. For comparison, I planted at the same time 41 English and French varieties. They differed greatly in height, namely from between 6 and 12 inches to 8 feet 84 in manner of growth. And in period of maturity, some differ in general aspect, even while only 2 or 3 inches in height. The stems of the Prussian pea are much branched. The tall kinds have larger leaves than the dwarf kinds, but not in strict proportion to their height. Hare's dwarf Monmouth has very large leaves, and the Pois Nain Hatif and the moderately tall blue Prussian have leaves about 2/3 of the size of the tallest kind. In the Dancroft, the leaflets are rather small and a little pointed. In the Queen of Dwarfs, rather rounded, and in the Queen of England, broad and large. In these three peas, the slight differences in the shape of the leaves are accompanied by slight differences in color. In the Pois Jeant sans Parchemin, which bears purple flowers, the leaflets in the young plant are edged with red, and in all the peas with purple flowers the stipules are marked with red. In the different varieties, 1, 2, or several flowers in a small cluster are borne on the same peduncle, and this is a difference which is considered of specific value in some of the leguminos. In all the varieties, the flowers closely resemble each other, except in color and size. They are generally white, sometimes purple, but the color is inconstant. Even in the same variety in Warner's Emperor, which is a tall kind, the flowers are nearly double the size of the Pois Nain Hatif. But Hare's dwarf Monmouth, which has large leaves likewise, has large flowers. The calyx in the Victoria Marrow is large, and in Bishop's Long Pod, the sepals are rather narrow. In no other kind is there any difference in the flower. The pods and seeds, which with natural species afford such constant characters, differ greatly in the cultivated varieties of the pea, and these are the valuable, and consequently, the selected parts. Sugar peas or pea are remarkable from their thin pods, which whilst young are cooked and eaten whole. And in this group, which according to Mr. Gordon includes 11 subvarieties, it is the pod which differs most. Thus Lewis negropodded pea has a straight, broad, smooth, and dark purple pod, with a husk not so thin as in the other kinds. The pod of another variety is extremely bowed, that of the Pois Jeant is much pointed at the extremity, and in the variety Agrans Casas the peas are seen through the husk in so conspicuous a manner that the pod, especially when dry, can hardly at first be recognized as that of a pea. In the ordinary varieties, the pods also differ much in size and color, that of Woodford's green marrow being bright green when dry instead of pale brown, and that of the purple-podded pea being expressed by its name and smoothness, that of Dancroft being remarkably glossy, whereas that of the Ni plus ultra is rugged in being either nearly cylindrical, broad and flattened, being pointed at the end, as in Thurston's Reliance, or much truncated, as in the American dwarf. In the Auvergne pea, the whole end of the pod is bowed upwards in the Queen of the Dwarfs, and in Scimitar peas, the pod is almost elliptic in shape. I here give drawings of the 4 most distinct pods produced by the plants cultivated by me. Illustration. Fig. 41 pods of the common pea. In the pea itself, we have every tint between almost pure white, brown, yellow, and intense green. In the varieties of the sugar peas, we have these same tints together, with red passing through fine purple into a dark chocolate tint. These colors are either uniform or distributed in dots, striae, or moss-like marks. They depend in some cases on the color of the cotyledons seen through the skin, and in other cases on the outer coats of the pea itself. In the different varieties, the pods contain, according to Mr. Gordon, from 11 or 12 to only 4 or 5 peas. The largest peas are nearly twice as much in diameter as the smallest, and the latter are not always borne by the most dwarfed kinds. Peas differ much in shape, being smooth and spherical, smooth and oblong, nearly oval in the Queen of the Dwarfs, and nearly cubical and crumpled in many of the larger kinds. With respect to the value of the differences between the chief varieties, it cannot be doubted that if one of the tall sugar peas with purple flowers, thin-skinned pods of an extraordinary shape, including large dark purple peas, grew wild by the side of the lowly Queen of the Dwarfs with white flowers, grayish-green rounded leaves, scimitar-like pods containing oblong, smooth, pale-colored peas, which became mature at a different season, or by the side of one of the gigantic sorts like the Champion of England, with leaves of great size, pointed pods, and large green, crumpled, almost cubical peas, all 3 kinds would be ranked as distinct species. Andrew Knight, 85, has observed that the varieties of peas keep very true, because they are not crossed by insects. As far as the fact of keeping true is concerned, I hear from Mr. Masters of Canterbury, Well known as the originator of several new kinds, that certain varieties have remained constant for a considerable time. For instance, Knight's blue dwarf, which came out about the year 182,086, but the greater number of varieties have a singularly short existence. Thus, Loudon remarks 87 that sorts which were highly approved in 1821 are now in 1833 nowhere to be found. And on comparing the lists of 1833 with those of 1855, I find that nearly all the varieties have changed. Mr. Masters informs me that the nature of the soil causes some varieties to lose their character. As with other plants, certain varieties can be propagated truly, whilst others show a determined tendency to vary. Thus, two peas differing in shape, one round and the other wrinkled, were found by Mr. Masters within the same pod. But the plants raised from the wrinkled kind always evinced strong tendency to produce round peas. Mr. Masters also raised from a plant of another variety 4 distinct subvarieties, which bore blue and round blue, and wrinkled and white and wrinkled peas. And although he sowed these 4 varieties separately during several successive years, each kind always reproduced all 4 kinds mixed together. With respect to the varieties not naturally intercrossing, I have ascertained that the pea, which in this respect differs from some other leguminos, is perfectly fertile without the aid of insects. Yet I have seen humblebees, whilst sucking the nectar, depress the keel petals, and become so thickly dusted with pollen that it could hardly fail to be left on the stigma of the next flower, which was visited. Nevertheless, distinct varieties, growing closely together, rarely cross, and I have reason to believe that this is due to their stigmas being prematurely fertilized in this country by pollen from the same flower. The horticulturists who raise seed peas are thus enabled to plant distinct varieties close together without any bad consequences, and it is certain, as I have myself found, that true seed may be saved during at least several generations under these circumstances. 88 Mr. Fitch raised, as he informs me, one variety for 20 years, and it always came true, though grown close to other varieties. From the analogy of kidney beans, I should have expected 89 that varieties thus circumstanced would have occasionally crossed, and I shall give in the 11th chapter 2 cases of this having occurred, as shown in a manner hereafter, to be explained by the pollen of the one variety having acted directly on the seeds of the other. Whether many of the new varieties which incessantly appear are due to such occasional and accidental crosses, I do not know, nor do I know whether the short existence of almost all the numerous varieties is the result of mere change of fashion, or of their having a weak constitution from being the product of long-continued self-fertilization. It may, however, be noticed that several of Andrew Knight's varieties, which have endured longer than most kinds, were raised towards the close of the last century by artificial crosses. Some of them, I believe, were still vigorous in 1860, but now, in 1865, a writer speaking 90 of Knight's 4 kinds of marrows says they have acquired a famous history, but their glory has departed. With respect to beans Faba vulgaris, I will say but little. Dr. Field has given 91 short diagnostic characters of 40 varieties. Everyone who has seen a collection must have been struck with the great difference in shape, thickness, proportional length, and breadth, color, and size, which beans present. What a contrast between a Windsor and horsebean! As in the case of the pea, our existing varieties were preceded during the Bronze Age in Switzerland 92 by a peculiar and now extinct variety producing very small beans 93. Potato Solanum tuberosum. There is little doubt about the parentage of this plant, for the cultivated varieties differ extremely little in general appearance from the wild species, which can be recognized in its native land at the first glance. 94. The varieties cultivated in Britain are numerous. Thus Lawson 95 gives a description of 175 kinds. I planted 18 kinds in adjoining rows. Their stems and leaves differed but little, and in several cases there was as great a difference between the individuals of the same variety as between the different varieties. The flower varied in size and in color between white and purple, but in no other respect, except that in one kind the sepals were somewhat elongated. One strange variety has been described which always produces 2 sorts of flowers, the first double and sterile, the second single and fertile. 96. The fruit or berries also differ, but only in a slight degree. 97. The varieties are liable in very different degree to the attack of the Colorado potato beetle. 98. The tubers, on the other hand, present a wonderful amount of diversity. This fact accords with the principle that the valuable and selected parts of all cultivated productions present the greatest amount of modification, they differ much in size and shape, being globular, oval, flattened, kidney-like, or cylindrical. One variety from Peru is described 99 as being quite straight, and at least 6 inches in length, though no thicker than a man's finger. The eyes or buds differ in form, position, and color. The manner in which the tubers are arranged on the so-called roots or rhizomes is different. Thus in the Gherkin they form a pyramid with the apex downwards, and in another variety they bury themselves deep in the ground. The roots themselves run either near the surface or deep in the ground. The tubers also differ in smoothness and color, being externally white, red, purple, or almost black, and internally white, yellow, or almost black. They differ in flavor and quality, being either waxy or mealy in their period of maturity, and in their capacity for long preservation. As with many other plants which have been long propagated by bulbs, tubers, cuttings, etc., by which means the same individual is exposed during a length of time to diversified conditions, seedling potatoes generally display innumerable slight differences. Several varieties, even when propagated by tubers, are far from constant, as will be seen in the chapter on bud variation. Dr. Anderson, 100, procured seed from an Irish purple potato, which grew far from any other kind, so that it could not, at least in this generation, have been crossed. Yet the many seedlings varied in almost every possible respect, so that scarcely 2 plants were exactly alike. Some of the plants, which closely resembled each other above ground, produced extremely dissimilar tubers, and some tubers which externally could hardly be distinguished differed widely in quality when cooked. Even in this case of extreme variability, the parent stock had some influence on the progeny, for the greater number of the seedlings resembled in some degree the parent. Irish potato, kidney potatoes, must be ranked amongst the most highly cultivated and artificial races. Nevertheless, their peculiarities can often be strictly propagated by seed. A great authority, Mr. Rivers 101, states that seedlings from the ash-leaved kidney always bear a strong resemblance to their parent. Seedlings from the fluke kidney are still more remarkable for their adherence to their parent stock. For on closely observing a great number during 2 seasons, I have not been able to observe the least difference either in earliness, productiveness, or in the size or shape of their tubers. References: Chapter Roman 10, Plants continued. Fruits, ornamental trees, flowers. Fruits, grapes vary in odd and trifling particulars. Mulberry, the orange group singular, results from crossing peach and nectarine. Bud variation, analogous variation relation to the almond, apricot, plums variation in their stones. Cherries, singular varieties, affable, pear, strawberry, interblending of the original forms. Gooseberry, steady increase in size of the fruit varieties. Off, walnut, nut, cucurbitaceous plants, wonderful variation of ornamental trees, their variation in degree and kind. Striscach, fir, hawthorn. Flowers, multiple origin of many kinds. Variation in constitutional peculiarities. Kind of variation. Roses, several species. Cultivate, Pensidalia, hyacinth. History and variation of the vine. Vitis vinifera. The best authorities consider all our grapes as the descendants of one species, which now grows wild in Western Asia, which grew wild during the Bronze Age in Italy. 1. And which has recently been found fossil in a tufaceous deposit in the south of France. 2. Some authors, however, entertain much doubt about the single parentage of our cultivated varieties, owing to the number of semi-wild forms found in southern Europe, especially as described by Clement III in a forest in Spain, but as the grape sows itself freely in southern Europe, and as several of the chief kinds transmit their characters by seed. 4. Whilst others are extremely variable, the existence of many different escaped forms could hardly fail to occur. Countries where this plant has been cultivated from the remotest antiquity, that the vine varies much when propagated by seed, we may infer from the largely increased number of varieties. Since the earlier historical records, new hothouse varieties are produced almost every year. For instance, 5. A golden-colored variety has been recently raised in England from a black grape without the aid of a cross. Van Mons, 6, reared a multitude of varieties from the seed of one vine, which was completely separated from all others, so that there could not, at least in this generation, have been any crossing, and the seedlings presented less analogues to touts, less sorties, and differed in almost every possible character, both in the fruits and foliage. The cultivated varieties are extremely numerous. Count Odart says that he will not deny that there may exist throughout the world 700 or 800, perhaps even 1,000 varieties, but not a third of these have any value in the catalogue of fruit cultivated in the horticultural gardens of London, published in 1842, 99 varieties are enumerated wherever the grape is grown. Many varieties occur. Pallas describes 24 in the Crimea, and Burns mentions 10 in Kabul. The classification of the varieties has much perplexed writers, and Count Odart is reduced to a geographical system. But I will not enter on this subject, nor on the many and great differences between the varieties. I will merely specify a few curious and trifling peculiarities, all taken from Odart's highly esteemed work. 7. For the sake of showing the diversified variability of this plant, Simon has classed grapes into two main divisions, those with downy leaves and those with smooth leaves. But he admits that in one variety, namely the Rebozo, the leaves are either smooth or downy, and Odart P70 states that some varieties have the nerves alone, and other varieties their young leaves downy, whilst the old ones are smooth. The Pedro Ximenes grape, Odart P397, presents a peculiarity by which it can be at once recognized amongst a host of other varieties, namely that when the fruit is nearly ripe, the nerves of the leaves, or even the whole surface, becomes yellow. The Barbara d'Asti is well marked by several characters, P426, amongst others by some of the leaves, and it is always the lowest on the branches, suddenly becoming of a dark red color. Several authors in classifying grapes have founded their main divisions on the berries being either round or oblong, and Odart admits the value of this character. Yet there is one variety, the Macabeo P71, which often produces small round and large oblong berries in the same bunch. Certain grapes, called Nebbiolo P429, present a constant character sufficient for their recognition, namely the slight adherence of that part of the pulp, which surrounds the seeds to the rest of the berry. When cut through transversely, a Rhenish variety is mentioned, P228, which likes a dry soil. The fruit ripens well, but at the moment of maturity, if much rain falls, the berries are apt to rot. On the other hand, the fruit of a Swiss variety, P243, is valued for well-sustaining prolonged humidity. This latter variety sprouts late in the spring, yet matures its fruit early. Other varieties, page 362, have the fault of being too much excited by the April sun, and in consequence suffer from frost. A Styrian variety, P254, has brittle footstalks, so that the clusters of fruit are often blown off. This variety is said to be particularly attractive to wasps and bees. Other varieties have tough stalks, which resist the wind. Many other variable characters could be given, but the foregoing facts are sufficient to show in how many small structural and constitutional details the vine varies during the vine disease in France. Certain old groups of varieties 8 have suffered far more from mildew than others. Thus the group of Chasselas, so rich in varieties, did not afford a single fortunate exception. Certain other groups suffered much less. The true old Burgundy, for instance, was comparatively free from disease, and the Carmenat likewise resisted the attack. The American vines, which belong to a distinct species, entirely escaped the disease in France, and we thus see that those European varieties, which best resist the disease, must have acquired in a slight degree the same constitutional peculiarities as the American species. White mulberry, Morris albi, mention this plant because it has varied in certain characters, namely in the texture and quality of the leaves, fitting them to serve as food for the domesticated silkworm, in a manner not observed with other plants. But this has arisen simply from such variations in the mulberry, having been attended to selected and rendered more or less constant. Roman 1000 de Quatrefages 9 briefly describes 6 kinds cultivated in one valley. In France, of these, the Amoroso produces excellent leaves, but is rapidly being abandoned because it produces much fruit mingled with the leaves. The Antofino yields deeply cut leaves of the finest quality, but not in great quantity. The Claro is much sought for because the leaves can be easily collected. Lastly, the Rosso bears strong hardy leaves produced in large quantity, but with the one inconvenience that they are best adapted for the worms after their fourth molt. Roman 2000 Jacquemet Bonifant of Lyon, however, remark in their catalogue, 1862, that 2 subvarieties have been confounded under the name of the Rosso, one having leaves too thick for the caterpillars, the other being valuable, because the leaves can easily be gathered from the branches without the bark being torn. In India, the mulberry has also given rise to many varieties. The Indian form is thought by many botanists to be a distinct species, but as Royal remarks 10, so many varieties have been produced by cultivation that it is difficult to ascertain whether they all belong to one species. They are, as he adds, nearly as numerous as those of the silkworm. The orange group we here meet with great confusion in the specific distinction and parentage of the several kinds. Galesio 11, who almost devoted his lifetime to the subject, considers that there are 4 species, namely sweet and bitter oranges, lemons, and citrons, each of which has given rise to whole groups of varieties, monsters, and supposed hybrids. One high authority 12 believes that these 4 reputed species are all varieties of the wild Citrus medica, but that the Shattuck Citrus decumana, which is not known in a wild state, is a distinct species, though its distinctness is doubted by another writer of great authority on such matters, namely Dr. Buchanan Hamilton Alf de Candolle, 13. On the other hand, there cannot be a more capable judge advances what he considers sufficient evidence of the orange. He doubts whether the bitter and sweet kinds are specifically distinct, the lemon and citron having been found wild, and, consequently, that they are distinct. He mentions 2 other forms cultivated in Japan and Java, which he ranks undoubted species. He speaks rather more doubtfully about the Shattuck, which varies much, and has not been found wild. And finally, he considers some forms such as Adam's apple and the bergamot as probably hybrids. I have briefly abstracted these opinions for the sake of showing those who have never attended to such subjects how perplexing they are. It would therefore be useless for my purpose to give a sketch of the conspicuous differences between the several forms, besides the ever-recurrent difficulty of determining whether forms found wild are truly aboriginal or are escaped seedlings. Many of the forms, which must be ranked as varieties, transmit their characters almost perfectly by seed. Sweet and bitter oranges differ in no important respect, except in the flavor of their fruit, but Galesio 14 is most emphatic that both kinds can be propagated by seed with absolute certainty. Consequently, in accordance with his simple rule, he classes them as distinct species, as he does sweet and bitter almonds, the peach and nectarine, etc. He admits, however, that the soft-chilled pine tree produces not only soft-chilled, but some hard-chilled seedlings, so that a little greater force in the power of inheritance would, according to this rule, raise a soft-chilled pine tree into the dignity of an aboriginally created species. The positive assertion made by Macfadden 15 that the pips of sweet oranges produced in Jamaica, according to the nature of the soil in which they are sown, either sweet or bitter oranges, is probably an error. For Roman 1000 Alf de Candolle informs me that since the publication of his great work he has received accounts from Guyana, the Antilles, and Mauritius, that in these countries sweet oranges faithfully transmit their character. Galesio found that the willow-leafed and the little China oranges reproduced their proper leaves and fruit, but the seedlings were not quite equal in merit to their parents. The red-fleshed orange, on the other hand, fails to reproduce itself. Galesio also observed that the seeds of several other singular varieties all reproduce trees, having a peculiar physiognomy, partly resembling their parent forms. I can adduce another case. The myrtle-leaved orange is ranked by all authors as a variety, but is very distinct in general aspect. In my father's greenhouse during many years, it rarely yielded any fruit, but at last produced one, and a tree thus raised was identical with the parent form. Another and more serious difficulty in determining the rank of the several forms is that, according to Galesio 16, they largely intercross without artificial aid. Thus he positively states that seeds taken from lemon trees Roman 100 lemonum growing mingled with the citron Roman 100 medica, which is generally considered as a distinct species, produced a graduated series of varieties between these 2 forms. Again, an Adam's apple was produced from the seed of a sweet orange, which grew close to lemons and citrons. But such facts hardly aid us in determining whether to rank these forms as species or varieties, for it is now known that undoubted species of Verbascum cistus, Primula salix, etc. frequently cross in a state of nature. If indeed it were proved that plants of the orange tribe raised from these crosses were even partially sterile, it would be a strong argument in favor of their rank as species. Galesio asserts that this is the case, but he does not distinguish between sterility from hybridism and from the effects of culture, and he almost destroys the force of this statement by another 17, namely, that when he impregnated the flowers of the common orange with the pollen taken from undoubted varieties of the orange, monstrous fruits were produced which included little pulp and had no seeds or imperfect seeds. In this tribe of plants, we meet with instances of 2 highly remarkable facts. In vegetable physiology, Galesio 18 impregnated an orange with pollen from a lemon, and the fruit borne on the mother tree had a raised stripe of peel like that of a lemon, both in color and taste, but the pulp was like that of an orange, and included only imperfect seeds, the possibility of pollen from one variety or species, directly affecting the fruit produced by another variety of species, is a subject which I shall fully discuss in the following chapter. The second remarkable fact is that two supposed hybrids 19 for their hybrid nature was not ascertained between an orange, and either a lemon or citron produced on the same tree, leaves flowers and fruit of both pure parent forms, as well as of a mixed or crossed nature. A bud taken from any one of the branches and grafted on another tree produces either one of the pure kinds or a capricious tree, reproducing the three kinds, whether the sweet lemon, which includes within the same fruit segments of differently flavored pulp 20, is an analogous case I know not, but to this subject I shall have to recur. I will conclude by giving from Aristo 21 a short account of a very singular variety of the common orange. It is the Citrus aurantium fructu variabile, which on the young shoots produces rounded oval leaves, spotted with yellow borne on petioles, with heart-shaped wings when these leaves fall off. They are succeeded by longer and narrower leaves with undulated margins of a pale green color, embroidered with yellow borne on footstalks, without wings the fruit, whilst young is pear-shaped yellow longitudinally striated and sweet, but as it ripens it becomes spherical of a reddish yellow and bitter. Peach and Nectarine Amygdalus persica, the best authorities are nearly unanimous that the peach has never been found wild. It was introduced from Persia into Europe a little before the Christian era, and at this period, few varieties existed. Alf de Candolle, 22, from the fact of the peach not having spread from Persia at an earlier period, and from its not having pure Sanskrit or Hebrew names, believes that it is not an aboriginal of Western Asia, but came from the terra incognita of China. The supposition, however, that the peach is a modified almond, which acquired its present character at a comparatively late period, would, I presume, account for these facts on the same principle that the nectarine, the offspring of the peach, has few native names, and became known in Europe at a still later period. Illustration: Peach and Almond Stones. Andrew Knight, 23, from finding that a seedling tree raised from a sweet almond, fertilized by the pollen of a peach, yielded fruit quite like that of a peach, suspected that the peach tree is a modified almond, and in this, he has been followed by various authors. 24. A first-rate peach, almost globular in shape, formed of soft and sweet pulp, surrounding a hard, much furrowed, and slightly flattened stone, certainly differs greatly from an almond with its soft, slightly furrowed, much flattened and elongated stone, protected by a tough greenish layer of bitter flesh. Mr. Bentham, 25, has particularly called attention to the stone of the almond being so much more flattened than that of the peach, but in the several varieties of the almond, the stone differs greatly in the degree to which it is compressed in size, shape, strength, and in the depth of the furrows, as may be seen in Fig. 42, knows 4 to 8 of such kinds, as I have been able to collect with peach stones. Also knows 1 to 3. The degree of compression and elongation is seen to vary, so that the stone of the Chinese honeypeach No. 3 is much more elongated and compressed than that of the No. 8 Smyrna almond. Mr. Rivers of Sawbridgeworth, to whom I am indebted for some of the specimens above figured, and who has had such great horticultural experience, has called my attention to several varieties which connect the almond and the peach. In France, there is a variety called the peach almond, which Mr. Rivers formerly cultivated, and which is correctly described in a French catalogue as being oval and swollen with the aspect of a peach, including a hard stone, surrounded by a fleshy covering which is sometimes eatable. 26. A remarkable statement by Roman 1000 Leuset has recently appeared in the Review Horticole 27, namely, that a peach almond grafted on a peach bore during 1863 and 1864 almonds alone, but in 1865 bore 6 peaches and no almonds. Roman 1000 Carrière, in commenting on this fact, cites the case of a double-flowered almond, which after producing during several years, almonds suddenly bore for 2 years in succession spherical fleshy peach-like fruits, but in 1865 reverted to its former state and produced large almonds. Again, as I hear from Mr. Rivers, the double-flowering Chinese peaches resemble almonds in their manner of growth, and in their flowers the fruit is much elongated and flattened, with the flesh both bitter and sweet, but not uneatable, and it is said to be of better quality in China. From this stage, one small step leads us to such inferior peaches as are occasionally raised from seed. For instance, Mr. Rivers sowed a number of peach stones imported from the United States, where they are collected for raising stocks. And some of the trees raised by him produced peaches, which were very like almonds in appearance, being small and hard with the pulp not softening till very late in the autumn. Van Mons, 28, also states that he once raised from a peachstone a peach having the aspect of a wild tree with fruit, like that of the almond from inferior peaches. Such as these just described, we may pass by small transitions through clingstones of poor quality to our best and most melting kinds from this gradation, from the cases of sudden variation above recorded, and from the fact that the peach has not been found wild. It seems to me by far the most probable view that the peach is the descendant of the almond improved and modified in a marvelous manner. One fact, however, is opposed to this conclusion. A hybrid raised by night from the sweet almond, by the pollen of the peach produced flowers, with little or no pollen yet bore fruit, having been apparently fertilized by a neighboring nectarine. Another, hybrid from a sweet almond, by the pollen of a nectarine produced during the first 3 years imperfect blossoms, but afterwards perfect flowers with an abundance of pollen, if this slight degree of sterility cannot be accounted for by the youth of the trees, and this often causes less infertility, or by the monstrous state of the flowers, or by the conditions to which the trees were exposed, these two cases would afford a good argument against the peach being the descendant of the almond. Whether or not the peach has proceeded from the almond, it has certainly given rise to nectarines or smooth peaches, as they are called by the French. Most of the varieties, both of the peach and nectarine, reproduce themselves truly, by seed. Galizio, 29, says, he has verified this with respect to 8 races of the peach. Mr. Rivers, 30, has given some striking instances from his own experience, and it is notorious that good peaches are constantly raised in North America from seed. Many of the American subvarieties come true or nearly true to their kind, such as the white blossoms, several of the yellow-fruited freestone peaches, the blood clingstone, the heath, and the lemon clingstone. On the other hand, a clingstone peach has been known to give rise to a freestone. 31. In England, it has been noticed that seedlings inherit from their parents flowers of the same size and color. Some characters, however contrary to what might have been expected, often are not inherited, such as the presence and form of the glands on the leaves. 32. With respect to nectarines, both cling and freestones are known in North America to reproduce themselves by seed. 33. In England, the new white nectarine was a seedling of the old white, and Mr. Rivers, 34, has recorded several similar cases from this strong tendency to inheritance which both peach and nectarine trees exhibit from certain slight constitutional differences. 35. In their naturine, from the great difference in their fruit both in appearance and flavor, it is not surprising, notwithstanding that the trees differ in no other respects, and cannot even be distinguished, as I am informed by Mr. Rivers, whilst young, that they have been ranked by some authors as specifically distinct. Galizio does not doubt that they are distinct. Even Alf de Candolle does not appear perfectly assured of their specific identity, and an eminent botanist has quite recently, 36, maintained that the nectarine probably constitutes a distinct species. Hence it may be worth while to give all the evidence on the origin of the nectarine. The facts in themselves are curious, and will hereafter have to be referred to when the important subject of bud variation is discussed. It is asserted, 37, that the Boston nectarine was produced from a peachstone, and this nectarine reproduced itself by seed. 38. Mr. Rivers states, 39, that from stones of 3 distinct varieties of the peach, he raised 3 varieties of nectarine, and in one of these cases no nectarine grew near the parent peach tree. In another instance, Mr. Rivers raised a nectarine from a peach, and in the succeeding generation, another nectarine from this nectarine. 40. Other such instances have been communicated to me, but they need not be given of the converse case, namely of nectarine stones yielding peach trees, both free and clingstones. We have 6 undoubted instances recorded by Mr. Rivers, and in 2 of these instances, the parent nectarines had been seedlings from other nectarines. 40. With respect to the more curious case of full-grown peach trees suddenly producing nectarines by bud variation, or sports, as they are called by gardeners, the evidence is superabundant. There is also good evidence of the same tree producing both peaches and nectarines, or half-and-half fruit. By this term, I mean a fruit with the one half a perfect peach, and the other half a perfect nectarine. Peter Collinson, in 1741, recorded the first case of a peach tree producing a nectarine. 42, and in 1766, he added 2 other instances in the same work. The editor, Sir J. E. Smith, describes the more remarkable case of a tree in Norfolk, which usually bore both perfect nectarines and perfect peaches. But during 2 seasons, some of the fruit were half and half in nature. Mr. Salisbury in 180,843 records 6 other cases of peach trees producing nectarines. 3 of the varieties are named, viz. The Alberge Belle Chevreuse and Royal George. This latter tree seldom failed to produce both kinds of fruit. He gives another case of a half-and-half fruit. At Radford in Devonshire 44, a clingstone peach purchased as the Chancellor was planted in 1815, and in 1824, after having previously produced peaches alone bore on one branch 12 nectarines in 1825, the same branch yielded 26 nectarines, and in 1826, 36 nectarines together with 18 peaches. One of the peaches was almost as smooth on one side as a nectarine. The nectarines were as dark as but smaller than the El Rouge. At Beccles, a Royal George peach 45 produced a fruit, 3 parts of it being peach, and 1 part nectarine, quite distinct in appearance as well as in flavor. The lines of division were longitudinal, as represented in the woodcut. A nectarine tree grew 5 yards from this tree. Professor Chapman states 46 that he has often seen in Virginia very old peach trees bearing nectarines. A writer in the Gardener's Chronicle says that a peach tree planted 15 years previously 47 produced this year a nectarine between 2 peaches. A nectarine tree grew close by. In 184,440, a vanguard peach tree produced in the midst of its ordinary fruit a single red Roman nectarine. Mr. Calver is stated 49 to have raised in the United States a seedling peach, which produced a mixed crop of both peaches and nectarines. Near Dorking 50, a branch of the Teton de Venus peach, which reproduces itself truly by seed 51, bore its own fruit so remarkable for its prominent point, and a nectarine rather smaller but well-formed and quite round. The previous cases all refer to peaches suddenly producing nectarines, but at Carclew 52, the unique case occurred of a nectarine tree raised 20 years before from seed and never grafted, producing a fruit half peach and half nectarine, subsequently bore a perfect peach. To sum up the foregoing facts, we have excellent evidence of peach stones producing nectarine trees and of nectarine stones producing peach treesoff, the same tree bearing peaches and nectarinesoff peach trees, suddenly producing by bud variation nectarines, such nectarines reproducing nectarines by seed as well as fruit in part nectarine and in part peach, and lastly of one nectarine tree first bearing half and half fruit and subsequently true peaches. As the peach came into existence before the nectarine, it might have been expected from the law of reversion that nectarines would have given birth by bud variation or by seed to peaches oftener than peaches to nectarines. But this is by no means the case. 2 explanations have been suggested to account for these conversions. First, that the parent trees have been in every case hybrids 53 between the peach and nectarine, and have reverted by bud variation, or by seed to one of their pure parent forms. This view in itself is not very improbable, for the mountaineer peach, which was raised by night from the red nutmeg peach by pollen of the violet hadave nectarine 54, produces peaches, but these are said sometimes to partake of the smoothness and flavor of the nectarine. But let it be observed that in the previous list, no less than 6 well-known varieties, and several unnamed varieties of the peach, have once suddenly produced perfect nectarines by bud variation, and it would be an extremely rash supposition that all these varieties of the peach which have been cultivated for years in many districts, and which show not a vestige of a mixed parentage, are nevertheless hybrids. A second explanation is that the fruit of the peach has been directly affected by the pollen of the nectarine. Although this certainly is possible, it cannot here apply, for we have not a shadow of evidence that a branch which has borne fruit directly affected by foreign pollen is so profoundly modified as afterwards to produce buds, which continue to yield fruit of the new and modified form. Now, it is known that when a bud on a peach tree has once borne a nectarine, the same branch has in several instances gone on, during successive years, producing nectarines. The Carclew nectarine, on the other hand, first produced half and half fruit, and subsequently pure peaches. Hence, we may confidently accept the common view that the nectarine is a variety of the peach, which may be produced either by bud variation or from seed. In the following chapter, many analogous cases of bud variation will be given. The varieties of the peach and the nectarine run in parallel lines in both classes. The kinds differ from each other in the flesh of the fruit being white, red, or yellow, in being clingstones or freestones, in the flowers being large or small, with certain other characteristic differences, and in the leaves being serrated without glands or crenated, and furnished with globose or reniform. Glands 55, we can hardly account for this parallelism by supposing that each variety of the nectarine is descended from a corresponding variety of the peach, for though our nectarines are certainly the descendants of several kinds of peaches, yet a large number are the descendants of other nectarines, and they vary so much when thus reproduced that we can scarcely admit the above explanation. The varieties of the peach have largely increased in number since the Christian era, when from 2 to 5 varieties were known. 56, and the nectarine was unknown at the present time, besides many varieties said to exist in China. Downing describes in the United States 7 to 9 native and imported varieties of the peach, and a few years ago Linley 57 enumerated 106 to 4 varieties of the peach and nectarine grown in England. I have already indicated the chief points of difference between the several varieties. Nectarines, even when produced from distinct kinds of peaches, always possess their own peculiar flavor, and are smooth and small clingstone and freestone peaches, which differ in the ripe flesh, either firmly adhering to the stone or easily separating from it. Also differ in the character of the stone itself, that of the freestones or melters being more deeply fissured, with the sides of the fissures smoother than in clingstones. In the various kinds, the flowers differ not only in size, but in the larger flowers, the petals are differently shaped, more imbricated, generally red in the center, and pale towards the margin, whereas in the smaller flowers, the margin of the petal is usually more darkly colored. One variety has nearly white flowers. The leaves are more or less serrated, and are either destitute of glands or have globose or reniform glands. 58, and some few peaches, such as the Brugnan, bear on the same tree both globular and kidney-shaped glands. 59, according to Robertson. 60, the trees with glandular leaves are liable to blister, but not in any great degree to mildew, whilst the non-glandular trees are more subject to curl, to mildew, and to the attacks of aphides. The varieties differ in the period of their maturity in the fruit keeping well, and in hardiness, latter circumstance being especially attended to. In the United States, certain varieties, such as the Bellegarde, stand forcing in hothouses better than other varieties. The flat peach of China is the most remarkable of all the varieties. It is so much depressed towards the summit that the stone is here covered only by roughened skin, and not by a fleshy layer. 61, another Chinese variety, called the honey peach, is remarkable from the fruit, terminating in a long sharp point. Its leaves are glandless and widely dentate. 62, the Emperor of Russia peach is a third singular variety having deeply double-serrated leaves. The fruit is deeply cleft with one half projecting considerably beyond the other. It originated in America, and its seedlings inherit similar leaves. 63. The peach has also produced in China a small class of trees valued for ornament, namely the double-flowered. Of these 5 varieties are now known in England, varying from pure white through rose to intense crimson. 64. One of these varieties, called the camellia-flowered, bears flowers above 214 inches in diameter, whilst those of the fruit-bearing kinds do not at most exceed 114 inch in diameter. The flowers of the double-flowered peaches have the singular property 65 of frequently producing double or treble fruit. Finally, there is good reason to believe that the peach is an almond profoundly modified, but whatever its origin may have been, there can be no doubt that it has yielded during the last 18 centuries many varieties, some of them strongly characterized, belonging both to the nectarine and peach form. Apricot, Prunus armeniaca. It is commonly admitted that this tree is descended from a single species, now found wild in the Caucasian region. 66. On this view, the varieties deserve notice, because they illustrate differences supposed by some botanists to be of specific value. In the almond and plum, the best monograph on the apricot is by Mr. Thompson. 67, who describes 17 varieties. We have seen that peaches and nectarines vary in a strictly parallel manner, and in the apricot, which forms a closely allied genus, we again meet with variations analogous to those of the peach, as well as to those of the plum. The varieties differ considerably in the shape of their leaves, which are either serrated or crenated, sometimes with ear-like appendages at their bases, and sometimes with glands on the petioles. The flowers are generally alike, but are small in the masculine. The fruit varies much in size, shape, and in having the suture little pronounced or absent, in the skin being smooth or downy, as in the orange apricot, and in the flesh clinging to the stone as in the last-mentioned kind, or in readily separating from it, as in the Turkey apricot. In all these differences, we see the closest analogy with the varieties of the peach and nectarine. In the stone, we have more important differences, and these in the case of the plum have been esteemed of specific value. In some apricots the stone is almost spherical, in others much flattened, being either sharp in front or blunt at both ends, sometimes channeled along the back, or with a sharp ridge along both margins. In the moorpark, and generally in the hemskirk, the stone presents a singular character in being perforated with a bundle of fibers passing through the perforation from end to end. The most constant and important character, according to Thompson, is whether the kernel is bitter or sweet, yet in this respect we have a graduated difference, for the kernel is very bitter. In Shipley's apricot in the hemskirk, less bitter than in some other kinds, slightly bitter in the royal, and sweet like a hazelnut in the Breda Angoumois, and others. In the case of the almond, bitterness has been thought by some high authorities to indicate specific difference. In N. America, the Roman apricot endures cold and unfavorable situations where no other sort except the masculine will succeed, and its blossoms bear quite a severe frost without injury. 68. According to Mr. Rivers, 69, seedling apricots deviate but little from the character of their race. In France, the alberge is constantly reproduced from seed, with but little variation. In Ladakh, according to Moorcroft, 70-10 varieties of the apricot very different from each other are cultivated, and all are raised from seed, excepting one which is budded. Illustration. Plum stones. Plums, Prunus insidica. Formerly, the slow P. spinosa was thought to be the parent of all our plums, but now this honor is very commonly accorded to P. insidica, or the bullace, which is found wild in the Caucasus and in western India, and is naturalized in England. 71. It is not at all improbable, in accordance with some observations made by Mr. Rivers, 72, that both these forms, which some botanists rank as a single species, may be the parents of our domesticated plums. Another supposed parent form, the P. domestica, is said to be found wild in the region of the Caucasus. Godrin remarks, 73, that the cultivated varieties may be divided into two main groups, which he supposes to be descended from two aboriginal stocks, namely those with oblong fruit and stones, pointed at both ends, having narrow separate petals and upright branches, and those with rounded fruit with stones, blunt at both ends, with rounded petals and spreading branches. From what we know of the variability of the flowers in the peach, and of the diversified manner of growth in our various fruit trees, it is difficult to lay much weight on these latter characters. With respect to the shape of the fruit, we have conclusive evidence that it is extremely variable. Downing, 74, gives outlines of the plums of two seedlings, namely the red and imperial gauges raised from the green gauge, and the fruit of both is more elongated than that of the green gauge. The latter has a very blunt, broad stone, whereas the stone of the imperial gauge is oval and pointed at both ends. These trees also differ in their manner of growth. The green gauge is a very short-jinted, slow-growing tree of spreading and rather dwarfish habit, whilst its offspring, the imperial gauge, grows freely and rises rapidly, and has long dark shoots. The famous Washington plum bears a globular fruit, but its offspring, the emerald drop, is nearly as much elongated as the most elongated plum figured by Downing, namely Manning's prune. I have made a small collection of the stones of 25 kinds, and they graduate in shape from the bluntest into the sharpest kinds, as characters derived from seeds are generally of high systematic importance. I have thought it worthwhile to give drawings of the most distinct kinds in my small collection, and they may be seen to differ in a surprising manner in size, outline, thickness, prominence of the ridges, and state of surface. It deserves notice that the shape of the stone is not always strictly correlated with that of the fruit. Thus the Washington plum is spherical and depressed at the pole with a somewhat elongated stone, whilst the fruit of the Goliath is more elongated, but the stone less so than in the Washington. Again, Denier's Victoria and Goliath bear fruit closely resembling each other, but their stones are widely different. On the other hand, the Harvest and Black Margate plums are very dissimilar, yet include closely similar stones. The varieties of the plum are numerous and differ greatly in size, shape, quality, and color, being bright yellow-green, almost white, blue, purple, or red. There are some curious varieties, such as the double or Siamese, and the stoneless plum. In the latter, the kernel lies in a roomy cavity, surrounded only by the pulp. The climate of North America appears to be singularly favorable for the production of new and good varieties. Downing, describes no less than 40, of which 7 of first-rate quality have been recently introduced into England's 75 varieties, occasionally arise having an innate adaptation for certain soils, almost as strongly pronounced as with natural species growing on the most distinct geological formations. Thus in America, the imperial gage, differently from almost all other kinds, is peculiarly fitted for dry light soils, where many sorts drop their fruit, whereas on rich heavy soils, the fruit is often insipid. 76. My father could never succeed in making the wine sour yield even a moderate crop in a sandy orchard near Shrewsbury, whilst in some parts of the same county, and in its native Yorkshire, it bears abundantly. One of my relations also repeatedly tried in vain to grow this variety in a sandy district in Staffordshire. Mr. Rivers has given 77 a number of interesting facts, showing how truly many varieties can be propagated by seed. He sowed the stones of 20 bushels of the greengage for the sake of raising stalks, and closely observed the seedlings. All had the smooth shoots, the prominent buds, and the glossy leaves of the greengage, but the greater number had smaller leaves and thorns. There are 2 kinds of damson, one the Shropshire with downy shoots, and the other the Kentish with smooth shoots, and these differ but slightly in any other respect. Mr. Rivers sowed some bushels of the Kentish damson, and all the seedlings had smooth shoots, but in some the fruit was oval, in others round or roundish, and in a few the fruit was small, and except in being sweet closely resembled that of the wild sloe. Mr. Rivers gives several other striking instances of inheritance. Thus he raised 80,000 seedlings from the common German quetch plum, and not one could be found varying in the least in foliage or habit. Similar facts were observed with the petite Mirabelle plum, yet this latter kind, as well as the quetch, is known to have yielded some well-established varieties, but as Mr. Rivers remarks, they all belong to the same group with the Mirabelle. Cherries, Prunus cerasus avium, etc. Botanists believe that our cultivated cherries are descended from 1 to 4 or even more wild stocks. 78. That there must be at least 2 parent species, we may infer from the sterility of 20 hybrids, raised by Mr. Knight, from the morello fertilized by pollen of the Elton cherry, for these hybrids produced in all only 5 cherries, and 1 alone of these contained a seed. 79. Mr. Thompson 80 has classified the varieties in an apparently natural method in 2 main groups, by characters taken from the flower's fruit and leaves, but some varieties which stand widely separate in this classification are quite fertile when crossed. Thus Knight's early black cherries are the product of a cross between 2 such kinds. Mr. Knight states that seedling cherries are more variable than those of any other fruit tree. 81. In the catalogue of the Horticultural Society, for 1842, 80 varieties are enumerated. Some varieties present singular characters. Thus the flower of the cluster cherry includes as many as 12 pistils, of which the majority abort, and they are said generally to produce from 2 to 5 or 6 cherries aggregated together and borne on a single peduncle. In the Ratafia cherry, several flower peduncles arise from a common peduncle upwards of an inch in length. The fruit of Gascagna's heart has its apex produced into a globule or drop. That of the white Hungarian gene has almost transparent flesh. The Flemish cherry is a very odd-looking fruit, much flattened at the summit and base, with the latter deeply furrowed and borne on a stout, very short footstock. In the Kentish cherry, the stone adheres so firmly to the footstock that it could be drawn out of the flesh, and this renders the fruit well fitted for drying. The Tabacolave cherry, according to Sadgerat and Thompson, produces gigantic leaves more than a foot, and sometimes even 18 inches in length and half a foot in breadth. The weeping cherry, on the other hand, is valuable only as an ornament, and according to Downing, is a charming little tree, with slender weeping branches, clothed with small, almost myrtle-like foliage. There is also a peach-leaved variety. Sadgerat describes a remarkable variety, Le Griaudier de la Toussaint, which bears at the same time, even as late as September, flowers and fruit of all degrees of maturity. The fruit, which is of inferior quality, is borne on long, very thin footstalks, but the extraordinary statement is made that all the leaf-bearing shoots spring from old flower buds. Lastly, there is an important physiological distinction between those kinds of cherries, which bear fruit on young or on old wood. But Sadgerat positively asserts that a Bigarreau in his garden bore fruit on wood of both ages. 82. Apple Pyrus Malus. The one source of doubt felt by botanists with respect to the parentage of the apple is whether, besides P. malus, 2 or 3 other closely allied wild forms, namely P. acerba and P. arcox or paradisiaca, do not deserve to be ranked as distinct species. The ppr is supposed by some authors 83 to be the parent of the dwarf paradise stock, which owing to the fibrous roots not penetrating deeply into the ground, is so largely used for grafting. But the paradise stalks, it is asserted 84 cannot be propagated true by seed. The common wild crab varies considerably in England, but many of the varieties are believed to be escaped seedlings. 85 Everyone knows the great difference in the manner of growth in the foliage flowers, and especially in the fruit, between the almost innumerable varieties of the apple. The pips or seeds, as I know, by comparison likewise differ considerably in shape, size, and color. The fruit is adapted for eating, or for cooking in various ways, and keeps for only a few weeks, or for nearly 2 years. Some few kinds have the fruit covered with a powdery secretion called bloom like that on plums, and it is extremely remarkable that this occurs almost exclusively among varieties cultivated in Russia. 86 Another Russian apple, the white astrakhan, possesses the singular property of becoming transparent when ripe like some sorts of crabs. The API Edel has 5 prominent ridges, hence its name. The API noir is nearly black. The twin cluster pippin often bears fruit joined in pairs. 87. The trees of the several sorts differ greatly in their periods of leafing and flowering in my orchard. The court penduplat produces leaves so late that during several springs I thought that it was dead. The tiffin apple scarcely bears a leaf, when in full bloom. The Cornish crab, on the other hand, bears so many leaves at this period that the flowers can hardly be seen. 88 In some kinds, the fruit ripens in midsummer, in others late in the autumn. These several differences in leafing, flowering, and fruiting are not at all necessarily correlated, for, as Andrew Knight has remarked, 89, no one can judge from the early flowering of a new seedling, or from the early shedding or change of color of the leaves, whether it will mature its fruit early in the season. The varieties differ greatly in constitution. It is notorious that our summers are not hot enough for the Newton pippin 90, which is the glory of the orchards near New York. And so it is with several varieties which we have imported from the continent. On the other hand, our Court of Wick succeeds well under the severe climate of Canada. The Cavil Rouge de Micaud occasionally bears 2 crops during the same year. The bur knot is covered with small excrescences, which emit roots so readily that a branch with blossom buds may be stuck in the ground, and will root and bear a few fruit, even during the first year. 90. Mr. Rivers has recently described 92 some seedlings valuable from their roots running near the surface. One of these seedlings was remarkable from its extremely dwarfed size, forming itself into a bush only a few inches in height. Many varieties are particularly liable to canker in certain soils, but perhaps the strangest constitutional peculiarity is that the winter magetan is not attacked by the mealy bug, or coccus. Lindley 93 states that in an orchard in Norfolk infested with these insects, the magetan was quite free, though the stalk on which it was grafted was affected. Knight makes a similar statement with respect to a cider apple, and adds that he only once saw these insects just above the stalk, but that 3 days afterwards they entirely disappeared. This apple, however, was raised from a cross between the golden harvey and the Siberian crab, and the latter, I believe, is considered by some authors as specifically distinct. The famous St. Valery apple must not be passed over. The flower has a double calyx with 10 divisions and 14 styles, surmounted by conspicuous oblique stigmas, but is destitute of stamens or corolla. The fruit is constricted round the middle, and is formed of 5 seed cells surmounted by 9 other cells, 94 not being provided with stamens. The tree requires artificial fertilization, and the girls of St. Valery annually go to fair Cez palms, each marking her own fruit with a ribbon, and as different pollen is used the fruit differs, and we here have an instance of the direct action of foreign pollen on the mother plant. These monstrous apples include, as we have seen, 14 seed cells. The pigeon apple 95, on the other hand, has only 4 instead of, as with all common apples, 5 cells, and this certainly is a remarkable difference. In the Catalogue of Apples published in 1842 by the Horticultural Society, 897 varieties are enumerated, but the differences between most of them are of comparatively little interest, as they are not strictly inherited. No one can raise, for instance, from the seed of the Ribston pippin, a tree of the same kind, and it is said that the sister Ribston pippin was a white semi-transparent, sour-fleshed apple, or rather large crab. 96. Yet it was a mistake to suppose that, with most varieties, the characters are not to a certain extent inherited in 2 lots of seedlings raised from 2 well-marked kinds. many worthless crab-like seedlings will appear, but it is now known that the two lots not only usually differ from each other, but resemble to a certain extent their parents. We see this, indeed, in the several subgroups of russet sweetings, codlins, pearmains, rionettes, etc. 97, which are all believed, and many are known to be descended from other varieties bearing the same names. Pears Pyrus communis. I need say little on this fruit, which varies much in the wild state, and to an extraordinary degree when cultivated in its fruit, flowers, and foliage. One of the most celebrated botanists in Europe, Roman 1000 Duquesne, has carefully studied the many varieties 98, although he formerly believed that they were derived from more than one species. He now thinks that all belong to one. He has arrived at this conclusion from finding in the several varieties a perfect gradation between the most extreme characters. So perfect is this gradation that he maintains it to be impossible to classify the varieties by any natural method. Roman 1000 Duquesne raised many seedlings from 4 distinct kinds, and has carefully recorded the variations in each. Notwithstanding this extreme degree of variability, it is now positively known that many kinds reproduce by seed the leading characters of their race. 99. Strawberries Fragaria. This fruit is remarkable on account of the number of species which have been cultivated, and from their rapid improvement within the last 50 or 60 years. Let anyone compare the fruit of one of the largest varieties exhibited at our shows with that of the wildwood strawberry, or which will be a fairer comparison, with the somewhat larger fruit of the wild American Virginian strawberry, and he will see what prodigies horticulture has effected. 100. The number of varieties has likewise increased in a surprisingly rapid manner. Only 3 kinds were known in France in 1746, where this fruit was early cultivated. In 1766, 5 species had been introduced, the same which are now cultivated, but only 5 varieties of Fragaria vesca with some subvarieties had been produced at the present day. The varieties of the several species are almost innumerable. The species consist of firstly the wood or alpine cultivated strawberries descended from F. vesca, a native of Europe and of North America. There are 8 wild European varieties, as ranked by Duchesne of F. vesca, but several of these are considered species by some botanists. Secondly, the green strawberries descended from the European F. Collina, and little cultivated in England. Thirdly, the hautbois from the European F. elatere. Fourthly, the scarlets descended from F. virginiana, a native of the whole breadth of North America. Fifthly, the chili descended from F. chilensis, an inhabitant of the west coast of the temperate parts both of North and South America. Lastly, the pines or Carolinas, including the old blacks, which have been ranked by most authors under the name of F. grandiflora, as a distinct species, said to inhabit Suriname, but this is a manifest error. This form is considered by the highest authority, Roman 1000 Gay, to be merely a strongly marked race of F. chilensis. 100. 1. These 5 or 6 forms have been ranked by most botanists as specifically distinct, but this may be doubted for Andrew Knight 102, who raised no less than 400 crossed strawberries, asserts that the F. virginiana chilensis and grandiflora may be made to breed together indiscriminately, and he found, in accordance with the principle of analogous variation, that similar varieties could be obtained from the seeds of any one of them. Since Knight's time, there is abundant and additional evidence, 103, of the extent to which the American forms spontaneously cross. We owe, indeed, to such crosses most of our choicest existing varieties. Knight did not succeed in crossing the European woodstrawberry with the American scarlet, or with the hautbois. Mr. Williams of Pitmeston, however, succeeded, but the hybrid offspring from the hautbois, though fruiting well, never produced seed, with the exception of a single one, which reproduced the parent hybrid form. 4 Major R. Trevor Clark informs me that he crossed 2 members of the pine class Myette's B. Queen and Keen's seedling with the wood and hautbois, and that in each case he raised only a single seedling. One of these fruited, but was almost barren. Mr. W. Smith of York has raised similar hybrids with equally poor success. 105. We thus see 106 that the European and American species can with some difficulty be crossed, but it is improbable that hybrids sufficiently fertile to be worth cultivation will ever be thus produced. This fact is surprising, as these forms structurally are not widely distinct, and are sometimes connected in the districts where they grow wild, as I hear from Professor Assagre, by puzzling intermediate forms. The energetic culture of the strawberry is of recent date, and the cultivated varieties can in most cases be classed under some one of the above native stocks, As the American strawberries cross so freely and spontaneously, we can hardly doubt that they will ultimately become inextricably confused. We find indeed that horticulturists at present disagree under which class to rank some few of the varieties, and a writer in the Bon Jardinier of 1840 remarks that formerly it was possible to class all of them under some one species, but that now this is quite impossible with the American forms, the New English varieties having completely filled up the gaps between them. 107. The blending together of two or more aboriginal forms, which there is every reason to believe has occurred with some of our anciently cultivated productions, we see now actually occurring with our strawberries. The cultivated species offer some variations. Worth notice the Black Prince, a seedling from Keen's Imperial, this latter being a seedling of a very white strawberry. The White Carolina is remarkable from its peculiar dark and polished surface, and from presenting an appearance entirely unlike that of any other kind. 108. Although the fruit in the different varieties differs so greatly in form, size, color, and quality, the so-called seed, which corresponds with the whole fruit in the plum, with the exception of being more or less deeply embedded in the pulp, is, according to De Jong 109, absolutely the same in all, and this no doubt may be accounted for by the seed being of no value, and consequently not having been subjected to selection. The strawberry is properly three-leaved. But in 1761, Duchesne raised a single-leaved variety of the European woodstrawberry, which Linnaeus doubtfully raised to the rank of a species. Seedlings of this variety, like those of most varieties, not fixed by long-continued selection, often revert to the ordinary form or present intermediate states. 110. A variety raised by Mr. Mayet 111, apparently belonging to one of the American forms, presents a variation of an opposite nature, for it has 5 leaves. Gaudron and Lamberti also mention a 5-leaved variety of F. Kalina. The red bush alpine strawberry, one of the F. vesca section, does not produce stolons or runners, and this remarkable deviation of structure is reproduced truly by seed. Another subvariety, the white bush alpine, is similarly characterized, but when propagated by seed, it often degenerates and produces plants with runners. 112. A strawberry of the American pine section is also said to make but few runners. 113. Much has been written on the sexes of strawberries. The true hautbois properly bears the male and female organs on separate plants. 114, and was consequently named by Duchesne dioica, but it frequently produces hermaphrodites, and Linley 115, by propagating such plants by runners at the same time destroying the males, soon raised a self-prolific stock. The other species often showed a tendency towards an imperfect separation of the sexes, as I have noticed with plants forced in a hothouse. Several English varieties, which in this country are free from any such tendency, when cultivated in rich soils under the climate of North America. 116 commonly produce plants with separate sexes. Thus a whole acre of Keen seedlings in the United States has been observed to be almost sterile from the absence of male flowers. But the more general rule is that the male plants overrun the females. Some members of the Cincinnati Horticultural Society, especially appointed to investigate this subject, report that few varieties have the flowers perfect in both sexual organs, etc. The most successful cultivators in Ohio plant, for every 7 rows of pistillata or female plants, 1 row of hermaphrodites, which afford pollen for both kinds, but the hermaphrodites, owing to their expenditure in the production of pollen, bear less fruit than the female plants. The varieties differ in constitution. Some of our best English kinds, such as Keen's seedlings, are too tender for certain parts of North America, where other English and many American varieties succeed perfectly. That splendid fruit, the British Queen, can be cultivated, but in few places either in England or France. But this apparently depends more on the nature of the soil than on the climate. A famous gardener says that no mortal could grow the British Queen at Shrubland Park, unless the whole nature of the soil was altered. 117 La Constantine is one of the hardiest kinds, and can withstand Russian winters, but it is easily burnt by the sun, so that it will not succeed in certain soils either in England or the United States. 118. The filbert pine strawberry requires more water than any other variety, and if the plants once suffer from drought, they will do little or no good afterwards. 119. Cuthill's Black Prince strawberry evinces a singular tendency to mildew. No less than 6 cases have been recorded of this variety suffering severely, whilst other varieties growing close by and treated in exactly the same manner were not at all infested by this fungus. 120. The time of maturity differs much in the different varieties. Some belonging to the wood or alpine section produce a succession of crops throughout the summer. Gooseberry ribs grossularia. No one, I believe, has hitherto doubted that all the cultivated kinds are sprung from the wild plant, bearing this name, which is common in Central and Northern Europe. Therefore, it will be desirable briefly to specify all the points, though not very important, which have varied if it be admitted that these differences are due to culture. Authors perhaps will not be so ready to assume the existence of a large number of unknown wild parent stocks for our other cultivated plants. The gooseberry is not alluded to by writers of the classical period. Turner mentions it in 1573, and Parkinson specifies 8 varieties in 1629. The Catalogue of the Horticultural Society for 1842 gives 149 varieties, and the lists of the Lancashire nurserymen are said to include above 300 names. 121 in the Gooseberry Growers' Register for 1862. I find that 243 distinct varieties have won prizes at various periods, so that a vast number must have been exhibited. No doubt, the difference between many of the varieties is very small, but Mr. Thompson, in classifying the fruit for the Horticultural Society, found less confusion in the nomenclature of the gooseberry than of any other fruit, and he attributes this to the great interest which the prize growers have taken in detecting sorts with wrong names, and this shows that all the kinds, numerous as they are, can be recognized with certainty. The bushes differ in their manner of growth, being erect or spreading or pendulous. The periods of leafing and flowering differ both absolutely and relatively to each other. Thus the whitesmith produces early flowers which, from not being protected by the foliage, as it is believed, continually fail to produce fruit. 122 The leaves vary in size, tint, and in depth of lobes. They are smooth, downy, or hairy on the upper surface. The branches are more or less downy or spinose. The hedgehog has probably derived its name from the singular bristly condition of its shoots. And fruit. The branches of the wild gooseberry, I may remark, are smooth with the exception of thorns at the bases of the buds. The thorns themselves are either very small, few, and single, or very large, and triple. They are sometimes reflexed and much dilated at their bases in the different varieties. The fruit varies in abundance in the period of maturity in hanging, until shriveled, and greatly in size, some sorts having their fruit large during a very early period of growth, whilst others are small. Until nearly ripe the fruit varies also much in color, being red, yellow, green, and whiteth pulp of one dark red. Gooseberry being tinged with yellow in flavor, in being smooth or downifu, however, of the red gooseberries, whilst many of the so-called whites are downy, or in being so spinose that one kind is called Henderson's porcupine. 2 kinds acquire, when mature, a powdery bloom on their fruit. The fruit varies in the thickness and veining of the skin, and lastly in shape, being spherical, oblong, oval, or obovate. 123. I cultivated 54 varieties, and considering how greatly the fruit differs, it was curious how closely similar the flowers were in all these kinds. In only a few, I detected a trace of difference in the size or color of the corolla. The calyx differed in a rather greater degree, for in some kinds it was much redder than in others, and in one smooth white gooseberry it was unusually red. The calyx also differed in the basal part, being smooth or woolly, or covered with glandular hairs. It deserves notice as being contrary to what might have been expected from the law of correlation, that a smooth red gooseberry had a remarkably hairy calyx. The flowers of the sportsman are furnished with very large colored bracteae, and this is the most singular deviation of structure which I have observed. These same flowers also varied much in the number of the petals, and occasionally in the number of the stamens and pistils, so that they were semi-monstrous in structure, yet they produced plenty of fruit. Mr. Thompson remarks that in the pastime, gooseberry extra bracts are often attached to the sides of the fruit. 124. The most interesting point in the history of the gooseberry is the steady increase in the size of the fruit. Manchester is the metropolis of the fanciers, and prizes from 5 shillings to 5 or 10 pounds are yearly given for the heaviest fruit. The Gooseberry Growers' Register is published annually. The earliest known copy is dated 1786, but it is certain that meetings for the adjudication of prizes were held some years previously. 125. The Register for 1845 gives an account of 171 gooseberry shows held in different places during that year, and this fact shows on how large a scale the culture has been carried on the fruit. Of the wild gooseberry is said 126 to weigh about a quarter of an ounce, or 5 dwts, that is 120 grains, about the year 1786, gooseberries were exhibited weighing 10 dwts, so that the weight was then doubled in 1817. 26 dwts 17 grs was attained. There was no advance till 1825, when 31 dwts 16 grs was reached. In 1830, teaser weighed 32 dwts 13 grs. In 1841, wonderful weighed 32 dwts 16 grs. In 1844, London weighed 35 dwts 12 grs, and in the following year 36 dwts 16 grs. And in 1852, in Staffordshire, the fruit of the same variety reached the astonishing weight of 37 dwts 7 grs 127, or 896 grs. That is between 7 or 8 times the weight of the wild fruit. I find that a small apple 612 inches in circumference has exactly this same weight. The London gooseberry, which in 1852 had altogether gained 333 prizes, has up to the present year of 1875 never reached a greater weight than that attained in 1852. Perhaps the fruit of the gooseberry has now reached the greatest possible weight, unless in the course of time some new and distinct variety shall arise. This gradual and on the whole steady increase of weight from the latter part of the last century to the year 1852 is probably in large part due to improved methods of cultivation. For extreme care is now taken. The branches and roots are trained, composts are made, the soil is mulched, and only a few berries are left on each bush. 128. But the increase, no doubt, is in main part due to the continued selection of seedlings, which have been found to be more and more capable of yielding such extraordinary fruit. Assuredly, the highwayman in 1817 could not have produced fruit like that of the roaring lion in 1825, nor could the roaring lion, though it was grown by many persons in many places, gain the supreme triumph achieved in 1852 by the London gooseberry. Walnut juglans regia. This tree and the common nut belong to a widely different order from the foregoing fruits, and are therefore here noticed. The walnut grows wild on the Caucasus, and in the Himalaya, where Dr. Hooker 129 found the fruit of full size, but as hard as a hickory nut. It has been found fossil, as Roman 1000 de Saporta informs me, in the Tertiary formation of France. In England, the walnut presents considerable differences in the shape and size of the fruit, in the thickness of the husk, and in the thinness of the shell. This latter quality has given rise to a variety called the thinshelled, which is valuable, but suffers from the attacks of titmice. 130. The degree to which the kernel fills the shell varies much. In France, there is a variety called the grape, or cluster walnut, in which the nuts grow in bunches of 10, 15, or even 20 together. There is another variety which bears on the same tree differently shaped leaves like the heterophyllous hornbeam. This tree is also remarkable from having pendulous branches and bearing elongated large thinshelled nuts. 131. Roman 1000 Cardan has minutely described 132 some singular physiological peculiarities in the junaleafing variety, which produces its leaves and flowers 4 or 5 weeks later than the common varieties, and, although in August it is apparently in exactly the same state of forwardness as the other kinds, it retains its leaves and fruit much later in the autumn. These constitutional peculiarities are strictly inherited. Lastly, walnut trees, which are properly monoicous, sometimes entirely fail to produce male flowers. 133. Nuts Corylus avellana. Most botanists rank all the varieties under the same species. The common wild nut 130 for the husk or involucre differs greatly, being extremely short in bars Spanish and extremely long in filberts, in which it is contracted so as to prevent the nut falling out. This kind of husk also protects the nut from birds, for titmice parus have been observed 135 to pass over filberts and attack cobs and common nuts growing in the same orchard. In the purple filbert the husk is purple, and in the frizzled filbert it is curiously laciniated. In the red filbert, the pellicle of the kernel is red. The shell is thick in some varieties, but is thin in Cosford's nut, and in one variety is of a bluish color. The nut itself differs much in size and shape, being ovate and compressed in filberts nearly round, and of great size in cobs and Spanish nuts, oblong and longitudinally striated in Cosfords, and obtusely four-sided in the Downton square nut. Cucurbitaceous plants. These plants have been for a long period the opprobrium of botanists. Numerous varieties have been ranked as species, and what happens more rarely forms, which now must be considered as species, have been classed as varieties owing to the admirable experimental researches of a distinguished botanist Roman 1000 Nauden 130. 6. A flood of light has recently been thrown on this group of plants Roman 1000 Nauden, during many years observed and experimented on above 1,200 living specimens, collected from all quarters of the world. 6 species are now recognized in the genus Cucurbita, but 3 alone have been cultivated and concern us, namely Roman 100 Maxima and Pepo, which include all pumpkins, gourds, squashes, and the vegetable marrow, and Roman 100 Machata. These 3 species are not known in a wild state, but Asag Gray 137 gives good reason for believing that some pumpkins are natives of N. America. These 3 species are closely allied and have the same general habit, but their innumerable varieties can always be distinguished according to Nauden by certain, almost fixed characters, and what is still more important, when crossed they yield no seed or only sterile seed, whilst the varieties spontaneously intercross with the utmost freedom. Nauden insists strongly P15 that though these 3 species have varied greatly in many characters, yet it has been in so closely an analogous manner that the varieties can be arranged in almost parallel series, as we have seen with the forms of wheat with the 2 main races of the peach, and in other cases, though some of the varieties are inconstant in character, yet others, when grown separately under uniform conditions of life, are, as Nauden repeatedly pp. 6 1635 urges Dowie's, Dune, stabilite pres comparable, a cell des aspects les mia characterices, one variety L. Orangen pp. 4363, has such prepotency in transmitting its character, that when crossed with other varieties a vast majority of the seedlings come true. Nauden, referring P47 to Roman 100 Pepo, says that its races need different des aspects veritables, quen si quels, puvent salier, les unes ox otters, parvoi diberdite sans, quelur descendants, perd la faculté de si perpetuer. If we were to trust to external differences alone, and give up the test of sterility, a multitude of species would have to be formed out of the varieties of these 3 species of Cucurbita. Many naturalists at the present day lay far too little stress, in my opinion, on the test of sterility, yet it is not improbable that distinct species of plants, after a long course of cultivation and variation, may have their mutual sterility eliminated, as we have every reason to believe has occurred with domesticated animals. Nor in the case of plants under cultivation should we be justified in assuming that varieties never acquire a slight degree of mutual sterility, as we shall more fully see in a future chapter, when certain facts are given on the high authority of Gartner and Kallreuter 138. The forms of Roman 100 Pepo are classed by Nauden under 7 sections, each including subordinate varieties. He considers this plant as probably the most variable in the world. The fruit of one variety pp. 3346 exceeds in value that of another by more than 2,000-fold. When the fruit is of very large size, the number produced is few p45. When of small size, many are produced. No less astonishing p33 is the variation in the shape of the fruit. The typical form apparently is egg-like, but this becomes either drawn out into a cylinder or shortened into a flat disc. We have also an almost infinite diversity in the color and state of surface of the fruit, in the hardness, both of the shell and of the flesh, and in the taste of the flesh, which is either extremely sweet farinaceous or slightly bitter. The seeds also differ in a slight degree in shape, and wonderfully in size p34, namely from 6 or 7 to more than 25 millimeters in length. In the varieties which grow upright, or do not run and climb the tendrils, though useless p31 are either present, or are represented by various semi-monstrous organs, or are quite absent. The tendrils are even absent in some running varieties, in which the stems are much elongated. It is a singular fact that p31 in all the varieties with dwarfed stems, the leaves closely resemble each other in shape. Those naturalists who believe in the immutability of species often maintain that even in the most variable forms, the characters which they consider of specific value are unchangeable. To give an example from a conscientious writer 139, who, relying on the labors of Roman 1000 Nauden, and referring to the species of Cucurbita, says, O maluditouts les variations, du fruit les taigas, les fuels les calix les carls les edamines, restent invariables dans chacune. Yet Roman 1000 Nauden, in describing Cucurbita Pepo p30, says Ici des lours si ne sont pas seulement les fruits qui variant cest. Aussi le feuillage et tout le port de la plante niemens G. Croix, quan la distinguera taugers facilement. Des du otters aspects si l'on veut, Ni pas perdre de vue les caractères différentiels, qui me force de faire ressortir ces caractères, sont quelquefois plus marques, il arrive même que plusieurs d'entre eux s'effacent presque entièrement, mais Roman II, en restent toujours quelques-uns qui remettent l'observateur sur la voie now. Let it be noted, what a difference with regard to the immutability of the so-called specific characters this paragraph produces on the mind from that above quoted from Roman 1000 Godrin. I will add another remark: naturalists continually assert that no important organ varies. But in saying this, they unconsciously argue in a vicious circle, for if an organ, let it be what it may, is highly variable, it is regarded as unimportant, and under a systematic point of view, this is quite correct. But as long as constancy is thus taken as the criterion of importance, it will indeed be long before an important organ can be shown to be inconstant. The enlarged form of the stigmas and their sessile position on the summit of the ovary must be considered as important characters, and were used by Gasparini to separate certain pumpkins as a distinct genus. But Naudin says p. 20 these parts have no constancy, and in the flowers of the turban varieties of Roman 100 maxima, they sometimes resume their ordinary structure again in Roman 100 maxima. The carpels p. 19, which form the turban project, even as much as 2/3 of their length out of the receptacle, and this latter part is thus reduced to a sort of platform. But this remarkable structure occurs only in certain varieties, and graduates into the common form, in which the carpels are almost entirely enveloped within the receptacle in Roman 100 machata. The ovarium p. 50 varies greatly in shape, being oval, nearly spherical, or cylindrical, more or less swollen in the upper part, or constricted round the middle, and either straight or curved when the ovarium is short and oval. The interior structure does not differ from that of Roman 100 maxima and Peppo, but when it is elongated, the carpels occupy only the terminal and swollen portion. I may add that in one variety of the cucumber, Cucumis sativus, the fruit regularly contains 5 carpels instead of 3. 140. I presume that it will not be disputed that we here have instances of great variability in organs of the highest physiological importance, and with most plants of the highest classificatory importance. Sadrat 141 and Naudin found that the cucumber Roman 100 sativus could not be crossed with any other species of the genus, therefore no doubt it is specifically distinct from the melon. This will appear to most persons a superfluous statement, yet we hear from Naudin 142 that there is a race of melons in which the fruit is so like that of the cucumber both externally and internally that it is hardly possible to distinguish the one from the other. Except by the leaves, the varieties of the melon seem to be endless for Naudin. After 6 years' study had not come to the end of them, he divides them into 10 sections, including numerous subvarieties which all intercross with perfect ease. 143 of the forms considered by Naudin to be varieties botanists have made 30 distinct species, and they had not the slightest acquaintance with the multitude of new forms which have appeared since their time, nor is the creation of so many species at all surprising when we consider how strictly their characters are transmitted by seed, and how wonderfully they differ in appearance. Mira est quitum foliarum, et habitus diversitas. Sed multo magis fructuum, says Naudin, the fruit is the valuable part, and this, in accordance with the common rule, is the most modified part. Some melons are only as large as small plums, others weigh as much as 6 to 6 pounds. One variety has a scarlet fruit, another is not more than an inch in diameter, but sometimes more than a yard in length, twisting about in all directions like a serpent. It is a singular fact that in this latter variety many parts of the plant, namely, the stems, the footstalks of the female, flowers, the middle lobe of the leaves, and especially the ovarium as well as the mature fruit, all show a strong tendency to become elongated. Several varieties of the melon are interesting from assuming the characteristic features of distinct species, and even of distinct though allied genera. Thus, the serpent melon has some resemblance to the fruit of Trichosanthes anguina. We have seen that other varieties closely resemble cucumbers. Some Egyptian varieties have their seeds attached to a portion of the pulp, and this is characteristic of certain wild forms. Lastly, a variety of melon from Algiers is remarkable from announcing its maturity by a spontaneous and almost sudden dislocation, when deep cracks suddenly appear and the fruit falls to pieces, and this occurs with the wild Roman 100 Mamordica. Finally, Roman 1000 Naudin well remarks that this extraordinary production of races and varieties by a single species, and their permanence when not interfered with by crossing, are phenomena well calculated to cause reflection. Useful and ornamental trees. Trees deserve a passing notice on account of the numerous varieties, which they present differing in their precocity in their manner of growth, their foliage and bark, thus of the common ash Fraxinus excelsior. The catalogue of Messrs. Lawson of Edinburgh includes 21 varieties, some of which differ much in their bark. There is a yellow, a streaked reddish-white, a purple, a wart-barked, and a fungouse-barked variety, 144 of hollies. No less than 84 varieties are grown alongside each other. In Mr. Paul's nursery, 145. In the case of trees, all the recorded varieties, as far as I can find out, have been suddenly produced by one single act of variation. The length of time required to raise many generations, and the little value set on the fanciful varieties, explains how it is that successive modifications have not been accumulated by selection. Hence also it follows that we do not here meet with subvarieties subordinate to varieties, and these again subordinate to higher groups on the continent. However, where the forests are more carefully attended to than in England. Alf de Candolle, 146, says that there is not a forester who does not search for seeds from that variety, which he esteems the most valuable. Our useful trees have seldom been exposed to any great change of conditions. They have not been richly manured, and the English kinds grow under their proper climate. Yet in examining extensive beds of seedlings, in nursery gardens, considerable differences may be generally observed in them, and whilst touring in England, I have been surprised at the amount of difference in the appearance of the same species in our hedgerows and woods. But as plants vary so much in a truly wild state, it would be difficult for even a skillful botanist to pronounce whether, as I believe to be the case, hedgerow trees vary more than those growing in a primeval forest. Trees, when planted by man in woods or hedges, do not grow where they would naturally be able to hold their place against a host of competitors, and are therefore exposed to conditions not strictly natural. Even this slight change would probably suffice to cause seedlings raised from such trees to be variable. Whether or not our half-old English trees, as a general rule, are more variable than trees growing in their native forests, there can hardly be a doubt that they have yielded a greater number of strongly marked and singular variations of structure. In manner of growth, we have weeping or pendulous varieties of the willow, ash, elm, oak, and yew, and other trees, and this weeping habit is sometimes inherited, though in a singularly capricious manner, in the Lombardy poplar, and in certain fastigiate or pyramid varieties of thorns, junipers, oaks, etc. We have an opposite kind of growth, the Hessian oak 147, which is famous from its fastigiate habit, and size bears hardly any resemblance in general appearance to a common oak. Its acorns are not sure to produce plants of the same habit. Some, however, turn out the same as the parent tree. Another fastigiate oak is said to have been found wild in the Pyrenees, and this is a surprising circumstance. It generally comes so true by seed that de Candolle considered it as specifically distinct. 148. The fastigiate juniper J. Susica likewise transmits its character by seed. 149. Dr. Falconer informs me that in the Botanic Gardens at Calcutta, the great heat caused apple trees to become fastigiate, and we thus see the same result following from the effects of climate, and from some unknown cause. 150. In foliage, we have variegated leaves, which are often inherited dark purple or red leaves, as in the hazel barberry, and beech. The color in these two latter trees being sometimes strongly, and sometimes weakly inherited. 151. Deeply cut leaves and leaves, covered with prickles, as in the variety of the holly well called ferox, which is said to reproduce itself by seed. 152. In fact, nearly all the peculiar varieties evince a tendency, more or less strongly marked, to reproduce themselves by seed. 153. This is to a certain extent the case, according to Bosc 154, with three varieties of the elm, namely the broadleafed, limeleafed, and twisted elm, in which latter the fibers of the wood are twisted, even with the heterophilous hornbeam carpinus, bichilus, which bears on each twig leaves of two shapes. Several plants, raised from seed, all retain the same peculiarity. 155. I will add only one other remarkable case of variation in foliage, namely the occurrence of two subvarieties of the ash with simple, instead of pinnated leaves, and which generally transmit their character by seed. 156. The occurrence in trees belonging to widely different orders of weeping and fastigiate varieties, and of trees bearing deeply cut variegated and purple leaves, shows that these deviations of structure must result from some very general physiological laws. Differences in general appearance and foliage, not more strongly marked than those above indicated, have led good observers to rank as distinct species certain forms, which are now known to be mere varieties. Thus a plantain long cultivated in England was considered by almost everyone as a North American species, but is now ascertained by old records, as I am informed by Dr. Hooker, to be a variety. So again, the Thuja pendula or filiformis was ranked by such good observers as Lambert Wallach, and others as a true species. But it is now known that the original plants 5 in number suddenly appeared in a bed of seedlings, raised at Mr. Lottage's nursery from T. orientalis, and Dr. Hooker has adduced excellent evidence that at Turin seeds of T. pendula have reproduced the parent form T. orientalis 157. Everyone must have noticed how certain individual trees regularly put forth and shed their leaves earlier or later than others of the same species. There is a famous horsechestnut in the Tuileries, which is named from leafing so much earlier than the others. There is also an oak near Edinburgh, which retains its leaves to a very late period. These differences have been attributed by some authors to the nature of the soil in which the trees grow, but Archbishop Whately grafted an early thorn on a late one, and vice versa, and both grafts kept to their proper periods, which differed by about a fortnight, as if they still grew on their own stalks. 158. There is a Cornish variety of the elm which is almost an evergreen, and is so tender that the shoots are often killed by the frost, and the varieties of the Turkish oak Q. ceres may be arranged as deciduous subevergreen, and evergreen. 159. Scotch fir Pinus sylvestris. I allude to this tree, as it bears on the question of the greater variability of our hedgerow trees compared with those under strictly natural conditions. A well-informed writer, 160, states that the Scotch fir presents few varieties in its native Scotch forests, but that it varies much in figure and foliage, and in the size, shape, and color of its cones when several generations have been produced away from its native locality. There is little doubt that the highland and lowland varieties differ in the value of their timber, and that they can be propagated truly by seed, thus justifying Loudon's remark that a variety is often of as much importance as a species, and sometimes far more so. 161. I may mention one rather important point in which this tree occasionally varies in the classification of the conifer sections are founded on whether 2, 3, or 5 leaves are included in the same sheath. The Scotch fir has properly only 2 leaves thus enclosed, but specimens have been observed with groups of 3 leaves in a sheath. 162. Besides these differences in the semi-cultivated Scotch fir, there are in several parts of Europe natural or geographical races which have been ranked by some authors as distinct species. 163. Loudon 164 considers P. pumilio with its several subvarieties as Mughas nana etc., which differ much when planted in different soils, and only come tolerably true from seed, as alpine varieties of the Scotch fir. If this were proved to be the case, it would be an interesting fact, as showing that dwarfing from long exposure to a severe climate is to a certain extent inherited. The hawthorn Cratchus oxyacantha has varied much besides endless slighter variations in the form of the leaves, and in the size, hardness, fleshiness, and shape of the berries. Loudon 165 enumerates 29 well-marked varieties, besides those cultivated for their pretty flowers. There are others with golden yellow, black, and whitish berries, others with woolly berries, and others with recurved thorns. Loudon truly remarks that the chief reason why the hawthorn has yielded more varieties than most other trees is that nurserymen select any remarkable variety out of the immense beds of seedlings, which are annually raised for making hedges. The flowers of the hawthorn usually include from 1 to 3 pistils, but in 2 varieties named Monogyna and Sibirica, there is only a single pistil, and DSO states that the common thorn in Spain is constantly in this state. 166. There is also a variety which is apetalous, or has its petals reduced to mere rudiments, the famous Glastonbury thorn flowers and leaves, towards the end of December, at which time it bears berries produced from an earlier crop of flowers. 167. It is worth notice that several varieties of the hawthorn, as well as of the lime and juniper, are very distinct in their foliage and habit whilst young, but in the course of 30 or 40 years, become extremely like each other. 168. Thus reminding us of the well-known fact that the deodar, the cedar of Lebanon, and that of the atlas are distinguished with the greatest ease whilst young, but with difficulty when old. Flowers. I shall not, for several reasons, treat the variability of plants, which are cultivated for their flowers alone, at any great length. Many of our favorite kinds in their present state are the descendants of two or more species crossed and commingled together, and this circumstance alone would render it difficult to detect the difference, due to variation. For instance, our roses, petunias calceolarias, fuchsias, verbenas, gladioli, pelargoniums, etc., certainly have had a multiple origin. A botanist well acquainted with the parent forms would probably detect some curious structural differences in their crossed and cultivated descendant, and he would certainly observe many new and remarkable constitutional peculiarities. I will give a few instances, all relating to the pelargonium, and taken chiefly from Mr. Beck 169, famous cultivator of this plant. Some varieties require more water than others. Some are very impatient of the knife, if too greedily used in making cuttings. Some, when potted, scarcely show a root at the outside of the ball of the earth. One variety requires a certain amount of confinement in the pot to make it throw up a flower stem. Some varieties bloom well at the commencement of the season, others at the close. One variety is known 170, which will stand even pineapple top and bottom heat, without looking any more drawn than if it had stood in a common greenhouse, and blanche fleur seems as if made on purpose for growing in winter like many bulbs, and to rest all summer. These odd constitutional peculiarities would enable a plant in a state of nature to become adapted to widely different circumstances and climates. Flowers possess little interest under our present point of view because they have been almost exclusively attended to and selected for their beautiful color, size, perfect outline, and manner of growth. In these particulars, hardly one long cultivated flower can be named which has not varied greatly. What does a florist care for the shape and structure of the organs of fructification, unless indeed they add to the beauty of the flower? When this is the case, flowers become modified in important points. Stamens and pistils may be converted into petals, and additional petals may be developed. As in all double flowers, the process of gradual selection, by which flowers have been rendered more and more double, each step in the process of conversion being inherited, has been recorded in several instances. In the so-called double flowers of the composite, the corollas of the central florets are greatly modified, and the modifications are likewise inherited in the columbine Aquilegia vulgaris. Some of the stamens are converted into petals, having the shape of nectaries, one neatly fitting into the other, but in one variety they are converted into simple petals. 171. In the hose, in hose primal, the calyx becomes brightly colored and enlarged so as to resemble a corolla, and Mr. W. Wooler informs me that this peculiarity is transmitted, for he crossed a common polyanthus with one having a colored calyx. 172. And some of the seedlings inherited the colored calyx during at least 6 generations. In the henenchicken daisy, the main flower is surrounded by a brood of small flowers developed from buds in the axils of the scales of the involucre. A wonderful poppy has been described, in which the stamens are converted into pistils, and so strictly was this peculiarity inherited that out of 154 seedlings, one alone reverted to the ordinary and common type. 173 of the coxcomb Celosia cristata, which is an annual. There are several races in which the flower stem is wonderfully fasciated or compressed, and one has been exhibited. 174, actually 18 inches in breadth. Peloric races of Gloxinia speciosa and Antirrhinum majus can be propagated by seed, and they differ in a wonderful manner from the typical form, both in structure and appearance. A much more remarkable modification has been recorded by Sir William and Dr. Hooker. 175, in Begonia frigida. This plant properly produces male and female flowers on the same fascicles, and in the female flowers the perianth is superior, but a plant at Q produced besides the ordinary flowers others which graduated towards a perfect hermaphrodite structure, and in these flowers the perianth was inferior. To show the importance of this modification under a classificatory point of view, I may quote what Prof. Harvey says, namely, that had it occurred in a state of nature, and had a botanist collected a plant with such flowers, he would not only have placed it in a distinct genus from Begonia, but would probably have considered it as the type of a new natural order. This modification cannot in one sense be considered as a monstrosity, for analogous structures naturally occur in other orders, as with Saxifrag and Aristolochias. The interest of the case is largely added to by Mr. Roman 100 W. Crocker's observation that seedlings from the normal flowers produced plants, which bore in about the same proportion as the parent plant hermaphrodite flowers, having inferior perianths. The hermaphrodite flowers fertilized with their own pollen were sterile. If florists had attended to selected and propagated by seed other modifications of structure, besides those, which are beautiful, a host of curious varieties would certainly have been raised, and they would probably have transmitted their characters so truly that the cultivator would have felt aggrieved, as in the case of culinary vegetables, if his whole bed had not presented a uniform appearance. Florists have attended in some instances to the leaves of their plant, and have thus produced the most elegant and symmetrical patterns of white, red, and green, which, as in the case of the pelargonium, are sometimes strictly inherited. 176 Anyone who will habitually examine highly cultivated flowers in gardens and greenhouses will observe numerous deviations in structure, but most of these must be ranked as mere monstrosities, and are only so far interesting as showing how plastic the organization becomes under high cultivation. From this point of view, such works as Professor Mauquin Tandon's Teratology are highly instructive. Roses. These flowers offer an instance of a number of forms, generally ranked as species, namely R. centifolia gallica, Alba damascena spinosissima, Bractita indica, semperflorens machata, etc., which have largely varied and been intercrossed. The genus Rosa is a notoriously difficult one, and though some of the above forms are admitted by all botanists to be distinct species, others are doubtful. Thus, with respect to the British forms, Babington, Make 17 and Bentham, only 5 species, the hybrids, from some of the most distinct forms, for instance, from R. indica, fertilized by the pollen of R. centifolia, produce an abundance of seed. I state this on the authority of Mr. Rivers 177, from whose work I have drawn most of the following statements. As almost all the aboriginal forms brought from different countries have been crossed and recrossed, it is no wonder that Targini Tizzetti, in speaking of the common roses of the Italian gardens, remarks that the native country and precise form of the wild type of most of them are involved in much uncertainty. 178. Nevertheless, Mr. Rivers, in referring to R. indica p. 68, says that the descendants of each group may generally be recognized by a close observer. The same author often speaks of roses as having been a little hybridized, but it is evident that in very many cases the differences due to variation and to hybridization can now only be conjecturally distinguished. The species have varied both by seed and by bud, such modified buds being often called by gardeners sports. In the following chapter, one shall fully discuss this latter subject, and shall show that bud variations can be propagated not only by grafting and budding, but often by seed. Whenever a new rose appears with any peculiar character, however produced, if it yields seed, Mr. Rivers p. 4 fully expects it to become the parent type of a new family. The tendency to vary is so strong in some kinds, as in the village made Rivers p. 16, that when grown in different soils, it varies so much in color that it has been thought to form several distinct kinds. Altogether, the number of kinds is very great. Thus, Roman 1000 de Sports, in his catalogue for 1829, enumerates 2562 as cultivated in France, but no doubt a large proportion of these are merely nominal. It would be useless to specify the many points of difference between the various kinds, but some constitutional peculiarities may be mentioned. Several French roses, Rivers p. 12, will not succeed in England, and an excellent horticulturist, 179, remarks that even in the same garden you will find that a rose that will do nothing under a south wall will do well under a north one. That is the case with Paul Joseph. Here it grows strongly and blooms beautifully close to a north wall. For 3 years 7 plants have done nothing under a south wall. Many roses can be forced. Many are totally unfit for forcing, among which is General Jacqueminot 180. From the effects of crossing and variation, Mr. Rivers enthusiastically anticipates p. 87 that the day will come when all our roses, even moss roses, will have evergreen foliage, brilliant and fragrant flowers, and the habit of blooming from June till November. A distant view this seems, but perseverance in gardening will yet achieve wonders, as assuredly it has already achieved wonders. It may be worth while briefly to give the well-known history of one class of roses. In 1793, some wild Scotch roses, R. spinosissima, were transplanted into a garden. 181, and one of these bore flowers slightly tinged with red, from which a plant was raised with semi-monstrous flowers, also tinged with red. Seedlings from this flower were semi-double, and by continued selection, in about 9 or 10 years 8 subvarieties were raised. In the course of less than 20 years, these double Scotch roses had so much increased in number and kind that 26 well-marked varieties classed in 8 sections were described by Mr. Sabine In 1,841,182, it is said that 300 varieties could be procured in the nursery gardens near Glasgow, and these are described as blush crimson, purple, red, marbled, two-colored, white, and yellow, and as differing much in the size and shape of the flower. Pansy or heartsease, viola tricolor, etc. The history of this flower seems to be pretty well known. It was grown in Evelyn's garden in 1687, but the varieties were not attended to till 18,101,812, when Lady Monk together with Mr. Lee, the well-known nurseryman, energetically commenced their culture, and in the course of a few years 20 varieties could be purchased. 183. At about the same period, namely in 1813 or 1814, Lord Gambier collected some wild plants, and his gardener Mr. Thomson cultivated them together with some common garden varieties, and soon effected a great improvement. The first great change was the conversion of the dark lines in the center of the flower into a dark eye or center, which at that period had never been seen, but is now considered one of the chief requisites of a first-rate flower. In 1835, a book entirely devoted to this flower was published, and 400 named varieties were on sale. From these circumstances, this plant seemed to me worth studying more, especially from the great contrast between the small, dull, elongated, irregular flowers of the wild pansy and the beautiful, flat, symmetrical, circular, velvet-like flowers more than 2 inches in diameter, magnificently and variously colored, which are exhibited at our shows. But when I came to inquire more closely, I found that though the varieties were so modern, yet that much confusion and doubt prevailed about their parentage. Florists believe that the varieties 184 are descended from several wild stocks, namely Roman 5 tricolor Lutea, grandiflora amna, and Alteca, more or less intercrossed. And when I looked to botanical works to ascertain whether these forms ought to be ranked as species, I found equal doubt and confusion. Viola alteca seems to be a distinct form, but what part it has played in the origin of our varieties, I know not. It is said to have been crossed with Roman 5 Lutea. Viola amna 185 is now looked at by all botanists as a natural variety of Roman 5 grandiflora, and this, and Roman 5 Sudetica, have been proved to be identical with Roman 5 Lutea, the latter, and Roman 5 tricolor, including its admitted variety Roman 5 arvensis, are ranked as distinct species by Babington and likewise by Roman 1000 Gay 186, who has paid particular attention to the genus, but the specific distinction between Roman 5 Lutea and tricolor is chiefly grounded on the one being strictly, and the other not strictly perennial, as well as on some other slight and unimportant differences in the form of the stem and stipules. Bentham unites these two forms, and a high authority on such matters, Mr. H. Roman 100 Watson, 187, says that while Roman 5 tricolor passes into Roman 5 arvensis on the one side, it approximates so much towards Roman 5 Lutea and Roman 5 curtice on the other side that a distinction becomes scarcely more easy between them. Hence, after having carefully compared numerous varieties, I gave up the attempt as too difficult for anyone, except a professed botanist. Most of the varieties present such inconstant characters that when grown in poor soil, or when flowering out of their proper season, they produced differently colored and much smaller flowers. Cultivators speak of this or that kind as being remarkably constant or true, but by this they do not mean, as in other cases, that the kind transmits its character by seed, but that the individual plant does not change much under culture. The principle of inheritance, however, does hold good to a certain extent even with the fleeting varieties of the heartsease, for to gain good sorts it is indispensable to sow the seed of good sorts. Nevertheless, in almost every large seedbed, a few almost wild seedlings reappear through reversion on comparing the choicest varieties with the nearest allied wild forms. Besides the difference in the size, outline, and color of the flowers, the leaves sometimes differ in shape, as does the calyx, occasionally in the length and breadth of the sepals. The differences in the form of the nectary more especially deserve notice, because characters derived from this organ have been much used in the discrimination of most of the species of viola. In a large number of flowers compared in 1842, I found that in the greater number the nectary was straight, in others the extremity was a little turned upwards or downwards or inwards, so as to be completely hooked. In others, instead of being hooked, it was first turned rectangularly downwards, and then backwards and upwards. In others, the extremity was considerably enlarged, and lastly, in some, the basal part was depressed, becoming, as usual, laterally compressed towards the extremity. In a large number of flowers, on the other hand, examined by me in 1856, from a nursery garden in a different part of England, the nectary hardly varied at all now. Roman 1000 Gay says that in certain districts, especially in Auvergne, the nectary of the wild Roman 5 grandiflora varies in the manner just described. Must we conclude from this that the cultivated varieties first mentioned were all descended from Roman 5 grandiflora, and that the second lot, though having the same general appearance, were descended from Roman 5 tricolor, of which the nectary, according to Roman 1000 Gay, is subject to little variation? Or is it not more probable that both these wild forms would be found, under other conditions, to vary in the same manner, and degree, thus showing that they ought not to be ranked as specifically distinct? The dahlia has been referred to by almost every author who has written on the variation of plants, because it is believed that all the varieties are descended from a single species, and because all have arisen since 1802 in France, and since 1804 in England. 188 Mr. Sabine remarks that it seems as if some period of cultivation had been required before the fixed qualities of the native plant gave way and began to sport into those changes which now so delight us. 189 The flowers have been greatly modified in shape from a flat to a globular form anemone and ranunculus-like races. 190 which differ in the form and arrangement of the florets have arisen, also dwarfed races, one of which is only 18 inches in height. The seeds vary much in size. The petals are uniformly colored or tipped or striped and present an almost infinite diversity of tint. Seedlings of 14 different colors, 191, have been raised from the same plant. Yet, as Mr. Sabine has remarked, many of the seedlings follow their parents in color. The period of flowering has been considerably hastened, and this has probably been affected by continued selection. Salisbury, writing 1808, says that they then flowered from September to November. In 1828, some new dwarf varieties began flowering in June. 192, and Mr. Grieve informs me that the dwarf purple Zelinda in his garden is in full bloom by the middle of June, and sometimes even earlier. Slight constitutional differences have been observed between certain varieties. Thus some kinds succeed much better in one part of England than in another. 193, and it has been noticed that some varieties require much more moisture than others. 194. Such flowers as the carnation, common tulip, and hyacinth, which are believed to be descended each from a single wild form, present innumerable varieties differing almost exclusively in the size, form, and color of the flowers. These, and some other anciently cultivated plants, which have been long propagated by offsets, pipings, bulbs, etc., become so excessively variable that almost each new plant raised from seed forms a new variety, all of which, to describe particularly, as old Gerard wrote in 1597, were to roll Sisyphus stone or to number the sands. Hyacinth, Hyacinthus orientalis. It may, however, be worth while to give a short account of this plant, which was introduced into England in 1596, from the Levant. 195. The petals of the original flower, says Mr. Paul, were narrow, wrinkled, pointed, and of a flimsy texture. Now they are broad, smooth, solid, and rounded. The erectness, breadth, and length of the whole spike, and the size of the flowers have all increased. The colors have been intensified and diversified. Gerard, in 1597, enumerates 4, and Parkinson, in 1629, 8 varieties. Now the varieties are very numerous, and they were still more numerous a century ago. Mr. Paul remarks that it is interesting to compare the hyacinths of 1629 with those of 1864, and to mark the improvement. 235 years have elapsed since then, and this simple flower serves well to illustrate the great fact that the original forms of nature do not remain fixed and stationary, at least when brought under cultivation. While looking at the extremes, we must not, however, forget that there are intermediate stages which are for the most part lost to us. Nature will sometimes indulge herself with a leap, but as a rule her march is slow and gradual. He adds that the cultivator should have in his mind an ideal of beauty, for the realization of which he works with head and hand. We thus see how clearly Mr. Paul, an eminently successful cultivator of this flower, appreciates the action of methodical selection. In a curious and apparently trustworthy treatise published at Amsterdam 196 in 1768, it is stated that nearly 2,000 sorts were then known. But in 1864, Mr. Paul found only 700 in the largest garden at Haarlem. In this treatise, it is said that not an instance is known of any one variety reproducing itself truly by seed. The white kinds, however, now 197, almost always yield white hyacinths, and the yellow kinds come nearly true, the hyacinth is remarkable from having given rise to varieties with bright blue-pink and distinctly yellow flowers. These three primary colors do not occur in the varieties of any other species, nor do they often all occur even in the distinct species of the same genus. Although the several kinds of hyacinths differ but slightly from each other except in color, yet each kind has its own individual character, which can be recognized by a highly educated eye. Thus the writer of the Amsterdam Treatise asserts p. 43 that some experienced florists such as the famous G. Voorhelm seldom failed in a collection of above 1,200 sorts to recognize each variety by the bulb alone. This same writer mentions some few singular variations. For instance, the hyacinth commonly produces 6 leaves, but there is one kind p. 35, which scarcely ever has more than 3 leaves, another never more than 5, whilst others regularly produce either 7 or 8 leaves. A variety called La Coryphée invariably produces p. 116 2 flowerstems united together and covered by one skin. The flowerstem in another kind p. 128 comes out of the ground in a colored sheath before the appearance of the leaves, and is consequently liable to suffer from frost. Another variety always pushes a second flowerstem after the first has begun to develop itself. Lastly, white hyacinths, with red, purple, or violet centers p. 129, are the most liable to rot. Thus the hyacinth, like so many previous plants, when long cultivated and closely watched, is found to offer many singular variations. In the 2 last chapters, I have given in some detail the range of variation and the history as far as known of a considerable number of plants, which have been cultivated for various purposes. But some of the most variable plants such as kidney beans, capsicum, millets, sorghum, etc., have been passed over, for botanists are not at all agreed which kinds ought to rank as species, and which as varieties, and the wild parent species are unknown. 198 Many plants long cultivated in tropical countries, such as the banana, have produced numerous varieties. But as these have never been described with even moderate care, they are here also passed over. Nevertheless, a sufficient, and perhaps more than sufficient number of cases have been given, so that the reader may be enabled to judge for himself on the nature and great amount of variation which cultivated plants have undergone. References: Chapter Roman 11 on bud variation and on certain anomalous modes of reproduction and variation. Bud variation in the peach, plum, cherry, vine, gooseberry, currant, and banana, as shown by the modified fruit and flowers, camellias, azaleas, chrysanthemums, roses, etkin, the running of the color in carnations. Bud variations in leaves variations by suckers, tubers, and bulbson. The breaking of tulips. Bud variations graduate into changes consequent on changed conditions of life. Hybridson, the segregation of the parental characters in seminal hybrids. By bud variationen, the direct or immediate action of foreign pollen on the mother plantain, the effects in female animals of a previous impregnation on the subsequent offspring. Conclusion and summary. This chapter will be chiefly devoted to a subject in many respects important, namely bud variation. By this term, I include all those sudden changes in structure or appearance which occasionally occur in full-grown plants in their flower buds or leaf buds. Gardeners call such changes sports, but this, as previously remarked, is an ill-defined expression, as it has often been applied to strongly marked variations in seedling plants. The difference between seminal and bud reproduction is not so great as it at first appears, for each bud is in one sense a new and distinct individual, but such individuals are produced through the formation of various kinds of buds, without the aid of any special apparatus, whilst fertile seeds are produced by the concourse of the two sexual elements. The modifications which arise through bud variation can generally be propagated to any extent by grafting, budding, cuttings, bulbs, etc., and occasionally even by seed. Some few of our most beautiful and useful productions have arisen by bud variation. Bud variations have as yet been observed only in the vegetable kingdom, but it is probable that if compound animals, such as corals, etc., had been subjected to a long course of domestication, they would have varied by buds, for they resemble plants in many respects. For instance, any new or peculiar character presented by a compound animal is propagated by budding, as occurs with differently colored hydras, and as Mr. Goss has shown to be the case with a singular variety of a true coral. Varieties of the hydra have also been grafted on other varieties, and have retained their character. I will in the first place give all the cases of bud variations which I have been able to collect, and afterwards show their importance. These cases prove that those authors who, like Pallas, attribute all variability to the crossing, either of distinct races, or of distinct individuals belonging to the same race, but somewhat different from each other, are in error, as are those authors who attribute all variability to the act of sexual union, nor can we account in all cases for the appearance through bud variation of new characters, by the principle of reversion to long-lost characters. He who wishes to judge how far the conditions of life directly cause each particular variation ought to reflect well on the cases immediately to be given. I will commence with bud variations as exhibited in the fruit, and then pass on to flowers, and finally to leaves. Peach Amygdalus persica in the last chapter 1 gave 2 cases of a peach almond and a double-flowered almond, which suddenly produced fruit closely resembling true peaches. I have also given many cases of peach trees producing buds, which when developed into branches, have yielded nectarines. We have seen that no less than 6 named and several unnamed varieties of the peach have thus produced several varieties of nectarine. I have shown that it is highly improbable that all these peach trees, some of which are old varieties, and have been propagated by the million, are hybrids from the peach and nectarine, and that it is opposed to all analogy to attribute the occasional production of nectarines on peach trees to the direct action of pollen from some neighboring nectarine tree. Several of the cases are highly remarkable, because firstly the fruit thus produced has sometimes been in part a nectarine, and in part a peach; secondly because nectarines thus suddenly produced have reproduced themselves by seed, and thirdly because nectarines are produced from peach trees from seed, as well as from buds. The seed of the nectarine, on the other hand, occasionally produces peaches, and we have seen in one instance that a nectarine tree yielded peaches by bud variation. As the peach is certainly the oldest or primary variety, the production of peaches from nectarines, either by seeds or buds, may perhaps be considered as a case of reversion. Certain trees have also been described as indifferently bearing peaches or nectarines, and this may be considered as bud variation carried to an extreme degree. The Gros Mignon peach at Montreuil, produced from a sporting branch, the Gros Mignon tardive, a most excellent variety, which ripens its fruit a fortnight later than the parent tree, and is equally good too. This same peach has likewise produced by bud variation the early Gros Mignon Hunt's large tawny nectarine, originated from Hunt's small tawny nectarine, but not through seminal reproduction. 3. Plums. Mr. Knight states that a tree of the yellow Magnum bonum plum 40 years old, which had always borne ordinary fruit, produced a branch, which yielded red Magnum bonums. 4. Mr. Rivers of Sawbridgeworth informs me Jan. 1863 that a single tree out of 400 or 500 trees of the early prolific plum, which is a purple kind, descended from an old French variety, bearing purple fruit, produced, when about 10 years old, bright yellow plums. These differed in no respect except color from those on the other trees, but were unlike any other known kind of yellow plum. 5. Cherry Prunus cerasus. Mr. Knight has recorded ibid the case of a branch of a Mayduke cherry, which though certainly never grafted, always produced fruit ripening later, and more oblong than the fruit on the other branches. Another account has been given of 2 Mayduke cherry trees in Scotland, with branches bearing oblong and very fine fruit, which invariably ripened, as in Knight's case, a fortnight later than the other cherries. 6. Roman 1000 Carriere gives p. 37 numerous analogous cases, and one of the same tree bearing 3 kinds of fruit. Grapes Vitis vinifera, the black or purple Frontignan, in one case produced during 2 successive years, and no doubt permanently spurs, which bore white Frontignan grapes in another case on the same footstalk. The lower berries were well-colored black Frontignans, those next the stalk were white with the exception of 1 black and 1 streaked berry, and altogether there were 15 black and 12 white berries on the same stalk in another kind of grape. Black and amber-colored berries were produced in the same cluster. 7. Count Odart describes a variety which often bears on the same stalk small round and large oblong berries, though the shape of the berry is generally a fixed character. 8. Here is another striking case, given on the excellent authority of Roman 1000 Carriere. 9. A black Hamburg grape Frankenthal was cut down, and produced 3 suckers. One of these was layered, and after a time produced much smaller berries, which always ripened at least a fortnight earlier than the others. Of the remaining 2 suckers, one produced every year fine grapes, whilst the other, although it set an abundance of fruit, matured only a few, and these of inferior quality. Gooseberry ribs Grossularia A remarkable case has been described by Dr. Lindley 10 of a bush which bore at the same time no less than 4 kinds of berries, namely hairy and red smooth small and red-green and yellow, tinged with buff. The 2 latter kinds had a different flavor from the red berries, and their seeds were colored red. 3 twigs on this bush grew close together. The first bore 3 yellow berries, and 1 red. The second twig bore 4 yellow, and 1 red, and the third 4 red and 1 yellow. Mr. Laxton also informs me that he has seen a red Warrington gooseberry bearing both red and yellow fruit on the same branch. Currant ribs rubrum. A bush purchased as the champagne, which is a variety that bears blush-colored fruit, intermediate between red and white, produced during 14 years on separate branches, and mingled on the same branch berries of the red, white, and champagne kinds. 11. The suspicion naturally arises that this variety may have originated from a cross between a red and white variety, and that the transformation may be accounted for by reversion to both parent forms. But from the foregoing complex case of the gooseberry, this view is doubtful. In France, a branch of a red currant bush about 10 years old produced near the summit 5 white berries, and lower down amongst the red berries, 1 berry half red and half white. 12. Alexander Braun 13 also has often seen branches on white currant trees bearing red berries. Père Pyrrhus Communis Duro de la Malle states that the flowers on some trees of an ancient variety, the Doyen Galou, were destroyed by frost. Other flowers appeared in July, which produced 6 pairs. These exactly resembled in their skin and taste the fruit of a distinct variety, the Gros Doyen Blanc, but in shape were like the Boncrution. It was not ascertained whether this new variety could be propagated by budding or grafting. The same author grafted a Boncrution on a quince, and it produced, besides its proper fruit, an apparently new variety of a peculiar form, with thick and rough skin. 14. Apple Pyrus Malison, Canada. A tree of the variety called Pound Sweet produced 15 between 2 of its proper fruit, an apple, which was well russeted, small in size, different in shape, and with a short peduncle, as no russet apple grew anywhere near this case, apparently cannot be accounted for by the direct action of foreign pollen. Roman 1000 Carriere p. 38 mentions an analogous instance. I shall hereafter give cases of apple trees, which regularly produce fruit of 2 kinds or half and half fruit. These trees are generally supposed, and probably with truth, to be of crossed parentage, and that the fruit reverts to both parent forms. Banana Musa sapientium. Sir R. Schomburg states that he saw in St. Domingo a raceme on the fig banana, which bore towards the base 125 fruits of the proper kind, and these were succeeded, as is usual higher up the raceme, by barren flowers, and these by 420 fruits having a widely different appearance, and ripening earlier than the proper fruit. The abnormal fruit closely resembled, except in being smaller, that of the Musa chinensis or Cavendishii, which has generally been ranked as a distinct species. 16. Flowers. Many cases have been recorded of a whole plant, or single branch, or bud, suddenly producing flowers different from the proper type in color, form, size, doubleness, or other character. Half the flower, or a smaller segment, sometimes changes color. Camellia. The meadow-leaved species, Roman 100 meadifolia, and 2 or 3 varieties of the common species, have been known to produce hexagonal and imperfectly quadrangular flowers, and the branches producing such flowers have been propagated by grafting. 17. The pompon variety often bears 4 distinguishable kinds of flowers, pure white, and the red-dyed, which appear promiscuously, the brindled pink, and the rose-colored, which may be kept separate with tolerable certainty by grafting from the branches that bear them. A branch also on an old tree of the rose-colored variety has been seen to revert to the pure white color, an occurrence less common than the departure from it. 18. Cracus oxyacantha, a dark pink hawthorn, has been known to throw out a single tuft of pure white blossoms. 19. And Mr. A Clapham, nurseryman of Bedford, informs me that his father had a deep crimson thorn, grafted on a white thorn, which during several years always bore high above the graft bunches of white pink and deep crimson flowers. Azalea indica is well known often to produce new varieties by buds. I have myself seen several cases. A plant of Azalea indica variegata has been exhibited bearing a truss of flowers of a Ind Gledstonesii, as true as could possibly be produced, thus evidencing the origin of that fine variety. On another plant of a Ind variegata, a perfect flower of a Ind lateritia was produced, so that both Gledstonesii and lateritia, no doubt, originally appeared as sporting branches of a Ind variegata. 20. Hibiscus peridium tricuspis, a seedling of this plant, when some years old, produced at Saharanpur 21. Some branches which bore leaves and flowers widely different from the normal form. The abnormal leaf is much less divided and not acuminated. The petals are considerably larger and quite entire. There is also in the fresh state a conspicuous large oblong gland, full of a viscid secretion, on the back of each of the calycine segments. Dr. King, who subsequently had charge of these gardens, informs me that a tree of Peridium tricuspis, probably the very same plant growing, there had a branch buried in the ground apparently by accident, and this branch changed its character wonderfully, growing like a bush, and producing flowers and leaves resembling in shape those of another species, viz. P. tiliaceum. A small branch, springing from this bush near the ground, reverted to the parent form. Both forms were extensively propagated during several years by cuttings, and kept perfectly true. Altha rosea, a double yellow hollyhock, suddenly turned one year into a pure white single kind. Subsequently, a branch bearing the original double yellow flowers reappeared in the midst of the branches of the single white kind. 22. Pelargonium. These highly cultivated plants seem eminently liable to bud variation. I will give only a few well-marked cases. Gartner has seen 23, a plant of P. zonale, with a branch having white edges, which remained constant for years, and bore flowers of a deeper red than usual. Generally speaking, such branches present little or no difference in their flowers. Thus a writer 24 pinched off the leading shoot of a seedling P. zonale, and it threw out 3 branches which differed in the size and color of their leaves and stems. But on all 3 branches the flowers were identical, except in being largest in the green-stemmed variety, and smallest in that with variegated foliage. These 3 varieties were subsequently propagated, and distributed many branches, and some whole plants of a variety called compactum, which bears orange-scarlet flowers, have been seen to produce pink flowers. 25 Hills Hector, which is a pale red variety, produced a branch with lilac flowers, and some trusses with both red and lilac flowers. This apparently is a case of reversion, for Hills Hector was a seedling from a lilac variety. 26 Here is a better case of reversion, a variety produced from a complicated cross, after having been propagated for 5 generations by seed yielded by bud variation, 3 very distinct varieties, which were undistinguishable from plants known to have been at some time ancestors of the plant in question. 27. Of all Pelargoniums, Roleson's unique seems to be the most sportive. Its origin is not positively known, but is believed to be from a cross. Mr. Salter of Hammersmith states 28 that he has himself known this purple variety to produce the lilac, the rose crimson or conspicuum, and the red or coccineum varieties. The latter has also produced the rose damer, so that altogether 4 varieties have originated by bud variation from Roleson's unique. Mr. Salter remarks that these 4 varieties may now be considered as fixed, although they occasionally produce flowers of the original color. This year coccineum has pushed flowers of 3 different colors, red, rose, and lilac, upon the same truss, and upon other trusses are flowers half red and half lilac. Besides these 4 varieties, 2 other scarlet uniques are known to exist, both of which occasionally produce lilac flowers, identical with Roleson's unique 29, but one at least of these did not arise through bud variation, but is believed to be a seedling from Roleson's unique 30. There are also in the trade 31 2 other slightly different varieties of unknown origin of Roleson's unique, so that altogether we have a curiously complex case of variation, both by buds and seeds. 32 Here is a still more complex case. Roman 1000 Raffarin states that a pale rose-colored variety produced a branch bearing deep red flowers. Cuttings were taken from this sport, from which 20 plants were raised, which flowered in 1867, when it was found that scarcely 2 were alike. Some resembled the parent form, some resembled the sport, some bore both kinds of flowers, and even some of the petals on the same flower were rose-colored, and others red. 33 An English wild plant, the Geranium pratense, when cultivated in a garden, has been seen to produce on the same plant both blue and white, and striped blue and white flowers. 34 Chrysanthemum. This plant frequently sports both by its lateral branches and occasionally by suckers. A seedling, raised by Mr. Salter, has produced by bud variation 6 distinct sorts, 5 different in color, and 1 in foliage, all of which are now fixed. 35 A variety called Cedo nulli bears small yellow flowers, but habitually produces branches with white flowers, and a specimen was exhibited which Prof. T. Dyer saw before the Horticultural Society. The varieties which were first introduced from China were so excessively variable that it was extremely difficult to tell which was the original color of the variety, and which was the sport. The same plant would produce one year only buff-colored, and next year only rose-colored flowers, and then would change again or produce at the same time flowers of both colors. These fluctuating varieties are now all lost, and when a branch sports into a new variety, it can generally be propagated and kept true. But as Mr. Salter remarks, every sport should be thoroughly tested in different soils before it can be really considered as fixed, as many have been known to run back when planted in rich compost. But when sufficient care and time are expended in proving, there will exist little danger of subsequent disappointment. Mr. Salter informs me that with all the varieties, the commonest kind of bud variation is the production of yellow flowers, and as this is the primordial color, these cases may be attributed to reversion. Mr. Salter has given me a list of 7 differently colored chrysanthemums, which have all produced branches with yellow flowers, but 3 of them have also sported into other colors. With any change of color in the flower, the foliage generally changes in a corresponding manner in lightness or darkness. Another compositous plant, namely Centaurea cyanus, when cultivated in a garden, not unfrequently produces on the same root flowers of 4 different colors, viz. Blue, white, dark purple, and parti-colored. 36. The flowers of Anthemis also vary on the same plant. 37. Roses. Many varieties of the rose are known, or are believed to have originated by bud variation. 38. The common double moss rose was imported into England from Italy about the year 173,539. Its origin is unknown, but from analogy, it probably arose from the Provence rose R. centifolia by bud variation, for the branches of the common moss rose have several times been known to produce Provence roses wholly or partially destitute of moss. I have seen one such instance, and several others have been recorded. 40. Mr. Rivers also informs me that he raised 2 or 3 roses of the Provence class from seed of the old single moss rose. 41. And this latter kind was produced in 1807 by bud variation from the common moss rose. The white moss rose was also produced in 1788 by an offset from the common red moss rose. It was at first pale blush-colored, but became white by continued budding. On cutting down the shoots which had produced this white moss rose, 2 weak shoots were thrown up, and buds from these yielded the beautiful striped moss rose. The common moss rose has yielded by bud variation, besides the old single red moss rose, the old scarlet semi-double moss rose, and the sageleaf moss rose, which has a delicate shell-like form and is of a beautiful blush color. It is now 1852 nearly extinct. 42. A white moss rose has been seen to bear a flower half white and half pink. 43. Although several moss roses have thus certainly arisen by bud variation, the greater number probably owe their origin to seed of moss roses, for Mr. Rivers informs me that his seedlings from the old single moss rose almost always produced moss roses, and the old single moss rose was, as we have seen, the product by bud variation of the double moss rose, originally imported from Italy. That the original moss rose was the product of bud variation is probable from the facts above given, and from the de Meaux moss rose, also a variety of R. centifolia. 44. Having appeared as a sporting branch on the common rose de Meaux, Prof. Caspary has carefully described. 45. The case of a 6-year-old white moss rose, which sent up several suckers, one of which was thorny, and produced red flowers destitute of moss exactly like those of the Provence rose R. centifolia. Another shoot bore both kinds of flowers and, in addition, longitudinally striped flowers, as this white moss rose had been grafted on the Provence rose. Prof. Caspary attributes the above changes to the influence of the stock, but from the facts already given and from others to be given, bud variation with reversion is probably a sufficient explanation. Many other instances could be added of roses varying by buds. The white Provence rose apparently originated in this way. 46. Roman 1000 Carriere states p. 36 that he himself knows of 5 varieties thus produced by the Baron Provost. The double and highly colored belladonna rose has produced by suckers both semi-double and almost single white roses. 47. While suckers from one of these semi-double white roses reverted to perfectly characterized belladonnas, in St. Domingo varieties of the China rose, propagated by cuttings, often revert after a year or 2 into the old China rose. 48. Many cases have been recorded of roses suddenly becoming striped or changing their character by segments. Some plants of the Comtesse de Chaberlant, which is properly rose-colored, were exhibited in 186,249, with crimson flakes on a rose ground. I have seen the beauty of billiard with a quarter. And, with half the flower almost white, the Austrian bramble R. lutea, not rarely 50, produces branches with pure yellow flowers, and Prof. Henslow has seen exactly half the flower of a pure yellow, and I have seen narrow yellow streaks on a single petal, of which the rest was of the usual copper color. The following cases are highly remarkable. Mr. Rivers, as I am informed by him, possessed a new French rose with delicate smooth shoots, pale glaucous green leaves, and semi-double pale flesh-colored flowers striped with dark red, and on branches thus characterized there suddenly appeared in more than one instance the famous old rose called the Baron Provost, with its stout thorny shoots, and immense uniformly and richly colored double flowers, so that in this case, the shoots, leaves, and flowers all at once changed their character by bud variation, according to Roman 1000 Verlot 51, a variety called Rosa cannabifolia, which has peculiarly shaped leaflets, and differs from every member of the family, in the leaves being opposite instead of alternate, suddenly appeared on a plant of R. alba in the gardens of the Luxembourg. Lastly, a running shoot was observed by Mr. H. Curtis 52 on the old Amy Vibert noisette, and he budded it on Celine. Thus a climbing Amy Vibert was first produced, and afterwards propagated. Dianthus is quite common with the sweet William Roman 500 barbatus to see differently colored flowers on the same root, and I have observed on the same truss 4 differently colored and shaded flowers, carnations, and pinks Roman 500 caryophyllus, etc., occasionally vary by layers, and some kinds are so little certain in character that they are called by floriculturists catchflowers. 53. Mr. Dixon has ably discussed the running of particolored, or striped carnations, and says it cannot be accounted for by the compost, in which they are grown. Layers from the same clean flower would come part of them clean and part foul, even when subjected to precisely the same treatment, and frequently one flower alone appears influenced by the taint, the remainder coming perfectly clean. 54. This running of the particolored flowers, apparently, is a case of reversion by buds to the original uniform tint of the species. I will briefly mention some other cases of bud variation to show how many plants belonging to many orders have varied in their flowers, and many others might be added. I have seen on a snapdragon Antirrhinum majus white pink, and striped flowers on the same plant and branches, with striped flowers on a red-colored variety on a double-stalk Mathiola incana. I have seen a branch bearing single flowers, and on a dingy-purple double variety of the wallflower Cheiranthus cherry, a branch which had reverted to the ordinary copper color on other branches of the same plant. Some flowers were exactly divided across the middle, one half being purple, and the other coppery, but some of the smaller petals towards the center of these same flowers were purple, longitudinally streaked with coppery color or coppery streaked with purple. A cyclamen 55 has been observed to bear white and pink flowers of 2 forms, the one resembling the persicum strain, and the other, the calm strain Onothera biennis, has been seen 56 bearing flowers of 3 different colors. The hybrid Gladiolus calvulae occasionally bears uniformly colored flowers, and one case is recorded 57 of all the flowers on a plant thus changing color. A fuchsia has been seen 58 bearing 2 kinds of flowers. Mirabilis jalapa is eminently sportive, sometimes bearing on the same root pure red, yellow, and white flowers, and others striped with various combinations of these 3 colors. 59. The plants of the Mirabilis, which bear such extraordinarily variable flowers, in most probably in all cases owe their origin, as shown by Prof. Lecoq, to crosses between differently colored varieties. Leaves and shoots changes through bud variation in fruits and flowers have hitherto been treated of. Incidentally, some remarkable modifications in the leaves and shoots of the rose and peridium, and in a lesser degree in the foliage of the pelargonium and chrysanthemum, have been noticed. I will now add a few more cases of variation in leaf buds. Verlot 60 states that on Aralia trifoliata, which properly has leaves with 3 leaflets, branches, frequently appear bearing simple leaves of various forms. These can be propagated by buds or by grafting, and have given rise, as he states, to several nominal species. With respect to trees, the history of but few of the many varieties with curious or ornamental foliage is known, but several probably have originated by bud variation. Here is one case, an old ash tree Fraxinus excelsior in the grounds of Necton, as Mr. Mason states, for many years, has had one bough of a totally different character to the rest of the tree, or of any other ash tree which I have seen being short-jointed and densely covered with foliage. It was ascertained that this variety could be propagated by grafts. 61. The varieties of some trees with cut leaves, as the oak-leaved laburnum, the parsley-leaved vine, and especially the fern-leaved beech, are apt to revert by buds to the common forms. 62. The fern-like leaves of the beech sometimes revert only partially, and the branches display here, and their sprouts bearing common leaves fern-like, and variously shaped leaves. Such cases differ but little from the so-called heterophyllous varieties, in which the tree habitually bears leaves of various forms, but it is probable that most heterophyllous trees have originated as seedlings. There is a subvariety of the weeping willow with leaves rolled up into a spiral coil, and Mr. Masters states that a tree of this kind kept true in his garden for 25 years, and then threw out a single upright shoot, bearing flat leaves. 63. I have often noticed single twigs and branches on beech and other trees, with their leaves fully expanded before those on the other branches had opened. And as there was nothing in their exposure or character to account for this difference, I presume that they had appeared as bud variations like the early and late fruit-maturing varieties of the peach and nectarine. Cryptogamic plants are liable to bud variation, for fronds on the same fern often display remarkable deviations of structure. Spores, which are of the nature of buds taken from such abnormal fronds, reproduce with remarkable fidelity the same variety after passing through the sexual stage. 64. With respect to color, leaves often become by bud variation zoned, blotched, or spotted with white, yellow, and red, and this occasionally occurs even with plants in a state of nature. Variegation, however, appears still more frequently in plants produced from seed, even the cotyledons or seed leaves being thus affected. 65. There have been endless disputes whether variegation should be considered as a disease. In a future chapter, we shall see that it is much influenced, both in the case of seedlings and of mature plants, by the nature of the soil. Plants which have become variegated, as seedlings generally transmit their character by seed to a large proportion of their progeny, and Mr. Salter has given me a list of 8 genera in which this occurred. 66. Sir F. Pollock has given me more precise information. He sowed seed from a variegated plant of Balota nigra, which was found growing wild, and 30% of the seedlings were variegated seed from these latter being sown. 60% came up variegated. When branches become variegated by bud variation, and the variety is attempted to be propagated by seed, the seedlings are rarely variegated. Mr. Salter found this to be the case with plants belonging to 11 genera, in which the greater number of the seedlings proved to be green-leaved, yet a few were slightly variegated, or were quite white, but none were worth keeping. Variegated plants, whether originally produced from seeds or buds, can generally be propagated by budding, grafting, etc., but all are apt to revert by bud variation to their ordinary foliage. This tendency, however, differs much in the varieties of even the same species. For instance, the golden-striped variety of Euonymus japonicus is very liable to run back to the green-leaved, while the silver-striped variety hardly ever changes. 67. I have seen a variety of the holly, with its leaves having a central yellow patch, which had everywhere partially reverted to the ordinary foliage, so that on the same small branch there were many twigs of both kinds in the pelargonium, and in some other plants. Variegation is generally accompanied by some degree of dwarfing, as is well exemplified in the dandy pelargonium, when such dwarf varieties sport back by buds or suckers to the ordinary foliage. The dwarfed stature still remains. 68. It is remarkable that plants propagated from branches, which have reverted from variegated to plain leaves. 69. Do not always, or never, as one observer asserts, perfectly resemble the original plain-leaved plant from which the variegated branch arose. It seems that a plant in passing by bud variation from plain leaves to variegated and back again, from variegated to plain, is generally in some degree affected, so as to assume a slightly different aspect. Bud variation by suckers, tubers, and bulbs. All the cases hitherto given of bud variation in fruits, flowers, leaves, and shoots have been confined to buds on the stems or branches, with the exception of a few cases, incidentally noticed, of varying suckers in the rose, pelargonium, and chrysanthemum. I will now give a few instances of variation in subterranean buds, that is, by suckers, tubers, and bulbs. Not that there is any essential difference between buds above and beneath the ground. Mr. Salter informs me that 2 variegated varieties of phlox originated as suckers, but I should not have thought these worth mentioning, had not Mr. Salter found after repeated trials that he could not propagate them by roots, whereas the variegated Tussilago farfara can thus be safely propagated 70. But this latter plant may have originated as a variegated seedling, which would account for its greater fixedness of character. The Barberry berberis vulgaris offers an analogous case. There is a well-known variety with seedless fruit which can be propagated by cuttings or layers, but suckers always revert to the common form, which produces fruit containing seeds. 71. My father repeatedly tried this experiment, and always with the same result. I may here mention that maize and wheat sometimes produce new varieties from the stalk or root, as does the sugarcane. 72. Turning now to tubers in the common potato Solanum tuberosum, a single bud or eye sometimes varies, and produces a new variety or occasionally, and this is a much more remarkable circumstance. All the eyes in a tuber vary in the same manner, and at the same time so that the whole tuber assumes a new character. For instance, a single eye in a tuber of the old 40-fold potato, which is a purple variety, was observed 73 to become white. This eye was cut out and planted separately, and the kind has since been largely propagated. Kemp's potato is properly white, but a plant in Lancashire produced 2 tubers which were red and 2 which were white. The red kind was propagated in the usual manner by eyes, and kept true to its new color, and being found a more productive variety, soon became widely known under the name of Taylor's 40-fold. 74. The old 40-fold potato, as already stated, is a purple variety, but a plant long cultivated on the same ground, produced not as in the case above given a single white eye, but a whole white tuber, which has since been propagated, and keeps true. 75. Several cases have been recorded of large portions of whole rows of potatoes, slightly changing their character. 76. Dahlias propagated by tubers under the hot climate of St. Domingo. Very much. Sir R. Schomburg gives the case of the butterfly variety, which the second year produced on the same plant double and single flowers, here white petals edged with maroon, there of a uniform deep maroon. 77. Mr. Bree also mentions a plant which bore 2 different kinds of self-colored flowers, as well as a third kind, which partook of both colors beautifully intermixed. 78. Another case is described of a dahlia with purple flowers, which bore a white flower streaked with purple. 79. Considering how long and extensively many bulbous plants have been cultivated, and how numerous are the varieties produced from seed, these plants have not perhaps varied so much by offsets that is by the production of new bulbs might have been expected with the hyacinth. However, several instances have been given by Roman 1000 Carriere. A case also has been recorded of a blue variety which for 3 successive years gave offsets producing white flowers with a red center. 80. Another hyacinth bore 81 on the same truss, a perfectly pink and a perfectly blue flower. I have seen a bulb producing at the same time one stalk or truss with fine blue flowers, another with fine red flowers, and a third with blue flowers on one side and red on the other, several of the flowers being also longitudinally striped red and blue. Mr. John Scott informs me that in 1862, Ematophyllum miniatum in the Botanic Gardens of Edinburgh threw up a sucker which differed from the normal form in the leaves being two-ranked instead of four-ranked. The leaves were also smaller with the upper surface raised instead of being channeled. In the propagation of tulip seedlings are raised called selfs or breeders, which consist of one plain color on a white or yellow bottom, these being cultivated on a dry and rather poor soil become broken or variegated, and produce new varieties. The time that elapses before they break varies from 1 to 20 years or more, and sometimes this change never takes place. 82. The broken or variegated colors, which give value to all tulips, are due to bud variation, for although the biblomens and some other kinds have been raised from several distinct breeders, yet all the bagates are said to have come from a single breeder, or seedling. This bud variation, in accordance with the views of Roman 2000 Vilmorin and Verlot 83, is probably an attempt to revert to that uniform color, which is natural to the species. A tulip, however, which has already become broken when treated with too strong manure, is liable to flush or lose, by a second act of reversion, its variegated colors. Some kinds, as Imperatrix florum, are much more liable than others to flushing, and Mr. Dixon maintains 84 that this can no more be accounted for than the variation of any other plant. He believes that English growers, from care in choosing seed from broken flowers, instead of from plain flowers, have to a certain extent diminished the tendency in flowers already broken to flushing or secondary reversion. Iris xiphium, according to Roman 1000 Carriere p. 65, behaves in nearly the same manner as do so many tulips. During 2 consecutive years, all the early flowers in a bed of Tigridia conchiflora 85 resembled those of the old T. pavonia, but the later flowers assumed their proper color of fine yellow spotted with crimson. An apparently authentic account has been published 86 of 2 forms of Hemerocallis, which have been universally considered as distinct species changing into each other for the roots of the large-flowered tawny H. fulva being divided and planted in a different soil and place, produced the small-flowered H. flava, as well as some intermediate forms. It is doubtful whether such cases as these latter, as well as the flushing of broken tulips and the running of party-colored carnations, that is their more or less complete return to a uniform tintot, to be classed under bud variation, or ought to be retained for the chapter in which I treat of the direct action of the conditions of life on organic beings. These cases, however, have this much in bud variation, that the change is effected through buds, and not through seminal reproduction. But on the other hand, there is this difference that in ordinary cases of bud variation, one bud alone changes, whilst in the foregoing cases, all the buds on the same plant were modified together. With the potato, we have seen an intermediate case, for all the eyes in one tuber simultaneously changed their character. I will conclude with a few allied cases, which may be ranked either under bud variation or under the direct action of the conditions of life. When the common hepatica is transplanted from its native woods, the flowers change color even during the first year. 87. It is notorious that the improved varieties of the Heartsease viola tricolor, when transplanted, often produce flowers widely different in size, form, and color. For instance, I transplanted a large uniformly colored dark purple variety whilst in full flower, and it then produced much smaller, more elongated flowers, with the lower petals yellow. These were succeeded by flowers marked with large purple spots, and ultimately towards the end of the same summer, by the original large dark purple flowers. The slight changes which some fruit trees undergo from being grafted and regrafted on various stocks 88 were considered by Andrew Knight 89 as closely allied to sporting branches or bud variations. Again, we have the case of young fruit trees changing their character as they grow. Old seedling pears, for instance, lose with age their spines and improve in the flavor of their fruit. Weeping birch trees, when grafted on the common variety, do not acquire a perfect pendulous habit until they grow old. On the other hand, I shall hereafter the case of some weeping ashes which slowly and gradually assumed an upright habit of growth. All such changes dependent on age may be compared with the changes alluded to in the last chapter, which many trees naturally undergo, as in the case of the deodar and cedar of Lebanon, which are unlike in youth, whilst they closely resemble each other in old age, and as with certain oaks, and with some varieties of the lime and hawthorn. 90. Grafthybrids. Before giving a summary on bud variation, I will discuss some singular and anomalous cases, which are more or less closely related to this same subject. I will begin with the famous case of Adam's laburnum, or Cytisus adami, a form or hybrid intermediate between 2 very distinct species, namely Roman 100 laburnum and Purpureus the common and purple laburnum. But as this tree has often been described, I will be as brief as I can. Throughout Europe, in different soils and under different climates, branches on this tree have repeatedly and suddenly reverted to the 2 parent species in their flowers and leaves. To behold mingled on the same tree tufts of dinged bright yellow and purple flowers borne on branches having widely different leaves and manner of growth is a surprising sight. The same raceme sometimes bears 2 kinds of flowers, and I have seen a single flower exactly divided into halves, one side being bright yellow and the other purple, so that one half of the standard petal was yellow and of larger size, and the other half purple and smaller. In another flower, the whole corolla was bright yellow, but exactly half the calyx was purple. In another, one of the dinged wing petals had a narrow bright yellow stripe on it, and lastly in another flower, one of the stamens, which had become slightly foliaceous, was half yellow and half purple, so that the tendency to segregation of character or reversion affects even single parts and organs. 91. The most remarkable fact about this tree is that in its intermediate state, even when growing near both parent species, it is quite sterile. But when the flowers become pure yellow or pure purple, they yield seed. I believe that the pods from the yellow flowers yield a full complement of seed. They certainly yield a larger number 2 seedlings, raised by Mr. Herbert from such seed 92, exhibited a purple tinge on the stalks of their flowers, but several seedlings raised by myself resembled in every character the common laburnum, with the exception that some of them had remarkably long racemes. These seedlings were perfectly fertile that such purity of character and fertility should be suddenly reacquired from so hybridized and sterile a form is an astonishing phenomenon. The branches with purple flowers appear at first sight exactly to resemble those of Roman 100 purpureus, but on careful comparison, I found that they differed from the pure species in the shoots being thicker, the leaves a little broader, and the flowers slightly shorter with the corolla and calyx less brightly purple. The basal part of the standard petal also plainly showed a trace of the yellow stain, so that the flowers, at least in this instance, had not perfectly recovered their true character. And in accordance with this, they were not perfectly fertile, for many of the pods contained no seed. Some produced one and very few contained as many as 2 seeds, whilst numerous pods on a tree of the pure Roman 100 purpureus in my garden contained 3, 4, and 5 fine seeds. The pollen, moreover, was very imperfect, a multitude of grains being small and shriveled. And this is a singular fact, for, as we shall immediately see, the pollen grains in the dinged and sterile flowers on the parent tree were in external appearance in a much better state, and included very few shriveled grains, although the pollen of the reverted purple flowers was in so poor a condition the ovules were well formed, and the seeds when mature germinated freely. With me Mr. Herbert raised plants from seeds of the reverted purple flowers, and they differed a very little from the usual state of Roman 100 purpureus. Some which I raised in the same manner did not differ at all either in the character of their flowers, or of the whole bush from the pure Roman 100 purpureus. Prof. Caspary has examined the ovules of the dinged and sterile flowers in several plants of Roman 100 Adami on the continent 93, and finds them generally monstrous. In 3 plants examined by me in England, the ovules were likewise monstrous, the nucleus varying much in shape and projecting irregularly beyond the proper coats. The pollen grains, on the other hand, judging from their external appearance, were remarkably good and readily protruded their tubes. By repeatedly counting under the microscope the proportional number of bad grains, Prof. Caspary ascertained that only 25% were bad, which is a less proportion than in the pollen of 3 pure species of cytisus in their cultivated state, viz. Roman 100 purpureus laburnum and alpinus. Although the pollen of Roman 100 Adami is thus in appearance good, it does not follow, according to Roman 1000 Naudin's observation 94 on mirabilis, that it would be functionally effective. The fact of the ovules of Roman 100 Adami being monstrous, and the pollen apparently sound, is all the more remarkable, because it is opposed to what usually occurs not only with most hybrids 95, but with 2 hybrids in the same genus, namely in Roman 100 purpureolongatus and Roman 100 alpinolaburnum. In both these hybrids, the ovules, as observed by Prof. Caspary and myself, were well-formed, whilst many of the pollen grains were ill-formed. In the latter hybrid 20%, and in the former no less than 848% of the grains were ascertained by Prof. Caspary to be bad. This unusual condition of the male and female reproductive elements in Roman 100 Adami has been used by Prof. Caspary as an argument against this plant being considered as an ordinary hybrid produced from seed. But we should remember that with hybrids, the ovules have not been examined nearly so frequently as the pollen, and they may be much oftener imperfect than is generally supposed. Dr. E. Bornet of Antibes informs me through Mr. J. Traherne Mogridge that with hybrid cysti, the ovarium is frequently deformed, the ovules being in some cases quite absent, and in other cases incapable of fertilization. Several theories have been propounded to account for the origin of Roman 100 Adami, and for the transformations which it undergoes. The whole case has been attributed by some authors to bud variation. But considering the wide difference between Roman 100 laburnum and purpureus, both of which are natural species, and considering the sterility of the intermediate form, this view may be summarily rejected. We shall presently see that with hybrid plants, 2 embryos differing in their characters may be developed within the same seed and cohere, and it has been supposed that Roman 100 Adami thus originated. Many botanists maintain that Roman 100 Adami is a hybrid produced in the common way by seed, and that it has reverted by buds to its 2 parent forms. Negative results are not of much value, but Riasek Caspary and myself tried in vain to cross Roman 100 laburnum and purpureus When I fertilized the former with pollen of the latter, I had the nearest approach to success, for pods were formed. But in 16 days after the withering of the flowers, they fell off nevertheless. The belief that Roman 100 Adami is a spontaneously produced hybrid between these two species is supported by the fact that such hybrids have arisen in this genus in a bed of seedlings from Roman 100 elongatus, which grew near to Roman 100 purpureus, and was probably fertilized by it through the agency of insects. For these, as I know by experiment, play an important part in the fertilization of the laburnum. The sterile hybrid Roman 100 purpureolongatus appeared 96, thus also Waterer's laburnum, the Roman 100 alpinolaburnum 97, spontaneously appeared, as I am informed by Mr. Waterer, in a bed of seedlings. On the other hand, we have a clear and distinct account given to Poito 98 by Roman 1000 Adam, who raised the plant, showing that Roman 100 Adami is not an ordinary hybrid, but is what may be called a graft hybrid, that is, one produced from the united cellular tissue of two distinct species, Roman 1000 Adam, inserted in the usual manner, a shield of the bark of Roman 100 purpureus into a stalk of Roman 100 laburnum, and the bud lay dormant, as often happens, for a year. The shield then produced many buds, and shoots, one of which grew more upright and vigorous with larger leaves than the shoots of Roman 100 purpureus, and was consequently propagated. Now, it deserves a special notice that these plants were sold by Roman 1000 Adam as a variety of Roman 100 purpureus before they had flowered, and the account was published by Poito after the plants had flowered, but before they had exhibited their remarkable tendency to revert into the two parent species, so that there was no conceivable motive for falsification, and it is difficult to see how there could have been any error. 99. If we admit as true Roman 1000 Adams account, we must admit the extraordinary fact that two distinct species can unite by their cellular tissue, and subsequently produce a plant bearing leaves and sterile flowers, intermediate in character between the scion and stalk, and producing buds liable to reversion, in short, resembling in every important respect a hybrid formed in the ordinary way by seminal reproduction. I will therefore give all the facts which I have been able to collect on the formation of hybrids between distinct species or varieties, without the intervention of the sexual organs, for if, as I am now convinced, this is possible, it is a most important fact, which will sooner or later change the views held by physiologists with respect to sexual reproduction. A sufficient body of facts will afterwards be adduced, showing that the segregation or separation of the characters of the two parent forms by bud variation, as in the case of Cytisus adami, is not an unusual though a striking phenomenon. We shall further see that a whole bud may thus revert, or only half or some smaller segment. The famous Bezeria orange offers a strictly parallel case to that of Cytisus adami. The gardener, who in 1644 in Florence raised this tree, declared that it was a seedling which had been grafted, and after the graft had perished the stalk sprouted, and produced the Bezeria galizio, who carefully examined several living specimens, and compared them with the description given by the original describer P. Nato 100 states that the tree produces at the same time leaves, flowers, and fruit, identical with the bitter orange, and with the citron of Florence, and likewise compound fruit with the two kinds, either blended together both externally and internally or segregated. In various ways, this tree can be propagated by cuttings, and retains its diversified character. The so-called trifacial orange of Alexandria and Smyrna, 101, resembles in its general nature the Bezeria, and differs only in the orange being of the sweet kind. This and the citron are blended together in the same fruit, or are separately produced on the same tree. Nothing is known of its origin in regard to the Bezeria. Many authors believe that it is a graft hybrid. Galizio, on the other hand, thinks that it is an ordinary hybrid, with the habit of partially reverting by buds to the two parent forms, and we have seen that the species in this genus often cross spontaneously. It is notorious that when the variegated jessamine is budded on the common kind, the stalk sometimes produces buds bearing variegated leaves. Mr. Rivers, as he informs me, has seen instances of this. The same thing occurs with the oleander. 1. 2. Mr. Rivers, on the authority of a trustworthy friend, states that some buds of a golden variegated ash, which were inserted into common ashes, all died, except one, but the ash stalks were affected. 103, and produced both above and below the points of insertion of the plates of bark, bearing the dead buds shoots, which bore variegated leaves. Mr. J. Anderson Henry has communicated to me a nearly similar case. Mr. Brown of Perth observed many years ago in a Highland glen. An ash tree, with yellow leaves and buds taken from this tree, were inserted into common ashes, which in consequence were affected, and produced the blotched Breadalbane ash. This variety has been propagated and has preserved its character during the last 50 years. Weeping ashes also were budded on the affected stalks, and became similarly variegated. It has been repeatedly proved that several species of abutilon, on which the variegated Thompsonia has been grafted, become variegated. 104. Many authors consider variegation as the result of disease, and the foregoing cases may be looked at as the direct result of the inoculation of a disease or some weakness. This has been almost proved to be the case by Morin in the excellent paper just referred to, who shows that even a leaf inserted by its footstalk into the bark of the stalk is sufficient to communicate variegation to it. Though the leaf soon perishes, even fully formed leaves on the stalk of abutilon are sometimes affected by the graft and become variegated. Variegation is much influenced, as we shall hereafter see, by the nature of the soil in which the plants are grown, and it does not seem improbable that whatever change in the sap or tissues certain soils induce, whether or not called a disease, might spread from the inserted piece of bark to the stalk. But a change of this kind cannot be considered to be of the nature of a graft hybrid. There is a variety of the hazel, with dark purple leaves like those of the copperbeech. No one has attributed this color to disease, and it apparently is only an exaggeration of a tint, which may often be seen on the leaves of the common hazel. When this variety is grafted on the common hazel 105, it sometimes colors, as has been asserted, the leaves below the graft. Although negative evidence is not of much value, I may add that Mr. Rivers, who has possessed hundreds of such grafted trees, has never seen an instance. Gartner 106 quotes two separate accounts of branches of dark and white-fruited vines, which had been united in various ways, such as being split longitudinally, and then joined, etc., and these branches produced distinct bunches of grapes of the two colors, and other bunches with berries either striped or of an intermediate and new tint. Even the leaves in one case were variegated. These facts are the more remarkable because Andrew Knight never succeeded in raising variegated grapes by fertilizing white kinds by pollen of dark kinds, though, as we have seen, he obtained seedlings with variegated fruits and leaves by fertilizing a white variety by the already variegated dark Aleppo grape. Gartner attributes the above-quoted cases merely to bud variation, but it is a strange coincidence that the branches which had been grafted in a peculiar manner should alone thus have varied, and H. Adorn de T. positively asserts that he produced the described result more than once, and could do so at will by splitting and uniting the branches in the manner described by him. I should not have quoted the following case had not the author of Des Jacynths 107 impressed me with the belief not only of his extensive knowledge, but of his truthfulness. He says that bulbs of blue and red hyacinths may be cut in two, and that they will grow together and throw up a united stem. And this I have myself seen with flowers of the two colors on the opposite sides. But the remarkable point is that flowers are sometimes produced with the two colors blended together, which makes the case closely analogous with that of the blended colors of the grapes on the united vine branches. In the case of roses, it is supposed that several graft hybrids have been formed, but there is much doubt about these cases owing to the frequency of ordinary bud variations. The most trustworthy instance known to me is one recorded by Mr. Pointer 108, who assures me in a letter of the entire accuracy of the statement Rosa devoniensis had been budded some years previously on a white Banksian rose, and from the much enlarged point of junction, whence the devoniensis and Banksian still continued to grow, a third branch issued, which was neither pure Banksian nor pure devoniensis, but partook of the character of both. The flowers resembled, but were superior in character to those of the variety called Lamarck, one of the noisettes, while the shoots were similar in their manner of growth to those of the Banksian rose, with the exception that the longer and more robust shoots were furnished with prickles. This rose was exhibited before the Floral Committee of the Horticultural Society of London. Dr. Lindley examined it, and concluded that it had certainly been produced by the mingling of R. banksii with some rose like R. devoniensis, for while it was very greatly increased in vigor and in size of all the parts, the leaves were halfway between a Banksian and tea-scented rose. It appears that rose growers were previously aware that the Banksian rose sometimes affects other roses, as Mr. Pointer's new variety is intermediate in its fruit and foliage between the stalk and scion, and as it arose from the point of junction between the two, it is very improbable that it owes its origin to mere bud variation, independently of the mutual influence of the stalk and scion. Lastly, with respect to potatoes, Mr. R. Traill stated in 1867 before the Botanical Society of Edinburgh, and has since given me fuller information that several years ago he cut about 60 blue and white potatoes into halves through the eyes or buds, and then carefully joined them, destroying at the same time the other eyes. Some of these united tubers produced white and others blue tubers. Some, however, produced tubers partly white and partly blue, and the tubers from about 4 or 5 were regularly mottled with the two colors. In these latter cases, we may conclude that a stem had been formed by the union of the bisected buds, that is, by graft hybridization. In the Botanische Zeitung, May 16, 1868, Professor Hildebrand gives an account with a colored figure of his experiments on two varieties, which were found during the same season to be constant in character, namely, a somewhat elongated rough-skinned red potato, and a rounded smooth white one. He inserted buds reciprocally into both kinds, destroying the other buds. He thus raised two plants, and each of these produced a tuber intermediate in character between the two parent forms, that from the red bud grafted into the white tuber was at one end red and rough, as the whole tuber ought to have been. If not affected in the middle, it was smooth with red stripes, and at the other end, smooth and altogether white like that of the stalk. Mr. Taylor, who had received several accounts of potatoes having been grafted by wedge-shaped pieces of one variety, inserted into another, though skeptical on the subject, made 24 experiments, which he described in detail before the Horticultural Society 109. He thus raised many new varieties, some like the graft, or like the stalk, others having an intermediate character. Several persons witnessed the digging up of the tubers from these graft hybrids, and one of them, Mr. Jameson, a large dealer in potatoes, writes, "Thus they were such a mixed lot as I have never before or since seen. They were of all colors and shapes, some very ugly, and some very handsome." Another witness says, "Some were round, some kidney pink-eyed, kidney, piebald and mottled red, and purple, of all shapes and sizes. Some of these varieties have been found valuable, and have been extensively propagated." Mr. Jameson took away a large piebald potato which he cut into 5 sets, and propagated. These yielded round, white, red, and piebald potatoes. Mr. Fitzpatrick followed a different plan. 110 he grafted together not the tubers, but the young stems of varieties producing black, white, and red potatoes. The tubers borne by 3 of these twin or united plants were colored in an extraordinary manner. One was almost exactly half black and half white, so that some persons on seeing it thought that 2 potatoes had been divided and rejoined. Other tubers were half red and half white, or curiously mottled with red and white, or with red and black, according to the colors of the graft and stalk. The testimony of Mr. Fenn is of much value, as he is a well-known potato grower who has raised many new varieties by crossing different kinds in the ordinary manner. He considers it demonstrated that new intermediate varieties can be produced by grafting the tubers, though he doubts whether such will prove valuable. 111. He made many trials, and laid the results exhibiting specimens before the Horticultural Society. Not only were the tubers affected, some being smooth and white at one end, and rough and red at the other, but the stems and leaves were modified in their manner of growth, color, and precocity. Some of these graft hybrids, after being propagated for 3 years, still showed in their haulms their new character, different from that of the kind from which the eyes had been taken. Mr. Fenn gave 12 of the tubers of the 3rd generation to Mr. Alex Dean, who grew them, and was thus converted into a believer in graft hybridization. Having previously been a complete skeptic for comparison, he planted the pure parent forms alongside the 12 tubers, and found that many of the plants from the latter 112 were intermediate between the 2 parent forms in precocity, in the tallness, uprightness, jointing, and robustness of the stems, and in the size and color of the leaves. Another experimentalist, Mr. Rintoul, grafted no less than 59 tubers, which differed in shape, some being kidneys in smoothness and color. 113, and many of the plants thus raised were intermediate in the tubers, as well as in the haulms. He describes the more striking cases. In 1871, I received a letter from Mr. Merrick of Boston, USA, who states that Mr. Fearing Burr, a very careful experimenter and author of a much valued book, The Garden Vegetables of America, has succeeded in producing distinctly mottled and most curious potatoes, evidently graft hybrids, by inserting eyes from blue or red potatoes into the substance of white ones. After removing the eyes of the latter, I have seen the potatoes, and they are very curious. We will now turn to the experiments made in Germany, since the publication of Prof. Hildebrand's paper Herr Magnus relates 114 the results of numerous trials made by Herrenreuter and Lindemuth, both attached to the Royal Gardens of Berlin. They inserted the eyes of red potatoes into white ones and vice versa, many different forms partaking of the characters of the inserted bud and of the stalk were thus obtained. For instance, some of the tubers were white with red eyes. Herr Magnus also exhibited in the following year before the same Society Nov 1872 the produce of grafts between black-white and red potatoes made by Dr. Neubert. These were made by uniting not the tubers, but the young stems, as was done by Mr. Fitzpatrick. The result was remarkable, inasmuch as all the tubers thus produced were intermediate in character, though in a variable degree. Those between the black and the white or the red were the most striking in appearance. Some from between the white and red had one half of one color and the other half of the other color. At the next meeting of the Society, Herr Magnus communicated the results of Dr. Hyman's experiments in grafting together the tubers of red Saxon blue and elongated white potatoes. The eyes were removed by a cylindrical instrument and inserted into corresponding holes in other varieties. The plants thus produced yielded a great number of tubers, which were intermediate between the two parent forms in shape and in the color, both of the flesh and skin. Herrenreuter experimented 115 by inserting wedges of the elongated white Mexican potato into a black kidney potato. Both sorts are known to be very constant and differ much not only in form and color, but in the eyes of the black kidney being deeply sunk, whereas those of the white Mexican are superficial and of a different shape. The tubers produced by these hybrids were intermediate in color and form, and some which resembled in form the graft Roman 1e, the Mexican had eyes deeply sunk, and of the same shape as in the stalk or black kidney. Anyone who will attentively consider the abstract, now given of the experiments made by many observers in several countries, will I think be convinced that by grafting two varieties of the potato together in various ways, hybridized plants can be produced. It should be observed that several of the experimentalists are scientific horticulturists, and some of them potato growers on a large scale, who though beforehand skeptical have been fully convinced of the possibility, even of the ease of making graft hybrids. The only way of escaping from this conclusion is to attribute all the many recorded cases to simple bud variation. Undoubtedly, the potato, as we have seen in this chapter, does sometimes, though not often, vary by buds, but it should be especially noted that it is experienced potato growers, whose business it is to look out for new varieties, who have expressed unbounded astonishment at the number of new forms produced by graft hybridization. It may be argued that it is merely the operation of grafting, and not the union of two kinds, which causes so extraordinary an amount of bud variation. But this objection is at once answered by the fact that potatoes are habitually propagated by the tubers being cut into pieces, and the sole difference in the case of graft hybrids is that either a half or a smaller segment or a cylinder is placed in close opposition with the tissue of another variety. Moreover, in two cases the young stems were grafted together, and the plants thus united yielded the same results as when the tubers were united. It is an argument of the greatest weight that when varieties are produced by simple bud variation, they frequently present quite new characters, whereas, in all the numerous cases above given, as Herr Magnus likewise insists the graft hybrids are intermediate in character between the two forms employed, that such a result should follow if the one kind did not affect the other is incredible. Characters of all kinds are affected by graft hybridization. In whatever way the grafting may have been affected, the plants thus raised yield tubers, which partake of the widely different colors, form, state of surface position, and shape of the eye of the parents, and according to two careful observers, they are also intermediate in certain constitutional peculiarities. But we should bear in mind that in all the varieties of the potato, the tubers differ much more than any other part. The potato affords the best evidence of the possibility of the formation of graft hybrids, but we must not overlook the account given of the origin of the famous Cytisus Adami by Roman 1000 Adam, who had no conceivable motive for deception, and the exactly parallel account of the origin of the Bezeria, orange, namely by graft hybridization, Nor must the cases be undervalued in which different varieties or species of vines, hyacinths and roses, have been grafted together and have yielded intermediate forms. It is evident that graft hybrids can be made much more easily with some plants, as the potato, than with others. For instance, our common fruit trees, for these latter, have been grafted by the million during many centuries. And though the graft is often slightly affected, it is very doubtful whether this may not be accounted for merely by a more or less free supply of nutriment. Nevertheless, the cases above given seem to me to prove that under certain unknown conditions graft hybridization can be effected. Herr Magnus asserts with much truth that graft hybrids resemble in all respects seminal hybrids, including their great diversity of character. There is, however, a partial exception inasmuch as the characters of the two parent forms are not often homogeneously blended together in graft hybrids. They much more commonly appear in a segregated condition that is in segments either at first or subsequently through reversion. It would seem that the reproductive elements are not so completely blended by grafting as by sexual generation, but segregation of this kind occurs by no means rarely, as will be immediately shown in seminal hybrids. Finally, it must, I think, be admitted that we learn from the foregoing cases a highly important physiological fact, namely that the elements that go to the production of a new being are not necessarily formed by the male and female organs. They are present in the cellular tissue, in such a state that they can unite without the aid of the sexual organs, and thus give rise to a new bud, partaking of the characters of the two parent forms. On the segregation of the parental characters in seminal hybrids by bud variation, I will now give a sufficient number of cases to show that segregation of this kind, namely by buds, may occur in ordinary hybrids raised from seed. Hybrids were raised by Gartner between Tropilum minus and Magus 116, which at first produced flowers intermediate in size, color, and structure between their two parents. But later in the season, some of these plants produced flowers in all respects like those of the mother form, mingled with flowers, still retaining the usual intermediate condition, a hybrid Sirius between Roman 100 Speciosissimus and Philanthus 117 plants, which are widely different in appearance, produced for the first 3 years angular five-sided stems, and then some flat stems, like those of Roman 100 Philanthus Colruter. Also gives cases of hybrid lobelias and verbascums, which at first produced flowers of one color and later, in the season, flowers of a different color. 118 Nauden 119, raised 40 hybrids from Datura elvis, fertilized by Roman 500 Stramonium, and 3 of these hybrids produced many capsules, of which a half or quarter or lesser segment was smooth, and of small size like the capsule of the pure Roman 500 elvis, the remaining part being spinos, and of larger size like the capsule of the pure Roman 500 Stramonium. From one of these composite capsules, plants perfectly resembling both parent forms were raised. Turning now to varieties, a seedling apple conjectured to be of crossed parentage has been described in France 120, which bears fruit with one half larger than the other, of a red color, acid taste, and peculiar odor, the other side being greenish-yellow, and very sweet. It is said scarcely ever to include perfectly developed seed. I suppose that this is not the same tree as that which Godeshow 121 exhibited before the French Institute, bearing on the same branch 2 distinct kinds of apples, one a Rionette rouge, and the other like a Rionette Canada. Jonator, this double-bearing variety, can be propagated by grafts and continues to produce both kinds. Its origin is unknown. The Rev. J. Roman 500 Latouche sent me a colored drawing of an apple which he brought from Canada, of which half surrounding, and including the whole of the calyx, and the insertion of the footstalk, is green, the other half being brown, and of the nature of the palm gris apple, with the line of separation between the two halves exactly defined. The tree was a grafted one, and Mr. Latouche thinks that the branches which bore this curious apple sprung from the point of junction of the graft and stalk. Had this fact been ascertained, the case would probably have come into the class of graft hybrids already given, but the branch may have sprung from the stalk, which no doubt was a seedling. Prof. H. Lecoq, who has made a great number of crossings between the differently colored varieties of mirabilis, Jalapa 122, finds that in the seedlings the colors rarely combine but form distinct stripes, or half the flower is of one color and half of a different color. Some varieties regularly bear flowers striped with yellow, white, and red, but plants of such varieties occasionally produce on the same root branches, with uniformly colored flowers of all three tints, and other branches with half-and-half colored flowers, and others with marbled flowers, Galizio 123, crossed reciprocally white and red carnations, and the seedlings were striped. But some of the striped plants also bore entirely white and entirely red flowers. Some of these plants produced 1 year red flowers alone, and in the following year striped flowers, or conversely some plants, after having borne for 2 or 3 years striped flowers, would revert and bear exclusively red flowers. It may be worth mentioning that I fertilized the purple Sweetbia Lathyrus odoratus with pollen from the light-colored, painted lady seedlings raised from the same pod, were not intermediate in character, but perfectly resembled either parent later. In the summer the plants which had at first borne flowers identical with those of the painted lady produced flowers streaked and blotched with purple showing in these darker, marks a tendency to reversion to the mother variety, Andrew Knight 124. Fertilized 2 white grapes with pollen of the Aleppo grape, which is darkly variegated both in its leaves and fruit. The result was that the young seedlings were not at first variegated, but all became variegated during the succeeding summer. Besides this, many produced on the same plant bunches of grapes, which were all black or all white or lead-colored, striped with white or white, dotted with minute black stripes, and grapes of all these shades could frequently be found on the same footstock. I will append a very curious case, not of bud variation, but of 2 cohering embryos different in character, and contained within the same seed. A distinguished botanist, Mr. G. H. Thwaites, states that a seed from Fuchsia coccinea fertilized by F. fulgens contained 2 embryos, and was a true vegetable twin. The 2 plants produced from the 2 embryos were extremely different in appearance and character, though both resembled other hybrids of the same parentage, produced at the same time. These twin plants were closely coherent below the 2 pairs of cotyledon leaves into a single cylindrical stem, so that they had subsequently the appearance of being branches on one trunk. Had the 2 united stems grown up to their full height, instead of dying a curiously mixed hybrid, would have been produced a mongrel melon described by Sadgerat 126 may perhaps have thus originated, for the 2 main branches, which arose from 2 cotyledon buds, produced very different fruitin, the one branch like that of the paternal variety, and on the other branch, like to a certain extent that of the maternal variety, the melon of China. In most of these cases of crossed varieties, and in some of the cases of cross species, the colors proper to both parents appeared in the seedlings as soon as they first flowered in the form of stripes or larger segments, or as whole flowers or fruit of different kinds borne on the same plant, and in this case, the appearance of the 2 colors cannot strictly be said to be due to reversion, but to some incapacity of fusion, when however the later flowers or fruit produced during the same season, or during a succeeding year or generation, become striped or half-and-half, etc., the segregation of the 2 colors is strictly a case of reversion. By bud variation, whether all the many recorded cases of striped flowers and fruit are due to previous hybridization and reversion, is by no means clear. For instance, with peaches and nectarines, moss roses, etc., in a future chapter, one shall show that with animals of crossed parentage, the same individual has been known to change its character during growth and to revert to one of its parents, which it did not at first resemble. Finally, from the various facts now given, there can be no doubt that the same individual plant, whether a hybrid or a mongrel, sometimes returns in its leaves, flowers, and fruit, either wholly or by segments, to both parent forms. On the direct or immediate action of the male element on the mother form, another remarkable class of facts must be here considered. Firstly, because they have a high physiological importance, and secondly, because they have been supposed to account for some cases of bud variation. I refer to the direct action of the male element, not in the ordinary way on the ovules, but on certain parts of the female plant, or in case of animals on the subsequent progeny of the female, by a second male. I may premise that with plants, the ovarium and the coats of the ovules are obviously parts of the female, and it could not have been anticipated that they would have been affected by the pollen of a foreign variety or species, although the development of the embryo inside the embryonic sac inside the ovule and ovarium, of course, depends on the male element. Even as long ago as 1729, it was observed 127 that white and blue varieties of the pea, when planted near each other, mutually crossed, no doubt through the agency of bees, and in the autumn blue and white peas were found within the same pods. Weigmann made an exactly similar observation in the present century. The same result has followed several times, when a variety with peas of one color has been artificially crossed by differently colored variety 128. These statements led Gartner, who was highly skeptical on the subject, carefully to try a long series of experiments. He selected the most constant varieties, and the result conclusively showed that the color of the skin of the pea is modified when pollen of a differently colored variety is used. This conclusion has since been confirmed by experiments made by the Rev. J. Roman 1000 Berkeley 129. Mr. Laxton of Stamford, whilst making experiments on peas for the express purpose of ascertaining the influence of foreign pollen on the mother plant, has recently 130 observed an important additional fact. He fertilized the tall sugar pea, which bears very thin green pods becoming brownish-white when dry with pollen of the purple-podded pea, which as its name expresses has dark purple pods with very thick skin, becoming pale reddish-purple when dry. Mr. Laxton has cultivated the tall sugar pea during 20 years and has never seen or heard of it producing a purple pod. Nevertheless, a flower fertilized by pollen from the purplipod yielded a pod clouded with purplishard, which Mr. Laxton kindly gave to me a space of about 2 inches in length towards the extremity of the pod and a smaller space near the stalk, were thus colored on comparing the color with that of the purple pod, both pods having been first dried and then soaked in water. It was found to be identically the same, and in both the color was confined to the cells lying immediately beneath the outer skin of the pod. The valves of the crossed pod were also decidedly thicker and stronger than those of the pods of the mother plant. But this may possibly have been an accidental circumstance, for I know not how far their thickness is of variable character in the tall sugar pea. The peas of the tall sugar pea, when dry, are pale greenish-brown, thickly covered with dots of dark purple, so minute as to be visible only through a lens, and Mr. Laxton has never seen or heard of this variety producing a purple pea. But in the crossed pod, one of the peas was of a uniform beautiful violet-purple tint, and a second was irregularly clouded with pale purple. The color lies in the outer of the 2 coats which surround the pea, as the peas of the purple-podded variety when dry are of a pale greenish buff. It would at first appear that this remarkable change of color in the peas in the crossed pod could not have been caused by the direct action of the pollen of the purplipod. But when we bear in mind that this latter variety has purple flowers, purple marks on its stipules and purple pods, and that the tall sugar pea likewise has purple flowers and stipules and microscopically minute purple dots on the peas, we can hardly doubt that the tendency to the production of purple in both parents has in combination modified the color of the peas in the crossed pod. After having examined these specimens, I crossed the same 2 varieties and the peas in one pod, but not the pods themselves were clouded and tinted with purplishard in a much more conspicuous manner than the peas in the uncrossed pods produced at the same time by the same plants. I may notice as a caution that Mr. Laxton sent me various other crossed peas slightly or even greatly modified in color, but the change in these cases was due, as had been suspected by Mr. Laxton, to the altered color of the cotyledons seen through the transparent coats of the peas. And as the cotyledons are parts of the embryo, these cases are not in any way remarkable. Turning now to the genus Matthiola, the pollen of one kind of stalk sometimes affects the color of the seeds of another kind. Used as the mother plant, I give the following case the more readily, as Gartner doubted similar statements previously made with respect to the stalk by other observers. A well-known horticulturist, Major Trevor Clark, informs me 131 that the seeds of the large red-flowered biennial stalk Matthiola, Noix of the French, are light brown, and those of the purple-branching queen stalk Roman 1000 Incana are violet-black, and he found that when flowers of the red stalk were fertilized by pollen from the purple stalk, they yielded about 50% of black seeds. He sent me 4 pods from a red-flowered plant, 2 of which had been fertilized by their own pollen, and they included pale brown seed, and 2 which had been crossed by pollen from the purple kind, and they included seeds all deeply tinged with black. These latter seeds yielded purple-flowered plants like their father, whilst the pale brown seeds yielded normal red-flowered plants. And Major Clark, by sowing similar seeds, has observed on a greater scale the same result. The evidence in this case of the direct action of the pollen of one species on the color of the seeds of another species appears to me conclusive. Galizio 132 fertilized the flowers of an orange with pollen from the lemon, and one fruit, thus produced, bore a longitudinal stripe of peel, having the color, flavor, and other characters of the lemon. Mr. Anderson 133 fertilized a green-fleshed melon with pollen from a scarlet-fleshed kind in 2 of the fruits. A sensible change was perceptible, and 4 other fruits were somewhat altered both internally and externally. The seeds of the 2 first-mentioned fruits produced plants, partaking of the good properties of both parents in the United States where cucurbitaceae are largely cultivated. It is the popular belief 134 that the fruit is thus directly affected high foreign pollen, and I have received a similar statement with respect to the cucumber in England. It is believed that grapes have been thus affected in color, size, and shape in France. A pale-colored grape had its juice tinted by the pollen of the dark-colored Tainterier in Germany. A variety bore berries, which were affected by the pollen of 2 adjoining kinds, some of the berries being only partially affected, or mottled 135. As long ago as 1,751,136, it was observed that when differently colored varieties of maize grew near each other, they mutually affected each other's seeds, and this is now a popular belief in the United States. Dr. Savvy 137 tried the experiment with care. He sowed yellow and black-seeded maize together, and on the same ear some of the seeds were yellow, some black, and some mottled, the differently colored seeds being arranged irregularly, or in rows. Prof. Hildebrand has repeated the experiment 138, with the precaution of ascertaining that the motherplant was true. A kind bearing yellow grains was fertilized with pollen of a kind having brown grains, and 2 ears produced yellow grains, mingled with others of a dirty violet tint. A third ear had only yellow grains, but one side of the spindle was tinted of a reddish-brown, so that here we have the important fact of the influence of the foreign pollen, extending to the axis. Mr. Arnold in Canada varied the experiment in an interesting manner. A female flower was subjected first to the action of pollen from a yellow variety, and then to that from a white variety. The result was an ear, each grain of which was yellow below and white above. 139. With other plants it has occasionally been observed that the crossed offspring showed the influence of 2 kinds of pollen, but in this case, the 2 kinds affected the mother plant. Mr. Sabine states 140 that he has seen the form of the nearly globular seed capsule of Amaryllis vittata altered by the application of the pollen of another species, of which the capsule has gibbous angles, with an allied genus. A well-known botanist, Maximovich, has described in detail the striking results of reciprocally fertilizing Lilium bulbiferum and Davuricum with each other's pollen. Each species produced fruit not like its own, but almost identical with that of the pollen-bearing species. But from an accident, only the fruit of the latter species was carefully examined. The seeds were intermediate in the development of their wings. 141. Fritz Muller fertilized Cattleya leopoldi with pollen of Epidendron cinnabarinum, and the capsules contained very few seeds, but these presented a most wonderful appearance, which from the description given 2 botanists Hildebrand and Maximovich attribute to the direct action of the pollen of the epidendron. 142. Mr. J. Anderson Henry 143 crossed Rhododendron dalhousii with the pollen of R. nuttallii, which is one of the largest flowered and noblest species of the genus. The largest pod produced by the former species, when fertilized with its own pollen, measured 114 inches in length and 112 in girth, whilst 3 of the pods which had been fertilized by pollen of R. nuttallii measured 158 inches in length and no less than 2 inches in girth. Here the effect of the foreign pollen was apparently confined to increasing the size of the ovarium, but we must be cautious in assuming, as the following case shows, that size had been transferred from the male parent to the capsule of the female plant. Mr. Henry fertilized Arabis blepharophila with pollen of a soyery, and the pods thus produced, of which he was so kind as to send me detailed measurements and sketches, were much larger in all their dimensions than those naturally produced by either the male or female parent species. In a future chapter, we shall see that the organs of vegetation in hybrid plants, independently of the character of either parent, are sometimes developed to a monstrous size, and the increased size of the pods in the foregoing cases may be an analogous fact. On the other hand, Roman 1000 de Saporta informs me that an isolated female plant of Pistacia vera is very apt to be fertilized by the pollen of neighboring plants of P. terebinthus, and in this case, the fruits are only half their proper size, which he attributes to the influence of the pollen of P. terebinthus. No case of the direct action of the pollen of one variety on another is better authenticated or more remarkable than that of the common apple. The fruit here consists of the lower part of the calyx, and of the upper part of the flower peduncle 144 in a metamorphosed condition, so that the effect of the foreign pollen has extended even beyond the limits of the ovarium. Cases of apples thus affected were recorded by Bradley in the early part of the last century, and other cases are given in old volumes of the Philosophical Transactions 145. In one of these, a russetting apple and an adjoining kind mutually affected each other's fruit, and in another case, a smooth apple affected a rough-coated kind. Another instance has been given 146 of two very different apple trees growing close to each other which bore fruit resembling each other, but only on the adjoining branches. It is, however, almost superfluous to adduce these or other cases after that of the St. Valery apple. The flowers which from the abortion of the stamens do not produce pollen, but are fertilized by the girls of the neighborhood with pollen of many kinds, and they bear fruit differing from one another in size, flavor, and color, but resembling in character the hermaphrodite kinds, by which they have been fertilized. 147. I have now shown on the authority of several excellent observers, in the case of plants belonging to widely different orders, that the pollen of one species or variety, when applied to the female of a distinct form, occasionally causes the coats of the seeds, the ovarium or fruit, including even the calyx and upper part of the peduncle of the apple, and the axis of the ear in maize to be modified. Sometimes the whole ovarium, or all the seeds, are thus affected, sometimes only a certain number of the seeds, as in the case of the pea, or only a part of the ovarium, as with the striped orange mottled grapes and maize, is thus affected. It must not be supposed that any direct or immediate effect invariably follows the use of foreign pollen. This is far from being the case, nor is it known on what conditions the result depends. Mr. Knight 148 expressly states that he has never seen the fruit thus affected, though he crossed thousands of apple and other fruit trees. There is not the least reason to believe that a branch which has borne seed or fruit directly modified by foreign pollen is itself affected so as afterwards to produce modified buds. Such an occurrence from the temporary connection of the flower with the stem would be hardly possible hence, but very few, if any, of the cases of bud variation in the fruit of trees given in the early part of this chapter can be accounted for by the action of foreign pollen, for such fruits have commonly been propagated by budding or grafting. It is also obvious that changes of color in flowers, which necessarily supervene long before they are ready for fertilization, and changes in the shape or color of leaves, when due to the appearance of modified buds, can have no relation to the action of foreign pollen. The proofs of the action of foreign pollen on the mother plant have been given in considerable detail, because this action, as we shall see in a future chapter, is of the highest theoretical importance, and because it is in itself a remarkable and apparently anomalous circumstance. That it is remarkable under a physiological point of view is clear, for the male element not only affects in accordance with its proper function the germ, but at the same time various parts of the mother plant in the same manner, as it affects the same part in the seminal offspring from the same two parents. We thus learn that an ovule is not indispensable for the reception of the influence of the male element, but this direct action of the male element is not so anomalous as it at first appears, for it comes into play in the ordinary fertilization of many flowers. Gartner gradually increased the number of pollen grains until he succeeded in fertilizing a malva, and has 149 proved that many grains are first expended in the development, or as he expresses it, in the satiation of the pistil and ovarium. Again, when one plant is fertilized by a widely distinct species, it often happens that the ovarium is fully and quickly developed without any seeds being formed, or the coats of the seeds are formed without any embryo being developed within. Prof. Hildebrand also has lately shown 150 that in the normal fertilization of several orchid the action of the plant's own pollen is necessary for the development of the ovarium, and that this development takes place not only long before the pollentubes have reached the ovules, but even before the placent and ovules have been formed, so that with these orchids, the pollen acts directly on the ovarium. On the other hand, we must not overrate the efficacy of pollen in the case of hybridized plants, for an embryo may be formed, and its influence excite the surrounding tissues of the mother plant, and then perish at a very early age, and be thus overlooked again. It is well known that with many plants the ovarium may be fully developed, though pollen be wholly excluded. Lastly, Mr. Smith, the late curator at Kew, as I hear through Dr. Hooker, observed with an orchid, the Benatia speciosa, the singular fact that the development of the ovarium could be affected by the mechanical irritation of the stigma, nevertheless, from the number of the pollen grains expended in the satiation of the ovarium, and pistil from the generality of the formation of the ovarium, and seed coats in hybridized plants, which produce no seedsend from Dr. Hildebrand's observations on orchids, we may admit that in most cases the swelling of the ovarium and the formation of the seed coats are at least aided, if not wholly caused, by the direct action of the pollen, independently of the intervention of the fertilized germ. Therefore, in the previously given cases, we have only to believe in the further power of pollen, when applied to a distinct species or variety, to influence the shape, size, color, texture, etc., of certain parts of the mother plant. Turning now to the animal kingdom, if we could imagine the same flower to yield seeds during successive years, then it would not be very surprising that a flower of which the ovarium had been modified by foreign pollen should next year produce, when self-fertilized offspring, modified by the previous male influence. Closely analogous cases have actually occurred with animals. In the case, often quoted from Lord Morton 151, a nearly pure-hybrid Arabian chestnut mare bore a hybrid to a quagga. She was subsequently sent to Sir Gore Auseli and produced 2 colts by a black Arabian horse. These colts were partially dun-colored and were striped on the legs more plainly than the real hybrid, or even than the quagga. One of the 2 colts had its neck and some other parts of its body plainly marked with stripes. Stripes on the body, not to mention those on the legs, are extremely rare. I speak after having long attended to the subject with horses of all kinds in Europe, and are almost unknown in the case of Arabians. But what makes the case still more striking is that in these colts, the hair of the mane resembled that of the quagga, being short, stiff, and upright. Hence, there can be no doubt that the quagga affected the character of the offspring subsequently begot by the black Arabian horse. Mr. Jenner Weir informs me of a strictly parallel case. His neighbor Mr. Lethbridge of Blackheath has a horse bred by Lord Mostyn, which had previously borne a foal by a quagga. This horse is done with a dark stripe down the back, faint stripes on the forehead, between the eyes, plain stripes on the inner side of the forelegs, and rather more faint ones on the hind legs, with no shoulder stripe. The mane grows much lower on the forehead than in the horse, but not so low as in the quagga or zebra. The hoofs are proportionally longer than in the horse, so much so that the farrier who first shod this animal, and knew nothing of its origin, said, "Had I not seen I was shoeing a horse, I should have thought I was shoeing a donkey." With respect to the varieties of our domesticated animals, many similar and well-authenticated facts have been published 152, and others have been communicated to me, plainly showing the influence of the first male on the progeny, subsequently borne by the mother to other males. It will suffice to give a single instance recorded in the Philosophical Transactions, in a paper following, that by Lord Morton Mr. Giles put a sow of Lord Western's black and white Essex breed to a wild boar of a deep chestnut color, and the pigs produced partook in appearance of both boar and sow, but in some the chestnut color of the boar strongly prevailed. After the boar had long been dead, the sow was put to a boar of her own black and white breed, a kind which is well known to breed very true, and never to show any chestnut coloriate. From this union, the sow produced some young pigs, which were plainly marked with the same chestnut tint, as in the first litter. Similar cases have so frequently occurred that careful breeders avoid putting a choice female of any animal to an inferior male on account of the injury to her subsequent progeny, which may be expected to follow. Some physiologists have attempted to account for these remarkable results from a previous impregnation by the imagination of the mother having been strongly affected, but it will hereafter be seen that there are very slight grounds for any such belief. Other physiologists attribute the result to the close attachment and freely intercommunicating blood vessels between the modified embryo and mother, but the analogy from the action of foreign pollen on the ovarium, seed coats, and other parts of the mother plant strongly supports the belief that with animals the male element acts directly on the female, and not through the crossed embryo. With birds there is no close connection between the embryo and mother, yet a careful observer, Dr. Chapuis, states 153, that with pigeons the influence of a first male sometimes makes itself perceived in the succeeding broods, but this statement requires confirmation. Conclusion and summary of the chapter. The facts given in the latter half of this chapter are well worthy of consideration, as they show us in how many extraordinary modes the union of one form with another may lead to the modification of the seminal offspring, or of the buds afterwards produced. There is nothing surprising in the offspring of species or varieties crossed in the ordinary manner being modified, But the case of two plants within the same seed, which cohere and differ from each other, is curious. When a bud is formed after the cellular tissue of two species or two varieties have been united, and it partakes of the characters of both parents, the case is wonderful, but I need not here repeat what has been so lately said on this subject. We have also seen that, in the case of plants, the male element may affect in a direct manner the tissues of the mother, and with animals may lead to the modification of her future progeny in the vegetable kingdom. The offspring from a cross between two species or varieties, whether affected by seminal generation or by grafting, often revert to a greater or less degree in the first or in a succeeding generation to the two parent forms, and this reversion may affect the whole flower, fruit, or leaf bud, or only the half or a smaller segment of a single organ in some cases. However, such segregation of character apparently depends on an incapacity for union, rather than on reversion for the flowers or fruit, which are first produced display by segments the characters of both parents. The various facts here given ought to be well considered by anyone who wishes to embrace under a single point of view the many modes of reproduction, by gemation division, and sexual union, the reparation of lost parts variation inheritance reversion, and other such phenomena. Towards the close of the second volume, one shall attempt to connect these facts together by the hypothesis of pangenesis. In the early half of the present chapter, one have given a long list of plants in which, through bud variation that is independently of reproduction by seed, the fruit has suddenly become modified in size, color, flavor, hairiness, shape, and time of maturity. Flowers have similarly changed in shape, color, in being double, and greatly in the character of the calyx. Young branches or shoots have changed in color, bearing spines, and in habit of growth, as in climbing or in weeping. Leaves have changed in becoming variegated in shape, period of unfolding, and in their arrangement on the axis. Buds of all kinds, whether produced on ordinary branches or on subterranean stems, whether simple or much modified and supplied with a stock of nutriment, as in tubers and bulbs, are all liable to sudden variations of the same general nature. In the list, many of the cases are certainly due to reversion to characters not acquired from a cross, but which were formerly present, and have since been lost for a longer or shorter time. As when a bud on a variegated plant produces plain leaves, or when the variously colored flowers of the chrysanthemum revert to the aboriginal yellow tint. Many other cases included in the list are probably due to the plants being of crossed parentage, and to the buds reverting either completely or by segments to one of the two parent forms. 154. We may suspect that the strong tendency in the chrysanthemum to produce by bud variation differently colored flowers results from the varieties having been at some time intentionally or accidentally crossed, and this is certainly the case with some kinds of pelargonium, so it may be to a large extent with the bud varieties of the dahlia, and with the broken colors of tulips. When, however, a plant reverts by bud variation to its two parent forms, or to one of them, it sometimes does not revert perfectly, but assumes a somewhat new character, of which fact instances have been given, and Carrière gives 155 another in the cherry. Many cases of bud variation, however, cannot be attributed to reversion, but to so-called spontaneous variability, as is so common with cultivated plants raised from seed, as a single variety of the chrysanthemum has produced by buds 6 other varieties, and as one variety of the gooseberry has borne at the same time 4 distinct kinds of fruit. It is scarcely possible to believe that all these variations are due to reversion. We can hardly believe, as remarked in a previous chapter, that all the many peaches which have yielded nectarine buds are of crossed parentage. Lastly, in such cases as that of the moss rose, with its peculiar calyx, and of the rose which bears opposite leaves, in that of the amatophyllum, etc., there is no known natural species or variety from which the characters in question could have been derived by a cross. We must attribute all such cases to the appearance of absolutely new characters in the buds. The varieties which have thus arisen cannot be distinguished by any external character from seedlings. This is notoriously the case with the varieties of the rose azalea and many other plants. It deserves notice that all the plants which have yielded bud variations have likewise varied greatly by seed. The plants which have varied by buds belong to so many orders that we may infer that almost every plant would be liable to variation if placed under the proper exciting conditions. These conditions, as far as we can judge, mainly depend on long-continued and high cultivation, for almost all the plants in the foregoing list are perennials, and have been largely propagated in many soils under different climates by cuttings, offsets, bulbs, tubers, and especially by budding or grafting. The instances of annuals varying by buds or producing on the same plant differently colored flowers are comparatively rare. Hopkirk 156 has seen this with convolvulus tricolor, and it is not uncommon with the balsam and annual delphinium. According to Sir R. Schomburg, plants from the warmer temperate regions, when cultivated under the hot climate of St. Domingo, are eminently liable to bud variation. I am informed by Mr. Sedgwick that moss roses which have often been taken to Calcutta always there lose their mossiness. But change of climate is by no means a necessary contingent, as we see with the gooseberry currant, and in many other cases plants living under their natural conditions are very rarely subject to bud variation. Variegated leaves have however been observed under such circumstances, and I have given an instance of variation by buds on an ash tree planted in ornamental grounds. But it is doubtful whether such a tree can be considered as living under strictly natural conditions. Gartner has seen white and dark red flowers produced from the same root of the wild Achillea millefolium, and Prof. Caspary has seen a completely wild Viola lutea bearing flowers of 2 different colors and sizes 157. As wild plants are so rarely liable to bud variation, whilst highly cultivated plants long propagated by artificial means have yielded many varieties by this form of reproduction, we are led through a series, such as the following, namely all the eyes in the same tuber of the potato varying in the same manner, all the fruit on a purple plum tree suddenly becoming yellow, all the fruit on a double-flowered almond suddenly becoming peach, like all the buds on grafted trees being in a very slight degree affected by the stalk on which they have been worked, all the flowers on a transplanted heartsease changing for a time in color, size, and shape, are led by such a series to look at every case of bud variation as the direct result of the conditions of life, to which the plant has been exposed. On the other hand, plants of the same variety may be cultivated in 2 adjoining beds, apparently under exactly the same conditions, and those in the one bed, as Carriere insists 158, will produce many bud variations, and those in the other not a single one. Again, if we look to such cases as that of a peach tree which, after having been cultivated by tens of thousands during many years in many countries, and after having annually produced millions of buds, all of which have apparently been exposed to precisely the same conditions, yet at last suddenly produces a single bud with its whole character greatly transformed, we are driven to the conclusion that the transformation stands in no direct relation to the conditions of life. We have seen that varieties produced from seeds and from buds resemble each other so closely in general appearance that they cannot be distinguished, just as certain species and groups of species, when propagated by seed, are more variable than other species or genera. So it is in the case of certain bud varieties. Thus the Queen of England chrysanthemum has produced by this latter process no less than 6, and Rollison's unique Pelargonium 4 distinct varieties. Moss roses have also produced several other moss roses. The roseae have varied by buds more than any other group of plants, but this may be in large part due to so many members having been long cultivated. But within this same group, the peach has often varied by buds, whilst the apple and pear, both grafted trees extensively cultivated, have afforded, as far as I can ascertain, extremely few instances of bud variation. The law of analogous variation holds good with varieties produced by buds, as with those produced from seed. More than one kind of rose has sported into a moss rose, more than one kind of camellia has assumed an hexagonal form, and at least 7 or 8 varieties of the peach have produced nectarines. The laws of inheritance seem to be nearly the same with seminal and bud varieties. We know how commonly reversion comes into play with both, and it may affect the whole or only segments of a leaf, flower, or fruit. When the tendency to reversion affects many buds on the same tree, it becomes covered with different kinds of leaves, flowers, or fruit. But there is reason to believe that such fluctuating varieties have generally arisen from seed. It is well known that out of a number of seedling varieties, some transmit their character much more truly by seed than others. So with bud varieties, some retain their character by successive buds more truly than others, of which instances have been given with 2 kinds of variegated euonymus, and with certain kinds of tulips and pelargoniums. Notwithstanding the sudden production of bud varieties, the characters thus acquired are sometimes capable of transmission by seminal reproduction. Mr. Rivers has found that moss roses generally reproduce themselves by seed, and the mossy character has been transferred by crossing from one species of rose to another, the Boston nectarine, which appeared as a bud variation produced by seed. Closely allied nectarine, on the other hand, seedlings from some bud variations, have proved variable to an extreme degree. 159. We have also heard, on the authority of Mr. Salter, that seeds taken from a branch with leaves variegated through bud variation transmit this character very feebly, whilst many plants which were variegated as seedlings transmit variegation to a large proportion of their progeny. Although I have been able to collect a good many cases of bud variation as shown in the previous lists, and might probably by searching foreign horticultural works have collected very many more cases, yet their total number is as nothing in comparison with that of seminal varieties, with seedlings raised from the more variable cultivated plants. The variations are almost infinitely numerous, but their differences are generally slight only at long intervals of time. A strongly marked modification appears. On the other hand, it is a singular and inexplicable fact that when plants vary by buds, the variations, though they occur with comparative rarity, are often or even generally strongly pronounced. It struck me that this might perhaps be a delusion, and that slight changes often occurred in buds, but were overlooked or not recorded from being of no value. Accordingly, I applied to two great authorities on this subject, namely to Mr. Rivers with respect to fruit trees, and to Mr. Salter with respect to flowers. Mr. Rivers is doubtful, but does not remember having noticed very slight variations in fruit buds. Mr. Salter informs me that with flowers such do occur, but if propagated they generally lose their new character in the following year, yet he concurs with me that bud variations usually at once assume a decided and permanent character. We can hardly doubt that this is the rule when we reflect on such cases as that of the peach, which has been so carefully observed, and of which such trifling seminal varieties have been propagated. Yet this tree has repeatedly produced by bud variation nectarines, and only twice, as far as I can learn, any other variety, namely the early and late Gros Mignon peaches, and these differ from the parent tree in hardly any character, except the period of maturity. To my surprise, I hear from Mr. Salter that he brings the principle of selection to bear on variegated plants propagated by buds, and has thus greatly improved and fixed several varieties. He informs me that at first, a branch often produces variegated leaves on one side alone, and that the leaves are marked only with an irregular edging, or with a few lines of white and yellow. To improve and fix such varieties, he finds it necessary to encourage the buds at the bases of the most distinctly marked leaves, and to propagate from them alone. By following with perseverance this plan, during 3 or 4 successive seasons, a distinct and fixed variety can generally be secured. Finally, the facts given in this chapter prove in how close and remarkable a manner the germ of a fertilized seed and the small cellular mass forming a bud resemble each other in all their functions, in their power of inheritance with occasional reversion, and in their capacity for variation of the same general nature in obedience to the same laws. This resemblance, or rather identity of character, is shown in the most striking manner by the fact that the cellular tissue of one species or variety, when budded or grafted on another, may give rise to a bud having an intermediate character. We have seen that variability does not depend on sexual generation, though much more frequently it's concomitant than of bud reproduction. We have seen that bud variability is not solely dependent on reversion or atavism to long-lost characters, or to those formerly acquired from a cross, but appears often to be spontaneous. But when we ask ourselves, what is the cause of any particular bud variation, we are lost in doubt, being driven in some cases to look to the direct action of the external conditions of life as sufficient, and in other cases, to feel a profound conviction that these have played a quite subordinate part of not more importance than the nature of the spark, which ignites a mass of combustible matter. References: Chapter Roman 12, Inheritance. Wonderful nature of inheritance. Pedigrees of our domesticated animals. Inheritance, not due to chance. Trifling characters. Inherite diseases. Inherite peculiarities in the eye. Inherite diseases in the horse. Longevity and vigor. Asymmetrical deviations of structure. Polydactylism and regrowth of supernumerary digits after amputation. Cases of several children similarly affected from non-affected parents. Weak and fluctuating inheritance in weeping trees, in dwarfness. Color of fruit and flowers. Color of horse. Inheritance in certain cases. Inheritance of structure and habits overborne by hostile conditions of life, by incessantly recurring variability, and by reversion conclusion. The subject of inheritance is an immense one, and has been treated by many authors. One work alone, De l'Hérédité naturelle, by Dr. Prosper Lucas, runs to the length of 1562 pages. We must confine ourselves to certain points, which have an important bearing on the general subject of variation, both with domestic and natural productions. It is obvious that a variation which is not inherited throws no light on the derivation of species nor is of any service to man, except in the case of perennial plants, which can be propagated by buds. If animals and plants had never been domesticated, and wild ones alone had been observed, we should probably never have heard the saying that like begets like. The proposition would have been as self-evident as that all the buds on the same tree are alike, though neither proposition is strictly true. For as has often been remarked, probably no two individuals are identically the same. All wild animals recognize each other, which shows that there is some difference between them. And when the eye is well practiced, the shepherd knows. Each sheep and man can distinguish a fellowman out of millions on millions of other men. Some authors have gone so far as to maintain that the production of slight differences is as much a necessary function of the powers of generation as the production of offspring like their parents. This view, as we shall see in a future chapter, is not theoretically probable, though practically it holds good. The saying that like begets like has in fact arisen from the perfect confidence felt by breeders that a superior or inferior animal will generally reproduce its kind. But this very superiority or inferiority shows that the individual in question has departed slightly from its type. The whole subject of inheritance is wonderful. When a new character arises, whatever its nature may be, it generally tends to be inherited, at least in a temporary, and sometimes in a most persistent manner. What can be more wonderful than that some trifling peculiarity, not primordially attached to the species, should be transmitted through the male or female sexual cells, which are so minute as not to be visible to the naked eye, and afterwards through the incessant changes of a long course of development, undergone either in the womb or in the egg, and ultimately appear in the offspring, when mature or even when quite old, as in the case of certain diseases. Or again, what can be more wonderful than the well-ascertained fact that the minute ovule of a good milking cow will produce a male, from whom a cell in union with an ovule will produce a female, and she when mature will have large mammary glands yielding an abundant supply of milk, and even milk of a particular quality. Nevertheless, the real subject of surprise is, as Sir H. Holland has well remarked, one, not that a character should be inherited, but that any should ever fail to be inherited. In a future chapter, devoted to an hypothesis which I have termed pangenesis, an attempt will be made to show the means by which characters of all kinds are transmitted from generation to generation. Some writers, too, who have not attended to natural history, have attempted to show that the force of inheritance has been much exaggerated. The breeders of animals would smile at such simplicity, and if they condescended to make any answer, might ask what would be the chance of winning a prize if two inferior animals were paired together. They might ask whether the half-old Arabs were led by theoretical notions to keep pedigrees of their horses. Why have pedigrees been scrupulously kept and published of the shorthorn cattle, and more recently of the Hereford breed? Is it an illusion that these recently improved animals safely transmit their excellent qualities, even when crossed with other breeds? Have the shorthorns, without good reason, been purchased at immense prices and exported to almost every quarter of the globe? 1,000 guineas having been given for a bull with greyhounds, pedigrees have likewise been kept, and the names of such dogs as Snowball, Major, etc., are as well known to coursers as those of Eclipse and Herod on the turf. Even with the gamecock, pedigrees of famous strains were formerly kept and extended back for a century. With pigs, the Yorkshire and Cumberland breeders preserve and print pedigrees. And to show how such hybrid animals are valued, I may mention that Mr. Brown, who won all the first prizes for small breeds at Birmingham in 1850, sold a young sow and boar of his breed to Lord Ducie for 43 guineas. The sow alone was afterwards sold to the Rev. F. Thursby for 65 guineas, who writes, "She paid me very well, having sold her produce for £300, and having now 4 breeding sows from her 3 hard cash paid down over and over again, is an excellent test of inherited superiority. In fact, the whole art of breeding, from which such great results have been attained during the present century, depends on the inheritance of each small detail of structure. But inheritance is not certain, for if it were the breeder's art, 4 would be reduced to a certainty, and there would be little scope left for that wonderful skill and perseverance shown by the men who have left an enduring monument of their success in the present state of our domesticated animals. It is hardly possible within a moderate compass to impress on the mind of those who have not attended to the subject the full conviction of the force of inheritance, which is slowly acquired by rearing animals, by studying the many treatises which have been published on the various domestic animals, and by conversing with breeders. I will select a few facts of the kind, which as far as I can judge have most influenced my own mind. With man and the domestic animals, certain peculiarities have appeared in an individual at rare intervals, or only once or twice in the history of the world, but have reappeared in several of the children and grandchildren. Thus Lambert the porcupineman, whose skin was thickly covered with warty projections which were periodically molted, had all his 6 children and 2 grandsons similarly affected, 5 the face and body being covered with long hair, accompanied by deficient teeth, to which I shall hereafter refer, occurred in 3 successive generations in a Siamese family. But this case is not unique, as a woman 6, with a completely hairy face, who was exhibited in London in 1663, and another instance has recently occurred. Colonel Hallam 7 has described a race of two-legged pigs, the hinder extremities being entirely wanting, and this deficiency was transmitted through 3 generations. In fact, all races presenting any remarkable peculiarity, such as solid-hoofed swine, Mauchamp sheep, Niota cattle, etc., are instances of the long-continued inheritance of rare deviations of structure. When we reflect that certain extraordinary peculiarities have thus appeared in a single individual out of many millions, all exposed in the same country to the same general conditions of life, and again, that the same extraordinary peculiarity has sometimes appeared in individuals living under widely different conditions of life, we are driven to conclude that such peculiarities are not directly due to the action of the surrounding conditions, but to unknown laws acting on the organization or constitution of the individual, that their production stands in hardly closer relation to the conditions of life than does life itself. If this be so, and the occurrence of the same unusual character in the child and parent cannot be attributed to both having been exposed to the same unusual conditions, then the following problem is worth consideration, as showing that the result cannot be due, as some authors have supposed, to mere coincidence, but must be consequent on the members of the same family inheriting something in common in their constitution. Let it be assumed that in a large population, a particular affection occurs on an average in 1 out of a million, so that the a priori chance that an individual taken at random will be so affected is only 1 in a million. Let the population consist of 60 millions composed, we will assume, of 10 million families, each containing 6 members. On these data, Professor Stokes has calculated for me that the odds will be no less than 33 millions to 1 that in the 10 million families there will not be even a single family in which 1 parent and 2 children will be affected by the peculiarity in question, but numerous instances could be given in which several children have been affected by the same rare peculiarity with one of their parents, and in this case, more especially if the grandchildren be included in the calculation, the odds against mere coincidence become something prodigious, almost beyond enumeration. In some respects, the evidence of inheritance is more striking when we consider the reappearance of trifling peculiarities. Dr. Hodgkin formerly told me of an English family in which for many generations some members had a single lock differently colored from the rest of the hair. I knew an Irish gentleman who, on the right side of his head, had a small white lock in the midst of his dark hair. He assured me that his grandmother had a similar lock on the same side, and his mother on the opposite side. But it is superfluous to give instances. Every shade of expression, which may often be seen alike in parents and children, tells the same story on what a curious combination of corporeal structure, mental character, and training handwriting depends. Yet everyone must have noted occasional close similarity of the handwriting in father and son, although the father had not taught his son, a great collector of autographs, assured me that in his collection there were several signatures of father and son, hardly distinguishable, except by their dates. Hofecker in Germany remarks on the inheritance of handwriting, and it has even been asserted that English boys, when taught to write in France, naturally cling to their English manner of writing. But for so extraordinary a statement more evidence is requisite. 8 gait, gestures, voice, and general bearing are all inherited, as the illustrious Hunter and Sir A. Carlyle have insisted. 9 My father communicated to me some striking instances in one of which a man died during the early infancy of his son, and my father, who did not see this son until grown up and out of health, declared that it seemed to him as if his old friend had risen from the grave, with all his highly peculiar habits, and peculiar manners, pass into tricks, and several instances could be given of their inheritance, as in the case often quoted of the father who generally slept on his back with his right leg crossed over the left, and whose daughter, whilst an infant in the cradle, followed exactly the same habit, though an attempt was made to cure her. 10. I will give one instance which has fallen under my own observation, and which is curious from being a trick, associated with a peculiar state of mind, namely pleasurable emotion. A boy had the singular habit, when pleased, of rapidly moving his fingers parallel to each other, and when much excited of raising both hands with the fingers still moving to the sides of his face, on a level with the eyes. When this boy was almost an old man, he could still hardly resist this trick, when much pleased, but from its absurdity concealed it. He had 8 children. Of these a girl, when pleased at the age of 4½ years, moved her fingers in exactly the same way. And what is still odder, when much excited, she raised both her hands with her fingers still moving to the sides of her face, in exactly the same manner as her father had done, and sometimes even still continued to do so. When alone, I never heard of anyone excepting this one man, and his little daughter, who had this strange habit, and certainly imitation was in this instance out of the question. Some writers have doubted whether those complex mental attributes, on which genius and talent depend, are inherited even when both parents are thus endowed. But he who will study Mr. Galton's able work on hereditary genius will have its doubts allayed. Unfortunately, it matters not as far as inheritance is concerned how injurious a quality or structure may be if compatible with life. No one can read the many treatises 11 on hereditary disease and doubt this. The ancients were strongly of this opinion, or as Ranchin expresses it, omnes grci Arabs, et Latini, in eo consentiunt. A long catalogue could be given of all sorts of inherited malformations, and of predisposition to various diseases. With gout, 50% of the cases observed in hospital practice are, according to Dr. Garrod, inherited, and a greater percentage in private practice. Everyone knows how often insanity runs in families, and some of the cases given by Mr. Sedgwick are ofulas of a surgeon whose brother father and 4 paternal uncles were all insane, the latter dying by suicide, of a Jew whose father, mother, and 6 brothers and sisters were all mad, and in some other cases, several members of the same family during 3 or 4 successive generations have committed suicide. Striking instances have been recorded of epilepsy, consumption, asthma, stone in the bladder, cancer, profuse bleeding from the slightest injuries of the mother not giving milk, and of bad parturition being inherited. In this latter respect, I may mention an odd case given by a good observer 12, in which the fault lay in the offspring, and not in the mother. In a part of Yorkshire, the farmers continued to select cattle with large hindquarters until they made a strain called Dutch buttock, and the monstrous size of the buttocks of the calf was frequently fatal to the cow, and numbers of cows were annually lost in calving. Instead of giving numerous details on various inherited malformations and diseases, I will confine myself to one organ, that which is the most complex, delicate, and probably best known in the human frame, namely the eye with its accessory parts. 13. To begin with the latter, I have received an account of a family in which one parent and the children are affected by drooping eyelids in so peculiar a manner that they cannot see without throwing their heads backwards. Mr. Wade of Wakefield has given me an analogous case of a man who had not his eyelids thus affected at birth, nor owed their state as far as was known to inheritance, but they began to droop whilst he was an infant after suffering from fits, and he has transmitted the affection to 2 out of his 3 children, as was evident in the photographs of the whole family sent to me, together with this account. Sir A. Carlyle 14 specifies a pendulous fold to the eyelids as inherited in a family, says Sir H. Holland 15, where the father had a singular elongation of the upper eyelid. 7 or 8 children were born with the same deformity, 2 or 3 other children having it. Not many persons, as I hear from Sir J. Paget, have 2 or 3 hairs in their eyebrows much longer than the others, and even so trifling a peculiarity as this certainly runs in families. With respect to the eye itself, the highest authority in England, Mr. Bowman, has been so kind as to give me the following remarks on certain inherited imperfections. First, hypermetropia, or morbidly long sight. In this affection, the organ, instead of being spherical, is too flat from front to back, and is often altogether too small, so that the retina is brought too forward for the focus of the humors. Consequently, a convex glass is required for clear vision of near objects, and frequently even of distant ones. This state occurs congenitally, or at a very early age, often in several children of the same family, where one of the parents has presented it. 16. Secondly, myopia, or short-sight, in which the eye is egg-shaped and too long from front to back. The retina in this case lies behind the focus, and is therefore fitted to see distinctly only very near objects. This condition is not commonly congenital, but comes on in youth, the liability to it being well known to be transmissible from parent to child. The change from the spherical to the ovoidal shape seems the immediate consequence of something like inflammation of the coats, under which they yield, and there is ground for believing that it may often originate in causes acting on the individual affected. 17. And may thenceforward become transmissible when both parents are myopic. Mr. Bowman has observed the hereditary tendency in this direction to be heightened, and some of the children to be myopic at an earlier age or in a higher degree than their parents. Thirdly, squinting is a familiar example of hereditary transmission. It is frequently a result of such optical defects as have been above mentioned, but the more primary and uncomplicated forms of it are also sometimes in a marked degree transmitted in a family. Fourthly, cataract, or opacity of the crystalline lens, is commonly observed in persons whose parents have been similarly affected, and often at an earlier age in the children than in the parents. Occasionally more than one child in a family is thus afflicted, one of whose parents or other relations presents the senile form of the complaint. When cataract affects several members of a family in the same generation, it is often seen to commence at about the same age in each. For example, in one family, several infants or young persons may suffer from it; in another, several persons of middle age. Mr. Bowman also informs me that he has occasionally seen in several members of the same family various defects in either the right or left eye, and Mr. White Cooper has often seen peculiarities of vision confined to one eye reappearing in the same eye in the offspring. 18. The following cases are taken from an able paper by Mr. W. Sedgwick and from Dr. Prosper Lucas. 19. Amaurosis, either congenital or coming on late in life, and causing total blindness, is often inherited. It has been observed in 3 successive generations. Congenital absence of the iris has likewise been transmitted for 3 generations, a clefteris for 4 generations, being limited in this latter case to the males of the family. Opacity of the cornea and congenital smallness of the eyes have been inherited. Portal records a curious case in which a father and 2 sons were rendered blind whenever the head was bent downwards, apparently owing to the crystalline lens, with its capsule slipping through an unusually large pupil into the anterior chamber of the eye. Dayblindness, or imperfect vision under a bright light, is inherited, as is nightblindness, or an incapacity to see except under a strong light. A case has been recorded by Roman 1000 Cunier of this latter defect having affected 8 of 5 members of the same family during 6 generations. The singular incapacity of distinguishing colors, which has been called daltonism, is notoriously hereditary and has been traced through 5 generations, in which it was confined to the female sex. With respect to the color of the iris, deficiency of coloring matter is well known to be hereditary in albinos, the iris of one eye being of different color from that of the other, and the iris being spotted, are cases which have been inherited. Mr. Sedgwick gives, in addition, on the authority of Dr. Osborne 20, the following curious instance of strong inheritance. A family of 16 sons and 5 daughters all had eyes resembling in miniature the markings on the back of a tortoiseshell cat. The mother of this large family had 3 sisters and a brother, all similarly marked, and they derived this peculiarity from their mother, who belonged to a family notorious for transmitting it to their posterity. Finally, Dr. Lucas emphatically remarks that there is not one single faculty of the eye which is not subject to anomalies, and not one which is not subjected to the principle of inheritance. Mr. Bowman agrees with the general truth of this proposition, which, of course, does not imply that all malformations are necessarily inherited. This would not even follow if both parents were affected by an anomaly, which in most cases was transmissible. Even if no single fact had been known with respect to the inheritance of disease and malformations by man, the evidence would have been ample in the case of the horse, and this might have been expected, as horses breed much quicker than man, are matched with care, and are highly valued. I have consulted many works, and the unanimity of the belief by veterinaries of all nations in the transmission of various morbid tendencies, is surprising. Authors who have had wide experience give in detail many singular cases and assert that contracted feet with the numerous contingent evils of ringbones, curbs, splint, spavin, founder, and weakness of the front legs roaring or broken, and thick-wind melanosis specific, ophthalmia and blindness. The great French veterinary Huzard going so far as to say that a blind race could soon be formed, cribbiting, jibbing, and ill temper, are all plainly hereditary. Youatt sums up by saying there is scarcely a malady to which the horse is subject, which is not hereditary, and Roman 1000 Bernard adds that the doctrine that there is scarcely a disease which does not run in the stock is gaining new advocates every day. 21. So it is in regard to cattle with consumption, good and bad teeth, fine skin, etc., etc. But enough and more than enough has been said on disease. Andrew Knight, from his own experience, asserts that disease is hereditary with plants, and this assertion is endorsed by Lindley. 22. Seeing how hereditary evil qualities are, it is fortunate that good health, vigor, and longevity are equally inherited. It was formerly a well-known practice, when annuities were purchased to be received during the lifetime of a nominee, to search out a person belonging to a family of which many members had lived to extreme old age. As to the inheritance of vigor and endurance, the English racehorse offers an excellent instance. Eclipse begot 334, and King Herod 497 winners. A cocktail is a horse not purely bred, but with only 1/8 or 1/16 impure blood in his veins, yet very few instances have ever occurred of such horses having won a great race. They are sometimes as fleet for short distances as thoroughbreds, but as Mr. Robson, the great trainer, asserts, they are deficient in wind and cannot keep up the pace. Mr. Lawrence also remarks perhaps no instance has ever occurred of a three-part bred horse saving his distance in running 2 miles with thoroughbred racers. It has been stated by Cecil that when unknown horses whose parents were not celebrated have unexpectedly won great races, as in the case of Priam, they can always be proved to be descended on both sides, through many generations, from first-rate ancestors. On the continent, Baron Cameron challenges, in a German veterinary periodical, the opponents of the English racehorse to name one good horse on the continent which has not some English raceblood in his veins. 23. With respect to the transmission of the many slight but infinitely diversified characters by which the domestic races of animals and plants are distinguished, nothing need be said, for the very existence of persistent races proclaims the power of inheritance. A few special cases, however, deserve some consideration. It might have been anticipated that deviations from the law of symmetry would not have been inherited, but Anderson 24 states that a rabbit produced in a litter a young animal having only one ear, and from this animal a breed was formed, which steadily produced one-eared rabbits. He also mentions a bitch with a single leg deficient, and she produced several puppies with the same deficiency from Hofecker's account. 25. It appears that a one-horned stag was seen in 1781 in a forest in Germany in 1788 too, and afterwards from year to year, many were observed with only one horn on the right side of the head. A cow lost a horn by suppuration. 26, and she produced 3 calves which had on the same side of the head, instead of a horn, a small bony lump, attached merely to the skin. But we here encroach on the subject of inherited mutilations. A man who is left-handed, and a shell in which the spire turns in the wrong directions, are departures from the normal asymmetrical condition, and they are well known to be inherited. Polydactylism, supernumerary fingers and toes, are eminently liable, as various authors have insisted, to be inherited. Polydactylism graduates. 27, by multifarious steps, from a mere cutaneous appendage, not including any bone, to a double hand, but an additional digit supported on a metacarpal bone and furnished with all the proper muscles, nerves, and vessels, is sometimes so perfect that it escapes detection, unless the fingers are actually counted. Occasionally, there are several supernumerary digits, but usually only one making the total number 6. This one may be attached to the inner or outer margin of the hand, representing either a thumb or little finger, the latter being the more frequent generally, through the law of correlation. Both hands and both feet are similarly affected. Dr. Bert Wilder has tabulated 28 a large number of cases, and finds that supernumerary digits are more common on the hands than on the feet, and that men are affected oftener than women. Both these facts can be explained on 2 principles, which seem generally to hold good. Firstly, That of two parts the more specialized one is the more variable, and the arm is more highly specialized than the leg, and secondly that male animals are more variable than females. The presence of a greater number of digits than 5 is a great anomaly for this number, is not normally exceeded by any existing mammal bird or reptile. Nevertheless, supernumerary digits are strongly inherited. They have been transmitted through 5 generations, and in some cases after disappearing for 1, 2, or even 3 generations, have reappeared through reversion. These facts are rendered, as Professor Huxley has observed, more remarkable from its being known in most cases that the affected person has not married one similarly affected. In such cases, the child of the 5th generation would have only 132nd part of the blood of his first sedigitated ancestor. Other cases are rendered remarkable by the affection-gathering force, as Dr. Struthers has shown, in each generation. Though in each the affected person married one not affected, moreover such additional digits are often amputated soon after birth and can seldom have been strengthened by use. Dr. Struthers gives the following instance: in the 1st generation, an additional digit appeared on one hand, in the 2nd on both hands, in the 3rd 3 brothers had both hands, and one of the brothers a foot affected. And in the 4th generation, all 4 limbs were affected. Yet we must not overestimate the force of inheritance. Dr. Struthers asserts that cases of non-inheritance and of the first appearance of additional digits in unaffected families are much more frequent than cases of inheritance. Many other deviations of structure of a nature, almost as anomalous as supernumerary digits, such as deficient phalanges, 29 thickened joints, crooked fingers, etc., are in like manner strongly inherited, and are equally subject to intermission together with reversion, though in such cases there is no reason to suppose that both parents had been similarly affected. 30. Additional digits have been observed in Negroes as well as in other races of man, and in several of the lower animals, and have been inherited. 6 toes have been described on the hind feet of the newt Salamandra cristata, and are said to have occurred with the frog. It deserves notice that the 6-toed newt, though adult, preserved some of its larval characters, for part of the hiatal apparatus which is properly absorbed during the act of metamorphosis was retained. It is also remarkable that in the case of man, various structures in an embryonic or arrested state of development, such as a cleft palate, bifid uterus, etc., are often accompanied by polydactylism. 31 6 toes on the hinder feet are known to have been inherited for 3 generations of cats. In several breeds of the fowl, the hinder toe is double, and is generally transmitted truly, as is well shown when Dorkings are crossed with common 4-toed breeds. 32. With animals which have properly less than 5 digits, the number is sometimes increased to 5, especially on the front legs, though rarely carried beyond that number. But this is due to the development of a digit already existing in a more or less rudimentary state. Thus the dog has properly 4 toes behind, but in the larger breeds, a 5th toe is commonly, though not perfectly developed horses, which properly have 1 toe alone fully developed, with rudiments of the others, have been described with each foot bearing 2 or 3 small separate hoofs. Analogous facts have been noticed with cows, sheep, goats, and pigs. 33. There is a famous case described by Mr. White of a child 3 years old with a thumb double from the first joint. He removed the lesser thumb, which was furnished with a nail, but to his astonishment it grew again, and reproduced a nail. The child was then taken to an eminent London surgeon, and the newly grown thumb was removed by its socket joint, but again it grew and reproduced a nail. Dr. Struthers mentions a case of the partial regrowth of an additional thumb, amputated, when a child was 3 months old, and the late Dr. Falconer communicated to me an analogous instance in the last edition of this work. I also gave a case of the regrowth of a supernumerary little finger after amputation, but having been informed by Dr. Bachmeier that several eminent surgeons expressed at a meeting of the Anthropological Society of Munich great doubt about my statements, I have made more particular inquiries. The full information thus gained, together with a tracing of the hand in its present state, has been laid before Sir J. Paget, and he has come to the conclusion that the degree of regrowth in this case is not greater than sometimes occurs with normal bones, especially with the humerus when amputated at an early age. He further does not feel fully satisfied about the facts recorded by Mr. White. This being so, it is necessary for me to withdraw the view, which I formerly advanced with much hesitation, chiefly on the ground of the supposed regrowth of additional digits, namely, that their occasional development in man is a case of reversion to a lowly organized progenitor, provided with more than 5 digits. I may here allude to a class of facts closely allied to, but somewhat different from ordinary cases of inheritance. Sir H. Holland, 34, states that brothers and sisters of the same family are frequently affected, often at about the same age, by the same peculiar disease not known to have previously occurred in the family. He specifies the occurrence of diabetes in 3 brothers under 10 years old. He also remarks that children of the same family often exhibit in common infantile diseases the same peculiar symptoms my father mentioned to me. The case of 4 brothers who died between the ages of 60 and 70, in the same highly peculiar comatose state and instance, has already been given of supernumerary digits, appearing in 4 children out of 6, in a previously unaffected family. Dr. Devey states 35 that 2 brothers married 2 sisters, their first cousins, none of the 4 nor any relation being an albino, but the 7 children produced from this double marriage were all perfect albinos. Some of these cases, as Mr. Sedgwick 36 has shown, are probably the result of reversion to a remote ancestor of whom no record had been preserved, and all these cases are so far directly connected with inheritance that no doubt the children inherited a similar constitution from their parents, and from being exposed to nearly similar conditions of life, it is not surprising that they should be affected in the same manner, and at the same period of life. Most of the facts hitherto given have served to illustrate the force of inheritance, but we must now consider cases, grouped as well as the subject allows into classes, showing how feeble, capricious, or deficient the power of inheritance sometimes is when a new peculiarity first appears. We can never predict whether it will be inherited. If both parents from their birth present the same peculiarity, the probability is strong that it will be transmitted to at least some of their offspring. We have seen that variegation is transmitted much more feebly by seed taken from a branch which had become variegated through bud variation than from plants which were variegated as seedlings. With most plants, the power of transmission notoriously depends on some innate capacity in the individual. Thus Vilmorin 37 raised from a peculiarly colored balsam some seedlings which all resembled their parent, but of these seedlings some failed to transmit the new character, whilst others transmitted it to all their descendants during several successive generations. So again, with a variety of the rose, 2 plants alone out of 6 were found by Vilmorin to be capable of transmitting the desired character. Numerous analogous cases could be given. The weeping or pendulous growth of trees is strongly inherited in some cases, and without any assignable reason feebly in other cases. I have selected this character as an instance of capricious inheritance, because it is certainly not proper to the parent species, and because both sexes being born on the same tree, both tend to transmit the same character, even supposing that there may have been in some instances crossing with adjoining trees of the same species. It is not probable that all the seedlings would have been thus affected. At Macha's court, there is a famous weeping oak. Many of its branches are 30 feet long, and no thicker in any part of this length than a common rope. This tree transmits its weeping character in a greater or less degree to all its seedlings, some of the young oaks being so flexible that they have to be supported by props, others not showing the weeping tendency till about 20 years old. 38. Mr. Rivers fertilized, as he informs me, the flowers of a new Belgian weeping thorn, Cracus oxyacantha, with pollen from a crimson knot-weeping variety, and 3 young trees, now 6 or 7 years old, show a decided tendency to be pendulous, but as yet are not so much so as the mother plant. According to Mr. MacNab, 39 seedlings from a magnificent weeping birch, Bichella alba, in the Botanic Garden at Edinburgh grew, for the first 10-15 years upright, but then all became weepers like their parent. A peach with pendulous branches like those of the weeping willow has been found capable of propagation by seed. 40. Lastly, a weeping, or rather, a prostrate yew, Taxus baccata, was found in a hedge in Shropshire. It was a male, but one branch bore female flowers, and produced berries. These being sown produced 17 trees, all of which had exactly the same peculiar habit with the parent tree. 41. These facts, it might have been thought, would have been sufficient to render it probable that a pendulous habit would in all cases be strictly inherited. But let us look to the other side. Mr. MacNab 42 sowed seeds of the weeping beech, Fagus sylvatica, but succeeded in raising only common beeches. Mr. Rivers, at my request, raised a number of seedlings from 3 distinct varieties of weeping elm, and at least one of the parent trees was so situated that it could not have been crossed by any other elm, but none of the young trees now about a foot or two in height show the least signs of weeping. Mr. Rivers formerly sowed above 20,000 seeds of the weeping ash Fraxinus excelsior, and not a single seedling was in the least degree pendulous in Germany. Roman 1000 Borchmeyer raised 1,000 seedlings with the same result. Nevertheless, Mr. Anderson of the Chelsea Botanic Garden, by sowing seed from a weeping ash, which was found before the year 1780 in Cambridgeshire, raised several pendulous trees. 43 Professor Henslow also informs me that some seedlings from a female weeping ash in the Botanic Garden at Cambridge were at first a little pendulous, but afterwards became quite upright. It is probable that this latter tree, which transmits to a certain extent its pendulous habit, was derived by a bud from the same original Cambridgeshire stock, whilst other weeping ashes may have had a distinct origin, but the crowning case communicated to me by Mr. Rivers, which shows how capricious is the inheritance of a pendulous habit, is that a variety of another species of ash F. lenticifolia, now about 20 years old, which was formerly pendulous, has long lost this habit, every shoot being remarkably erect, but seedlings formerly raised from it were perfectly prostrate, the stems not rising more than 2 inches above the ground. Thus the weeping variety of the common ash, which has been extensively propagated by buds during a long period, did not, with Mr. Rivers, transmit its character to one seedling out of above 20,000, whereas the weeping variety of a second species of ash, which could not whilst grown in the same garden retain its own weeping character, transmitted to its character the pendulous habit in excess. Many analogous facts could be given showing how apparently capricious is the principle of inheritance. All the seedlings from a variety of the Barberry B. vulgaris, with red leaves, inherited the same character. Only about 1/3 of the seedlings of the copper beech Fagus sylvatica had purple leaves. Not one out of 100 seedlings of a variety of the Cerasus patus with yellow fruit bore yellow fruit. 1/12 of the seedlings of the variety of Cornus mascula with yellow fruit came true. 44. And lastly, all the trees raised by my father from a yellow-berried holly Ilex aquifolium found wild produced yellow berries. Vilmorin 45. Observed in a bed of Saponaria calabrica, an extremely dwarf variety, and raised from it a large number of seedlings. Some of these partially resembled their parent, and he selected their seed, but the grandchildren were not in the least dwarfed. On the other hand, he observed a stunted and bushy variety of Tagetes signata growing in the midst of the common varieties, by which it was probably crossed, for most of the seedlings raised from this plant were intermediate in character, only 2 perfectly resembling their parent. But seed saved from these 2 plants reproduced the new variety so truly that hardly any selection has since been necessary. Flowers transmit their color truly, or most capriciously many annuals come true. Thus I purchased German seeds of 34, named subvarieties, of one race of 10-week stalks Matthiola annua, and raised 140 plants, all of which with the exception of a single plant came true. In saying this, however, it must be understood that I could distinguish only 20 kinds out of the 34 named subvarieties, nor did the color of the flower always correspond with the name affixed to the packet. But I say that they came true because in each of the 36 short rows, every plant was absolutely alike, with the one single exception again. I procured packets of German seed of 25 named varieties of common and quilled asters, and raised 124 plants. Of these, all except 10 were true in the above limited sense, and I considered even a wrong shade of color as false. It is a singular circumstance that white varieties generally transmit their color much more truly than any other variety. This fact probably stands in close relation with one observed by Verlot 46, namely, that flowers which are normally white rarely vary into any other color. I have found that the white varieties of Delphinium consolida and of the stock are the truest. It is indeed sufficient to look through a nurseryman's seed list to see the large number of white varieties, which can be propagated by seed. The several colored varieties of the Sweetbia lathyrus odoratus are very true, but I hear from Mr. Masters of Canterbury, who has particularly attended to this plant, that the white variety is the truest. The hyacinth, when propagated by seed, is extremely inconstant in color, but white hyacinths almost always give by seed white-flowered plants. 47, and Mr. Masters informs me that the yellow varieties also reproduce their color, but of different shades. On the other hand, pink and blue varieties, the latter being the natural color, are not nearly so true. Hence, as Mr. Masters has remarked to me, we see that a garden variety may acquire a more permanent habit than a natural species, but it should have been added that this occurs under cultivation, and therefore under changed conditions. With many flowers, especially perennials, nothing can be more fluctuating than the color of the seedlings, as is notoriously the case with verbenas, carnations, dahlias cinerarias, and others 48 isode seed of 12, named varieties of snapdragon Antirrhinum majus, and utter confusion was the result. In most cases, the extremely fluctuating color of seedling plants is probably in chief part due to crosses between differently colored varieties during previous generations. It is almost certain that this is the case with the polyanthus and colored primrose primulaveris and vulgaris from their reciprocally dimorphic structure 49, and these are plants which florists speak of as never coming true by seed, but if care be taken to prevent crossing, neither species is by any means very inconstant in color. Thus I raised 23 plants from a purple primrose, fertilized by Mr. J. Scott with its pollen, and 18 came up purple of different shades, and only 5 reverted to the ordinary yellow color again. I raised 20 plants from a brighted cowslip, similarly treated by Mr. Scott, and every one perfectly resembled its parent in color, as likewise did, with the exception of a single plant, 72 grandchildren. Even with the most variable flowers, it is probable that each delicate shade of color might be permanently fixed, so as to be transmitted by seed by cultivation in the same soil by long-continued selection, and especially by the prevention of crosses. I infer this from certain annual larkspurs, Delphinium consolida and Agassiz, of which common seedlings present a greater diversity of color than any other plant known to me, yet on procuring seed of 5 named German varieties of Roman 500 consolida, only 9 plants out of 94 were false, and the seedlings of 6 varieties of Roman 500 Agassiz were true in the same manner and degree, as with the stocks above described. A distinguished botanist maintains that the annual species of Delphinium are always self-fertilized. Therefore, I may mention that 32 flowers on a branch of Roman 500 consolida, enclosed in a net, yielded 27 capsules, with an average of 172 seed in each, whilst 5 flowers under the same net, which were artificially fertilized in the same manner as must be effected by bees, during their incessant visits, yielded 5 capsules, with an average of 352 fine seed. And this shows that the agency of insects is necessary for the full fertility of this plant. Analogous facts could be given with respect to the crossing of many other flowers, such as carnations, etc., of which the varieties fluctuate much in color. As with flowers, so with our domesticated animals, no character is more variable than color, and probably in no animal more so than with the horse. Yet with a little care in breeding, it appears that races of any color might soon be formed. Hofecker gives the result of matching 216 mares of 4 different colors with like-colored stallions, without regard to the color of their ancestors, and of the 216 colts born, 11 alone failed to inherit the color of their parents. Ottenreith and Ammon assert that after 2 generations colts of a uniform color are produced with certainty. 50. In a few rare cases, peculiarities fail to be inherited apparently from the force of inheritance being too strong. I have been assured by breeders of the canaribird that to get a good jonquil-colored bird, it does not answer to pair 2 jonquils, as the color then comes out too strong or is even brown. But this statement is disputed by other breeders. So again, if 2 crested canaries are paired, the young birds rarely inherit this character. 51. For in crested birds, a narrow space of bare skin is left on the back of the head, where the feathers are upturned to form the crest, and when both parents are thus characterized, the bareness becomes excessive, and the crest itself fails to be developed. Mr. Hewitt, speaking of lace sebright bantams, says 52, that why this should be so I know not, but I am confident that those that are best laced frequently produce offspring very far from perfect in their markings, whilst those exhibited by myself, which have so often proved successful, were bred from the union of heavily laced birds with those that were scarcely sufficiently laced. It is a singular fact that although several deaf mutes often occur in the same family, and though their cousins and other relations are often in the same condition, yet their parents are rarely deaf mutes. To give a single instance, not one scholar, out of 148, who were at the same time in the London institution, was the child of parents similarly affected. So again, when a male or female deaf mute marries a sound person, their children are most rarely affected. In Ireland, out of 203 children, thus produced one alone, was mute even when both parents have been deaf mutes, as in the case of 41 marriages in the United States, and of 6 in Ireland, only 2 deaf and dumb children were produced. Mr. Sedgwick 53, in commenting on this remarkable and fortunate failure in the power of transmission in the direct line, remarks that it may possibly be owing to excess, having reversed the action of some natural law in development, but it is safer in the present state of our knowledge to look at the whole case as simply unintelligible. Although many congenital monstrosities are inherited, of which examples have already been given, and to which may be added the lately recorded case of the transmission, during a century of harelip, with a cleft palate in the writer's own family, 54, yet other malformations are rarely or never inherited. Of these latter cases, many are probably due to injuries in the womb or egg, and would come under the head of non-inherited injuries or mutilations. With plants, a long catalogue of inherited monstrosities of the most serious and diversified nature could easily be given, and with plants, there is no reason to suppose that monstrosities are caused by direct injuries to the seed or embryo. With respect to the inheritance of structures mutilated by injuries or altered by disease, it was until lately difficult to come to any definite conclusion. Some mutilations have been practiced for a vast number of generations, without any inherited result. Godrin remarks 55 that different races of man have from time immemorial knocked out their upper incisors, cut off joints of their fingers, made holes of immense size through the lobes of their ears, or through their nostrils, tattooed themselves, made deep gashes in various parts of their bodies. And there is no reason to suppose that these mutilations have ever been inherited. 56 adhesions, due to inflammation and pits from the smallpox, and formerly many consecutive generations must have been thus pitted, are not inherited. With respect to Jews, I have been assured by 3 medical men of the Jewish faith that circumcision, which has been practiced for so many ages, has produced no inherited effect. Blumenbach, however, asserts, 57, that Jews are often born in Germany in a condition rendering circumcision difficult, so that a name is given them signifying born circumcised, and Professor Prayer informs me that this is the case in Bonn, such children being considered the special favorites of Jehovah. I have also heard from Dr. A. Newman, of Guy's Hospital, of the grandson of a circumcised Jew, the father not having been circumcised in a similar condition. But it is possible that all these cases may be accidental coincidence, for Sir J. Paget has seen 5 sons of a lady, and 1 son of her sister, with adherent prepuces, and one of these boys was affected in a manner which might be considered like that commonly produced by circumcision, yet there was no suspicion of Jewish blood in the family of these 2 sisters. Circumcision is practiced by Mahomedans, but at a much later age than by Jews, and Dr. Riedel, assistant resident in North Celebes, writes to me that the boys there go naked until from 6 to 10 years old, and he has observed that many of them, though not all, have their prepuces much reduced in length, and this he attributes to the inherited effects of the operation. In the vegetable kingdom, oaks and other trees have borne galls from primeval times, yet they do not produce inherited excrescences, and many other such facts could be adduced. Notwithstanding the above several negative cases, we now possess conclusive evidence that the effects of operations are sometimes inherited. Dr. Brown Sequard, 58, gives the following summary of his observations on guinea pigs, and this summary is so important that I will quote the whole. First appearance of epilepsy in animals born of parents having been rendered epileptic by an injury to the spinal cord. Second appearance of epilepsy also in animals born of parents having been rendered epileptic by the section of the sciatic nerve. Third, a change in the shape of the ear in animals born of parents, in which such a change was the effect of a division of the cervical sympathetic nerve. Fourth, partial closure of the eyelids in animals born of parents, in which that state of the eyelids had been caused either by the section of the cervical sympathetic nerve or the removal of the superior cervical ganglion. Fifth, exophthalmia in animals born of parents, in which an injury to the rustiform body had produced that protrusion of the eyeball. This interesting fact I have witnessed a good many times, and I have seen the transmission of the morbid state of the eye continue through 4 generations in these animals modified by heredity. The 2 eyes generally protruded, although in the parents usually only one showed exophthalmia, the lesion having been made in most cases only on one of the corpora rustiformia. Sixth, hematoma and dry gangrene of the ears, in animals born of parents, in which these ear alterations had been caused by an injury to the rustiform body, near the nib of the calamus. Seventh, absence of 2 toes out of the 3 of the hind leg, and sometimes of the 3 in animals, whose parents had eaten up their hind leg toes, which had become anesthetic from a section of the sciatic nerve alone, or of that nerve, and also of the crural sometimes, instead of complete absence of the toes, only a part of 1 or 2 or 3 was missing in the young, although in the parent, not only the toes, but the whole foot was absent, partly eaten off, partly destroyed, by inflammation, ulceration, or gangrene. Eighth, appearance of various morbid states of the skin and hair of the neck and face, in animals born of parents, having had similar alterations in the same parts, as effects of an injury to the sciatic nerve. It should be especially observed that brown sequard has bred during 30 years many thousand guinea pigs from animals which had not been operated upon, and not one of these manifested the epileptic tendency, nor has he ever seen a guinea pig born without toes, which was not the offspring of parents which had gnawed off their own toes owing to the sciatic nerve. Having been divided of this latter fact, 13 instances were carefully recorded, and a greater number were seen, yet brown sequard speaks of such cases as one of the rarer forms of inheritance. It is a still more interesting fact that the sciatic nerve in the congenitally toeless animal has inherited the power of passing through all the different morbid states which have occurred in one of its parents from the time of the division, till after its reunion with the peripheric end. It is not therefore simply the power of performing an action which is inherited, but the power of performing a whole series of actions in a certain order. In most of the cases of inheritance recorded by brown sequard, only one of the 2 parents had been operated upon, and was affected. He concludes by expressing his belief that what is transmitted is the morbid state of the nervous system, due to the operation performed on the parents. With the lower animals, Dr. Prosper Lucas has collected a long list of inherited injuries. A few instances will suffice. A cow lost a horn from an accident with consequent suppuration, and she produced 3 calves which were hornless on the same side of the head with the horse. There seems hardly a doubt that exostoses on the legs caused by too much traveling on hard roads are inherited. Blumenbach records the case of a man who had his little finger on the right hand almost cut off, and which in consequence grew crooked, and his sons had the same finger on the same hand. Similarly crooked, a soldier 15 years before his marriage lost his left eye from purulent ophthalmia, and his 2 sons were microphthalmic on the same side. 59. In all cases in which a parent has had an organ injured on one side, and 2 or more of the offspring are born with the same organ affected on the same side, the chances against mere coincidence are almost infinitely great. Even when only a single child is born having exactly the same part of the body affected as that of his injured parent, the chances against coincidence are great, and Professor Rolleston has given me 2 such cases which have fallen under his own observation, namely of 2 men, one of whom had his knee, and the other his cheek severely cut, and both had children born with exactly the same spot, marked or scarred. Many instances have been recorded of cats, dogs, and horses, which have had their tails, legs, etc. amputated or injured, producing offspring with the same parts ill-formed. But as it is not very rare for similar malformations to appear spontaneously, all such cases may be due to coincidence. It is, however, an argument on the other side that under the old excise laws the shepherdog was only exempt from tax when without a tail, and for this reason it was always removed. 60. And there still exist breeds of the shepherdog which are always born destitute of a tail. Finally, it must be admitted, more especially since the publication of Brown Sequard's observations, that the effects of injuries, especially when followed by disease, or perhaps exclusively when thus followed, are occasionally inherited. 61. Causes of non-inheritance. A large number of cases of non-inheritance are intelligible on the principle that a strong tendency to inheritance does exist, but that it is overborne by hostile or unfavorable conditions of life. No, one would expect that our improved pigs, if forced during several generations to travel about and root in the ground for their own subsistence, would transmit as truly as they now do their short muzzles and legs, and their tendency to fatten dray horses assuredly would not long transmit their great size and massive limbs. If compelled to live on a cold, mountainous region, we have indeed evidence of such deterioration in the horses which have run wild on the Falkland Islands. European dogs in India often fail to transmit their true character. Our sheep in tropical countries lose their wool in a few generations. There seems also to be a close relation between certain peculiar pastures and the inheritance of an enlarged tail in fat-tailed sheep, which form one of the most ancient breeds in the world. With plants, we have seen that tropical varieties of maize lose their proper character in the course of 2 or 3 generations when cultivated in Europe, and conversely, so it is with European varieties cultivated in Brazil. Our cabbages, which here come so true by seed, cannot form heads in hot countries. According to Carriere 62, the purple-leafed beech and barberry transmit their character by seed far less truly in certain districts than in others. Under changed circumstances, periodical habits of life soon fail to be transmitted, as the period of maturity in summer and winter wheat, barley, and vetches. So it is with animals. For instance, a person whose statement, "I can trust," procured eggs of Aylesbury ducks from that town where they are kept in houses and are reared as early as possible for the London market. The ducks bred from these eggs in a distant part of England hatched their first brood on January 24th, whilst common ducks kept in the same yard and treated in the same manner did not hatch till the end of March, and this shows that the period of hatching was inherited. But the grandchildren of these Aylesbury ducks completely lost their habit of early incubation and hatched their eggs at the same time with the common ducks of the same place. Many cases of non-inheritance apparently result from the conditions of life continually inducing fresh variability. We have seen that when the seeds of pears, plums, apples, etc. are sown, the seedlings generally inherit some degree of family likeness. Mingled with these seedlings, a few and sometimes many worthless wild-looking plants commonly appear, and their appearance may be attributed to the principle of reversion. But scarcely a single seedling will be found perfectly to resemble the parent form, and thus may be accounted for by constantly recurring variability induced by the conditions of life. I believe in this, because it has been observed that certain fruit trees truly propagate their kind whilst growing on their own roots, but when grafted on other stalks, and by this process their natural state is manifestly affected, they produce seedlings, which vary greatly departing from the parental type in many characters. 63 Metzger, as stated in the 9th chapter, found that certain kinds of wheat brought from Spain and cultivated in Germany failed during many years to reproduce themselves truly, but at last, when accustomed to their new conditions, they ceased to be variable. That is, they became amenable to the power of inheritance. Nearly all the plants which cannot be propagated with any approach to certainty by seed are kinds which have been long propagated by buds, cuttings, offsets, tubers, etc., and have in consequence been frequently exposed during what may be called their individual lives to widely diversified conditions of life. Plants thus propagated become so variable that they are subject, as we have seen in the last chapter, even to bud variation. Our domesticated animals, on the other hand, are not commonly exposed during the life of the individual to such extremely diversified conditions, and are not liable to such extreme variability. Therefore, they do not lose the power of transmitting most of their characteristic features. In the foregoing, remarks on non-inheritance crossed breeds are of course excluded, as their diversity mainly depends on the unequal development of character derived from either parent or their ancestors. Conclusion. It has been shown in the early part of this chapter how commonly new characters of the most diversified nature, whether normal or abnormal, injurious or beneficial, whether affecting organs of the highest or most trifling importance, are inherited. It is often sufficient for the inheritance of some peculiar character that one parent alone should possess it, as in most cases in which the rarer anomalies have been transmitted, but the power of transmission is extremely variable in a number of individuals descended from the same parents and treated in the same manner. Some display this power in a perfect manner, and in some it is quite deficient, and for this difference no reason can be assigned. The effects of injuries or mutilations are occasionally inherited, and we shall see in a future chapter that the long-continued use and disuse of parts produces an inherited effect. Even those characters which are considered the most fluctuating, such as color, are with rare exceptions transmitted much more forcibly than is generally supposed. The wonder, indeed, in all cases, is not that any character should be transmitted, but that the power of inheritance should ever fail. The checks to inheritance, as far as we know them, are firstly, circumstances hostile to the particular character in question; secondly, conditions of life, incessantly inducing fresh variability; And lastly, the crossing of distinct varieties during some previous generation together with reversion or atavism, that is the tendency in the child to resemble its grandparents or more remote ancestors instead of its immediate parents. This latter subject will be discussed in the following chapter. References: Chapter Roman 13, Inheritance Continued Reversion of Atavism. Different forms of reversion in pure or uncrossed breeds, as in pigeons, fowls, hornless cattle, and sheep; in cultivated plants reversion, in feral animals and plants reversion, in crossed varieties and species reversion through bud propagation, and by segments in the same flower or fruit in different parts of the body, in the same animal act of crossing a direct cause of reversion. Various cases of with instincts author proximate causes of reversion: latent character, secondary sexual character, unequal development of the two sides of the body appearance, with advancing age of characters, derived from a crossed germ with all its latent characters, a wonderful object. Monstrositas pyloric flowers due, in some cases, to reversion. The great principle of inheritance to be discussed in this chapter has been recognized by agriculturists and authors of various nations, as shown by the scientific term atavism, derived from atavis, an ancestor, by the English terms of reversion or throwing back, by the French paysan arrière, and by the German Rückschlag or Rückschritt, when the child resembles either grandparent more closely than its immediate parents. Our attention is not much arrested, though in truth the fact is highly remarkable, but when the child resembles some remote ancestor or some distant member in a collateral lineage. In the last case, we must attribute this to the descent of all the members from a common progenitor. We feel a just degree of astonishment when one parent alone displays some newly acquired and generally inheritable character, and the offspring do not inherit it. The cause may lie in the other parent having the power of prepotent transmission. But when both parents are similarly characterized, and the child does not, whatever the cause may be, inherit the character in question, but resembles its grandparents, we have one of the simplest cases of reversion. We continually see another, and even more simple case of atavism, though not generally included under this head, namely when the son more closely resembles his maternal than his paternal grandsire in some male attribute, as in any peculiarity in the beard of man, the horns of the bull, the hackles or comb of the cock, or as in certain diseases necessarily confined to the male sex, for as the mother cannot possess or exhibit such male attributes, the child must inherit them through her blood from his maternal grandsire. The cases of reversion may be divided into two main classes, which however in some instances blend into one another, namely first those occurring in a variety or race which has not been crossed, but has lost by variation some character that it formerly possessed and which afterwards reappears. The second class includes all cases in which an individual with some distinguishable character, a race or species, has at some former period been crossed, and a character derived from this cross, after having disappeared during one or several generations, suddenly reappears. A third class, differing only in the manner of reproduction, might be formed to include all cases of reversion effected by means of buds, and therefore independent of true or seminal generation. Perhaps even a fourth class might be instituted to include reversions by segments in the same individual flower or fruit, and in different parts of the body in the same individual animal as it grows old. But the two first main classes will be sufficient for our purpose. Reversion to lost characters by pure or uncrossed forms. Striking instances of this first class of cases were given in the 6th chapter, namely of the occasional reappearance, in variously colored breeds, of the pigeon of blue birds, with all the marks characteristic of the wild Columba livia. Similar cases were given in the case of the fowl, with the common ass, as the legs of the wild progenitor are almost always striped. We may feel assured that the occasional appearance of such stripes in the domestic animal is a case of simple reversion, but I shall be compelled to refer again to these cases, and therefore here pass them over. The aboriginal species from which our domesticated cattle and sheep are descended no doubt possessed horns, but several hornless breeds are now well established. Yet in the Sefer instance in Southdown sheep it is not unusual to find among the male lambs some with small horns. The horns which thus occasionally reappear in other polled breeds either grow to the full size or are curiously attached to the skin alone, and hang loosely down or drop off one. The Galloways and Suffolk cattle have been hornless for the last 100 or 150 years, but a horned calf with the horn often loosely attached is occasionally produced too. There is reason to believe that sheep in their early domesticated condition were brown or dingy black, but even in the time of David, certain flocks were spoken of as white as snow during the classical period. The sheep of Spain are described by several ancient authors as being black red or tawny 3, at the present day, notwithstanding the great care which is taken to prevent it party-colored lambs, and some entirely black are occasionally or even frequently dropped by our most highly improved and valued breeds, such as the Southdowns. Since the time of the famous Bakewell during the last century, the Leicester sheep have been bred with the most scrupulous care, yet occasionally gray-faced or black-spotted or wholly black lambs appear, for this occurs still more frequently with the less improved breeds, such as the Norfolk's 5, as bearing on this tendency in sheep to revert to dark colors. I may state, though in doing so I trench on the reversion of crossed breeds, and likewise on the subject of prepotency, that the Rev. W. Roman 500 Fox was informed that 7 white Southdown ewes were put to a so-called Spanish ram, which had 2 small black spots on his sides, and they produced 13 lambs, all perfectly black. Mr. Fox believes that this ram belonged to a breed which he has himself kept, and which is always spotted with black and white, and he finds that Leicester sheep crossed by rams of this breed always produce black lambs. He has gone on recrossing these crossed sheep with pure white Leicesters during 3 successive generations, but always with the same result. Mr. Fox was also told by the friend, from whom the spotted breed was procured, that he likewise had gone on for 6 or 7 generations crossing with white sheep, but still, black lambs were invariably produced. Similar facts could be given with respect to tailless breeds of various animals. For instance, Mr. Hewitt 6 states that chickens bred from some rumpless fowls, which were reckoned so good that they won a prize at an exhibition in a considerable number of instances, were furnished with fully developed tail feathers. On inquiry, the original breeder of these fowls stated that from the time when he had first kept them, they had often produced fowls furnished with tails, but that these latter would again reproduce rumpless chickens. Analogous cases of reversion occur in the vegetable kingdom. Thus, from seeds gathered from the finest cultivated varieties of Heartsease viola tricolor plants, perfectly wild, both in their foliage and their flowers, are frequently produced 7. But the reversion in this instance is not to a very ancient period, for the best existing varieties of the Heartsease are of comparatively modern origin. With most of our cultivated vegetables, there is some tendency to reversion to what is known to be, or may be presumed to be, their aboriginal state, and this would be more evident if gardeners did not generally look over their beds of seedlings and pull up the false plants, or rogues, as they are called. It has already been remarked that some few seedling apples and pears generally resemble, but apparently are not, identical with the wild trees from which they are descended. In our turnip 8 and carrot beds, a few plants often break, that is, flower too soon, and their roots are generally hard and stringy as in the parent species. By the aid of a little selection, carried on during a few generations, most of our cultivated plants could probably be brought back without any great change in their conditions of life to a wild or nearly wild condition. Mr. Buckman has effected this with the parsnip 9 and Mr. Hewitt Roman 100 Watson, as he informs me, selected during 3 generations, the most diverging plants of Scotch Kyle, perhaps one of the least modified varieties of the cabbage. And in the 3rd generation, some of the plants came very close to the forms now established in England about old castle walls, and called indigenous. Reversion in animals and plants, which have run wild. In the cases hitherto considered, the reverting animals and plants have not been exposed to any great or abrupt change in their conditions of life, which could have induced this tendency, but it is very different with animals and plants, which have become feral or run wild. It has been repeatedly asserted in the most positive manner by various authors that feral animals and plants invariably return to their primitive specific type. It is curious on what little evidence this belief rests. Many of our domesticated animals could not subsist in a wild state. Thus, the more highly improved breeds of the pigeon will not field or search for their own food. Sheep have never become feral, and would be destroyed by almost every beast of prey. 10. In several cases, we do not know the aboriginal parent species, and cannot possibly tell whether or not there has been any close degree of reversion. It is not known in any instance what variety was first turned out. Several varieties have probably in some cases run wild, and their crossing alone would tend to obliterate their proper character. Our domesticated animals and plants, when they run wild, must always be exposed to new conditions of life, for as Mr. Wallace 11 has well remarked, they have to obtain their own food, and are exposed to competition with the native productions under these circumstances. If our domesticated animals did not undergo change of some kind, the result would be quite opposed to the conclusions arrived at in this work. Nevertheless, I do not doubt that the simple fact of animals and plants becoming feral does cause some tendency to reversion to the primitive state, though this tendency has been much exaggerated by some authors. I will briefly run through the recorded cases. With neither horses nor cattle is the primitive stock known, and it has been shown in former chapters that they have assumed different colors in different countries. Thus the horses which have run wild in South America are generally brownish-bay, and in the East dun-colored, their heads have become larger and coarser, and this may be due to reversion. No careful description has been given of the feral goat dogs which have run wild in various countries, have hardly anywhere assumed a uniform character, but they are probably descended from several domestic races, and aboriginally from several distinct species. Feral cats, both in Europe and La Plata, are regularly striped in some cases. They have grown to an unusually large size, but do not differ from the domestic animal in any other character. When variously colored tame rabbits are turned out in Europe, they generally reacquire the coloring of the wild animal. There can be no doubt that this does really occur, but we should remember that oddly colored and conspicuous animals would suffer much from beasts of prey, and from being easily shot. This at least was the opinion of a gentleman who tried to stock his woods with a nearly white variety. If thus destroyed, they would be supplanted by, instead of being transformed into the common rabbit. We have seen that the feral rabbits of Jamaica, and especially of Porto Santo, have assumed new colors and other new characters. The best-known case of reversion, and that on which the widely spread belief in its universality apparently rests, is that of pigs. These animals have run wild in the West Indies, South America, and the Falkland Islands, and have everywhere acquired the dark color, the thick bristles and great tusks of the wild boar, and the young have reacquired longitudinal stripes. But even in the case of the pig, Rulin describes the half-old animals in different parts of South America as differing in several respects. In Louisiana, the pig 12 has run wild, and is said to differ little in form and much in color from the domestic animal, yet does not closely resemble the wild boar of Europe. With pigeons and fowls 13, it is not known what variety was first turned out, nor what character the feral birds have assumed. The guinea fowl in the West Indies, when feral, seems to vary more than in the domesticated state. With respect to plants run wild, Dr. Hooker 14 has strongly insisted on what slight evidence the common belief in their reversion to a primitive state rests. Godrin 15 describes wild turnips, carrots, and celery, but these plants in their cultivated state hardly differ from their wild prototypes, except in the succulency and enlargement of certain parts, characters which would certainly be lost by plants growing in poor soil and struggling with other plants. No cultivated plant has run wild on so enormous a scale as the cardoon Cynara cardunculus in La Plata. Every botanist who has seen it growing there in vast beds as high as a horse's back has been struck with its peculiar appearance. But whether it differs in any important point from the cultivated Spanish form, which is said not to be prickly like its American descendant, or whether it differs from the wild Mediterranean species, which is said not to be social, though this may be due merely to the nature of the conditions, I do not know. Reversion to characters derived from a cross in the case of subvarieties races, and species when an individual having some recognizable peculiarity unites with another of the same subvariety not having the peculiarity in question, it often reappears in the descendants after an interval of several generations. Every one must have noticed or heard from old people of children closely resembling in appearance or mental disposition, or in so small and complex a character as expression, one of their grandparents or some more distant collateral relation. Very many anomalies of structure and diseases, 16 of which instances have been given in the last chapter, have come into a family from one parent, and have reappeared in the progeny after passing over 2 or 3 generations. The following case has been communicated to me on good authority, and may, I believe, be fully trusted. A pointer bitch produced 7 puppies. 4 were marked with blue and white, which is so unusual a color with pointers that she was thought to have played false with one of the greyhounds, and the whole litter was condemned, but the gamekeeper was permitted to save one as a curiosity. 2 years afterwards, a friend of the owner saw the young dog, and declared that he was the image of his old pointer bitch, Sappho, the only blue and white pointer of pure descent which he had ever seen. This led to close inquiry, and it was proved that he was the great-great-grandson of Sappho, so that according to the common expression, he had only 1/16th of her blood in his veins. I may give one other instance on the authority of Mr. R. Walker, a large cattle breeder in Kincardineshire. He bought a black bull, the son of a black cow, with white legs, white belly, and part of the tail white. And in 1870, a calf, the GR grandchild of this cow, was born colored in the same very peculiar manner, all the intermediate offspring having been black. In these cases, there can hardly be a doubt that a character derived from a cross, with an individual of the same variety, reappeared after passing over 3 generations in the one case, and 5 in the other. When 2 distinct races are crossed, it is notorious that the tendency in the offspring to revert to one or both parent forms is strong and endures for many generations. I have myself seen the clearest evidence of this in crossed pigeons. And with various plants, Mr. Sidney 17 states that in a litter of Essex pigs, 2 young ones appeared which were the image of the Berkshire boar that had been used 28 years before in giving size and constitution to the breed. I observed in the farmyard at Betley Hall some fowls, showing a strong likeness to the Malay breed, and was told by Mr. Tollett that he had 40 years before crossed his birds with Malays, and that though he had at first attempted to get rid of this strain, he had subsequently given up the attempt in despair, as the Malay character would reappear. This strong tendency in crossed breeds to revert has given rise to endless discussions in how many generations after a single cross, either with a distinct breed or merely with an inferior animal, the breed may be considered as pure and free from all danger of reversion. No one supposes that less than 3 generations suffices, and most breeders think that 6, 7, or 8 are necessary, and some go to still greater lengths, 18, but neither in the case of a breed which has been contaminated by a single cross, nor when in the attempt to form an intermediate breed half-bred animals have been matched together during many generations can any rule be laid down how soon the tendency to reversion will be obliterated. It depends on the difference in the strength or prepotency of transmission in the 2 parent forms, on their actual amount of difference, and on the nature of the conditions of life to which the crossed offspring are exposed. But we must be careful not to confound these cases of reversion to characters which were gained by a cross with those, under the first class, in which characters originally common to both parents, but lost at some former period reappear, for such characters may recur after an almost indefinite number of generations. The law of reversion is as powerful with hybrids when they are sufficiently fertile to breed together, or when they are repeatedly crossed with either pure parent form. As in the case of mongrels, it is not necessary to give instances. With plants, almost everyone who has worked on this subject from the time of Kallreuter to the present day has insisted on this tendency. Gartner has recorded some good instances, but no one has given more striking ones than Naudin 19. The tendency differs in degree or strength in different groups, and partly depends, as we shall presently see, on whether the parent plants have been long cultivated. Although the tendency to reversion is extremely general with nearly all mongrels and hybrids, it cannot be considered as invariably characteristic of them. It may also be mastered by long-continued selection, but these subjects will more properly be discussed in a future chapter on crossing. From what we see of the power and scope of reversion, both in pure races and when varieties or species are crossed, we may infer that characters of almost every kind are capable of reappearing after having been lost for a great length of time. But it does not follow from this that, in each particular case, certain characters will reappear. For instance, this will not occur when a race is crossed with another, endowed with prepotency of transmission. Sometimes the power of reversion wholly fails, without our being able to assign any cause for the failure. Thus it has been stated that in a French family, in which 85 out of above 600 members during 6 generations had been subject to nightblindness, there has not been a single example of this affection in the children of parents who were themselves free from it. 20. Reversion through bud propagation, partial reversion by segments in the same flower or fruit, or in different parts of the body, in the same individual animal. In the 11th chapter, many cases of reversion by buds, independently of seminal generation, were given when a leaf bud on a variegated, a curled, or laciniated variety suddenly reassumes its proper character, or as when a Provençal rose appears on a moss rose, or a peach on a nectarine tree. In some of these cases, only half the flower or fruit, or a smaller segment or mere stripes reassume their former character, and here we have reversion by segments. Vilmore in 21 has also recorded several cases with plants derived from seed of flowers, reverting by stripes or blotches to their primitive colors. He states that in all such cases, a white or pale-colored variety must first be formed, and when this is propagated for a length of time by seeds, striped seedlings occasionally make their appearance, and these can afterwards by care be multiplied by seed. The stripes in segments just referred to are not due as far as is known to reversion to characters derived from a cross, but to characters lost by variation. These cases, however, as Naudin 22 insists in his discussion on disjunction of character, are closely analogous with those given in the 11th chapter, in which crossed plants have been known to produce half and half, or striped flowers, and fruit or distinct kinds of flowers on the same root resembling the two parent forms. Many piebald animals probably come under this same head. Such cases, as we shall see in the chapter on crossing, apparently result from certain characters not readily blending together. And as a consequence of this incapacity for fusion, the offspring either perfectly resemble one of their two parents, or resemble one parent in one part and the other parent in another part, or, whilst young, are intermediate in character, but with advancing age revert wholly, or by segments to either parent form, or to both. Thus young trees of the Cytisus adami are intermediate in foliage and flowers between the two parent forms. But when older, the buds continually revert either partially or wholly to both forms. The cases given in the 11th chapter on the changes which occurred during growth in crossed plants of Tropolum, Sirius, Datura, and Lathyrus are all analogous, as however these plants are hybrids of the first generation, and as their buds after a time come to resemble their parents and not their grandparents. These cases do not at first appear to come under the law of reversion in the ordinary sense of the word. Nevertheless, as the change is effected through a succession of bud generations on the same plant, they may be thus included. Analogous facts have been observed in the animal kingdom and are more remarkable as they occur in the same individual in the strictest sense, and not as with plants through a succession of bud generations. With animals, the act of reversion, if it can be so designated, does not pass over a true generation, but merely over the early stages of growth in the same individual. For instance, I crossed several white hens with a black cock, and many of the chickens were during the first year perfectly white but acquired during the second year black feathers. On the other hand, some of the chickens which were at first black became during the second year piebald with white. A great breeder 23 says that a penciled Brahma hen, which has any of the blood of the light Brahma in her, will occasionally produce a pullet well penciled during the first year, but she will most likely molt brown on the shoulders and become quite unlike her original colors in the second year. The same thing occurs with light Brahmas if of impure blood. I have observed exactly similar cases with the crossed offspring from differently colored pigeons, but here is a more remarkable fact. I crossed a turbot, which has a frill formed by the feathers being reversed on its breast with a trumpeter, and one of the young pigeons thus raised at first showed not a trace of the frill, but after molting thrice, a small yet unmistakably distinct frill appeared on its breast. According to Gyru, 24 calves produced from a red cow by a black bull, or from a black cow by a red bull, are not rarely born red, and subsequently become black. I possess a dog, the daughter of a white terrier by a fox-colored bulldog. As a puppy she was quite white, but when about 6 months old, a black spot appeared on her nose, and brown spots on her ears. When a little older she was badly wounded on the back, and the hair which grew on the cicatrix was of a brown color, apparently derived from her father. This is the more remarkable, as with most animals having colored hair, that which grows on a wounded surface is white. In the foregoing cases, the characters which with advancing age reappeared were present in the immediately preceding generations, but characters sometimes reappear in the same manner after a much longer interval of time. Thus the calves of a hornless race of cattle, which originated in corrients, though at first quite hornless, as they become adult sometimes acquire small crooked and loose horns, and these in succeeding years occasionally become attached to the skull. 25 white and black bantams, both of which generally breed true, sometimes assume, as they grow old, a saffron or red plumage. For instance, a first-rate black bantam has been described, which during 3 seasons was perfectly black, but then annually became more and more red. And it deserves notice that this tendency to change whenever it occurs in a bantam is almost certain to prove hereditary. 26 The cuckoo, or blue-mottled dorking cock, when old is liable to acquire yellow or orange hackles in place of his proper bluish-gray hackles. 27 Now, as Gallus bankova is colored red and orange, and as Dorking fowls and bantams are descended from this species, we can hardly doubt that the change which occasionally occurs in the plumage of these birds, as their age advances, results from a tendency in the individual to revert to the primitive type. Crossing as a direct cause of reversion. It has long been notorious that hybrids and mongrels often revert to both or to one of their parent forms after an interval of from 2 to 7 or 8, or according to some authorities, even a greater number of generations, but that the act of crossing in itself gives an impulse towards reversion as shown by the reappearance of long-lost characters has never, I believe, been hitherto proved. The proof lies in certain peculiarities which do not characterize the immediate parents, and therefore cannot have been derived from them, frequently appearing in the offspring of two breeds, when crossed, which peculiarities never appear or appear with extreme rarity in these same breeds, as long as they are precluded from crossing. As this conclusion seems to me highly curious and novel, I will give the evidence in detail. My attention was first called to this subject, and I was led to make numerous experiments by Roman 2000 Boydard and Corby, having stated that when they crossed certain breeds of pigeons birds, colored like the wild Roman 100 Livia, or the common dovecote, namely Slatablue, with double black wingbars sometimes checkered with black-white, loins the tail barred with black with the outer feathers edged with white, were almost invariably produced the breeds which I crossed, and the remarkable results attained have been fully described. In the 6th chapter, I selected pigeons belonging to true and ancient breeds which had not a trace of blue or any of the above specified marks, but when crossed, and their mongrels recrossed young birds were often produced more or less plainly colored Slatablue, with some or all of the proper characteristic marks. I may recall to the reader's memory one case, namely that of a pigeon hardly distinguishable from the wild Shetland species, the grandchild of a red spot white fantail, and two black barbs, from any of which, when purelibred, the production of a pigeon colored like the wild Roman 100 Livia would have been almost a prodigy. I was thus led to make the experiments recorded in the 7th chapter on fowls. I selected long-established pure breeds, in which there was not a trace of red, yet in several of the mongrels feathers of this color appeared, and one magnificent bird, the offspring of a black Spanish cock and white silk hen, was colored almost exactly like the wild Gallus bankova. All who know anything of the breeding of poultry will admit that tens of thousands of pure Spanish and of pure white silk fowls might have been reared without the appearance of a red feather, the fact given on the authority of Mr. Tegetmeier of the frequent appearance in mongrel fowls of penciled or transversalibard feathers, like those common to many gallinaceous birds, is likewise apparently a case of reversion to a character formerly possessed by some ancient progenitor of the family. I owe to the kindness of this excellent observer the opportunity of inspecting some neck hackles and tail feathers from a hybrid between the common fowl and a very distinct species, the Gallus varius, and these feathers are transversely striped in a conspicuous manner with dark metallic blue and gray, a character which could not have been derived from either immediate parent. I have been informed by Mr. B.P. Brent that he crossed a white Aylesbury drake and a black so-called Labrador duck, both of which are true breeds, and he obtained a young drake closely like the mallard, abashes of the muskduck Carina machata lin. There are two subbreeds, namely white and slate-colored, and these I am informed breed true or nearly true, but the Rev. W. Roman 500 Fox tells me that by putting a white drake to a slate-colored duck, black birds pied with white like the wild muskduck were always produced. I hear from Mr. Blyth that hybrids from the canary and goldfinch almost always have streaked feathers on their backs, and this streaking must be derived from the original wild canary. We have seen in the 4th chapter that the so-called Himalayan rabbit with its snow-white body, black ears, nose, tail, and feet breeds perfectly true. This race is known to have been formed by the union of two varieties of silvergrey rabbits. Now, when a Himalayan doe was crossed by a sandy-colored buck, a silvergrey rabbit was produced, and this is evidently a case of reversion to one of the parent varieties. The young of the Himalayan rabbit are born snow-white, and the dark marks do not appear until some time subsequently, but occasionally young Himalayan rabbits are born of a light silvergrey, which color soon disappears, so that here we have a trace of reversion during an early period of life to the parent varieties, independently of any recent cross. In the 3rd chapter, it was shown that at an ancient period, some breeds of cattle in the wilder parts of Britain were white with dark ears, and that the cattle now kept half wild in certain parks, and those which have run quite wild in two distant parts of the world, are likewise thus colored. Now an experienced breeder, Mr. J. Beasley of Northamptonshire 28, crossed some carefully selected West Highland cows with pure-libred shorthorn bulls. The bulls were red and white or dark roan, and the Highland cows were all of a red color, inclining to a light or yellow shade, but a considerable number of the offspring and Mr. Beasley calls attention to this as a remarkable fact were white with red ears, bearing in mind that none of the parents were white, and that they were pure-libred animals. It is highly probable that here the offspring reverted in consequence of the cross to the color of some ancient and half-wild parent breed. The following case perhaps comes under the same head. Cows in their natural state have their udders but little developed, and do not yield nearly so much milk as our domesticated animals now. There is some reason to believe 29 that crossbred animals between two kinds, both of which are good milkers, such as Alderneys and Shorthorns, often turn out worthless in this respect. In the chapter on the horse, reasons were assigned for believing that the primitive stock was striped and dun-colored, and details were given showing that in all parts of the world stripes of a dark color frequently appear along the spine across the legs, and on the shoulders where they are occasionally double or treble, and even sometimes on the face and body of horses of all breeds and of all colors, but the stripes appear most frequently on the various kinds of duns. In foals they are sometimes plainly seen, and subsequently disappear the dun color, and the stripes are strongly transmitted when a horse thus characterized is crossed with any other. But I was not able to prove that striped duns are generally produced from the crossing of two distinct breeds, neither of which are duns, though this does sometimes occur. The legs of the ass are often striped, and this may be considered as a reversion to the wild parent form, the Equus teneopus of Abyssinia 30, which is generally thus striped in the domestic animal. The stripes on the shoulder are occasionally double or forked at the extremity, as in certain zebrine species. There is reason to believe that the foal is more frequently striped on the legs than the adult animal. As with the horse, I have not acquired any distinct evidence that the crossing of differently colored varieties of the ass brings out the stripes. But now let us turn to the result of crossing the horse and ass. Although mules are not nearly so numerous in England, as asses I have seen a much greater number with striped legs, and with the stripes far more conspicuous than in either parent form. Such mules are generally light-colored, and might be called fallow-duns. The shoulder stripe in one instance was deeply forked at the extremity, and in another instance was double though united in the middle. Mr. Martin gives a figure of a Spanish mule with strong zebra-like marks on its legs 31, and remarks that mules are particularly liable to be thus striped on their legs in South America. According to Rulin 30, two such stripes are more frequent and conspicuous in the mule than in the ass in the United States. Mr. Goss 33, speaking of these animals, says that in a great number, perhaps in 9 out of every 10, the legs are banded with transverse dark stripes. Many years ago I saw in the zoological gardens a curious triple hybrid from a bay mare by a hybrid from a male ass and female zebra. This animal, when old, had hardly any stripes, but I was assured by the superintendent that when young it had shoulder stripes and faint stripes on its flanks and legs. I mention this case more especially as an instance of the stripes being much plainer during youth than in old age. As the zebra has such a conspicuously striped body and legs, it might have been expected that the hybrids from this animal and the common ass would have had their legs in some degree striped, but it appears from the figures given in Dr. Gray's Knowsley Gleanings, and still more plainly from that given by Geoffroy and F. Cuvier 34, that the legs are much more conspicuously striped than the rest of the body. And this fact is intelligible only on the belief that the ass aids in giving, through the power of reversion, this character to its hybrid offspring. The quagga is banded over the whole front part of its body like a zebra, but has no stripes on its legs or mere traces of them. But in the famous hybrid bred by Lord Morton 35, from a chestnut nearly pure-libred Arabian mare by a male quagga, the stripes were more strongly defined and darker than those on the legs of the quagga. The mare was subsequently put to a black Arabian horse, and bore two colts, both of which, as formerly stated, were plainly striped on the legs, and one of them likewise had stripes on the neck and body. The Equus indicus 36 is characterized by a spinal stripe without shoulder or leg stripes, but traces of these latter stripes may occasionally be seen even in the adult 37, and Colonel S. Poole, who has had ample opportunities for observation, informs me that in the foal when first born the head and legs are often striped, but the shoulder stripe is not so distinct as in the domestic ass all. These stripes excepting that along the spine soon disappear now. A hybrid raised at Nosely 38 from a female of this species by a male domestic ass had all 4 legs transversely and conspicuously striped, had 3 short stripes on each shoulder, and had even some zebra-like stripes on its face. Dr. Gray informs me that he has seen a second hybrid of the same parentage, similarly striped. From these facts, we see that the crossing of the several equine species tends in a marked manner to cause stripes to appear on various parts of the body, especially on the legs. As we do not know whether the parent form of the genus was striped, the appearance of the stripes can only hypothetically be attributed to reversion, but most persons, after considering the many undoubted cases of variously colored marks reappearing by reversion in my experiments on crossed pigeons and fowls, will come to the same conclusion with respect to the horse genus. And if so, we must admit that the progenitor of the group was striped on the legs, shoulders, face, and probably over the whole body like a zebra. Lastly, Professor Jaeger has given 39 a good case with pigs. He crossed the Japanese, or masked breed, with the common German breed, and the offspring were intermediate in character. He then recrossed one of these mongrels with the pure Japanese, and in the litter thus produced one of the young resembled in all its characters a wild pig. It had a long snout and upright ears, and was striped on the back. It should be borne in mind that the young of the Japanese breed are not striped, and that they have a short muzzle and ears remarkably dependent. A similar tendency to the recovery of long-lost characters holds good even with the instincts of crossed animals. There are some breeds of fowls which are called everlasting layers, because they have lost the instinct of incubation, and so rare is it for them to incubate that I have seen notices published in works on poultry, when hens of such breeds have taken to sit 40, yet the aboriginal species was of course a good incubator. And with birds in state of nature, hardly any instinct is so strong as this now. So many cases have been recorded of the crossed offspring, from 2 races neither of which are incubators becoming first-rate sitters, that the reappearance of this instinct must be attributed to reversion from crossing. One author goes so far as to say that a cross between 2 non-sitting varieties almost invariably produces a mongrel that becomes broody and sits with remarkable steadiness. 40. Another author, after giving a striking example, remarks that the fact can be explained only on the principle that 2 negatives make a positive. It cannot, however, be maintained that hens produced from a cross between 2 non-sitting breeds invariably recover their lost instinct any more than that crossed fowls or pigeons invariably recover the red or blue plumage of their prototypes. Thus I raised several chickens from a Polish hen by a Spanish cock breeds, which do not incubate, and none of the young hens at first showed any tendency to sit, but one of them, only one which was preserved in the 3rd year, sat well on her eggs, and reared a brood of chickens, so that here we have the reappearance with advancing age of a primitive instinct in the same manner, as we have seen that the red plumage of the Gallus bancova is sometimes reacquired, both by crossed and purulibrid fowls of various kinds, as they grow old. The parents of all our domesticated animals were of course aboriginally wild in disposition, and when a domesticated species is crossed with a distinct species, whether this is a domesticated or only a tamed animal, the hybrids are often wild to such a degree that the fact is intelligible only on the principle that the cross has caused a partial return to a primitive disposition. Thus the Earl of Powys formerly imported some thoroughly domesticated humped cattle from India, and crossed them with English breeds which belong to a distinct species, and his agent remarked to me, without any question having been asked, how oddly wild the crossbred animals were. The European wild boar and the Chinese domesticated pig are almost certainly specifically distinct. Sir F. Darwin crossed a sow of the latter breed with a wild alpine boar, which had become extremely tame, but the young, though having half-domesticated blood in their veins, were extremely wild in confinement, and would not eat swill like common English pigs. Captain Hutton in India crossed a tame goat with a wild one from the Himalaya, and he remarked to me how surprisingly wild the offspring were. Mr. Hewitt, who has had great experience in crossing tame cock pheasants with fowls belonging to 5 breeds, gives as the character of all extraordinary wildness 42, but I have myself seen one exception to this rule. Mr. S. J. Salter 43, who raised a large number of hybrids from a bantam hen by Gallus sonoradii, states that all were exceedingly wild. Mr. Waterton 44 bred some wild ducks from eggs hatched under a common duck, and the young were allowed to cross freely both amongst themselves. And with the tame ducks, they were half wild and half tame, they came to the windows to be fed. But still, they had a wariness about them quite remarkable. On the other hand, mules from the horse and ass are certainly not in the least wild, though notorious for obstinacy and vice. Mr. Brent, who has crossed canaribirds with many kinds of finches, has not observed, as he informs me, that the hybrids were in any way remarkably wild, but Mr. Jenner Weir, who has had still greater experience, is of a directly opposite opinion. He remarks that the siskin is the tamest of finches, but its mules are as wild when young as newly caught birds, and are often lost through their continued efforts to escape. Hybrids are often raised between the common and musk duck, and I have been assured by 3 persons who have kept these crossed birds that they were not wild, but Mr. Garnet 45 observed that his hybrids were wild and exhibited migratory propensities of which there is not a vestige in the common or musk duck. No case is known of this latter bird having escaped and become wild in Europe or Asia, except according to Pallas on the Caspian Sea, and the common domestic duck only occasionally becomes wild in districts where large lakes and fens abound. Nevertheless, a large number of cases have been recorded, 46 of hybrids from these 2 ducks having been shot in a completely wild state, although so few are reared in comparison with purulibrid birds of either species. It is improbable that any of these hybrids could have acquired their wildness from the musk duck having paired with a truly wild duck. And this is known not to be the case in North America. Hence we must infer that they have reacquired through reversion their wildness, as well as renewed powers of flight. These latter facts remind us of the statements so frequently made by travelers in all parts of the world on the degraded state and savage disposition of crossed races of man, that many excellent and kind-hearted mulattoes have existed no one will dispute, and a more mild and gentle set of men could hardly be found than the inhabitants of the island of Chiloe, who consist of Indians commingled with Spaniards in various proportions. On the other hand, many years ago, long before I had thought of the present subject, I was struck with the fact that in South America, men of complicated descent between Negroes, Indians, and Spaniards seldom had, whatever the cause might be, a good expression. 47 Livingstone and a more unimpeachable authority cannot be quoted after speaking of a half-caste man on the Zambesi, described by the Portuguese as a rare monster of inhumanity, remarks it is unaccountable why half-castes such as he are so much more cruel than the Portuguese. But such is undoubtedly the case. An inhabitant remarked to Livingstone, God made white men and God made black men, but the devil made half-castes. 48 When 2 races both low in the scale are crossed, the progeny seems to be eminently bad. Thus the noble-hearted Humboldt, who felt no prejudice against the inferior races, speaks in strong terms of the bad and savage disposition of Zambos, or half-castes between Indians and Negroes, and this conclusion has been arrived at by various observers. 49 From these facts, we may perhaps infer that the degraded state of so many half-castes is in part due to reversion to a primitive and savage condition, induced by the act of crossing, even if mainly due to the unfavorable moral conditions under which they are generally reared. Summary on the proximate causes leading to reversion: when purulibrid animals or plants reassume long-lost characters. When the common ass, for instance, is born with striped legs, when a pure race of black or white pigeons throws a slatted blue bird, or when a cultivated heartsease with large and rounded flowers produces a seedling with small and elongated flower-sweet, are quite unable to assign any proximate cause. When animals run wild, the tendency to reversion, which, though it has been greatly exaggerated, no doubt exists, is sometimes to a certain extent intelligible. Thus, with feral pigs, exposure to the weather will probably favor the growth of the bristles, as is known to be the case with the hair of other domesticated animals, and through correlation, the tusks will tend to be redeveloped, but the reappearance of colored longitudinal stripes on young feral pigs cannot be attributed to the direct action of external conditions in this case. And in many others, we can only say that any change in the habits of life apparently favor a tendency, inherent or latent in the species, to return to the primitive state. It will be shown in a future chapter that the position of flowers on the summit of the axis and the position of seeds within the capsule sometimes determine a tendency towards reversion, and this apparently depends on the amount of sap or nutriment which the flower buds and seeds receive. The position also of buds either on branches or on roots sometimes determines, as was formerly shown, the transmission of the character proper to the variety or its reversion to a former state. We have seen in the last section that when two races or species are crossed, there is the strongest tendency to the reappearance in the offspring of long-lost characters, possessed by neither parent nor immediate progenitor. When two white or red or black pigeons of well-established breeds are united, the offspring are almost sure to inherit the same colors. But when differently colored birds are crossed, the opposed forces of inheritance apparently counteract each other, and the tendency which is inherent in both parents to produce slata-blue offspring becomes predominant. So it is in several other cases. But when, for instance, the ass is crossed with E. indicus, or with the horse animals which have not striped legs, and the hybrids have conspicuous stripes on their legs, and even on their faces, all that can be said is that an inherent tendency to reversion is evolved through some disturbance in the organization caused by the act of crossing. Another form of reversion is far commoner, indeed, is almost universal with the offspring from a cross, namely to the characters proper to either pure parent form. As a general rule, crossed offspring in the first generation are nearly intermediate between their parents, but the grandchildren and succeeding generations continually revert in a greater or lesser degree to one or both of their progenitors. Several authors have maintained that hybrids and mongrels include all the characters of both parents, not fused together but merely mingled in different proportions in different parts of the body. Or as Nauden 50 has expressed it, a hybrid is a living mosaic work in which the eye cannot distinguish the discordant elements, so completely are they intermingled. We can hardly doubt that in a certain sense this is true, as when we behold in a hybrid the elements of both species segregating themselves into segments in the same flower or fruit by a process of self-attraction or self-affinity, this segregation taking place either by seminal or bud propagation. Nauden further believes that the segregation of the two specific elements or essences is eminently liable to occur in the male and female reproductive matter, and he thus explains the almost universal tendency to reversion in successive hybrid generations, for this would be the natural result of the union of pollen and ovules, in both of which the elements of the same species had been segregated by self-affinity. If, on the other hand, pollen, which included the elements of one species, happened to unite with ovules including the elements of the other species, the intermediate or hybrid state would still be retained, and there would be no reversion. But it would, as I suspect, be more correct to say that the elements of both parent species exist in every hybrid in a double state, namely blended together and completely separate. How this is possible, and what the term specific essence or element may be supposed to express, I shall attempt to show in the chapter on the hypothesis of pangenesis. But Nauden's view, as propounded by him, is not applicable to the reappearance of characters lost long ago by variation, and it is hardly applicable to races or species which, after having been crossed at some former period with a distinct form, and having since lost all traces of the cross, nevertheless occasionally yield an individual which reverts, as in the case of the great-great-grandchild of the pointer Sappho, to the crossing form. The most simple case of reversion, namely of a hybrid or mongrel to its grandparents, is connected by an almost perfect series with the extreme case of a pluralhybrid race, recovering characters which had been lost during many ages, and we are thus led to infer that all the cases must be related by some common bond. Gartner believed that only highly sterile hybrid plants exhibit any tendency to reversion to their parent forms. This erroneous belief may perhaps be accounted for by the nature of the genera crossed by him, for he admits that the tendency differs in different genera. The statement is also directly contradicted by Nauden's observations, and by the notorious fact that perfectly fertile mongrels exhibit the tendency in a high degree in a higher degree, according to Gartner himself, than hybrids. 51. Gartner further states that reversions rarely occur with hybrid plants raised from species which have not been cultivated, whilst with those which have been long cultivated, they are of frequent occurrence. This conclusion explains a curious discrepancy. Max Wichura 52, who worked exclusively on willows which had not been subjected to culture, never saw an instance of reversion, and he goes so far as to suspect that the careful Gartner had not sufficiently protected his hybrids from the pollen of the parent species. Nauden, on the other hand, who chiefly experimented on cucurbitaceous and other cultivated plants, insists more strenuously than any other author on the tendency to reversion in all hybrids. The conclusion that the condition of the parent species as affected by culture is one of the proximate causes leading to reversion, agrees well with the converse case of domesticated animals and cultivated plants being liable to reversion when they become feral, for in both cases, the organization or constitution must be disturbed, though in a very different way. 53. Finally, we have seen that characters often reappear in purelibrid races without our being able to assign any proximate cause. But when they become feral, this is either indirectly or directly induced by the change in their conditions of life. With crossed breeds, the act of crossing in itself certainly leads to the recovery of long-lost characters as well as of those derived from either parent form changed conditions consequent on cultivation, and the relative position of buds, flowers, and seeds on the plant all apparently aid in giving this same tendency. Reversion may occur either through seminal or bud generation, generally at birth, but sometimes only with an advance of age. Segments or portions of the individual may alone be thus affected that a being should be born resembling in certain characters an ancestor removed by 2 or 3, and in some cases by hundreds or even thousands of generations, is assuredly a wonderful fact. In these cases, the child is commonly said to inherit such characters directly from its grandparent or more remote ancestors. But this view is hardly conceivable if, however, we suppose that every character is derived exclusively from the father or mother, but that many characters lie latent or dormant in both parents during a long succession of generations. The foregoing facts are intelligible. In what manner characters may be conceived to lie latent will be considered in a future chapter to which I have lately alluded. Latent characters. But I must explain what is meant by characters lying latent. The most obvious illustration is afforded by secondary sexual characters. In every female, all the secondary male characters, and in every male, all the secondary female characters, apparently exist in a latent state, ready to be evolved under certain conditions. It is well known that a large number of female birds, such as fowls, various pheasants, partridges, peahens, ducks, etc., when old or diseased, or when operated on, assume many or all of the secondary male characters of their species. In the case of the hen pheasant, this has been observed to occur far more frequently during certain years than during others. 54. A duck 10 years old has been known to assume both the perfect winter and summer plumage of the drake. 55. Waterton 56 gives a curious case of a hen which had ceased laying, and had assumed the plumage, voice, spurs, and warlike disposition of the cock. When opposed to an enemy, she would erect her hackles and show fight. Thus every character, even to the instinct and manner of fighting, must have lain dormant in this hen, as long as her ovaria continued to act. The females of 2 kinds of deer, when old, have been known to acquire horns, and as Hunter has remarked, we see something of an analogous nature in the human species. On the other hand, with male animals, it is notorious that the secondary sexual characters are more or less completely lost when they are subjected to castration. Thus, if the operation be performed on a young cock, he never, as Yarrell states, crows again. The comb, wattles, and spurs do not grow to their full size, and the hackles assume an intermediate appearance between true hackles, and the feathers of the hen cases are recorded of confinement, which often affects the reproductive system, causing analogous results. But characters properly confined to the female are likewise acquired by the male. The capon takes to sitting on eggs and will bring up chickens, and what is more curious, the utterly sterile male hybrids from the pheasant and the fowl act in the same manner, their delight being to watch when the hens leave their nests, and to take on themselves the office of a sitter. 57. That admirable observer Reaumur 58 asserts that a cock, by being long confined in solitude and darkness, can be taught to take charge of young chickens. He then utters a peculiar cry, and retains during his whole life this newly acquired maternal instinct. The many well-ascertained cases of various male mammals giving milk shows that their rudimentary mammary glands retain this capacity in a latent condition. We thus see that in many, probably in all cases, the secondary characters of each sex lie dormant or latent in the opposite sex, ready to be evolved under peculiar circumstances. We can thus understand how, for instance, it is possible for a good milking cow to transmit her good qualities through her male offspring to future generations, for we may confidently believe that these qualities are present, though latent, in the males of each generation. So it is with the gamecock, who can transmit his superiority in courage and vigor through his female to his male offspring. And with man, it is known. 59 that diseases such as hydrocele, necessarily confined to the male sex, can be transmitted through the female to the grandson. Such cases, as these offer, as was remarked at the commencement of this chapter, the simplest possible examples of reversion, and they are intelligible on the belief that characters common to the grandparent and grandchild of the same sex are present though latent in the intermediate parent of the opposite sex. The subject of latent characters is so important, as we shall see in a future chapter, that I will give another illustration. Many animals have the right and left sides of their body unequally developed. This is well known to be the case with flatfish, in which the one side differs in thickness and color, and in the shape of the fins from the other. And during the growth of the young fish, one eye is gradually twisted from the lower to the upper surface. 60 in most flatfishes. The left is the blind side, but in some it is the right, though in both cases reversed or wrong fishes are occasionally developed, and in Platycephalus, the right or left side is indifferently the upper one. With gastropods or shellfish, the right and left sides are extremely unlike. The far greater number of species are dextral with rare and occasional reversals of development, and some few are normally sinistral, but certain species of Bulimus, and many a chatinal 61, are as often sinistral as dextral. I will give an analogous case in the great articulate kingdom. The two sides of Verruca 62 are so wonderfully unlike that without careful dissection, it is extremely difficult to recognize the corresponding parts on the opposite sides of the body, yet it is apparently a mere matter of chance whether it be the right or the left side that undergoes so singular amount of change. One plant is known to me 63, in which the flower according as it stands on the one or other side of the spike is unequally developed. In all the foregoing cases, the two sides are perfectly symmetrical at an early period of growth. Now, whenever species is as liable to be unequally developed on the one as on the other side, we may infer that the capacity for such development is present though latent in the undeveloped side. And as a reversal of development occasionally occurs in animals of many kinds, this latent capacity is probably very common. The best yet simplest cases of characters lying dormant are perhaps those previously given, in which chickens and young pigeons raised from a cross between differently colored birds are at first of one color, but in a year or two acquire feathers of the color of the other parent. For in this case, the tendency to a change of plumage is clearly latent in the young bird. So it is with hornless breeds of cattle, some of which acquire small horns as they grow old. Purely bred black and white bantams and some other fowls occasionally assume with advancing years the red feathers of the parent species. I will here add a somewhat different case, as it connects in a striking manner latent characters of two classes. Mr. Hewitt 64 possessed an excellent sebright gold-laced bantam hen, which as she became old grew diseased in her ovaria, and assumed male characters in this breed. The males resemble the females in all respects, except in their combs, wattles, spurs, and instincts. Hence it might have been expected that the diseased hen would have assumed only those masculine characters which are proper to the breed, but she acquired in addition well-arched tail, cyclofeathers, quite a foot in length, saddle feathers on the loins, and hackles on the neck ornaments, which as Mr. Hewitt remarks would be held as abominable in this breed. The sebright bantam is known 65 to have originated about the year 1800, from a cross between a common bantam and a Polish fowl recrossed hen-tailed bantam, and carefully selected. Hence, there can hardly be a doubt that the cyclofeathers and hackles which appeared in the old hen were derived from the Polish fowl or common bantam. And we thus see that not only certain masculine characters proper to the sebright bantam, but other masculine characters derived from the first progenitors of the breed, removed by a period of above 60 years, were lying latent in this henbird, ready to be evolved as soon as her ovaria became diseased. From these several facts, it must be admitted that certain characters, capacities, and instincts may lie latent in an individual, and even in a succession of individuals, without our being able to detect the least sign of their presence when fowls, pigeons, or cattle of different colors are crossed, and their offspring change color as they grow old, or when the crossed turbot acquired the characteristic frill after its third molt, or when rarely bred bantams partially assume the red plumage of their prototype. We cannot doubt that these qualities were from the first present, though latent in the individual animal, like the characters of a moth in the caterpillar. Now, if these animals had produced offspring before they had acquired with advancing age their new characters, nothing is more probable than that they would have transmitted them to some of their offspring, who in this case would in appearance have received such characters from their grandparents or more distant progenitors. We should then have had a case of reversion, that is, of the reappearance in the child of an ancestral character, actually present though during youth completely latent in the parent, and this, we may safely conclude, is what occurs in all reversions to progenitors however remote. This view of the latency in each generation of all the characters which appear through reversion is also supported by their actual presence in some cases during early youth alone, or by their more frequent appearance and greater distinctness at this age than during maturity. We have seen that this is often the case with the stripes on the legs and faces of the several species of the horse genus, the Himalayan rabbit, when crossed sometimes produces offspring which revert to the parent silvergray breed. And we have seen that in purely bred animals pale gray fur occasionally reappears during early youth. Black cats, we may feel assured, would occasionally produce by reversion tabbies, and on young black kittens, with a pedigree 66 known to have been long pure faint. Traces of stripes may almost always be seen, which afterwards disappear. Hornless Suffolk cattle occasionally produce by reversion horned animals, and Youat 67 asserts that even in hornless individuals, the rudiment of a horn may be often felt at an early age. No doubt it appears at first sight in the highest degree improbable that in every horse of every generation there should be a latent capacity and tendency to produce stripes, though these may not appear once in 1,000 generations, that in every white, black, or other colored pigeon which may have transmitted its proper color during centuries, there should be a latent capacity in the plumage to become blue, and to be marked with certain characteristic bars, that in every child in a six-fingered family, there should be the capacity for the production of an additional digit, and so in other cases. Nevertheless, there is no more inherent improbability in this being the case than in a useless and rudimentary organ, or even in only a tendency to the production of a rudimentary organ being inherited during millions of generations, as is well known to occur with a multitude of organic beings. There is no more inherent improbability in each domestic pig during 1,000 generations, retaining the capacity and tendency to develop great tusks under fitting conditions, than in the young calf having retained for an indefinite number of generations rudimentary incisor teeth, which never protrude through the gums. I shall give at the end of the next chapter a summary of the 3 preceding chapters, but as isolated and striking cases of reversion have here been chiefly insisted on, I wish to guard the reader against supposing that reversion is due to some rare or accidental combination of circumstances when a character lost during hundreds of generations suddenly reappears. No doubt some such combination must occur, but reversions to the immediately preceding generations may be constantly observed at least in the offspring of most unions. This has been universally recognized in the case of hybrids and mongrels, but it has been recognized simply from the difference between the united forms, rendering the resemblance of the offspring to their grandparents or more remote progenitors of easy detection. Reversion is likewise almost invariably the rule, as Mr. Sedgwick has shown with certain diseases. Hence, we must conclude that a tendency to this peculiar form of transmission is an integral part of the general law of inheritance. Monstrosities, a large number of monstrous growths and of lesser anomalies, are admitted by everyone to be due to an arrest of development, that is, to the persistence of an embryonic condition, but many monstrosities cannot be thus explained for parts of which no trace can be detected in the embryo, but which occur in other members of the same class of animals, occasionally appear, and these may probably with truth be attributed to reversion, as however I have treated this subject as fully as I could in my Descent of Man, ch. 1 2nd edition, I will not here recur to it. When flowers which have normally an irregular structure become regular or peloric, the change is generally looked at by botanists as a return to the primitive state, but Dr. Maxwell Masters, 68, who has ably discussed this subject, remarks that when, for instance, all the sepals of a tropolum become green and of the same shape, instead of being colored, with one prolonged into a spur, or when all the petals of a linaria become simple and regular, such cases may be due merely to an arrest of development, for in these flowers, all the organs during their earliest condition are symmetrical and, if arrested at this stage of growth, they would not become irregular. If moreover the arrest were to take place at a still earlier period of development, the result would be a simple tuft of green leaves, and no one probably would call this a case of reversion. Dr. Masters designates the cases first alluded to as regular peloria, and others in which all the corresponding parts assume a similar form of irregularity, as when all the petals in a linaria become spurred as irregular peloria, we have no right to attribute these latter cases to reversion until it can be shown that the parent form, for instance of the genus Linaria, had all its petals spurred for a chance of this nature, might result from the spreading of an anomalous structure, in accordance with the law to be discussed in a future chapter of homologous parts, tending to vary in the same manner. But as both forms of peloria frequently occur on the same individual plant of the Linaria 69, they probably stand in some close relation to one another, on the doctrine that peloria is simply the result of an arrest of development. It is difficult to understand how an organ arrested at a very early period of growth should acquire its full functional perfection, how a petal supposed to be thus arrested should acquire its brilliant colors and serve as an envelope to the flower or a stamen produce efficient pollen. Yet this occurs with many peloric flowers, that pelorism is not due to mere chance variability, but either to an arrest of development or to reversion. We may infer from an observation made by C.H. Morin 70, namely, that families which have irregular flowers often return by these monstrous growths to their regular form, whilst we never see a regular flower realize the structure of an irregular one. Some flowers have almost certainly become more or less completely peloric through reversion, as the following interesting case shows. Corydalus tuberosa, properly, has one of its two nectaries colorless, destitute of nectar, only half the size of the other, and therefore to a certain extent in a rudimentary state. The pistil is curved towards the perfect nectary, and the hood formed of the inner petals slips off the pistil and stamen in one direction alone, so that when a bee sucks the perfect nectary, the stigma and stamens are exposed and rubbed against the insect's body. In several closely allied genera, as in Delytra etc., there are two perfect nectaries. The pistil is straight and the hood slips off on either side according as the bee sucks either nectary. Now, I have examined several flowers of Corydalus tuberosa, in which both nectaries were equally developed and contained nectar. In this, we see only the redevelopment of a partially aborted organ. But with this redevelopment, the pistil becomes straight and the hood slips off in either direction, so that these flowers have acquired the perfect structure so well adapted for insect agency of Delytra and its allies. We cannot attribute these co-adapted modifications to chance or to correlated variability. We must attribute them to reversion to a primordial condition of the species. The peloric flowers of Pelargonium have their 5 petals in all respects alike, and there is no nectary, so that they resemble the symmetrical flowers of the closely allied genus Geranium, but the alternate stamens are also sometimes destitute of anthers, the short filaments being left as rudiments, and in this respect, they resemble the symmetrical flowers of the closely allied genus Erodium. Hence, we may look at the peloric flowers of Pelargonium as having reverted to the state of some primordial form, the progenitor of the 3 closely related genera of Pelargonium, Geranium, and Erodium. In the peloric form of Antirrhinum majus, appropriately called the wonder, the tubular and elongated flowers differ wonderfully from those of the common snapdragon, the calyx, and the mouth of the corolla consist of 6 equal lobes, and include 6 equal, instead of 4 unequal stamens. One of the 2 additional stamens is manifestly formed by the development of a microscopically minute papilla, which may be found at the base of the upper lip of the flower of the common snapdragons. In the 19 plants examined by me, that this papilla is a rudiment of a stamen was well shown by its various degrees of development in crossed plants between the common and the peloric Antirrhinum. Again, a peloric Galebdolin luteum, growing in my garden, had 5 equal petals all striped like the ordinary lower lip, and included 5 equal instead of 4 unequal stamens. But Mr. R. Keeley, who sent me this plant, informs me that the flowers vary greatly, having from 4 to 6 lobes to the corolla, and from 3 to 6 stamens. 71 Now, as the members of the 2 great families, to which the Antirrhinum and Galebdolin belong, are properly pentamerous with some of the parts confluent, and others suppressed, we ought not to look at the 6th stamen and the 6th lobe to the corolla in either case as due to reversion any more than the additional petals in double flowers in these same 2 families. But the case is different with the 5th stamen in the peloric Antirrhinum, which is produced by the redevelopment of a rudiment always present and which probably reveals to us the state of the flower as far as the stamens are concerned at some ancient epoch. It is also difficult to believe that the other 4 stamens and the petals, after an arrest of development at a very early embryonic age, would have come to full perfection in color, structure, and function, unless these organs had at some former period normally passed through a similar course of growth. Hence, it appears to me probable that the progenitor of the genus Antirrhinum must at some remote epoch have included 5 stamens and borne flowers in some degree resembling those now produced by the peloric form. The conclusion that Peloria is not a mere monstrosity irrespective of any former state of the species is supported by the fact that this structure is often strongly inherited, as in the case of the peloric Antirrhinum and Gloxinia, and sometimes in that of the peloric Corydalus solida, 72. Lastly, I may add that many instances have been recorded of flowers, not generally considered as peloric, in which certain organs are abnormally augmented in number, as an increase of parts cannot be looked at as an arrest of development, nor as due to the redevelopment of rudiments, for no rudiments are present. And as these additional parts bring the plant into closer relationship with its natural allies, they ought probably to be viewed as reversions to a primordial condition. These several facts show us in an interesting manner how intimately certain abnormal states are connected together, namely arrests of development, causing parts to become rudimentary, or to be wholly suppressed. Redevelopment of parts, now, in a more or less rudimentary condition. Reappearance of organs of which not a vestige can be detected, and to these may be added in the case of animals the presence during youth and subsequent disappearance of certain characters which occasionally are retained throughout life. Some naturalists look at all such abnormal structures as a return to the ideal state of the group to which the affected being belongs, but it is difficult to conceive what is meant to be conveyed by this expression. Other naturalists maintain with greater probability and distinctness of view that the common bond of connection between the several foregoing cases is an actual, though partial, return to the structure of the ancient progenitor of the group. If this view be correct, we must believe that a vast number of characters capable of evolution lie hidden in every organic being. But it would be a mistake to suppose that the number is equally great in all beings. We know, for instance, that plants of many orders occasionally become peloric, but many more cases have been observed in the Labiat and Scrophulariaceae than in any other order, and in one genus of the Scrophulariaceae, namely Linaria, no less than 13 species have been described in this condition. 73. On this view of the nature of peloric flowers, and bearing in mind certain monstrosities in the animal kingdom, we must conclude that the progenitors of most plants and animals have left an impression capable of redevelopment on the germs of their descendants, although these have since been profoundly modified. The fertilized germ of one of the higher animals subjected, as it is to so vast a series of changes from the germinal cell, to old age incessantly agitated, by what Quatrefages well calls the turbilin vitalis, perhaps the most wonderful object in nature, it is probable that hardly a change of any kind affects either parent, without some mark being left on the germ. But on the doctrine of reversion, as given in this chapter, the germ becomes a far more marvelous object, for besides the visible changes which it undergoes, we must believe that it is crowded with invisible characters, proper to both sexes, to both the right and left side of the body, and to a long line of male and female ancestors, separated by hundreds or even thousands of generations from the present time, and these characters, like those written on paper with invisible ink, lie ready to be evolved whenever the organization is disturbed by certain known or unknown conditions. References: Chapter Roman 14, Inheritance continued fixedness of character prepotential limitation correspondence of age. Fixedness of character, apparently not due to antiquity of initen separopotency of transmission, in individuals of the same family in crossed breeds and species, often stronger in one sex than the other, sometimes, due to the same character being present and visible in one breed, and latent in the other inheritance, as limited by sexually acquired characters in our domesticated animals, often transmitted by one sex alone, sometimes lost by one sex alone inheritance, at corresponding periods of life. Importance of the principle, with respect to embryology, as exhibited in domesticated animals, as exhibited in the appearance and disappearance of inherited diseases, sometimes supervening earlier in the child than in the parent. Summary of the 3 preceding chapters. In the last 2 chapters, the nature and force of inheritance, the circumstances which interfere with its power, and the tendency to reversion with its many remarkable contingencies, were discussed. In the present chapter, some other related phenomena will be treated of as fully as my materials permit. Fixedness of character. It is a general belief amongst breeders that the longer any character has been transmitted by a breed, the more fully it will continue to be transmitted. I do not wish to dispute the truth of the proposition that inheritance gains strength simply through long continuance, but I doubt whether it can be proved in one sense. The proposition is little better than a truism. If any character has remained constant during many generations, it will be likely to continue, so if the conditions of life remain the same so. Again, in improving a breed, if care be taken for a length of time, to exclude all inferior individuals, the breed will obviously tend to become truer, as it will not have been crossed during many generations by an inferior animal we have previously seen, but without being able to assign any cause that when a new character appears, it is occasionally from the first constant or fluctuates much or wholly fails to be transmitted. So it is with the aggregate of slight differences, which characterize a new variety for some, propagate their kind from the first much truer than others, even with plants multiplied by bulbs, layers, etc., which may in one sense be said to form parts of the same individual. It is well known that certain varieties retain and transmit through successive generations their newly acquired characters more truly than others. In none of these nor in the following cases does there appear to be any relation between the force with which a character is transmitted and the length of time during which it has been transmitted. Some varieties, such as white and yellow hyacinths and white sweetpeas, transmit their colors more faithfully than do the varieties which have retained their natural color in the Irish family mentioned in the 12th chapter. The peculiar tortoiseshell-like coloring of the eyes was transmitted far more faithfully than any ordinary color. Ancon and Mauchamp sheep and Niota cattle, which are all comparatively modern breeds, exhibit remarkably strong powers of inheritance. Many similar cases could be adduced. As all domesticated animals and cultivated plants have varied, and yet are descended from aboriginally wild forms, which no doubt had retained the same character from an immensely remote epoch, we see that scarcely any degree of antiquity ensures a character being transmitted perfectly true. In this case, however, it may be said that changed conditions of life induce certain modifications, and not that the power of inheritance fails, but in every case of failure, some cause, either internal or external, must interfere. It will generally be found that the organs or parts which in our domesticated productions have varied, or which still continue to vary, that is, which fail to retain their former state, are the same with the parts which differ in the natural species of the same genus. As on the theory of descent with modification, the species of the same genus have been modified since they branched off from a common progenitor, it follows that the characters by which they differ from one another have varied, whilst other parts of the organization have remained unchanged, and it might be argued that these same characters now vary under domestication or fail to be inherited from their lesser antiquity, but variation in a state of nature seems to stand in some close relation with changed conditions of life, and characters, which have already varied under such conditions, would be apt to vary under the still greater changes consequent on domestication, independently of their greater or less antiquity. Fixedness of character, or the strength of inheritance, has often been judged of by the preponderance of certain characters in the crossed offspring between distinct races, but prepotency of transmission here comes into play, and this, as we shall immediately see, is a very different consideration from the strength or weakness of inheritance. One, it has often been observed that breeds of animals inhabiting wild and mountainous countries cannot be permanently modified by our improved breeds, and as these latter are of modern origin, it has been thought that the greater antiquity of the wilder breeds has been the cause of their resistance to improvement by crossing, but it is more probably due to their structure and constitution being better adapted to the surrounding conditions. When plants are first subjected to culture, it has been found that during several generations they transmit their characters truly, that is, do not vary, and this has been attributed to ancient characters being strongly inherited. But it may with equal or greater probability be consequent on changed conditions of life, requiring a long time for their cumulative action. Notwithstanding these considerations, it would perhaps be rash to deny that characters become more strongly fixed the longer they are transmitted. But I believe that the proposition resolves itself into this: that characters of all kinds, whether new or old, tend to be inherited, and that those which have already withstood all counteracting influences and been truly transmitted will, as a general rule, continue to withstand them, and consequently be faithfully inherited. Prepotency in the transmission of character. When individuals belonging to the same family but distinct enough to be recognized, or when two well-marked races or two species are crossed, the usual result, as stated in the previous chapter, is that the offspring in the first generation are intermediate between their parents, or resemble one parent in one part and the other parent in another part. But this is by no means the invariable rule, for in many cases it is found that certain individuals' races and species are prepotent in transmitting their likeness. This subject has been ably discussed by Prosper Lucas too, but is rendered extremely complex by the prepotency, sometimes running equally in both sexes, and sometimes more strongly in one sex than in the other. It is likewise complicated by the presence of secondary sexual characters, which render the comparison of crossed breeds with their parents difficult. It would appear that in certain families some one ancestor, and after him others in the same family, have had great power in transmitting their likeness through the male line, for we cannot otherwise understand how the same features should so often be transmitted after marriages with many females, as in the case of the Austrian emperors. And so it was according to Niebuhr with the mental qualities of certain Roman families. 3. The famous bull favorite is believed to have had a prepotent influence on the shorthorn race. It has also been observed 5 with English racehorses that certain mares have generally transmitted their own character, whilst other mares of equally pure blood have allowed the character of the sire to prevail. A famous black greyhound Bedlamite, as I hear from Mr. Roman 100 Roman 1000 Brown, invariably got all his puppies black no matter what was the color of the bitch. But then Bedlamite had a preponderance of black in his blood, both on the sire and dam side. The truth of the principle of prepotency comes out more clearly when distinct races are crossed. The improved shorthorns, notwithstanding that the breed is comparatively modern, are generally acknowledged to possess great power in impressing their likeness on all other breeds, and it is chiefly in consequence of this power that they are so highly valued for exportation. 6. Godin has given a curious case of a ram of a goat-like breed of sheep from the Cape of Good Hope, which produced offspring hardly to be distinguished from himself when crossed with ewes of 12 other breeds. But 2 of these half-bred ewes, when put to a merino ram, produced lambs closely resembling the merino breed Giroux de Buzerings. 7. Found that of 2 races of French sheep, the ewes of one when crossed during successive generations with merino rams yielded up their character far sooner than the ewes of the other race. Sturm and Giroux have given analogous cases with other breeds of sheep, and with cattle the prepotency running in these cases through the male side. But I was assured on good authority in South America that when Niota cattle are crossed with common cattle, though the Niota breed is prepotent whether males or females are used, yet that the prepotency is strongest through the female line. The Manx cat is tailless and has long hind legs. Dr. Wilson crossed a male Manx with common cats, and out of 23 kittens 17 were destitute of tails. But when the female Manx was crossed by common male cats, all the kittens had tails, though they were generally short and imperfect. 8. In making reciprocal crosses between pouter and fantail pigeons, the pouterists seem to be prepotent through both sexes over the fantail. But this is probably due to weak power in the fantail, rather than to any unusually strong power in the pouter, for I have observed that barbs also preponderate over fantails. This weakness of transmission in the fantail, though the breed is an ancient one, is said to be general. But I have observed one exception to the rule, namely in a cross between a fantail and Laffer. The most curious instance known to me of weak power in both sexes is in the trumpeter pigeon. This breed has been well known for at least 130 years. It breeds perfectly true, as I have been assured by those who have long kept many birds. It is characterized by a peculiar tuft of feathers over the beak, by crest on the head, by a singular coo, quite unlike that of any other breed, and by much feathered feet. I have crossed both sexes with turbits of 2 subbreeds with almond tumblers, spots, and runts, and reared many mongrels and recrossed them. And though the crest on the head and feathered feet were inherited, as is generally the case with most breeds, I have never seen a vestige of the tuft over the beak, or heard the peculiar coo. Boitard and Corby 10 assert that this is the invariable result of crossing trumpeters with other breeds. Neumeister 11, however, states that in Germany mongrels have been obtained, though very rarely, which were furnished with the tuft and would trumpet, but a pair of these mongrels with a tuft, which I imported, never trumpeted. Mr. Brent states 12, that the crossed offspring of a trumpeter were crossed with trumpeters for 3 generations, by which time the mongrels had 78 ths of this blood in their veins, yet the tuft over the beak did not appear at the fourth generation. The tuft appeared, but the birds, though now having 1,516 ths trumpeter's blood, still did not trumpet this. Case well shows the wide difference between inheritance and prepotency, for here we have a well-established old race, which transmits its characters faithfully, but which when crossed with any other race, has the feeblest power of transmitting its two chief characteristic qualities. I will give one other instance with fowls and pigeons of weakness and strength, in the transmission of the same character to their crossed offspring. The silk fowl breeds true, and there is reason to believe is a very ancient race, but when I reared a large number of mongrels from a silk hen by a Spanish cock, not one exhibited even a trace of the so-called silkiness. Mr. Hewitt also asserts that in no instance are the silky feathers transmitted by this breed, when crossed with any other variety but 3 birds out of many raised by Mr. Orton, from a cross between a silk cock and a bantam hen had silky feathers 13, so that it is certain that this breed very seldom has the power of transmitting its peculiar plumage to its crossed progeny. On the other hand, there is a silk subvariety of the fantail pigeon which has its feathers in nearly the same state as in the silk fowl. Now, we have already seen that fantails, when crossed, possess singularly weak power in transmitting their general qualities, but the silk subvariety, when crossed with any other small-sized race, invariably transmits its silky feathers 14. The well-known horticulturist Mr. Paul informs me that he fertilized the black prince hollyhock with pollen of the white globe, and the lemonade and black prince hollyhocks reciprocally, but not one seedling from these 3 crosses inherited the black color of the black prince. So again, Mr. Laxton, who has had such great experience in crossing peas, writes to me that whenever a cross has been effected between a white-blossomed and a purple-blossomed pea, or between a white-seeded and a purple-spotted brown or maple-seeded pea, the offspring seems to lose nearly all the characteristics of the white-flowered and white-seeded varieties, and this result follows whether these varieties have been used as the pollen-bearing or seed-producing parents. The law of prepotency comes into action when species are crossed, as with races and individuals. Gartner has unequivocally shown 15 that this is the case with plants. To give one instance, when Nicotiana paniculata and Vincflora are crossed, the character of N. paniculata is almost completely lost in the hybrid, but if N. quadrivalvis be crossed with N. Vincflora, this latter species, which was before so prepotent, now in its turn almost disappears under the power of N. quadrivalvis. It is remarkable that the prepotency of one species over another in transmission is quite independent, as shown by Gartner, of the greater or less facility with which the one fertilizes the other. With animals, the jackal is prepotent over the dog, as is stated by Flowerens, who made many crosses between these animals. And this was likewise the case with a hybrid which I once saw between a jackal and a terrier. I cannot doubt from the observations of Collin and others that the ass is prepotent over the horse, the prepotency in this instance running more strongly through the male than through the female ass, so that the mule resembles the ass more closely than does the hinny. 16. The male pheasant, judging from Mr. Hewitt's descriptions. 17. And from the hybrids which I have seen, preponderates over the domestic fowl, but the latter, as far as color is concerned, has considerable power of transmission, for hybrids raised from 5 differently colored hens differed greatly in plumage. I formerly examined some curious hybrids in the zoological gardens between the penguin variety of the common duck and the Egyptian goose, answered Gyptiacus, and although I will not assert that the domesticated variety preponderated over the natural species, yet it had strongly impressed its unnatural upright figure on these hybrids. I am aware that such cases as the foregoing have been ascribed by various authors, not to one species, race, or individual being prepotent over the other, in impressing its character on its crossed offspring, but to such rules as that the father influences the external characters, and the mother the internal or vital organs. But the great diversity of the rules given by various authors almost proves their falseness. Dr. Prosper Lucas has fully discussed this point, and has shown 18 that none of the rules, and I could add others to those quoted by him, apply to all animals. Similar rules have been announced for plants, and have been proved by Gartner. 19 to be all erroneous. If we confine our view to the domesticated races of a single species, or perhaps even to the species of the same genus, Some such rules may hold good. For instance, it seems that in reciprocally crossing various breeds of fowls, the male generally gives color 20, but conspicuous exceptions have passed under my own eyes. It seems that the ram usually gives its peculiar horns and fleece to its crossed offspring, and the bull the presence or absence of horns. In the following chapter on crossing, I shall have occasion to show that certain characters are rarely or never blended by crossing, but are transmitted in an unmodified state from either parent form. I refer to this fact here because it is sometimes accompanied on the one side by prepotency, which thus acquires the false appearance of unusual strength. In the same chapter 1 shall show that the rate at which a species or breed absorbs and obliterates another by repeated crosses depends in chief part on prepotency in transmission. In conclusion, some of the cases above given, for instance that of the trumpeter pigeon, prove that there is a wide difference between mere inheritance and prepotency. This latter power seems to us, in our ignorance, to act in most cases quite capriciously. The very same character, even though it be an abnormal or monstrous one, such as silky feathers, may be transmitted by different species, when crossed either with prepotent force or singular feebleness. It is obvious that a purulibrid form of either sex, in all cases in which prepotency does not run more strongly in one sex than the other, will transmit its character with prepotent force over a mongrelized and already variable form. 21. From several of the above given cases, we may conclude that mere antiquity of character does not by any means necessarily make it prepotent. In some cases, prepotency apparently depends on the same character being present and visible in one of the two breeds, which are crossed, and latent or invisible in the other breed. And in this case, it is natural that the character which is potentially present in both breeds should be prepotent. Thus, we have reason to believe that there is a latent tendency in all horses to be dun-colored and striped, and when a horse of this kind is crossed with one of any other color, it is said that the offspring are almost sure to be striped. Sheep have a similar latent tendency to become dark-colored, and we have seen with what prepotent force a ram with a few black spots, when crossed with white sheep of various breeds, colored its offspring. All pigeons have a latent tendency to become slatablue with certain characteristic marks, and it is known that when a bird thus colored is crossed with one of any other color, it is most difficult afterwards to eradicate the blue tint. A nearly parallel case is offered by those black bantams which, as they grow old, develop a latent tendency to acquire red feathers, but there are exceptions to the rule. Hornless breeds of cattle possess a latent capacity to reproduce horns, yet when crossed with horned breeds, they do not invariably produce offspring bearing horns. We meet with analogous cases with plants. Striped flowers, though they can be propagated truly by seed, have a latent tendency to become uniformly colored, but when once crossed by a uniformly colored variety, they ever afterwards fail to produce striped seedlings. 22. Another case is in some respects more curious. Plants bearing peloric flowers have so strong a latent tendency to reproduce their normally irregular flowers that this often occurs by buds when a plant is transplanted into poorer or richer soil. 23. Now, I crossed the peloric snapdragon Antirrhinum majus, described in the last chapter, with pollen of the common form, and the latter reciprocally with peloric pollen. I thus raised two great beds of seedlings, and not one was peloric nodon. 24. Obtained the same result from crossing a peloric linaria with the common form. I carefully examined the flowers of 90 plants of the crossed Antirrhinum in the two beds, and their structure had not been in the least affected by the cross, except that in a few instances, the minute rudiment of the fifth stamen, which is always present, was more fully or even completely developed. It must not be supposed that this entire obliteration of the peloric structure in the crossed plants can be accounted for by any incapacity of transmission, for I raised a large bed of plants from the peloric Antirrhinum, artificially fertilized by its own pollen, and 16 plants, which alone survived the winter, were all as perfectly peloric as the parent plant. Here we have a good instance of the wide difference between the inheritance of a character and the power of transmitting it to crossed offspring. The crossed plants, which perfectly resembled the common snapdragon, were allowed to sow themselves, and out of 127 seedlings, 88 proved to be common snapdragons. 2 were in an intermediate condition between the peloric and normal state, and 37 were perfectly peloric, having reverted to the structure of their one grandparent. This case seems at first sight to offer an exception to the rule just given, namely, that a character which is present in one form and latent in the other is generally transmitted with prepotent force, when the two forms are crossed for in all the Scrophulariaceae and especially in the genera Antirrhinum and Linaria, there is, as was shown in the last chapter, a strong latent tendency to become peloric. But there is also, as we have seen, a still stronger tendency in all peloric plants to reacquire their normal irregular structure, so that we have two opposed latent tendencies in the same plants now with the crossed antirrhinums, the tendency to produce normal or irregular flowers like those of the common snapdragon prevailed in the first generation, whilst the tendency to pelorism, appearing to gain strength by the intermission of a generation, prevailed to a large extent in the second set of seedlings. How it is possible for a character to gain strength by the intermission of a generation will be considered in the chapter on pangenesis. On the whole, the subject of prepotency is extremely intricate from its varying so much in strength, even in regard to the same character in different animals from its running either equally in both sexes, or as frequently is the case with animals, but not with plants much stronger in one sex than the other from the existence of secondary sexual characters from the transmission of certain characters being limited, as we shall immediately see by sex from certain characters, not blending togethorand, perhaps occasionally, from the effects of a previous fertilization on the mother. It is therefore not surprising that no one has hitherto succeeded in drawing up general rules on the subject of prepotency. Inheritance as limited by sex. New characters often appear in one sex, and are afterwards transmitted to the same sex either exclusively or in a much greater degree than to the other. This subject is important because with animals of many kinds in a state of nature, both high and low, in the scale secondary sexual characters, not directly connected with the organs of reproduction, are conspicuously present with our domesticated animals. Characters of this kind often differ widely from those distinguishing the two sexes of the parent species, and the principle of inheritance, as limited by sex, explains how this is possible. Dr. P. Lucas has shown 25 that when a peculiarity in no manner connected with the reproductive organs appears in either parent, it is often transmitted exclusively to the offspring of the same sex, or to a much greater number of them than of the opposite sex. Thus, in the family of Lambert, the horn-like projections on the skin were transmitted from the father to his sons and grandsons alone. So it has been with other cases of ichthyosis, with supernumerary digits, with a deficiency of digits, and phalanges, and in a lesser degree with various diseases, especially with colorblindness, and the hemorrhagic diathesis, that is an extreme liability to profuse and uncontrollable bleeding. From trifling wounds, on the other hand, mothers have transmitted during several generations to their daughters alone supernumerary and deficient digits, colorblindness, and other peculiarities, so that the very same peculiarity may become attached to either sex, and be long inherited by that sex alone. But the attachment in certain cases is much more frequent to one than the other sex. The same peculiarities also may be promiscuously transmitted to either sex. Dr. Lucas gives other cases showing that the male occasionally transmits his peculiarities to his daughters alone and the mother to her sons alone. But even in this case, we see that inheritance is to a certain extent, though inversely regulated by sex. Dr. Lucas, after weighing the whole evidence, comes to the conclusion that every peculiarity tends to be transmitted in a greater or lesser degree to that sex in which it first appears, but a more definite rule, as I have elsewhere shown, 26, generally holds good, namely that variations which first appear in either sex at a late period of life, when the reproductive functions are active, tend to be developed in that sex alone, whilst variations which first appear early in life in either sex are commonly transmitted to both sexes. I am, however, far from supposing that this is the sole determining cause. A few details from the many cases collected by Mr. Sedgwick 27 may be here given. Colorblindness from some unknown cause shows itself much oftener in males than in females in upwards of 200 cases collected by Mr. Sedgwick 19 related to men, but it is eminently liable to be transmitted through women. In the case given by Dr. Earle, members of 8 related families were affected during 5 generations. These families consisted of 61 individuals, namely of 32 males, of whom 9/16 were incapable of distinguishing color, and of 29 females, of whom only 1/15 were thus affected. Although colorblindness thus generally clings to the male sex, nevertheless, in one instance, in which it first appeared in a female, It was transmitted during 5 generations to 13 individuals, all of whom were females. The hemorrhagic diathesis, often accompanied by rheumatism, has been known to affect the males alone during 5 generations, being transmitted, however, through the females. It is said that deficient phalanges in the fingers have been inherited by the females alone during 10 generations. In another case, a man thus deficient in both hands and feet transmitted the peculiarity to his 2 sons and 1 daughter. But in the 3rd generation out of 19 grandchildren, 12 sons had the family defect, whilst the 7 daughters were free. In ordinary cases of sexual limitation, the sons or daughters inherit the peculiarity, whatever it may be, from their father or mother, and transmit it to their children of the same sex, but generally with the hemorrhagic diathesis, and often with colorblindness, and in some other cases the sons never inherit the peculiarity directly from their fathers, but the daughters alone transmit the latent tendency, so that the sons of the daughters alone exhibit it. Thus the father, grandson, and great-great-grandson will exhibit a peculiaritith grandmother, daughter, and great-granddaughter, having transmitted it in a latent state. Hence, we have, as Mr. Sedgwick remarks, a double kind of atavism, or reversion, each grandson apparently receiving and developing the peculiarity from his grandfather, and each daughter apparently receiving the latent tendency from her grandmother. From the various facts recorded by Dr. Prosper Lucas, Mr. Sedgwick, and others, there can be no doubt that peculiarities first appearing in either sex, though not in any way necessarily or invariably connected with that sex, strongly tend to be inherited by the offspring of the same sex, but are often transmitted in a latent state through the opposite sex. Turning now to domesticated animals, we find that certain characters not proper to the parent species are often confined to and inherited by one sex alone, but we do not know the history of the first appearance of such characters. In the chapter on sheep, we have seen that the males of certain races differ greatly from the females in the shape of their horns. These being absent in the ewes of some breeds, they differ also in the development of fat in the tail, and in the outline of the forehead. These differences, judging from the character of the allied wild species, cannot be accounted for by supposing that they have been derived from distinct parent forms. There is also a great difference between the horns of the 2 sexes in one Indian breed of goats. The bull zebu is said to have a larger hump than the cow. In the Scotch deerhound, the 2 sexes differ in size more than in any other variety of the dog. 28. And judging from analogy, more than in the aboriginal parent species. The peculiar color called tortoiseshell is very rarely seen in a male cat, the males of this variety being of a rusty tint. In various breeds of the fowl, the males and females often differ greatly, and these differences are far from being the same with those which distinguish the 2 sexes of the parent species, the Gallus bancova, and consequently have originated under domestication. In certain subvarieties of the game race, we have the unusual case of the hens, differing from each other more than the cocks. In an Indian breed of a white color shaded with black, the hens invariably have black skins, and their bones are covered by a black periosteum, whilst the cocks are never or most rarely thus characterized. Pigeons offer a more interesting case, for throughout the whole great family, the 2 sexes do not often differ much, and the males and females of the parent form, the Roman 100 Livia, are undistinguishable. Yet we have seen that with pouters, the male has the characteristic quality of pouting more strongly developed than the female, and in certain subvarieties the males alone are spotted or striated with black or otherwise differ in color. When male and female English carrier pigeons are exhibited in separate pens, the difference in the development of the wattle over the beak and round the eyes is conspicuous, so that here we have instances of the appearance of secondary sexual characters in the domesticated races of a species in which such differences are naturally quite absent. On the other hand, secondary sexual characters, which belong to the species in a state of nature, are sometimes quite lost or greatly diminished under domestication. We see this in the small size of the tusks in our improved breeds of the pig. In comparison with those of the wild boar, there are subbreeds of fowls in which the males have lost the fine-flowing tail feathers and hackles, and others in which there is no difference in color between the 2 sexes. In some cases, the barred plumage, which in gallinaceous birds is commonly the attribute of the hen, has been transferred to the cock. As in the cuckoo subbreeds, in other cases, masculine characters have been partly transferred to the female, as with the splendid plumage of the golden-spangled Hamburg hen, the enlarged comb of the Spanish hen, the pugnacious disposition of the game hen, And as in the well-developed spurs, which occasionally appear in the hens of various breeds in Polish fowls, both sexes are ornamented with a topknot, that of the male being formed of hackle-like feathers. And this is a new male character. In the genus Gallus on the whole, as far as I can judge, new characters are more apt to appear in the males of our domesticated animals than in the females 29 and afterwards, to be inherited exclusively or more strongly by the males, finally in accordance with the principle of inheritance, as limited by sex. The preservation and augmentation of secondary sexual characters in natural species offers no especial difficulty, as this would follow through that form of selection, which I have called sexual selection. Inheritance at corresponding periods of life. This is an important subject. Since the publication of my Origin of Species, I have seen no reason to doubt the truth of the explanation there given of one of the most remarkable facts in biology, namely the difference between the embryo and the adult animal. The explanation is that variations do not necessarily or generally occur at a very early period of embryonic growth, and that such variations are inherited at a corresponding age. As a consequence of this, the embryo, even after the parent form has undergone great modification, is left only slightly modified, and the embryos of widely different animals, which are descended from a common progenitor, remain in many important respects like one another, and probably like their common progenitor. We can thus understand why embryology throws a flood of light on the natural system of classification, as this ought to be as far as possible genealogical. When the embryo leads an independent life, that is, becomes a larva, it has to be adapted to the surrounding conditions in its structure and instincts independently of those of its parents, and the principle of inheritance at corresponding periods of life renders this possible. This principle is indeed in one way so obvious that it escapes attention. We possess a number of races of animals and plants, which when compared with one another, and with their parent forms, present conspicuous differences, both in their immature and mature states. Look at the seeds of the several kinds of peas, beans, maize, which can be propagated truly, and see how they differ in size, color, and shape, whilst the full-grown plants differ but little. Cabbages, on the other hand, differ greatly in foliage and manner of growth, but hardly at all in their seeds. And generally, it will be found that the differences between cultivated plants at different periods of growth are not necessarily closely connected together, for plants may differ much in their seeds and little when full-grown, and conversely, may yield seeds hardly distinguishable, yet differ much when full-grown. In the several breeds of poultry descended from a single species, differences in the eggs and chickens, whilst covered with down in the plumage, at the first and subsequent molts, as well as in the comb and wattles, are all inherited with man. Peculiarities in the milk and second teeth of which I have received the details are inheritable, and longevity is often transmitted. So again, with our improved breeds of cattle and sheep, early maturity, including the early development of the teeth, and with certain breeds of fowl, the early appearance of secondary sexual characters, all come under the same head of inheritance at corresponding periods. Numerous analogous facts could be given. The silkmoth, perhaps, offers the best instance, for in the breeds which transmit their characters truly the eggs differ in size, color, and shape. The caterpillars differ in molting 3 or 4 times in color, even in having a dark-colored mark like an eyebrow, and in the loss of certain instincts. Cocoons differ in size, shape, and in the color and quality of the silk, these several differences being followed by slight or barely distinguishable differences in the mature moth. But it may be said that if in the above cases a new peculiarity is inherited, it must be at the corresponding stage of development. For an egg or seed can resemble only an egg or seed, and the horn in a full-grown ox can resemble only a horn. The following cases show inheritance at corresponding periods more plainly, because they refer to peculiarities which might have supervened as far as we can see earlier or later in life, yet are inherited at the same period at which they first appeared. In the Lambert family, the porcupine-like excrescences appeared in the father and sons at the same age, namely about 9 weeks after birth. 30. In the extraordinary hairy family, described by Mr. Crawford, 31 children were produced during 3 generations with hairy ears in the father. The hair began to grow over his body at 6 years old in his daughter somewhat earlier, namely at 1 year, and in both generations the milk teeth appeared late in life, the permanent teeth being afterwards singularly deficient. Grayness of hair, at an unusually early age, has been transmitted in some families. These cases border on diseases inherited at corresponding periods of life, to which I shall immediately refer. It is a well-known peculiarity with almond tumbler pigeons that the full beauty and peculiar character of the plumage does not appear until the bird has molted 2 or 3 times. Neumeister describes and figures a brace of pigeons in which the whole body is white, except the breast, neck, and head. But in their first plumage, all the white feathers have colored edges. Another breed is more remarkable. Its first plumage is black with rusted wing bars and a crescent-shaped mark on the breast. These marks then become white and remain so during 3 or 4 molts. But after this period, the white spreads over the body, and the bird loses its beauty. 32 prize canary birds have their wings and tail black. This color, however, is only retained until the first molt, so that they must be exhibited ere the change takes place. Once molted, the peculiarity has ceased. Of course, all the birds emanating from this stock have black wings and tails. The first year. 33. A curious and somewhat analogous account has been given. 34 of a family of wild-pied rooks, which were first observed in 1798 near Chaffont, and which every year from that date up to the period of the published notice, viz. 1837, have several of their brood parti-colored black and white. This variegation of the plumage, however, disappears with the first molt. But among the next young families, there are always a few pied ones. These changes of plumage, which are inherited at various corresponding periods of life in the pigeon, canary bird, and rook, are remarkable because the parent species passes through no such change. Inherited diseases afford evidence in some respects of less value than the foregoing cases, because diseases are not necessarily connected with any change in structure, but in other respects of more value, because the periods have been more carefully observed. Certain diseases are communicated to the child, apparently by a process like inoculation, and the child is from the first affected. Such cases may be here passed over. Large classes of diseases usually appear at certain ages, such as St. Vitus dance in youth, consumption in early midlife, gout later, and apoplexy still later, and these are naturally inherited at the same period. But even in diseases of this class, instances have been recorded, as with St. Vitus dance, showing that an unusually early or late tendency to the disease is inheritable. 35. In most cases, the appearance of any inherited disease is largely determined by certain critical periods in each person's life, as well as by unfavorable conditions. There are many other diseases which are not attached to any particular period, but which certainly tend to appear in the child at about the same age at which the parent was first attacked. An array of high authorities, ancient and modern, could be given in support of this proposition. The illustrious Hunter believed in it, and Piori 36 cautions the physician to look closely to the child at the period when any grave inheritable disease attacked the parent. Dr. Prosper Lucas 37, after collecting facts from every source, asserts that affections of all kinds, though not related to any particular period of life, tend to reappear in the offspring at whatever period of life they first appeared in the progenitor. As the subject is important, it may be well to give a few instances simply as illustrations, not as proof, for proof recourse must be had to the authorities above quoted. Some of the following cases have been selected for the sake of showing that when a slight departure from the rule occurs, the child is affected somewhat earlier in life than the parent. In the family of Lecomte, blindness was inherited through 3 generations, and no less than 27 children and grandchildren were all affected. At about the same age, their blindness in general began to advance about the 15th or 16th year, and ended in total deprivation of sight at the age of about 22. 38. In another case, a father and his 4 children all became blind at 21 years old. In another, a grandmother grew blind at 35, her daughter at 19, and 3 grandchildren at the ages of 13 and 11. 39. So with deafness, 2 brothers, their father and paternal grandfather, all became deaf at the age of 40. Esquirol gives several striking instances of insanity coming on at the same age, as that of a grandfather, father, and son, who all committed suicide near their 50th year. Many other cases could be given as of a whole family who became insane at the age of 40. 41. Other cerebral affections sometimes follow the same rule. For instance, epilepsy and apoplexy. A woman died of the latter disease when 6 to 3 years old, one of her daughters at 4 to 3, and the other at 6 to 7. The latter had 12 children, who all died from tubercular meningitis. 42. I mention this latter case because it illustrates a frequent occurrence, namely a change in the precise nature of an inherited disease, though still affecting the same organ. Asthma has attacked several members of the same family, When 40 years old and other families during infancy, the most different diseases such as angina pectoris, stone in the bladder, and various affections of the skin have appeared in successive generations. At nearly the same age, the little finger of a man began from some unknown cause to grow inwards, and the same finger in his two sons began at the same age to bend inwards in a similar manner. Strange and inexplicable neuralgic affections have caused parents and children to suffer agonies at about the same period of life. 43. I will give only two other cases, which are interesting as illustrating the disappearance, as well as the appearance of disease at the same age. Two brothers, their father, their paternal uncles, 7 cousins, and their paternal grandfather were all similarly affected by a skindisease called pityriasis versicolor, the disease strictly limited to the males of the family, though transmitted through the females, usually appeared at puberty and disappeared at about the age of 40 or 45 years. The second case is that of 4 brothers who, when about 12 years old, suffered almost every week from severe headaches, which were relieved only by a recumbent position in a dark room. Their father, paternal uncles, paternal grandfather, and granduncles all suffered in the same way from headaches, which ceased at the age of 54 or 55. In all those who lived so long, none of the females of the family were affected. 40. It is impossible to read the foregoing accounts, and the many others which have been recorded of diseases coming on during 3 or even more generations in several members of the same family at the same age, especially in the case of rare affections, in which the coincidence cannot be attributed to chance, and to doubt that there is a strong tendency to inheritance in disease at corresponding periods of life. When the rule fails, the disease is apt to come on earlier in the child than in the parent, the exceptions in the other direction being very much rarer. Dr. Lucas, 45, alludes to several cases of inherited diseases coming on at an earlier period. I have already given one striking instance with blindness during 3 generations, and Mr. Bowman remarks that this frequently occurs with cataract. With cancer, there seems to be a peculiar liability to earlier inheritance. Sir J. Paget, who has particularly attended to this subject and tabulated a large number of cases, informs me that he believes that in 9 cases out of 10, the later generation suffers from the disease at an earlier period than the previous generation. He adds, in the instances in which the opposite relation holds, and the members of later generations have cancer at a later age than their predecessors, I think it will be found that the non-cancerous parents have lived to extreme old ages, so that the longevity of a non-affected parent seems to have the power of influencing the fatal period in the offspring, and we thus apparently get another element of complexity in inheritance. The facts showing that with certain diseases the period of inheritance occasionally, or even frequently advances, are important with respect to the general descent theory, for they render it probable that the same thing would occur with ordinary modifications of structure. The final result of a long series of such advances would be the gradual obliteration of characters proper to the embryo and larva, which would thus come to resemble more and more closely the mature parent form. But any structure which was of service to the embryo or larva would be preserved by the destruction at this stage of growth of each individual, which manifested any tendency to lose its proper character at too early an age. Finally, from the numerous races of cultivated plants and domestic animals, in which the seeds or eggs, the young or old, differ from one another, and from those of the parent species, from the cases in which new characters have appeared at a particular period, and afterwards been inherited at the same period, and from what we know with respect to disease, we must believe in the truth of the great principle of inheritance at corresponding periods of life. Summary of the 3 preceding chapters. Strong as is the force of inheritance, it allows the incessant appearance of new characters, these whether beneficial or injurious, of the most trifling importance, such as a shade of color in a flower, a colored lock of hair, or a mere gesture of the highest importance, as when affecting the brain or an organ so perfect and complex, as the ire of so grave a nature, as to deserve to be called a monstrosity, or so peculiar, as not to occur normally in any member of the same natural class, often inherited by man by the lower animals and plants in numberless cases. It suffices for the inheritance of a peculiarity that one parent alone should be thus characterized. Inequalities in the 2 sides of the body, though opposed to the law of symmetry, may be transmitted. There is ample evidence that the effects of mutilations and of accidents, especially or perhaps exclusively, when followed by disease, are occasionally inherited, there can be no doubt that the evil effects of the long-continued exposure of the parent to injurious conditions are sometimes transmitted to the offspring. So it is, as we shall see in a future chapter, with the effects of the use and disuse of parts, and of mental habits. Periodical habits are likewise transmitted, but generally as it would appear with little force. Hence we are led to look at inheritance as the rule and non-inheritance as the anomaly, but this power often appears to us in our ignorance to act capriciously, transmitting a character with inexplicable strength or feebleness, the very same peculiarity as the weeping habit of trees, silky feathers, etc., may be inherited either firmly or not at all by different members of the same group, and even by different individuals of the same species. Though treated in the same manner in this latter case, we see that the power of transmission is a quality which is merely individual in its attachment. As with single characters, so it is with the several concurrent slight differences which distinguish subvarieties or races, for of these some can be propagated almost as truly as species, whilst others cannot be relied on. The same rule holds good with plants when propagated by bulbs, offsets, etc., which in one sense still form parts of the same individual, for some varieties retain or inherit through successive bud generations their character far more truly than others. Some characters not proper to the parent species have certainly been inherited from an extremely remote epoch, and may therefore be considered as firmly fixed. But it is doubtful whether length of inheritance in itself gives fixedness of character, though the chances are obviously in favor of any character which has long been transmitted true or unaltered still being transmitted true, as long as the conditions of life remain the same. We know that many species, after having retained the same character for countless ages, whilst living under their natural conditions, when domesticated have varied in the most diversified manner, that is, have failed to transmit their original form, so that no character appears to be absolutely fixed. We can sometimes account for the failure of inheritance by the conditions of life being opposed to the development of certain characters, and still oftener, as with plants cultivated by grafts and buds, by the conditions causing new and slight modifications incessantly to appear. In this latter case, it is not that inheritance wholly fails, but that new characters are continually superadded. In some few cases, in which both parents are similarly characterized, inheritance seems to gain so much force by the combined action of the two parents that it counteracts its own power, and a new modification is the result. In many cases, the failure of the parents to transmit their likeness is due to the breed having been at some former period crossed, and the child takes after his grandparent or more remote ancestor of foreign blood. In other cases, in which the breed has not been crossed, but some ancient character has been lost through variation, it occasionally reappears through reversion, so that the parents apparently fail to transmit their own likeness. In all cases, however, we may safely conclude that the child inherits all its characters from its parents, in whom certain characters are latent, like the secondary sexual characters of one sex in the other. When after a long succession of bud generations, a flower or fruit becomes separated into distinct segments, having the colors or other attributes of both parent forms, we cannot doubt that these characters were latent in the earlier buds, though they could not then be detected, or could be detected only in an intimately commingled state. So it is with animals of crossed parentage, which with advancing years occasionally exhibit characters derived from one of their two parents, of which not a trace could at first be perceived. Certain monstrosities, which resemble what naturalists call the typical form of the group in question, apparently come under the same law of reversion. It is assuredly an astonishing fact that the male and female sexual elements that buds, and even full-grown animals, should retain characters during several generations in the case of crossed breeds, and during thousands of generations in the case of pure breeds, written, as it were, in invisible ink, yet ready at any time to be evolved under certain conditions. What these conditions precisely are we do not know, but any cause which disturbs the organization or constitution seems to be sufficient across, certainly, gives a strong tendency to the reappearance of long-lost characters, both corporeal and mental, in the case of plants. This tendency is much stronger with those species which have been crossed after long cultivation, and which therefore have had their constitutions disturbed by this cause, as well as by crossing, than with species which have always lived under their natural conditions, and have then been crossed. A return, also of domesticated animals and cultivated plants, to a wild state favors reversion, but the tendency under these circumstances has been much exaggerated. When individuals of the same family, which differ somewhat, and when races or species are crossed, the one is often prepotent over the other in transmitting its character. A race may possess a strong power of inheritance, and yet when crossed, as we have seen with trumpeter pigeons, yield to the prepotency of every other race. Prepotency of transmission may be equal in the two sexes of the same species, but often runs more strongly in one sex. It plays an important part in determining the rate at which one race can be modified or wholly absorbed by repeated crosses with another. We can seldom tell what makes one race or species prepotent over another, but it sometimes depends on the same character being present and visible in one parent, and latent or potentially present in the other. Characters may first appear in either sex, but oftener in the male than in the female, and afterwards be transmitted to the offspring of the same sex. In this case, we may feel confident that the peculiarity in question is really present, though latent in the opposite sex. Hence, the father may transmit through his daughter any character to his grandson, and the mother conversely to her granddaughter. We thus learn, and the fact is an important one, that transmission and development are distinct powers. Occasionally, these two powers seem to be antagonistic or incapable of combination in the same individual. For several cases have been recorded in which the son has not directly inherited a character from his father or directly transmitted it to his son, but has received it by transmission through his non-affected mother and transmitted it through his non-affected daughter. Owing to inheritance being limited by sex, we see how secondary sexual characters may have arisen under nature, their preservation and accumulation being dependent on their service to either sex. At whatever period of life a new character first appears, it generally remains latent in the offspring until a corresponding age is attained, and then is developed. When this rule fails, the child generally exhibits the character at an earlier period than the parent. On this principle of inheritance at corresponding periods, we can understand how it is that most animals display from the germ to maturity such a marvelous succession of characters. Finally, though much remains obscure with respect to inheritance, we may look at the following laws as fairly well established. Firstly, a tendency, in every character new and old, to be transmitted by seminal and bud generation, though often counteracted by various known and unknown causes. Secondly, reversion or atavism, which depends on transmission and development being distinct powers. It acts in various degrees and manners through both seminal and bud generation. Thirdly, prepotency of transmission, which may be confined to one sex or be common to both sexes. Fourthly, transmission as limited by sex, generally to the same sex in which the inherited character first appeared, and this in many, probably most cases, depends on the new character having first appeared at a rather late period of life. Fifthly, inheritance at corresponding periods of life with some tendency to the earlier development of the inherited character. In these laws of inheritance, as displayed under domestication, we see an ample provision for the production, through variability and natural selection, of new specific forms. References: Chapter Roman 15 on crossing. Free intercrossing obliterates the differences between allied breeds. When the numbers of two commingling breeds are unequal, one absorbs the other. The rate of absorption, determined by prepotency of transmission, by the conditions of life, and by natural selection. All organic beings occasionally intercross. Apparent exceptions: certain characters incapable of fusion, chiefly or exclusively those which have suddenly appeared in the individualin, the modification of old races, and the formation of new races by crossing. Some crossed races have bred true from their first production in the crossing of distinct species in relation to the formation of domestic races. In the two previous chapters, when discussing reversion and prepotency, I was necessarily led to give many facts on crossing. In the present chapter, one shall consider the part which crossing plays in two opposed directions: firstly, in obliterating characters and consequently in preventing the formation of new races, and secondly, in the modification of old races, or in the formation of new and intermediate races, by a combination of characters. I shall also show that certain characters are incapable of fusion. The effects of free or uncontrolled breeding between the members of the same variety, or of closely allied varieties, are important, but are so obvious that they need not be discussed at much length. It is free intercrossing which chiefly gives uniformity both under nature and under domestication to the individuals of the same species or variety when they live mingled together, and are not exposed to any cause inducing excessive variability. The prevention of free crossing and the intentional matching of individual animals are the cornerstones of the breeder's art. No man in his senses would expect to improve or modify a breed in any particular manner, or keep an old breed true and distinct, unless he separated his animals. The killing of inferior animals in each generation comes to the same thing as their separation in savage and semi-civilized countries, where the inhabitants have not the means of separating their animals. More than a single breed of the same species rarely or never exists. In former times, even in the United States, there were no distinct races of sheep, for all had been mingled together. The celebrated agriculturist Marshall II remarks that sheep that are kept within fences, as well as shepherded flocks in open countries, have generally a similarity, if not a uniformity of character, in the individuals of each flock, for they breed freely together and are prevented from crossing with other kinds, whereas in the unenclosed parts of England, the unshepherded sheep, even of the same flock, are far from true or uniform, owing to various breeds having mingled and crossed. We have seen that the half-old cattle in each of the several British parks are nearly uniform in character, but in the different parks, from not having mingled and crossed during many generations, they differ to a certain small extent. We cannot doubt that the extraordinary number of varieties and subvarieties of the pigeon, amounting to at least 150, is partly due to their remaining differently from other domesticated birds, paired for life once matched on the other. Hand breeds of cats imported into this country soon disappear, for their nocturnal and rambling habits render it hardly possible to prevent free crossing. Renger 3 gives an interesting case with respect to the cat in Paraguay. In all the distant parts of the kingdom, it has assumed, apparently from the effects of the climate, a peculiar character, but near the capital, this change has been prevented owing, as he asserts, to the native animal frequently crossing with cats imported from Europe. In all cases like the foregoing, the effects of an occasional cross will be augmented by the increased vigor and fertility of the crossed offspring, of which fact evidence will hereafter be given. For this will lead to the mongrels increasing more rapidly than the pure parent breeds. When distinct breeds are allowed to cross freely, the result will be a heterogeneous body. For instance, the dogs in Paraguay are far from uniform and can no longer be affiliated to their parent races, for the character which a crossed body of animals will ultimately assume must depend on several contingencies, namely, on the relative members of the individuals belonging to the two or more races, which are allowed to mingle, on the prepondency of one race over the other in the transmission of character, and on the conditions of life to which they are exposed. When two commingled breeds exist at first in nearly equal numbers, the whole will sooner or later become intimately blended, but not so soon, both breeds being equally favored in all respects, as might have been expected. The following calculation 5 shows that this is the case if a colony with an equal number of black and white men were founded, and we assume that they marry indiscriminately, are equally prolific, and that 1 in 30 annually dies, and is born then in 65 years. The number of blacks, whites, and mulattoes would be equal in 91 years. The whites would be 110th, the blacks 110th, and the mulattoes, or people of intermediate degrees of color, 810 ths of the whole number. In 3 centuries, not 1,100th part of the whites would exist. When one of two mingled races exceed the other greatly in number, the latter will soon be wholly or almost wholly absorbed and lost. 6. Thus European pigs and dogs have been largely introduced in the islands of the Pacific Ocean, and the native races have been absorbed and lost in the course of about 50 or 60 years. 7. But the imported races, no doubt, were favored. Rats may be considered as semi-domesticated animals. Some snacker rats, Mus alexandrinus, escaped in the zoological gardens of London, and for a long time afterwards, the keepers frequently caught crossbred rats, at first half-breds, afterwards, with less of the character of the snacker rat, till at length all traces of it disappeared. 8. On the other hand, in some parts of London, especially near the docks, where fresh rats are frequently imported, an endless variety of intermediate forms may be found between the brown, black, and snake rat, which are all three usually ranked as distinct species. How many generations are necessary for one species or race to absorb another by repeated crosses has often been discussed. 9. And the requisite number has probably been much exaggerated. Some writers have maintained that a dozen or score or even more generations are necessary, But this in itself is improbable, for in the 10th generation, there would be only 11,024th part of foreign blood in the offspring Gartner. Found 10. That with plants one species could be made to absorb another in from 3 to 5 generations, and he believes that this could always be effected in from 6 to 7 generations. In one instance, however, Kallreuter 11 speaks of the offspring of Mirabilis vulgaris, crossed during 8 successive generations by Roman 1000 longiflora, as resembling this latter species so closely that the most scrupulous observer could detect vix aliquem notabilum differentium, or as he says, he succeeded ad planarium fear transmutationum. But this expression shows that the act of absorption was not even then absolutely complete, though these crossed plants contained only the 1256th part of Roman 1000 vulgaris. The conclusions of such accurate observers as Gartner and Kallreuter are of far higher worth than those made without scientific aim by breeders. The most precise account which I have met with is given by Stonehenge 12, and is illustrated by photographs. Mr. Hanley crossed a greyhound bitch with a bulldog, the offspring in each succeeding generation being recrossed with first-rate greyhounds. As Stonehenge remarks, it might naturally be supposed that it would take several crosses to get rid of the heavy form of the bulldog. But Asterix, the GRGR granddaughter of a bulldog, showed no trace whatever of this breed in external form. She and all of the same litter, however, were remarkably deficient in stoutness. Though fast as well as clever, I believe clever refers to skill in turning. Hysterix was put to a son of Bedlamite, but the result of the 5th cross is not as yet, I believe, more satisfactory than that of the 4th. On the other hand, with sheep Fleshman 13 shows how persistent the effects of a single cross may be. He says that the original coarse sheep of Germany have 5,500 fibers of wool on a square inch. Grades of the 3rd or 4th Merino cross produced about 8,000, the 20th cross 27,000, the perfect pure Merino blood 40,000 to 48,000. So that common German sheep crossed 20 times successively with Merino did not by any means acquire wool as fine as that of the pure breed. But in all cases, the rate of absorption will depend largely on the conditions of life being favorable to any particular character, and we may suspect that there would be a constant tendency to degeneration in the wool of Merinos under the climate of Germany, unless prevented by careful selection, and thus perhaps the foregoing remarkable case may be explained. The rate of absorption must also depend on the amount of distinguishable difference between the two forms which are crossed, and especially as Gartner insists on prepotency of transmission in the one form over the other. We have seen in the last chapter that one of 2 French breeds of sheep yielded up its character when crossed with Merinos very much more slowly than the other, and the common German sheep referred to by Fleshman may be, in this respect, analogous. In all cases, there will be more or less liability to reversion during many subsequent generations, and it is this fact which has probably led authors to maintain that a score or more of generations are requisite for one race to absorb another. In considering the final result of the commingling of 2 or more breeds, we must not forget that the act of crossing in itself tends to bring back long-lost characters, not proper to the immediate parent forms. With respect to the influence of the conditions of life on any 2 breeds, which are allowed to cross freely, unless both are indigenous and have long been accustomed to the country where they live, they will in all probability be unequally affected by the conditions, and this will modify the result. Even with indigenous breeds, it will rarely or never occur that both are equally well adapted to the surrounding circumstances, more especially when permitted to roam freely and not carefully tended, as is generally the case with breeds allowed to cross. As a consequence of this natural selection, will to a certain extent come into action, and the best fitted will survive, and this will aid in determining the ultimate character of the commingled body. How long a time it would require before such a crossed body of animals would assume a uniform character within a limited area, no one can say. That they would ultimately become uniform from free intercrossing, and from the survival of the fittest, we may feel assured, but the characters thus acquired would rarely or never, as may be inferred from the previous considerations, be exactly intermediate between those of the 2 parent breeds, with respect to the very slight differences by which the individuals of the same subvariety, or even of allied varieties, are characterized. It is obvious that free crossing would soon obliterate such small distinctions. The formation of new varieties independently of selection would also thus be prevented, except when the same variation continually recurred from the action of some strongly predisposing cause, we may therefore conclude that free crossing has in all cases played an important part in giving uniformity of character to all the members of the same domestic race, and of the same natural species, though largely governed by natural selection, and by the direct action of the surrounding conditions. On the possibility of all organic beings occasionally intercrossing, but it may be asked, can free crossing occur with hermaphrodite animals and plants? All the higher animals, and the few insects which have been domesticated, have separate sexes, and must inevitably unite for each birth with respect to the crossing of hermaphrodites. The subject is too large for the present volume, but in the origin of species, I have given a short abstract of the reasons which induce me to believe that all organic beings occasionally cross, though perhaps, in some cases, only at long intervals of time. 14. I will merely recall the fact that many plants, though hermaphrodite in structure, are unisexual in function, such as those called by Roman 100K sprengel dichogamous, in which the pollen and stigma of the same flower are matured at different periods, or those called by me reciprocally dimorphic, in which the flower's own pollen is not fitted to fertilize its own stigma, or again the many kinds, in which curious mechanical contrivances exist effectually preventing self-fertilization. There are, however, many hermaphrodite plants, which are not in any way specially constructed to favor intercrossing, but which nevertheless commingle almost as freely as animals with separated sexes. This is the case with cabbages, radishes, and onions. As I know from having experimented on them, even the peasants of Liguria say that cabbages must be prevented from falling in love with each other in the orange tribe Galizio. 15. Remarks that the amelioration of the various kinds is checked by their continual and almost regular crossing. So it is with numerous other plants. On the other hand, some cultivated plants rarely or never intercross, for instance the common pea and Sweetbea lathyrus odoratus, yet their flowers are certainly adapted for cross-fertilization. The varieties of the tomato and aubergine solanum and the pimenta vulgaris are said 16 never to cross even when growing alongside one another. But it should be observed that these are all exotic plants, and we do not know how they would behave in their native country when visited by the proper insects. With respect to the common pea, I have ascertained that it is rarely crossed in this country owing to premature fertilization. There exist, however, some plants which, under their natural conditions, appear to be always self-fertilized, such as the bee Ophrys epifera, and a few other orchids. Yet these plants exhibit the plainest adaptations for cross-fertilization. Again, some few plants are believed to produce only closed flowers called cleistogene, which cannot possibly be crossed. This was long thought to be the case with the Liercia oryzoides 17, but this grass is now known occasionally to produce perfect flowers which set seed. Although some plants, both indigenous and naturalized, rarely or never produce flowers, or if they flower never produce seeds, yet no one doubts that phanerogamic plants are adapted to produce flowers, and the flowers to produce seed. When they fail, we believe that such plants under different conditions would perform their proper function, or that they formerly did so, and will do so again on analogous grounds. I believe that the flowers in the above specified anomalous cases, which do not now intercross, either would do so occasionally under different conditions, or that they formerly did so. Means for effecting this being generally still retained and will again intercross at some future period. Unless, indeed, they become extinct. On this view alone, many points in the structure and action of the reproductive organs in hermaphrodite plants and animals are intelligible. For instance, the fact of the male and female organs never being so completely enclosed as to render access from without impossible. Hence, we may conclude that the most important of all the means for giving uniformity to the individuals of the same species, namely, the capacity of occasionally intercrossing, is present, or has been formerly present with all organic beings, except perhaps some of the lowest. On certain characters not blending, when two breeds are crossed, their characters usually become intimately fused together, but some characters refuse to blend, and are transmitted in an unmodified state, either from both parents, or from one. When gray and white mice are paired, the young are piebald or pure white, or gray but not of an intermediate tint. So it is when white and common collared turtledoves are paired in breeding game. Fowls. A great authority, Mr. J. Douglas, remarks, I may here state a strange fact, If you cross a black with a white game, you get birds of both breeds of the clearest color Sir R. Heron crossed during many years white, black, brown, and fawn-colored Angora rabbits, and never once got these colors mingled in the same animal, but often all four colors in the same litter. 18. From cases like these, in which the colors of the two parents are transmitted quite separately to the offspring, we have all sorts of gradations leading to complete fusion. I will give an instance: a gentleman with a fair complexion, light hair, but dark eyes, married a lady with dark hair and complexion. Their 3 children have very light hair, but on careful search, about a dozen black hairs were found scattered in the midst of the light hair on the heads of all 3. When turnspit dogs and Ancon sheep, both of which have dwarfed limbs, are crossed with common breeds, the offspring are not intermediate in structure, but take after either parent. When tailless or hornless animals are crossed with perfect animals, it frequently, but by no means invariably, happens that the offspring are either furnished with these organs in a perfect state, or are quite destitute of them. According to Renger, the hairless condition of the Paraguay dog is either perfectly or not at all transmitted to its mongrel offspring, but I have seen one partial exception in a dog of this parentage, which had part of its skin hairy and part naked, the parts being distinctly separated, as in a piebald animal when Dorking fowls with 5 toes are crossed with other breeds. Chickens often have 5 toes on one foot, and 4 on the other. Some crossed pigs, raised by Sir R. Heron between the solid-hoofed and common pig, had not all 4 feet in an intermediate condition, but 2 feet were furnished with properly divided, and 2 with united hoofs. Analogous facts have been observed with plants. Major Trevor Clark crossed the little glabrous-leaved annual stock Matthiola with pollen of a large red-flowered rough-leaved biennial stock, called cocardo by the French, and the result was that half the seedlings had glabrous, and the other half rough leaves, but none had leaves in an intermediate state. That the glabrous seedlings were the product of the rough-leaved variety, and not accidentally of the mother plant's own pollen, was shown by their tall and strong habit of growth. 19. In the succeeding generations raised from the rough-leaved crossed seedlings, some glabrous plants appeared, showing that the glabrous character, though incapable of blending with and modifying the rough leaves, was all the time latent in this family of plants. The numerous plants formerly referred to, which I raised from reciprocal crosses between the peloric and common Annurinum, offer a nearly parallel case, for in the first generation, all the plants resembled the common form, and in the next generation, out of 137 plants, 2 alone were in an intermediate condition, the others perfectly resembling either the peloric or common form. Major Trevor Clark also fertilized the above-mentioned red-flowered stock with pollen from the purple queen stock, and about half the seedlings scarcely differed in habit, and not at all in the red color of the flower from the mother plant, the other half bearing blossoms of a rich purple, closely like those of the paternal plant Gartner, crossed many white and yellow-flowered species and varieties of verbascum, and these colors were never blended, but the offspring bore either pure white or pure yellow blossoms, the former in the larger proportion. 20. Dr. Herbert raised many seedlings, as he informed me, from Swedish turnips crossed by 2 other varieties, and these never produced flowers of an intermediate tint, but always like one of their parents. I fertilized the purple Sweetbia lathyrus odoratus, which has a dark reddish-purple standard petal and violet-colored wings and keel, with pollen of the painted lady Sweetbia, which has a pale cherry-colored standard and almost white wings and keel. And from the same pod, I twice raised plants perfectly resembling both sorts, the greater number resembling the father. So perfect was the resemblance that I should have thought there had been some mistake if the plants which were at first identical with the paternal variety, namely the painted lady, had not later in the season produced, as mentioned in a former chapter, flowers blotched and streaked with dark purple. I raised grandchildren and great-grandchildren from these crossed plants, and they continued to resemble the painted lady, but during later generations became rather more blotched with purple, yet none reverted completely to the original mother plant, the purple Sweetbia. The following case is slightly different, but still shows the same principle. Nauden 21 raised numerous hybrids between the yellow Linaria vulgaris and the purple Roman 50 purpurea, and during 3 successive generations, the colors kept distinct in different parts of the same flower. From cases such as the foregoing, in which the offspring of the first generation perfectly resemble either parent, we come by a small step to those cases in which differently colored flowers borne on the same root resemble both parents, and by another step to those in which the same flower or fruit is striped or blotched with the 2 parental colors, or bears a single stripe of the color, or other characteristic quality, of one of the parent forms with hybrids and mongrels. It frequently, or even generally happens, that one part of the body resembles more or less closely one parent, and another part the other parent, and here again some resistance to fusion, or what comes to the same thing, some mutual affinity between the organic atoms of the same nature, apparently comes into play, for otherwise, all parts of the body would be equally intermediate in character. So again, when the offspring of hybrids or mongrels, which are themselves nearly intermediate in character, revert either wholly or by segments to their ancestors, the principle of the affinity of similar, or the repulsion of dissimilar atoms, must come into action. To this principle, which seems to be extremely general, we shall recur in the chapter on pangenesis. It is remarkable, as has been strongly insisted upon by Isidore Geoffroy, Saint-Hilaire in regard to animals, that the transmission of characters without fusion occurs very rarely. When species are crossed, I know of one exception alone, namely with the hybrids naturally produced between the common and hooded crow Corvus coron and cornix, which however are closely allied species differing in nothing except color, nor have I met with any well-ascertained cases of transmission of this kind, even when one form is strongly prepotent over another, when two races are crossed, which have been slowly formed by man's selection, and therefore resemble to a certain extent natural species. Such cases as puppies in the same litter closely resembling two distinct breeds are probably due to superfetation, that is, to the influence of two fathers. All the characters above enumerated which are transmitted in a perfect state to some of the offspring, and not to others, such as distinct colors, nakedness of skin, smoothness of leaves, absence of horns or tail, additional toes, pelorism, dwarfed structure, etc., have all been known to appear suddenly in individual animals and plants. From this fact, and from the several slight aggregated differences which distinguish domestic races and species from one another, not being liable to this peculiar form of transmission, we may conclude that it is in some way connected with the sudden appearance of the characters in question. On the modification of old races and the formation of new races by crossing, we have hitherto chiefly considered the effects of crossing in giving uniformity of character. We must now look to an opposite result. There can be no doubt that crossing with the aid of rigorous selection during several generations has been a potent means in modifying old races and in forming new ones. Lord Orford crossed his famous stud of greyhounds once with the bulldog, in order to give them courage and perseverance. Certain pointers have been crossed, as I hear from the Rev. W. Roman 500 fox, with the foxhound, to give them dash and speed. Certain strains of Dorking fowls have had a slight infusion of game blood, and I have known a great fancier who on a single occasion crossed his turbot pigeons with barbs for the sake of gaining greater breadth of beak. In the foregoing cases, breeds have been crossed once for the sake of modifying some particular character, but with most of the improved races of the pig, which now breed true, there have been repeated crosses. For instance, the improved Essex owes its excellence to repeated crosses with the Neapolitan, together, probably with some infusion of Chinese blood. 22. So with our British sheep, almost all the races, except the Southdown, have been largely crossed. This, in fact, has been the history of our principal breeds. 23. To give an example, the Oxfordshire Downs now rank as an established breed. 24. They were produced about the year 1830 by crossing Hampshire, and in some instances, Southdown ewes with Cotswold rams. Now the Hampshire ram was itself produced by repeated crosses between the native Hampshire sheep and Southdowns, and the Longwold Cotswold were improved by crosses with the Leicester, which latter again is believed to have been a cross between several Longwold sheep. Mr. Spooner, after considering the various cases which have been carefully recorded, concludes that from a judicious pairing of crossbred animals, it is practicable to establish a new breed on the continent. The history of several crossed races of cattle and of other animals has been well ascertained. To give one instance, the King of Württemberg, after 25 years' careful breeding, that is, after 6 or 7 generations, made a new breed of cattle from a cross between a Dutch and a Swiss breed, combined with other breeds. 25. The Sebright Bantam, which breeds as true as any other kind of fowl, was formed about 60 years ago by a complicated cross. 26. Dark Brahmas, which are believed by some fanciers to constitute a distinct species, were undoubtedly formed. 27. In the United States within a recent period, by a cross between chittagongs and cochins with plants. There is little doubt that the sweet turnip originated from a cross, and the history of a variety of wheat raised from two very distinct varieties, and which after 6 years culture presented an even sample, has been recorded on good authority 28. Until lately cautious and experienced breeders, though not averse to a single infusion of foreign blood, were almost universally convinced that the attempt to establish a new race intermediate between two widely distinct races was hopeless. They clung, with superstitious tenacity, to the doctrine of purity of blood, believing it to be the ark in which alone true safety could be found. 29. Nor was this conviction unreasonable when two distinct races are crossed. The offspring of the first generation are generally nearly uniform in character, but even this sometimes fails to be the case, especially with crossed dogs and fowls, the young of which from the first are sometimes much diversified. As crossbred animals are generally of large size and vigorous, they have been raised in great numbers for immediate consumption, but for breeding they are found utterly useless, for though they may themselves be uniform in character, they yield during many generations astonishingly diversified offspring. The breeder is driven to despair, and concludes that he will never form an intermediate race, but from the cases already given, and from others which have been recorded, it appears that patience alone is necessary. As Mr. Spooner remarks, nature opposes no barrier to successful admixture in the course of time. By the aid of selection and careful weeding, it is practicable to establish a new breed. After 6 or 7 generations, the hoped for result will in most cases be obtained, but even then an occasional reversion or failure to keep true may be expected. The attempt, however, will assuredly fail if the conditions of life be decidedly unfavorable to the characters of either parent breed. 30. Although the grandchildren and succeeding generations of crossbred animals are generally variable in an extreme degree, some curious exceptions to the rule have been observed both with crossed races and species. Thus Boydard and Corby 31 assert that from a pouter and a runt, a cavalier will appear, which we have classed amongst pigeons of pure race, because it transmits all its qualities to its posterity. The editor of the Poultry Chronicle 32 bred some bluish fowls from a black Spanish cock and a Malay hen, and these remain true to color generation after generation. The Himalayan breed of rabbits was certainly formed by crossing two subvarieties of the silvergree rabbit, although it suddenly assumed its present character, which differs much from that of either parent breed, yet it has ever since been easily and truly propagated. I crossed some Labrador and penguin ducks, and recrossed the mongrels with penguins afterwards. Most of the ducks reared during 3 generations were nearly uniform in character, being brown with a white crescentic mark on the lower part of the breast, and with some white spots at the base of the beak, so that by the aid of a little selection, a new breed might easily have been formed with regard to crossed varieties of plants. Mr. Beaton 33 remarks that Melville's extraordinary cross between the Scotch kale and an early cabbage is as true and genuine as any on record. But in this case, no doubt selection was practiced. Gartner 34 has given 5 cases of hybrids, in which the progeny kept constant, and hybrids between Dianthus armyria and deltoids remained true and uniform. To the 10th generation, Dr. Herbert likewise showed me a hybrid from 2 species of Losa, which from its first production had kept constant during several generations. We have seen in the first chapter that the several kinds of dogs are almost certainly descended from more than one species, and so it is with cattle, pigs, and some other domesticated animals. Hence the crossing of aboriginally distinct species probably came into play at an early period in the formation of our present races. From Rudimer's observations, there can be little doubt that this occurred with cattle, but in most cases, one form will probably have absorbed and obliterated the other, for it is not likely that semi-civilized men would have taken the necessary pains to modify by selection their commingled, crossed, and fluctuating stock. Nevertheless, those animals which were best adapted to their conditions of life would have survived through natural selection, and by this means crossing will often have indirectly aided in the formation of primeval domesticated breeds within recent times. As far as animals are concerned, the crossing of distinct species has done little or nothing towards the formation or modification of our races. It is not yet known whether the several species of silk moth which have been recently crossed in France will yield permanent races with plants which can be multiplied by buds and cuttings. Hybridization has done wonders, as with many kinds of roses, rhododendrons, pelargoniums, calceolarias, and petunias. Nearly all these plants can be propagated by seed, most of them freely, but extremely few or none come true by seed. Some authors believe that crossing is the chief cause of variability, that is of the appearance of absolutely new characters. Some have gone so far as to look at it as the sole cause. But this conclusion is disproved by the facts given in the chapter on bud variation. The belief that characters not present in either parent or in their ancestors frequently originate from crossing is doubtful. That they occasionally do so is probable, but this subject will be more conveniently discussed in a future chapter on the causes of variability. A condensed summary of this, and of the 3 following chapters together with some remarks on hybridism, will be given in the 19th chapter. References: 23. See Mr. W. Roman 100 Spooners, excellent paper on crossbreeding, Journal Royal Agricult Soc Vol. Roman 20 Part 2. See also an equally good article by Mr. C.H. Howard in Gardner's Chronicle, 1860 p. 320. Chapter Roman Causes which interfere with the free crossing of varietous influence of domestication on fertility. Difficulties in judging of the fertility of varieties when crossed. Various causes which keep varieties distinct as the period of breeding and sexual preference of varieties of wheat, said to be sterile, when crossed varieties of maize, verbascum, hollyhock, gourds, melons, and tobacco, rendered in some degree mutually sterile. Domestication eliminates the tendency to sterility natural to species, when crossed and the increased fertility of uncrossed animals and plants from domestication and cultivation. The domesticated races of both animals and plants when crossed are with extremely few exceptions quite prolific, in some cases even more so than the purulibrid parent races. The offspring also raised from such crosses are likewise, as we shall see in the following chapter, generally more vigorous and fertile than their parents. On the other hand, species when crossed, and their hybrid offspring, are almost invariably in some degree sterile. And here there seems to exist a broad and insuperable distinction between races and species. The importance of this subject, as bearing on the origin of species, is obvious, and we shall hereafter recur to it. It is unfortunate how few precise observations have been made on the fertility of mongrel animals and plants during several successive generations. Dr. Broca. One has remarked that no one has observed whether, for instance, mongrel dogs bred in Tercy are indefinitely fertile, yet if a shade of infertility be detected by careful observation in the offspring of natural forms when crossed, it is thought that their specific distinction is proved. But so many breeds of sheep, cattle, pigs, dogs, and poultry have been crossed and recrossed in various ways, that any sterility, if it had existed, would, from being injurious, almost certainly have been observed in investigating the fertility of crossed varieties. Many sources of doubt occur whenever the least trace of sterility between two plants, however closely allied, was observed by Kallreuter, and more especially by Gartner, who counted the exact number of seed in each capsule. The two forms were at once ranked as distinct species. And if this rule be followed assuredly, it will never be proved that varieties when crossed are in any degree sterile. We have formerly seen that certain breeds of dogs do not readily pair together, but no observations have been made whether when paired they produce the full number of young, and whether the latter are perfectly fertile in Tercy. But supposing that some degree of sterility were found to exist, naturalists would simply infer that these breeds were descended from aboriginally distinct species, and it would be scarcely possible to ascertain whether or not this explanation was the true one. The Sebright bantam is much less prolific than any other breed of fowls, and is descended from a cross between two very distinct breeds, recrossed by a third subvariety. But it would be extremely rash to infer that the loss of fertility was in any manner connected with its crossed origin, for it may with more probability be attributed either to long-continued close interbreeding, or to an innate tendency to sterility, correlated with the absence of hackles and sickle tail feathers. Before giving the few recorded cases of forms, which must be ranked as varieties being in some degree sterile, when crossed, I may remark that other causes sometimes interfere with varieties freely intercrossing. Thus they may differ too greatly in size, as with some kinds of dogs and fowls. For instance, the editor of the Journal of Horticulture, etc., 2, says that he can keep bantams with the larger breeds without much danger of their crossing, but not with the smaller breeds such as games, Hamburgs, etc. With plants, a difference in the period of flowering serves to keep varieties distinct, as with the various kinds of maize and wheat. Thus Colonel Le Couture 3 remarks the Talavera wheat, from flowering much earlier than any other kind, is sure to continue pure in different parts of the Falkland Islands. The cattle are breaking up into herds of different colors, and those on the higher ground, which are generally white, usually breed, as I am informed by Sir J. Sullivan 3 months earlier than those on the lowland, and this would manifestly tend to keep the herds from blending. Certain domestic races seem to prefer breeding with their own kind, and this is a fact of some importance, for it is a step towards that instinctive feeling which helps to keep closely allied species in a state of nature distinct. We have now abundant evidence that if it were not for this feeling, many more hybrids would be naturally produced than in this case. We have seen in the first chapter that the Alco dog of Mexico dislikes dogs of other breeds, and the hairless dog of Paraguay mixes less readily with the European races than the latter do with each other in Germany. The female Spitzdog is said to receive the fox more readily than will other dogs, a female Australian dingo in England attracted the wild male foxes. But these differences in the sexual instinct and attractive power of the various breeds may be wholly due to their descent from distinct species. In Paraguay, the horses have much freedom, and an excellent observer believes that the native horses of the same color and size prefer associating with each other, and that the horses, which have been imported from Entre Rios and Banda Oriental into Paraguay, likewise prefer associating together in Circassia. 6 subraces of the horse have received distinct names, and a native proprietor of rank 5 asserts that horses of 3 of these races, whilst living a free life, almost always refuse to mingle and cross, and will even attack one another. It has been observed in a district stocked with heavy Lincolnshire and light Norfolk sheep that both kinds, though bred together, when turned out in a short time separate to a sheep, the Lincolnshires drawing off to the rich soil, and the Norfolks to their own dry light soil, and as long as there is plenty of grass, the 2 breeds keep themselves as distinct as rooks and pigeons. In this case, different habits of life tend to keep the races distinct. On one of the Faroe Islands, not more than half a mile in diameter, the half-old native black sheep are said not to have readily mixed with the imported white sheep. It is a more curious fact that the semi-monstrous Ancon sheep of modern origin have been observed to keep together, separating themselves from the rest of the flock, when put into enclosures with other sheep. 6. With respect to fallow deer, which live in a semi-domesticated condition, Mr. Bennett 7 states that the dark and pale-colored herds, which have long been kept together in the Forest of Dean in High Meadow Woods, and in the New Forest, have never been known to mingle. The dark-colored deer, it may be added, are believed to have been first brought by James Roman I from Norway on account of their greater hardiness. I imported from the island of Porto Santo 2 of the feral rabbits, which differ as described in the 4th chapter from common rabbits. Both proved to be males, and though they lived during some years in the zoological gardens, the superintendent Mr. Bartlett in vain endeavored to make them breed with various tame kinds. But whether this refusal to breed was due to any change in the instinct or simply to their extreme wildness, or whether confinement had rendered them sterile, as often occurs, cannot be determined. Whilst matching for the sake of experiment many of the most distinct breeds of pigeons, it frequently appeared to me that the birds, though faithful to their marriage vow, retained some desire after their own kind. Accordingly, I asked Mr. Wicking, who has kept a larger stock of various breeds together than any man in England, whether he thought that they would prefer pairing with their own kind, supposing that there were males and females enough of each, and he without hesitation answered that he was convinced that this was the case. It has often been noticed that the dovecot pigeon seems to have an actual aversion towards the several fancy breeds 8, yet all have certainly sprung from a common progenitor. The Rev. W. Roman 500 Fox informs me that his flocks of white and common Chinese geese kept distinct. These facts and statements, though some of them are incapable of proof, resting only on the opinion of experienced observers, show that some domestic races are led by different habits of life to keep to a certain extent separate, and that others prefer coupling with their own kind in the same manner as species in a state of nature, though in a much less degree. With respect to sterility from the crossing of domestic races, I know of no well-ascertained case. With animals, this fact, seeing the great difference in structure between some breeds of pigeons, fowls, pigs, dogs, etc., is extraordinary in contrast with the sterility of many closely allied natural species when crossed, but we shall hereafter attempt to show that it is not so extraordinary as it at first appears, and it may be well here to recall to mind that the amount of external difference between 2 species is not a safe guide for predicting whether or not they will breed together. Some closely allied species, when crossed, being utterly sterile, and others which are extremely unlike being moderately fertile. I have said that no case of sterility in crossed races rests on satisfactory evidence, but here is one which at first seems trustworthy. Mr. Youatt 9, and a better authority cannot be quoted, states that formerly in Lancashire crosses were frequently made between Longhorn and Shorthorn cattle. The first cross was excellent, but the produce was uncertain in the third or fourth generation. The cows were bad milkers, in addition to which there was much uncertainty whether the cows would conceive, and full one-third of the cows among some of these half-breds failed to be in calf. This at first seems a good case, but Mr. Wilkinson states 10 that a breed derived from the same cross was actually established in another part of England. And if it had failed in fertility, the fact would surely have been noticed. Moreover, supposing that Mr. Youatt had proved his case, it might be argued that the sterility was wholly due to the two parent breeds being descended from primordially distinct species. In the case of plants, Gartner states that he fertilized 13 heads, and subsequently 9 others on a dwarf maize bearing yellow seed. 11, with pollen of a tall maize having red seed, and 1 head alone, produced good seed, but only 5 in number. Though these plants are monstrous, and therefore do not require castration, yet I should have suspected some accident in the manipulation, had not Gartner expressly stated that he had during many years grown these two varieties together, and they did not spontaneously cross, and this considering that the plants are monoecious and abound with pollen, and are well known generally to cross freely, seems explicable only on the belief that these two varieties are in some degree mutually infertile. The hybrid plants raised from the above 5 seeds were intermediate in structure, extremely variable, and perfectly fertile. 12. In like manner, Prof. Hildebrand 13 could not succeed in fertilizing the female flowers of a plant bearing brown grains with pollen from a certain kind bearing yellow grains, although other flowers on the same plant, which were fertilized with their own pollen, yielded good seed. No one, I believe, even suspects that these varieties of maize are distinct species. But had the hybrids been in the least sterile, no doubt Gartner would at once have so classed them. I may here remark that with undoubted species there is not necessarily any close relation between the sterility of a first cross and that of the hybrid offspring. Some species can be crossed with facility, but produce utterly sterile hybrids. Others can be crossed with extreme difficulty, but the hybrids when produced are moderately fertile. I am not aware, however, of any instance quite like this of the maize, namely of a first cross made with difficulty, but yielding perfectly fertile hybrids. 14. The following case is much more remarkable and evidently perplexed Gartner, whose strong wish it was to draw a broad line of distinction between species and varieties. In the genus Verbascum, he made during 18 years a vast number of experiments, and crossed no less than 1085 flowers, and counted their seeds. Many of these experiments consisted in crossing white and yellow varieties of both Roman 5 lichnitis and Roman 5 blattaria with 9 other species, and their hybrids. That the white and yellow flowered plants of these two species are really varieties, no one has doubted, and Gartner actually raised in the case of both species one variety from the seed of the other. Now in 2 of his works, 15, he distinctly asserts that crosses between similarly colored flowers yield more seed than between dissimilarly colored, so that the yellow-flowered variety of either species, and conversely with the white-flowered variety, when crossed with pollen of its own kind, yields more seed than when crossed with that of the white variety, and so it is when differently colored species are crossed. The general results may be seen in the table at the end of his volume. In one instance, he gives 16 the following details, but I must premise that Gartner, to avoid exaggerating the degree of sterility in his crosses, always compares the maximum number obtained from a cross with the average number naturally given by the pure mother plant, the white variety of Roman 5 lichnitis, naturally fertilized by its own pollen, gave from an average of 12 capsules 96 good seeds in each, whilst 20 flowers fertilized with pollen from the yellow variety of the same species gave as the maximum only 89 good seeds, so that we have the proportion of 1,000 to 908, according to Gartner's usual scale. I should have thought it possible that so small a difference in fertility might have been accounted for by the evil effects of the necessary castration, but Gartner shows that the white variety of Roman 5 lichnitis, when fertilized first by the white variety of Roman 5 blattaria, and then by the yellow variety of this species, yielded seed in the proportion of 622 to 438. And in both these cases castration was performed. Now the sterility, which results from the crossing of the differently colored varieties of the same species, is fully as great as that which occurs in many cases. When distinct species are crossed, unfortunately Gartner compared the results of the first unions alone, and not the sterility of the two sets of hybrids produced from the white variety of Roman 5 lichnitis, when fertilized by the white and yellow varieties of Roman 5 blattaria, for it is probable that they would have differed in this respect. Mr. J. Scott has given me the results of a series of experiments on verbascum made by him in the Botanic Gardens of Edinburgh 17. He repeated some of Gartner's experiments on distinct species, but obtained only fluctuating results, some confirmatory, the greater number contradictory nevertheless. These seem hardly sufficient to overthrow the conclusion arrived at by Gartner from experiments tried on a larger scale. Mr. Scott also experimented on the relative fertility of unions between similarly and dissimilarly colored varieties of the same species. Thus he fertilized 6 flowers of the yellow variety of Roman 5 lichnitis by its own pollen, and obtained 6 capsules, and calling for the sake of comparison the average number of good seed in each of their capsules, 100, he found that this same yellow variety, when fertilized by the white variety, yielded from 7 capsules an average of 9 to 4 seed. On the same principle, the white variety of Roman 5 lichnitis, by its own pollen from 6 capsules, and by the pollen of the yellow variety 8 capsules yielded seed, in the proportion of 100 to 82, the yellow variety of Roman 5 thapsus, by its own pollen 8 capsules, and by that of the white variety, only 2 capsules yielded seed, in the proportion of 100 to 94. Lastly, the white variety of Roman 5 blattaria, by its own pollen 8 capsules, and by that of the yellow variety 5 capsules yielded seed, in the proportion of 100 to 79, so that in every case the unions of similarly colored varieties of the same species were more fertile than the unions of dissimilarly colored varieties. When all the cases are grouped together, the difference of fertility is as 100 to 86. Some additional trials were made, and altogether 36 similarly colored unions yielded 35 good capsules, whilst 35 dissimilarly colored unions yielded only 26 good capsules. Besides the foregoing experiments, the purple Roman 5 pH Nycium was crossed by a rose-colored and a white variety of the same species. These 2 varieties were also crossed together, and these several unions yielded less seed than Roman 5 pH Nycium by its own pollen. Hence, it follows from Mr. Scott's experiments that in the genus verbascum the similarly and dissimilarly colored varieties of the same species behave when crossed like closely allied but distinct species. 18. This remarkable fact of the sexual affinity of similarly colored varieties, as observed by Gartner and Mr. Scott, may not be a very rare occurrence for the subject, has not been attended to by others. The following case is worth giving partly to show how difficult it is to avoid error. Dr. Herbert 19 has remarked that variously colored double varieties of the hollyhock Althea rosea may be raised with certainty by seed from plants growing close together. I have been informed that nurserymen who raise seed for sale do not separate their plants accordingly. I procured seed of 18 named varieties. Of these, 11 varieties produced 6 to 2 plants, all perfectly true to their kind, and 7 produced 49 plants, half of which were true and half false. Mr. Masters of Canterbury has given me a more striking case. He saved seed from a great bed of 24 named varieties, planted in closely adjoining rows, and each variety reproduced itself truly with only sometimes a shade of difference in tint. Now in the hollyhock, the pollen which is abundant is matured, and nearly all shed before the stigma of the same flower is ready to receive it. 20. And as bees covered with pollen incessantly fly from plant to plant, it would appear that adjoining varieties could not escape being crossed. As however this does not occur, it appeared to me probable that the pollen of each variety was prepotent on its own stigma over that of all other varieties, but I have no evidence on this point. Mr. Roman 100 Turner of Slough, well known for his success in the cultivation of this plant, informs me that it is the doubleness of the flowers which prevents the bees gaining access to the pollen and stigma, and he finds that it is difficult even to cross them artificially. Whether this explanation will fully account for varieties in close proximity, propagating themselves so truly by seed, I do not know. The following cases are worth giving as they relate to monoecious forms, which do not require, and consequently, cannot have been injured by castration. Giro de Buserings crossed what he designates 3 varieties of gourd 21, and asserts that their mutual fertilization is less easy in proportion to the difference which they present. I am aware how imperfectly the forms in this group were until recently known, but Sadrat 22, who ranked them according to their mutual fertility, considers the three forms above alluded to as varieties, as does a far higher authority, namely Roman 1023. Sadrat 24 has observed that certain melons have a greater tendency, whatever the cause may be, to keep true than others, and Roman 1000, who has had such immense experience in this group, informs me that he believes that certain varieties intercross more readily than others of the same species. But he has not proved the truth of this conclusion, the frequent abortion of the pollen near Paris being one great difficulty. Nevertheless, he has grown close together during 7 years certain forms of citrullus, which, as they could be artificially crossed with perfect facility and produced fertile offspring, are ranked as varieties. But these forms, when not artificially crossed, kept true. Many other varieties, on the other hand, in the same group cross with such facility, as Roman 1000 repeatedly insists that without being grown far apart they cannot be kept in the least true. Another case, though somewhat different, may be here given, as it is highly remarkable, and is established on excellent evidence. Kallreuter minutely describes 5 varieties of the common tobacco, 25, which were reciprocally crossed, and the offspring were intermediate in character, and as fertile as their parents. From this fact, Kallreuter inferred that they are really varieties, and no one, as far as I can discover, seems to have doubted that such is the case. He also crossed reciprocally these 5 varieties with N. glutinosa, and they yielded very sterile hybrids. But those raised from the var. perennis, whether used as the father or mother plant, were not so sterile as the hybrids from the 4 other varieties. 26. So that the sexual capacity of this one variety has certainly been in some degree modified, so as to approach in nature that of N. glutinosa. 27. These facts with respect to plants show that in some few cases, certain varieties have had their sexual powers so far modified that they cross together less readily and yield less seed than other varieties of the same species. We shall presently see that the sexual functions of most animals and plants are eminently liable to be affected by the conditions of life to which they are exposed, and hereafter we shall briefly discuss the conjoint bearing of this fact, and others on the difference in fertility between crossed varieties and crossed species. Domestication eliminates the tendency to sterility, which is general with species when crossed. This hypothesis was first propounded by Pallas 28, and has been adopted by several authors. I can find hardly any direct facts in its support, but unfortunately, no one has compared, in the case of either animals or plants, the fertility of anciently domesticated varieties, when crossed with a distinct species, with that the wild parent species when similarly crossed. No one has compared, for instance, the fertility of Gallus bancova and of the domesticated fowl when crossed with a distinct species of Gallus or Fascianus, and the experiment would in all cases be surrounded by many difficulties. Duro de la Malle, who has so closely studied classical literature, states 29 that in the time of the Romans, the common mule was produced with more difficulty than at the present day. But whether this statement may be trusted, I know not. A much more important, though somewhat different case, is given by Roman 1000 Groenland 30, namely that plants known from their intermediate character and sterility to be hybrids between gylops and wheat have perpetuated themselves under culture since 1857, with a rapid but varying increase of fertility in each generation. In the 4th generation, the plants, still retaining their intermediate character, had become as fertile as common cultivated wheat. The indirect evidence in favor of the Pallasian doctrine appears to me to be extremely strong. In the earlier chapters, I have shown that our various breeds of the dog are descended from several wild species, and this probably is the case with sheep. There can be no doubt that the zebu, or humped Indian ox, belongs to a distinct species from European cattle. The latter, moreover, are descended from 2 forms, which may be called either species or races. We have good evidence that our domesticated pigs belong to at least 2 specific types, S. scrofa and indicus. Now, a widely extended analogy leads to the belief that if these several allied species, when first reclaimed, had been crossed, they would have exhibited, both in their first unions and in their hybrid offspring, some degree of sterility. Nevertheless, the several domesticated races descended from them are now, all as far as can be ascertained, perfectly fertile together. If this reasoning be trustworthy, and it is apparently sound, we must admit the Pallasian doctrine that long-continued domestication tends to eliminate that sterility which is natural to species when crossed in their aboriginal state. On increased fertility from domestication and cultivation. Increased fertility from domestication without any reference to crossing may be here, briefly considered. This subject bears indirectly on 2 or 3 points connected with the modification of organic beings, as Buffon long ago remarked. 31 domestic animals breed oftener in the year and produce more young at a birth than wild animals of the same species. They also sometimes breed at an earlier age. The case would hardly have deserved further notice had not some authors lately attempted to show that fertility increases and decreases in an inverse ratio with the amount of food. This strange doctrine has apparently arisen from individual animals when supplied with an inordinate quantity of food, and from plants of many kinds when grown on excessively rich soil, as on a dunghill becoming sterile. But to this latter point, I shall have occasion presently to return. With hardly an exception, our domesticated animals, which have been long habituated to a regular and copious supply of food, without the labor of searching for it, are more fertile than the corresponding wild animals. It is notorious how frequently cats and dogs breed, and how many young they produce at a birth. The wild rabbit is said generally to breed 4 times yearly, and to produce each time at most 6 young. The tame rabbit breeds 6 or 7 times yearly, producing each time from 4 to 11 young. And Mr. Harrison Weir tells me of a case of 18 young having been produced at a birth, all of which survived. The ferret, though generally so closely confined, is more prolific than its supposed wild prototype. The wild sow is remarkably prolific. She often breeds twice in the year, and bears from 4 to 8, and sometimes even 12 young. But the domestic sow regularly breeds twice a year, and would breed oftener if permitted, and a sow that produces less than 8 at a birth is worth little, and the sooner she is fattened for the butcher the better. The amount of food affects the fertility of the same individual. Thus sheep, which on mountains never produce more than 1 lamb at a birth, when brought down to lowland pastures, frequently bear twins. This difference apparently is not due to the cold of the higher land, for sheep and other domestic animals are said to be extremely prolific in Lapland. Hard living also retards the period at which animals conceive, for it has been found disadvantageous in the northern islands of Scotland to allow cows to bear calves before they are 4 years old. 32. Birds offer still better evidence of increased fertility from domestication. The hen of the wild Gallus bancova lays from 6 to 10 eggs, a number which would be thought nothing of with the domestic hen. The wild duck lays from 5 to 10 eggs, the tame one in the course of the year from 80 to 100. The wild greylag goose lays from 5 to 8 eggs, the tame from 13 to 18, and she lays a second time. As Mr. Dixon has remarked, high-feeding care and moderate warmth induce a habit of prolificacy, which becomes in some measure hereditary. Whether the semi-domesticated dovecote pigeon is more fertile than the wild rock pigeon Rome and 100 Livia, I know not, but the more thoroughly domesticated breeds are nearly twice as fertile as dovecotes. The latter, however, when caged and highly fed, become equally fertile with house pigeons. I hear from Judge Catton that the wild turkey in the United States does not breed when a year old, as the domesticated turkeys there invariably do. The peahen alone of domesticated birds is rather more fertile, according to some accounts, when wild in its native Indian home than in Europe, when exposed to our much colder climate. 33. With respect to plants, no one would expect wheat to tiller more and each ear to produce more grain in poor than in rich soil, or to get in poor soil a heavy crop of peas or beans. Seeds vary so much in number that it is difficult to estimate them, but on comparing beds of carrots in a nursery garden with wild plants, the former seem to produce about twice as much seed. Cultivated cabbages yielded thrice as many pods by measure as wild cabbages from the rocks of South Wales. The excess of berries produced by the cultivated asparagus in comparison with the wild plant is enormous. No doubt, many highly cultivated plants such as pears, pineapples, bananas, sugarcane, etc., are nearly or quite sterile, and I am inclined to attribute this sterility to excess of food and to other unnatural conditions, but to this subject I shall recur. In some cases, as with the pig, rabbit, etc., and with those plants which are valued for their seed, the direct selection of the more fertile individuals has probably much increased their fertility, and in all cases, this may have occurred indirectly from the better chance of some of the numerous offspring from the more fertile individuals having been preserved. But with cats, ferrets, and dogs, and with plants like carrots, cabbages, and asparagus, which are not valued for their prolificacy selection, can have played only a subordinate part, and their increased fertility must be attributed to the more favorable conditions of life under which they have long existed. References: Chapter Romans 17 on the good effects of crossing and on the evil effects of close interbreeding. Definition of close interbreeding: augmentation of morbid tendencies. General evidence of the good effects derived from crossing and on the evil effects from close interbreeding. Cattle, closely interbred half-old cattle, long kept in the same park. Sheep follow deer. Dogs, rabbits, pigsman. Origin of his abhorrence of incestuous marriages. False pigeon. Shivabi splints. General considerations on the benefits derived from crossing: melons, fruit trees, peas, cabbages, wheat, and forestreson. The increased size of hybrid plants, not exclusively due to their sterility in certain plants, which either normally or abnormally are self-impotent, but are fertile both on the male and female side, when crossed with distinct individuals, either of the same or another species. Inclusion. The gain in constitutional vigor derived from an occasional cross between individuals of the same variety, but belonging to distinct families, or between distinct varieties, has not been so largely or so frequently discussed as have the evil effects of too close interbreeding. But the former point is the more important of the two, inasmuch as the evidence is more decisive. The evil results from close interbreeding are difficult to detect, for they accumulate slowly and differ much in degree with different species, whilst the good effects which almost invariably follow a cross are from the first manifest. It should, however, be clearly understood that the advantage of close interbreeding as far as the retention of character is concerned is indisputable, and often outweighs the evil of a slight loss of constitutional vigor. In relation to the subject of domestication, the whole question is of some importance, as too close interbreeding interferes with the improvement of old races. It is important as indirectly bearing on hybridism, and possibly on the extinction of species, when any form has become so rare that only a few individuals remain within a confined area. It bears in an important manner on the influence of free intercrossing in obliterating individual differences, and thus giving uniformity of character to the individuals of the same race or species. For if additional vigor and fertility be thus gained, the crossed offspring will multiply and prevail, and the ultimate result will be far greater than otherwise would have occurred. Lastly, the question is of high interest, as bearing on mankind. I shall therefore discuss this subject at full length, as the facts which prove the evil effects of close interbreeding are more copious though less decisive than those on the good effects of crossing. I shall under each group of beings begin with the former. There is no difficulty in defining what is meant by a cross, but this is by no means easy in regard to breeding in or too close interbreeding, because, as we shall see, different species of animals are differently affected by the same degree of interbreeding. The pairing of a father and daughter, or mother and son, or brothers and sisters, if carried on during several generations, is the closest possible form of interbreeding. But some good judges, for instance Sir J. Sebright, believe that the pairing of a brother and sister is much closer than that of parents and children, for when the father is matched with his daughter, he crosses, as is said, with only half his own blood. The consequences of close interbreeding, carried on for too long a time, are, as is generally believed, loss of size, constitutional vigor, and fertility, sometimes accompanied by a tendency to malformation. Manifest evil does not usually follow from pairing the nearest relations for 2, 3, or even 4 generations, but several causes interfere with our detecting the evil, such as the deterioration being very gradual and the difficulty of distinguishing between such direct evil and the inevitable augmentation of any morbid tendencies, which may be latent or apparent in the related parents. On the other hand, the benefit from a cross, even when there has not been any very close interbreeding, is almost invariably at once conspicuous. There is good reason to believe, and this was the opinion of that most experienced observer Sir J. Sebright I, that the evil effects of close interbreeding may be checked or quite prevented by the related individuals being separated for a few generations and exposed to different conditions of life. This conclusion is now held by many breeders. For instance, Mr. Cartu remarks, it is a well-known fact that a change of soil and climate affects perhaps almost as great a change in the constitution as would result from an infusion of fresh blood. I hope to show in a future work that consanguinity by itself counts for nothing, but acts solely from related organisms, generally having a similar constitution, and having been exposed in most cases to similar conditions. That any evil directly follows from the closest interbreeding has been denied by many persons, but rarely by any practical breeder, and never, as far as I know, by one who has largely bred animals, which propagate their kind quickly. Many physiologists attribute the evil exclusively to the combination and consequent increase of morbid tendencies common to both parents, and that this is an active source of mischief. There can be no doubt it is unfortunately too notorious that men and various domestic animals endowed with a wretched constitution, and with a strong hereditary disposition to disease, if not actually ill, are fully capable of procreating their kind close. Interbreeding, on the other hand, often induces sterility, and this indicates something quite distinct from the augmentation of morbid tendencies common to both parents. The evidence immediately to be given convinces me that it is a great law of nature that all organic beings profit from an occasional cross, with individuals not closely related to them in blood, and that on the other hand, long-continued close interbreeding is injurious. Various general considerations have had much influence in leading me to this conclusion, but the reader will probably rely more on special facts and opinions, the authority of experienced observers, even when they do not advance the grounds of their belief, is of some little value. Now almost all men who have bred many kinds of animals and have written on the subject, such as Sir J. Sebright, Andrew Knight, etc., 3, have expressed the strongest conviction on the impossibility of long-continued close interbreeding. Those who have compiled works on agriculture and have associated much with breeders such as the sagacious Youat Low, etc., have strongly declared their opinion to the same effect. Prosper Lucas, trusting largely to French authorities, has come to a similar conclusion. The distinguished German agriculturist Hermann von Nathusius, who has written the most able treatise on this subject which I have met with, concurs. And, as I shall have to quote from this treatise, I may state that Nathusius is not only intimately acquainted with works on agriculture in all languages, and knows the pedigrees of our British breeds better than most Englishmen, but has imported many of our improved animals, and is himself an experienced breeder. Evidence of the evil effects of close interbreeding can most readily be acquired in the case of animals, such as fowls, pigeons, etc., which propagate quickly, and from being kept in the same place, are exposed to the same conditions. Now I have inquired of very many breeders of these birds, and I have hitherto not met with a single man who was not thoroughly convinced that an occasional cross with another strain of the same subvariety was absolutely necessary. Most breeders of highly improved or fancy birds value their own strain, and are most unwilling, at the risk, in their opinion, of deterioration, to make across. The purchase of a first-rate bird of another strain is expensive, and exchanges are troublesome. Yet all breeders, as far as I can hear, excepting those who keep large stocks at different places for the sake of crossing, are driven after a time to take this step. Another general consideration which has had great influence on my mind is that with all hermaphrodite animals and plants, which it might have been thought would have perpetually fertilized themselves, and been thus subjected for long ages to the closest interbreeding, there is not a single species, as far as I can discover, in which the structure ensures self-fertilization. On the contrary, there are in a multitude of cases, as briefly stated in the 15th chapter, manifest adaptations, which favor or inevitably lead to an occasional cross between one hermaphrodite and another of the same species, and these adaptive structures are utterly purposeless as far as we can see for any other end. With cattle, there can be no doubt that extremely close interbreeding may be long carried on advantageously with respect to external characters, and with no manifest evil as far as constitution is concerned. The case of Bakewell's Longhorns, which were closely interbred, for a long period has often been quoted, yet Youat says for the breed had acquired a delicacy of constitution inconsistent with common management, and the propagation of the species was not always certain. But the Shorthorns offer the most striking case of close interbreeding. For instance, the famous bull favorite, who was himself the offspring of a half-brother and sister from Foljambe, was matched with his own daughter, granddaughter, and great-granddaughter, so that the produce of this last union, or the great-great-granddaughter, had 1,516 ths, or 93.75% of the blood of favorite in her veins. This cow was matched with the bull Wellington, having 625% of favorite blood in his veins, and produced Clarissa. Clarissa was matched with the bull Lancaster, having 68.75 of the same blood, and she yielded valuable offspring, 5 nevertheless Collings, who reared these animals, and was a strong advocate for close breeding, once crossed his stock with a Galloway, and the cows from this cross realized the highest prices. Bedas herd was esteemed the most celebrated in the world. For 13 years he bred most closely in and in, but during the next 17 years, though he had the most exalted notion of the value of his own stock, he thrice infused fresh blood into his herd. It is said that he did this not to improve the form of his animals, but on account of their lessened fertility. Mr. Bedas' own view, as given by a celebrated breeder 6, was that to breed inandin from a bad stock was ruin and devastation, yet that the practice may be safely followed within certain limits, when the parents so related are descended from first-rate animals. We thus see that there has been much close interbreeding with shorthorns, but Nathusius, after the most careful study of their pedigrees, says that he can find no instance of a breeder who has strictly followed this practice during his whole life. From this study and his own experience, he concludes that close interbreeding is necessary to ennoble the stock, but that in effecting this, the greatest care is necessary, on account of the tendency to infertility and weakness. It may be added that another high authority 7 asserts that many more calves are born cripples from shorthorns than from other and less closely interbred races of cat. Although by carefully selecting the best animals, as nature effectually does by the law of battle, close interbreeding may be long carried on with cattle, yet the good effects of a cross between almost any two breeds is at once shown by the greater size and vigor of the offspring. As Mr. Spooner writes to me, crossing distinct breeds certainly improves cattle for the butcher. Such crossed animals are of course of no value to the breeder, but they have been raised during many years in several parts of England to be slaughtered 8, and their merit is now so fully recognized that at fat cattle shows a separate class has been formed for their reception. The best fat ox at the great show at Islington in 1862 was a crossed animal. The half-old cattle which have been kept in British parks, probably for 400 or 500 years, or even for a longer period, have been advanced by Cully and others, as a case of long-continued interbreeding within the limits of the same herd, without any consequent injury. With respect to the cattle at Chillingham, the late Lord Tankerville owned that they were bad breeders. 9. The agent Mr. Hardy estimates, in a letter to me dated May 1861, that in the herd of about 50, the average number annually slaughtered, killed by fighting and dying, is about 10 or 1 in 5, as the herd is kept up to nearly the same average number. The annual rate of increase must be likewise about 1 in 5. The bulls, I may add, engage in furious battles, of which battles the present Lord Tankerville has given me a graphic description, so that there will always be rigorous selection of the most vigorous males. I procured in 1855, from Mr. Roman 500 Gardner, agent to the Duke of Hamilton, the following account of the wild cattle kept in the Duke's Park in Lanarkshire, which is about 200 acres. In extent the number of cattle varies from 65 to 80, and the number annually killed, I presume by all causes, is from 8 to 10, so that the annual rate of increase can hardly be more than 1 in 6 now in South America, where the herds are half-willed, and therefore offer a nearly fair standard of comparison. According to Azara, the natural increase of the cattle on an estancia is from 1/3 to 1/4 of the total number, or 1 in between 3 and 4, and this no doubt applies exclusively to adult animals fit for consumption. Hence the half-willed British cattle, which have long interbred within the limits of the same herd, are relatively far less fertile, although in an unenclosed country like Paraguay, there must be some crossing between the different herds, yet even there, the inhabitants believe that the occasional introduction of animals from distant localities is necessary to prevent degeneration in size and diminution of fertility. 10. The decrease in size from ancient times in the Chillingham and Hamilton cattle must have been prodigious, for Professor Rudimere has shown that they are almost certainly the descendants of the gigantic Bos primigenius. No doubt this decrease in size may be largely attributed to less favorable conditions of life. Yet animals roaming over large parks and fed during severe winters can hardly be considered as placed under very unfavorable conditions. With sheep there has often been long-continued interbreeding within the limits of the same flock, but whether the nearest relations have been matched so frequently, as in the case of shorthorn cattle, I do not know. The Messrs. Brown during 50 years have never infused fresh blood into their excellent flock of Leicesters. Since 1810, Mr. Barford has acted on the same principle with the Foscote flock, He asserts that half a century of experience has convinced him that, when two nearly related animals are quite sound in constitution, inandin breeding does not induce degeneracy, but he adds that he does not pride himself on breeding from the nearest affinities in France. The Naz flock has been bred for 60 years, without the introduction of a single strange ram. 11. Nevertheless, most great breeders of sheep have protested against close interbreeding, prolonged for too great a length of time. 12. The most celebrated of recent breeders, Jonas Webb, kept 5 separate families to work on, thus retaining the requisite distance of relationship between the sexes. 13. And what is probably of greater importance, the separate flocks will have been exposed to somewhat different conditions. Although by the aid of careful selection, the near interbreeding of sheep may be long continued without any manifest evil, yet it has often been the practice with farmers to cross distinct breeds to obtain animals for the butcher, which plainly shows that good of some kind is derived from this practice. We have excellent evidence on this head from Mr. S. Druce 14, who gives in detail the comparative numbers of 4 pure breeds, and of a crossbreed which can be supported on the same ground, and he gives their produce in fleece and carcass a high authority. Mr. Pusey sums up the result in money value during an equal length of time, namely neglecting shillings for Cotswolds 248 L, for Leicester's 223 L, for Southdowns 204 L, for Hampshire Downs 264 L, and for the crossbred 293 L. A former celebrated breeder, Lord Somerville, states that his half-breeds from Riolands and Spanish sheep were larger animals than either the pure Riolands or pure Spanish sheep. Mr. Spooner concludes his excellent essay on crossing by asserting that there is a pecuniary advantage in judicious crossbreeding, especially when the male is larger than the female. 15. As some of our British parks are ancient, it occurred to me that there must have been long-continued close interbreeding with the fallow deer service dama kept in them. But on inquiry, I find that it is a common practice to infuse new blood by procuring bucks from other parks. Mr. Shirley 16, who has carefully studied the management of deer, admits that in some parks there has been no admixture of foreign blood from a time beyond the memory of man. But he concludes that in the end, the constant breeding inandin is sure to tell to the disadvantage of the whole herd, though it may take a very long time to prove it. Moreover, when we find, as is very constantly the case, that the introduction of fresh blood has been of the very greatest use to deer, both by improving their size and appearance, and particularly by being of service in removing the taint of rickback, if not of other diseases to which deer are sometimes subject when the blood has not been changed, there can, I think, be no doubt but that a judicious cross with a good stock is of the greatest consequence, and is indeed essential sooner or later to the prosperity of every well-ordered park. Mr. Meynell's famous foxhounds have been adduced as showing that no ill effects follow from close interbreeding, and Sir J. Sebright ascertained from him that he frequently bred from father and daughter, mother and son, and sometimes even from brothers and sisters. With greyhounds also there has been much close interbreeding, but the best breeders agree that it may be carried too far. 17. But Sir J. Sebright declares 18 that by breeding inandin, by which he means matching brothers and sisters, he has actually seen the offspring of strong spaniels degenerate into weak and diminutive lapdogs. The Rev. W. Roman 500 Fox has communicated to me the case of a small lot of bloodhounds, long kept in the same family, which had become very bad breeders, and nearly all had a bony enlargement in the tail. A single cross with a distinct strain of bloodhounds restored their fertility and drove away the tendency to malformation in the tail. I have heard the particulars of another case with bloodhounds, in which the female had to be held to the male. Considering how rapid is the natural increase of the dog, it is difficult to understand the large price of all highly improved breeds, which almost implies long-continued close interbreeding, except on the belief that this process lessens fertility and increases liability to distemper and other diseases. A high authority, Mr. Scrope, attributes the rarity and deterioration in size of the Scotch deerhound, the few individuals formerly existing throughout the country being all related in large part to close interbreeding. With all hybrid animals, there is more or less difficulty in getting them to procreate quickly, and all suffer much from delicacy of constitution. A great judge of rabbits 19 says the long-eared does are often too highly bred or forced in their youth to be of much value, as breeders often turning out barren or bad mothers, they often desert their young, so that it is necessary to have nurse rabbits, But I do not pretend to attribute all these evil results to close interbreeding. 20. With respect to pigs, there is more unanimity amongst breeders on the evil effects of close interbreeding than perhaps with any other large animal. Mr. Druce, a great and successful breeder of the improved Oxfordshires, a crossed race, writes without a change of boars of a different tribe, but of the same breed constitution, cannot be preserved. Mr. Fisher Hobbs, the raiser of the celebrated improved Essex breed, divided his stock into 3 separate families, by which means he maintained the breed for more than 20 years, by judicious selection from the 3 distinct families. 21. Lord Western was the first importer of a Neapolitan boar, and so from this pair he bred Inandon, until the breed was in danger of becoming extinct, a sure result, as Mr. Sidney remarks of Inandon breeding. Lord Western then crossed his Neapolitan pigs with the old Essex, and made the first great step towards the improved Essex breed. Here is a more interesting case. Mr. J. Wright, well known as a breeder, crossed 22 the same boar with the daughter, granddaughter, and great-granddaughter, and so on for 7 generations. The result was that in many instances the offspring failed to breed, in others they produced few that lived, and of the latter, many were idiotic, without sense even to suck, and when attempting to move could not walk straight. Now, it deserves a special notice that the 2 last sows produced by this long course of interbreeding were sent to other boars, and they bore several litters of healthy pigs. The best sow in external appearance produced during the whole 7 generations was one in the last stage of descent, but the litter consisted of this one sow. She would not breed to her sire, yet bred at the first trial to a stranger in blood, so that in Mr. Wright's case long continued and extremely close interbreeding did not affect the external form or merit of the young, but with many of them, the general constitution and mental powers, and especially the reproductive functions, were seriously affected. Nathusius gives 23 an analogous, and even more striking case. He imported from England a pregnant sow of the large Yorkshire breed, and bred the product closely Inandon for 3 generations. The result was unfavorable, as the young were weak in constitution with impaired fertility. One of the latest sows, which he esteemed a good animal, produced, when paired with her own uncle, who was known to be productive with sows of other breeds, a litter of 6, and a second time a litter of only 5 weak young pigs. He then paired this sow with a boar of a small black breed, which he had likewise imported from England. This boar, when matched with sows of his own breed, produced from 7 to 9 young. Now the sow of the large breed, which was so unproductive, when paired with her own uncle, yielded to the small black boar in the first litter 21, and in the second litter 18 young pigs, so that in 1 year she produced 39 fine young animals. As in the case of several other animals already mentioned, even when no injury is perceptible from moderately close interbreeding, yet, to quote the words of Mr. Coate, who 5 times won the annual gold medal of the Smithfield Club show for the best pen of pigs, crosses answer well for profit to the farmer, as you get more constitution and quicker growth. But for me, who sell a great number of pigs for breeding purposes, I find it will not do, as it requires many years to get anything like purity of blood again. 24. Almost all the animals as yet mentioned are gregarious, and the males must frequently pair with their own daughters, for they expel the young males as well as all intruders, until forced by old age and loss of strength to yield to some stronger male. It is therefore not improbable that gregarious animals may have been rendered less susceptible than non-social species to the evil consequences of close interbreeding, so that they may be enabled to live in herds without injury to their offspring. Unfortunately, we do not know whether an animal like the cat, which is not gregarious, would suffer from close interbreeding in a greater degree than our other domesticated animals, but the pig is not, as far as I can discover, strictly gregarious, and we have seen that it appears eminently liable to the evil effects of close interbreeding. Mr. Huth, in the case of the pig, attributes chapter 24 these effects to their having been cultivated most for their fat, or to the selected individuals having had a weak constitution, but we must remember that it is great breeders who have brought forward the above cases, and who are far more familiar than ordinary men can be with the causes which are likely to interfere with the fertility of their animals. The effects of close interbreeding in the case of man is a difficult subject on which I will say but little. It has been discussed by various authors under many points of view. 25. Mr. Tyler, 26, has shown that with widely different races, in the most distant quarters of the world, marriages between distant relations have been strictly prohibited, There are however many exceptions to the rule, which are fully given by Mr. Huth 27. It is a curious problem how these prohibitions arose during early and barbarous times. Mr. Tyler is inclined to attribute them to the evil effects of consanguineous marriages having been observed, and he ingeniously attempts to explain some apparent anomalies in the prohibition, not extending equally to the relations on the male and female side. He admits, however, that other causes, such as the extension of friendly alliances, may have come into play. Mr. W. Adam, on the other hand, concludes that related marriages are prohibited and viewed with repugnance from the confusion which would thus arise in the descent of property, and from other still more recondite reasons. But I cannot accept these views, seeing that incest is held in abhorrence by savages, such as those of Australia and South America, 28, who have no property to bequeath or fine moral feelings to confuse, and who are not likely to reflect on distant evils to their progeny. According to Mr. Huth, the feeling is the indirect result of exogamy inasmuch as when this practice ceased in any tribe, and it became endogamous so that marriages were strictly confined to the same tribe, it is not unlikely that a vestige of the former practice would still be retained, so that closely related marriages would be prohibited. With respect to exogamy itself, Mr. Lennon believes that it arose from a scarcity of women owing to female infanticide, aided perhaps by other causes. It has been clearly shown by Mr. Huth that there is no instinctive feeling in man against incest, any more than in gregarious animals. We know also how readily any prejudice or feeling may rise to abhorrence, as shown by Hindus in regard to objects causing defilement. Although there seems to be no strong inherited feeling in mankind against incest, it seems possible that men during primeval times may have been more excited by strange females than by those whom they habitually lived in the same manner, as according to Mr. Couples, 29 male deerhounds are inclined towards strange females, while the females prefer dogs with whom they have associated. If any such feeling formerly existed in man, this would have led to a preference for marriages beyond the nearest kin, and might have been strengthened by the offspring of such marriages surviving in greater numbers, as analogy would lead us to believe would have occurred. Whether consanguineous marriages, such as are permitted in civilized nations, and which would not be considered as close interbreeding in the case of our domesticated animals, cause any injury will never be known with certainty until a census is taken with this object in view. My son, George Darwin, has done what is possible at present by a statistical investigation 30, and he has come to the conclusion from his own researches, and those of Dr. Mitchell, that the evidence as to any evil thus caused is conflicting, but on the whole points to the evil being very small. Birds. In the case of the fowl, a whole array of authorities could be given against too close interbreeding. Sir J. Sebright positively asserts that he made many trials, and that his fowls, when thus treated, became long in the legs, small in the body, and bad breeders. 31. He produced the famous Sebright bantams by complicated crosses and by breeding Anandon, and since his time there has been much close interbreeding with these animals, and they are now notoriously bad breeders. I have seen silver bantams directly descended from his stock which had become almost as barren as hybrids, for not a single chicken had been that year hatched from 2 full nests of eggs. Mr. Hewitt says that with these bantams, the sterility of the male stands with rare exceptions in the closest relation with their loss of certain secondary male characters. He adds, I have noticed as a general rule that even the slightest deviation from feminine character in the tail of the male Sebright, say, the elongation by only half an inch of the 2 principal tail feather springs, with it improved probability of increased fertility. 32. Mr. Wright states 33 that Mr. Clark, whose fighting cocks were so notorious, continued to breed from his own kind, till they lost their disposition to fight, but stood to be cut up without making any resistance, and were so reduced in size as to be under those weights required for the best prizes. But on obtaining a cross from Mr. Leeton, they again resumed their former courage, and weighed. It should be borne in mind that gamecocks before they fought were always weighed, so that nothing was left to the imagination about any reduction or increase of weight. Mr. Clark does not seem to have bred from brothers and sisters, which is the most injurious kind of union, and he found after repeated trials that there was a greater reduction in weight in the young from a father paired with his daughter than from a mother with her son. I may add that Mr. Eiton of Eiton, the well-known ornithologist, who is a large breeder of gray Dorkings, informs me that they certainly diminish in size and become less prolific unless a cross with another strain is occasionally obtained, So it is with melees according to Mr. Hewitt as far as size is concerned. 34. An experienced writer 35 remarks that the same amateur as is well known seldom long maintains the superiority of his birds, and this he adds undoubtedly is due to all his stock being of the same blood, hence it is indispensable that he should occasionally procure a bird of another strain. But this is not necessary with those who keep a stock of fowls at different stations. Thus Mr. Balance, who has bred melees for 30 years and has won more prizes with these birds than any other fancier in England, says that breeding in Andon does not necessarily cause deterioration, but all depends upon how this is managed. My plan has been to keep about 5 or 6 distinct runs, and to rear about 200 or 300 chickens each year, and select the best birds from each run for crossing. I thus secure sufficient crossing to prevent deterioration. 36. We thus see that there is almost complete unanimity with poultry breeders, that when fowls are kept at the same place, evil quickly follows from interbreeding, carried on to an extent which would be disregarded in the case of most quadrupeds. Moreover, it is a generally received opinion that crossbred chickens are the hardiest and most easily reared. 37. Mr. Tegetmeier, who has carefully attended to poultry of all breeds, says 38 that Dorking hens allowed to run with Howden or Crevecoeur cocks produce in the early spring chickens that, for size, hardihood, early maturity, and fitness for the market, surpass those of any pure breed that we have ever raised. Mr. Hewitt gives it as a general rule with fowls that crossing the breed increases their size. He makes this remark after stating that hybrids from the pheasant and fowl are considerably larger than either progenitor. So again, hybrids from the male golden pheasant and female common pheasant are of far larger size than either parent bird. 39. To this subject of the increased size of hybrids, I shall presently return. With pigeons, breeders are unanimous, as previously stated, that it is absolutely indispensable, notwithstanding the trouble and expense thus caused occasionally, to cross their much-prized birds with individuals of another strain, but belonging of course to the same variety. It deserves notice that when size is one of the desired characters, as with pouters. 40, the evil effects of close interbreeding are much sooner perceived than when small birds such as short-faced tumblers are valued. The extreme delicacy of the high fancy breeds, such as these tumblers and improved English carriers, is remarkable. They are liable to many diseases, and often die in the egg, or during the first molt, and their eggs have generally to be hatched under foster mothers. Although these highly prized birds have invariably been subjected to much close interbreeding, yet their extreme delicacy of constitution cannot perhaps be thus fully explained. Mr. Yarrell informed me that Sir J. Sebright continued closely interbreeding some alpagins, until from their extreme sterility, he as nearly as possible lost the whole family. Mr. Brent 40. One tried to raise a breed of trumpeters by crossing a common pigeon, and recrossing the daughter, granddaughter, great-granddaughter, and great-great-granddaughter with the same male trumpeter, until he obtained a bird with 15/16 of trumpeter's blood. But then the experiment failed for breeding, so close stopped reproduction. The experienced Neumeister 42 also asserts that the offspring from dovecotes and various other breeds are generally very fertile and hardy birds. So again, Roman 2000 Boydard and Corby 43, after 4 to 5 years, experience recommend persons to cross their breeds for amusement, for if they fail to make interesting birds, they will succeed under an economical point of view, as it is found that mongrels are more fertile than pigeons of pure race. I will refer only to one other animal, namely, the hivebee, because a distinguished entomologist has advanced this as a case of inevitable close interbreeding. As the hive is tenanted by a single female, it might have been thought that her male and female offspring would always have bred together, more especially as bees of different hives are hostile to each other, a strange worker being almost always attacked when trying to enter another hive. But Mr. Tegetmeier has shown 44 that this instinct does not apply to drones, which are permitted to enter any hive, so that there is no a priori improbability of a queen receiving a foreign drone. The fact of the union, invariably and necessarily taking place on the wing during the queen's nuptial flight, seems to be a special provision against continued interbreeding. However this may be, experience has shown, since the introduction of the yellow-banded Ligurian race into Germany and England, that bees freely cross. Mr. Woodbury, who introduced Ligurian bees into Devonshire, found during a single season that 3 stocks at distances of from 1 to 2 miles from his hives were crossed by his drones. In one case, the Ligurian drones must have flown over the city of Exeter, and over several intermediate hives on another occasion. Several common black queens were crossed by Ligurian drones at a distance of from 1 to 3.5 miles, 45. Plants. When a single plant of a new species is introduced into any country if propagated by seed, many individuals will soon be raised, so that if the proper insects be present, there will be crossing with newly introduced trees or other plants not propagated by seed. We are not here concerned. Old established plants. It is an almost universal practice, occasionally, to make exchanges of seed, by which means individuals which have been exposed to different conditions of life and this, as we have seen with animals, diminishes the evil from close interbreeding will occasionally be introduced into each district. With respect to individuals belonging to the same subvariety, Gartner, whose accuracy and experience exceeded that of all other observers, states 46 that he has many times observed good effects from this step, especially with exotic genera, of which the fertility is somewhat impaired, such as Passiflora lobelia fuchsia. Herbert also says 47. I am inclined to think that I have derived advantage from impregnating the flower from which I wish to obtain seed with pollen from another individual of the same variety, or at least from another flower, rather than with its own again. Professor Lecoq ascertained that crossed offspring are more vigorous and robust than their parents. 48. General statements of this kind, however, can seldom be fully trusted. I therefore began a long series of experiments, continued for about 10 years, which will, I think, conclusively show the good effects of crossing two distinct plants of the same variety, and the evil effects of long-continued self-fertilization. A clear light will thus be thrown on such questions as why flowers are almost invariably constructed so as to permit or favor or necessitate the union of two individuals. We shall clearly understand why Montius and Dioecious, dichogamous, dimorphic, and trimorphic plants exist, and many other such cases. I intend soon to publish an account of these experiments, and I can here give only a few cases in illustration. The plan which I followed was to grow plants in the same pot, or in pots of the same size, or close together in the open ground, carefully to exclude insects, and then to fertilize some of the flowers with pollen from the same flower, and others on the same plant with pollen from a distinct but adjoining plant. In many of these experiments, the crossed plants yielded much more seed than the self-fertilized plants, and I have never seen the reversed case. The self-fertilized and crossed seeds, thus obtained, were allowed to germinate in the same glass vessel on damp sand. And as the seeds germinated, they were planted in pairs on opposite sides of the same pot, with a superficial partition between them, and were placed so as to be equally exposed to the light. In other cases, the self-fertilized and crossed seeds were simply sown on opposite sides of the same small pot. I have in short followed different plans, but in every case have taken all the precautions which I could think of, so that the two lots should be equally favored. The growth of the plants raised from the crossed and self-fertilized seed were carefully observed from their germination to maturity in species belonging to 52 genera, and the difference in their growth and in withstanding unfavorable conditions was in most cases manifest and strongly marked. It is of importance that the two lots of seed should be sown or planted on opposite sides of the same pot, so that the seedlings may struggle against each other, for if sown separately in ample and good soil, there is often but little difference in their growth. I will briefly describe two of the first cases observed by me. 6 crossed and 6 self-fertilized seeds of Ipomoea purpurea from plants treated in the manner above described were planted as soon as they had germinated in pairs on opposite sides of 2 pots, and rods of equal thickness were given them to twine up. 5 of the crossed plants grew from the first more quickly than the opposed self-fertilized plants. The 6th, however, was weakly, and was for a time beaten, but at last its sounder constitution prevailed, and it shot ahead of its antagonist as soon as each crossed plant reached the top of its 7-foot rod. Its fellow was measured, and the result was that when the crossed plants were 7 feet high, the self-fertilized had attained the average height of only 5 feet 4.5 inches. The crossed plants flowered a little before, and more profusely, than the self-fertilized plants on opposite sides of another small pot. A large number of crossed and self-fertilized seeds were sown, so that they had to struggle for bare existence. A single rod was given to each lot. Here again, the crossed plants showed from the first their advantage. They never quite reached the summit of the 7-foot rod, but, relatively to the self-fertilized plants, their average height was as 7 feet to 5 feet 2 inches. The experiment was repeated during several succeeding generations, treated in exactly the same manner, and with nearly the same result in the second generation. The crossed plants which were again crossed produced 121 seed capsules, whilst the self-fertilized produced only 84 capsules. Some flowers of the Mimulus luteus were fertilized with their own pollen, and others were crossed with pollen from distinct plants growing in the same pot. The seeds were thickly sown on opposite sides of a pot. The seedlings were at first equal in height, but when the young crossed plants were half an inch, self-fertilized plants were only a quarter of an inch high. But this degree of inequality did not last, for when the crossed plants were 4.5 inches high, the self-fertilized were 3 inches, and they retained the same relative difference till their growth was complete. The crossed plants looked far more vigorous than the uncrossed and flowered before them. They produced also a far greater number of capsules. As in the former case, the experiment was repeated during several succeeding generations. Had I not watched these plants of Mimulus and Ipomoea during their whole growth, I could not have believed it possible that a difference apparently so slight as that of the pollen being taken from the same flower or from a distinct plant growing in the same pot could have made so wonderful a difference in the growth and vigor of the plants. Thus produced this, under a physiological point of view, is a most remarkable phenomenon. With respect to the benefit derived from crossing distinct varieties, plenty of evidence has been published. Sagerit 49 repeatedly speaks in strong terms of the vigor of melons raised by crossing different varieties and adds that they are more easily fertilized than common melons, and produce numerous good seed. Here follows the evidence of an English gardener. 50. I have this summer met with better success in my cultivation of melons in an unprotected state from the seeds of hybrids, Roman 1e mongrels, obtained by cross-impregnation, than with old varieties, the offspring of 3 different hybridizations, one more especially of which the parents were the 2 most dissimilar varieties. I could select. Each yielded more ample and finer produce than any one of between 20 and 30 established varieties. Andrew Knight 51 believed that his seedlings from crossed varieties of the apple exhibited increased vigor and luxuriance, and Roman 1000 Chevreul 52 alludes to the extreme vigor of some of the crossed fruit trees raised by Sagerit. By crossing reciprocally the tallest and shortest peas, Knight 53 says, I had in this experiment a striking instance of the stimulative effects of crossing the breeds, for the smallest variety, whose height rarely exceeded 2 feet, was increased to 6 feet, whilst the height of the large and luxuriant kind was very little diminished. Mr. Laxton gave me seed peas produced from crosses between 4 distinct kinds, and the plants thus raised were extraordinarily vigorous, being in each case from 1 to 2 or 3 feet taller than the parent forms growing close alongside them. Wiegman 54 made many crosses between several varieties of cabbage, and he speaks with astonishment of the vigor and height of the mongrels, which excited the amazement of all the gardeners who beheld them. Mr. Chaundi raised a great number of mongrels by planting together 6 distinct varieties of cabbage. These mongrels displayed an infinite diversity of character, but the most remarkable circumstance was that while all the other cabbages and borkels in the nursery were destroyed by a severe winter, these hybrids were little injured and supplied the kitchen when there was no other cabbage to be had. Mr. Mond exhibited before the Royal Agricultural Society 55 specimens of crossed wheat together with their parent varieties, and the editor states that they were intermediate in character, united with that greater vigor of growth, which it appears in the vegetable, as in the animal world, is the result of a first cross. Knight also crossed several varieties of wheat. 56, and he says that in the years 1795 and 1796, when almost the whole crop of corn in the island was blighted, the varieties thus obtained, and these only escaped in this neighborhood though sown in several different soils and situations. Here is a remarkable case. Roman 1000 Klotch 57 crossed Pinus sylvestris and nigricans Quercus robur and pedunculata, Ulmus glutinosa, and Incana ulmus campestris and effusa, and the cross-fertilized seeds, as well as seeds of the pure parent trees, were all sown at the same time, and in the same place. The result was that after an interval of 8 years, the hybrids were 1/3 taller than the pure trees. The facts above given refer to undoubted varieties, excepting the trees crossed by Klotch, which are ranked by various botanists as strongly marked races, subspecies, or species, that true hybrids raised from entirely distinct species, though they lose in fertility, often gain in size, and constitutional vigor is certain. It would be superfluous to quote any facts, for all experimenters Kallreuter, Gartner, Herbert, Sadrat, Lecoq, and Naudin have been struck with the wonderful vigor, height, size, tenacity of life, precocity, and hardiness of their hybrid productions. Gartner 58 sums up his conviction on this head in the strongest terms. Kallreuter 59 gives numerous precise measurements of the weight and height of his hybrids in his comparison with measurements of both parent forms, and speaks, with astonishment, of their statura portentosa, their ambitus vastissimus ac altitudo valda. Conspicuous. Some exceptions to the rule in the case of very sterile hybrids have however been noticed by Gartner and Herbert, but the most striking exceptions are given by Max Wichura 60, who found that hybrid willows were generally tender in constitution, dwarf, and short-lived. Kallreuter explains the vast increase in the size of the roots, stems, etc. of his hybrids as the result of a sort of compensation, due to their sterility, in the same way as many emasculated animals are larger than the perfect males. This view seems at first sight extremely probable, and has been accepted by various authors. 61, but Gartner 62 has well remarked that there is much difficulty in fully admitting it, for with many hybrids, there is no parallelism between the degree of their sterility and their increased size and vigor. The most striking instances of luxuriant growth have been observed with hybrids which were not sterile in any extreme degree. In the genus Mirabilis, certain hybrids are unusually fertile, and their extraordinary luxuriance of growth, together with their enormous roots, 63, have been transmitted to their progeny. The result in all cases is probably in part due to the saving of nutriment and vital force through the sexual organs acting imperfectly or not at all, but more especially to the general law of good being derived from a cross, for it deserves especial attention that mongrel animals and plants, which are so far from being sterile that their fertility is often actually augmented, have, as previously shown, their size, hardiness, and constitutional vigor generally increased. It is not a little remarkable that an accession of vigor and size should thus arise under the opposite contingencies of increased and diminished fertility. It is a perfectly well ascertained fact. 64, that hybrids invariably breed with either pure parent, and not rarely with a distinct species, more readily than with one another. Herbert is inclined to explain even this fact by the advantage derived from a cross, but Gartner more justly accounts for it by the pollen of the hybrid, and probably its ovules being in some degree vitiated, whereas the pollen and ovules of both pure parents and of any third species are sound. Nevertheless, there are some well-ascertained and remarkable facts which, as we shall presently see, show that a cross by itself undoubtedly tends to increase or re-establish the fertility of hybrids. The same law, namely that the crossed offspring, both of varieties and species, are larger than the parent forms, holds good in the most striking manner with hybrid animals, as well as with mongrels. Mr. Bartlett, who has had such large experience, says among all hybrids of vertebrated animals, there is a marked increase of size. He then enumerates many cases with mammals, including monkeys, and with various families of birds. 65. On certain hermaphrodite plants, which either normally or abnormally require to be fertilized by pollen from a distinct individual or species. The facts now to be given differ from the foregoing, as self-sterility is not here the result of long-continued close interbreeding. These facts are, however, connected with our present subject, because a cross with a distinct individual is shown to be either necessary or advantageous. Dimorphic and trimorphic plants, though they are hermaphrodites, must be reciprocally crossed, one set of forms by the other, in order to be fully fertile, and in some cases to be fertile in any degree. But I should not have noticed these plants had it not been for the following cases given by Dr. Hildebrand. 66. Primula sinensis is a reciprocally dimorphic species. Dr. Hildebrand fertilized 28 flowers of both forms, each by pollen of the other form, and obtained the full number of capsules, containing on an average 427 seed per capsule. Here we have complete and normal fertility. He then fertilized 42 flowers of both forms with pollen of the same form, but taken from a distinct plant, and all produced capsules, containing on an average only 196 seed. Lastly, and here we come to our more immediate point, he fertilized 48 flowers of both forms with pollen of the same form, and taken from the same flower, and now he obtained only 32 capsules, and these contained on an average 186 seed, or one less per capsule, than in the former case, so that with these illegitimate unions, the act of impregnation is less assured and the fertility slightly less when the pollen and ovules belong to the same flower than when belonging to two distinct individuals of the same form. Dr. Hildebrand has recently made analogous experiments on the long-stalled form of Oxalis rosea with the same result. 67. It has recently been discovered that certain plants, whilst growing in their native country under natural conditions, cannot be fertilized with pollen from the same plant. They are sometimes so utterly self-impotent that though they can readily be fertilized by the pollen of a distinct species or even distinct genus, yet wonderful as is the fact they never produce a single seed by their own pollen. In some cases, moreover, the plant's own pollen and stigma mutually act on each other in a deleterious manner. Most of the facts to be given relate to orchids, but I will commence with a plant belonging to a widely different family. 6 to 3 flowers of Corydalus cava borne on distinct plants were fertilized by Dr. Hildebrand. 68, with pollen from other plants of the same species, and 58 capsules were obtained, including on an average 4 seed in each. He then fertilized 16 flowers produced by the same raceme one with another, but obtained only 3 capsules, one of which alone contained any good seeds, namely 2 in number. Lastly, he fertilized 27 flowers each with its own pollen. He left also 57 flowers to be spontaneously fertilized, and this would certainly have ensued if it had been possible for the anthers not only touch the stigma, but the pollen tubes were seen by Dr. Hildebrand to penetrate it. Nevertheless, these 84 flowers did not produce a single seed capsule. This whole case is highly instructive, as it shows how widely different the action of the same pollen is according as it is placed on the stigma of the same flower, or on that of another flower on the same raceme, or on that of a distinct plant. With exotic orchids, several analogous cases have been observed, chiefly by Mr. John Scott. 69. Oncidium sphaeculatum has effective pollen, for Mr. Scott fertilized 2 distinct species with it. The ovules are likewise capable of impregnation, for they were readily fertilized by the pollen of O. divricatum. Nevertheless, between 1 and 200 flowers fertilized by their own pollen did not produce a single capsule, though the stigmas were penetrated by the pollen tubes. Mr. Robertson Munro, of the Royal Botanic Gardens of Edinburgh, also informs me 1864 that 120 flowers of this same species were fertilized by him with their own pollen, and did not produce a capsule, but 8 flowers, fertilized by the pollen of O. divricatum, produced 4 fine capsules. Again, between 2 and 300 flowers of O. divricatum fertilized by their own pollen did not set a capsule, but 12 flowers fertilized by O. flexuosum produced 8 fine capsules, so that here we have 3 utterly self-impotent species, with their male and female organs perfect as shown by their mutual fertilization. In these cases, fertilization was effected only by the aid of a distinct species, but as we shall presently see, distinct plants raised from seed of Oncidium flexuosum, and probably of the other species, would have been perfectly capable of fertilizing each other, for this is the natural process. Again, Mr. Scott found that the pollen of a plant of O. microchilum was effective, for with it he fertilized 2 distinct species. He found its ovules good, for they could be fertilized by the pollen of one of these species, and by the pollen of a distinct plant of O. microchilum, but they could not be fertilized by pollen of the same plant, though the pollen tubes penetrated the stigma. An analogous case has been recorded by Roman 1000 Riviere 70, with 2 plants of O. cavendishianum, which were both self-sterile but reciprocally fertilized each other. All these cases refer to the genus Oncidium, but Mr. Scott found that Maxillaria atrorubens was totally insusceptible of fertilization with its own pollen, but fertilized, and was fertilized by a widely distinct species, viz. Roman 1000 squalens. As these orchids had been grown under unnatural conditions in hothouses, I concluded that their self-sterility was due to this cause, but Fritz Müller informs me that at Desterro in Brazil, he fertilized above 100 flowers of the above-mentioned Oncidium flexuosum, which is there endemic with its own pollen, and with that taken from distinct plants. All the former were sterile, whilst those fertilized by pollen from any other plant of the same species were fertile during the first 3 days. There was no difference in the action of the 2 kinds of pollen that placed on stigma of the same plant, separated in the usual manner into grains and emitted tubes, which penetrated the column, and the stigmatic chamber shut itself. But only those flowers which had been fertilized by pollen taken from a distinct plant produced seed capsules on a subsequent occasion. These experiments were repeated on a large scale, with the same result. Fritz Müller found that 4 other endemic species of Oncidium were in like manner utterly sterile with their own pollen but fertile with that from any other plant. Some of them likewise produced seed capsules, when impregnated with pollen of widely distinct genera, such as Ceadopodium and Rodriguezia. Oncidium crispum, however, differs from the foregoing species in varying much in its self-sterility, some plants producing fine pods with their own pollen, others failing to do so, in 2 or 3 instances. Fritz Müller observed that the pods produced by pollen taken from a distinct flower on the same plant were larger than those produced by the flower's own pollen in Epidendrum cinnabarinum, an orchid belonging to another division of the family. Fine pods were produced by the plant's own pollen, but they contained by weight only about half as much seed as the capsules which had been fertilized by pollen from a distinct plant, and in one instance from a distinct species, moreover a very large proportion, and in some cases, nearly all the seeds produced by the plant's own pollen were destitute of an embryo. Some self-fertilized capsules of a maxillaria were in a similar state. Another observation made by Fritz Müller is highly remarkable, namely, that with various orchids, the plant's own pollen not only fails to impregnate the flower, but acts on the stigma, and is acted on in an injurious or poisonous manner. This is shown by the surface of the stigma in contact with the pollen, and by the pollen itself becoming in from 3 to 5 days dark brown, and then decaying. The discoloration and decay are not caused by parasitic cryptograms, which were observed by Fritz Müller in only a single instance. These changes are well shown by placing on the same stigma at the same time the plant's own pollen, and that from a distinct plant of the same species, or of another species, or even of another and widely remote genus. Thus on the stigma of Oncidium flexuosum the plant's own pollen and that from a distinct plant were placed side by side, and in 5 days' time the latter was perfectly fresh, whilst the plant's own pollen was brown. On the other hand, when the pollen of a distinct plant of the Oncidium flexuosum and of the Epidendrum zebra nov spec were placed together on the same stigma, they behaved in exactly the same manner, the grains separating emitting tubes and penetrating the stigma, so that the 2 pollen masses after an interval of 11 days could not be distinguished, except by the difference of their cauticles, which of course undergo no change. Fritz Müller has moreover made a large number of crosses between orchids belonging to distinct species and genera, and he finds that in all cases when the flowers are not fertilized, their footstalks first begin to wither, and the withering slowly spreads upwards, until the germans fall off after an interval of 1 or 2 weeks, and in one instance of between 6 and 7 weeks. But even in this latter case, and in most other cases, the pollen and stigma remained in appearance fresh. Occasionally, however, the pollen becomes brownish generally on the external surface, and not in contact with the stigma, as is invariably the case when the plant's own pollen is applied. Fritz Müller observed the poisonous action of the plant's own pollen in the above-mentioned Oncidium flexuosum, O unicorn pubis, and in 2 other unnamed species, also in 2 species of Rodriguezia, in 2 of Natalia, in 1 of Burlingtonia, and of a 4th genus in the same group. In all these cases, except the last, it was proved that the flowers were, as might have been expected, fertile with pollen. Distinct plant of the same species, numerous flowers of 1 species of Natalia were fertilized with pollen from the same raceme. In 2 days' time, they all withered. The germans began to shrink, the pollen masses became dark brown, and not 1 pollen grain emitted a tube, so that in this orchid the injurious action of the plant's own pollen is more rapid than with Oncidium flexuosum. 8 other flowers on the same raceme were fertilized with pollen from a distinct plant of the same species. 2 of these were dissected, and their stigmas were found to be penetrated by numberless pollentubes, and the germans of the other 6 flowers became well developed. On a subsequent occasion, many other flowers were fertilized with their own pollen, and all fell off dead in a few days, whilst some flowers on the same raceme, which had been left simply unfertilized, adhered, and long remained fresh. We have seen that in cross-unions between extremely distinct orchids, the pollen long remains undecayed, but Natalia behaved in this respect differently, for when its pollen was placed on the stigma of Oncidium flexuosum, both the stigma and pollen quickly became dark brown in the same manner, as if the plant's own pollen had been applied. Fritz Müller suggests that as in all these cases the plant's own pollen is not only impotent, thus effectually preventing self-fertilization, but likewise prevents, as was ascertained in the case of the Natilia and Oncidium flexuosum, the action of subsequently applied pollen from a distinct individual, it would be an advantage to the plant to have its own pollen rendered more and more deleterious, for the Germans would thus quickly be killed, and dropping off, there would be no further waste in nourishing a part, which ultimately could be of no avail. The same naturalist found in Brazil 3 plants of a bignonia growing near together. He fertilized 29 flowerets on one of them with their own pollen, and they did not set a single capsule. 30 flowers were then fertilized with pollen from a distinct plant. One of the 3, and they yielded only 2 capsules. Lastly, 5 flowers were fertilized with pollen from a 4th plant growing at a distance, and all 5 produced capsules. Fritz Müller thinks that the 3 plants which grew near one another were probably seedlings from the same parent, and that from being closely related, they acted very feebly on one another. This view is extremely probable, for he has since shown in a remarkable paper 71 that in the case of some Brazilian species of abutilon which are self-sterile, and between which he raised some complex hybrids, that these if near relatives were much less fertile inter se than when not closely related. We now come to cases closely analogous with those just given but different in so far that only certain individuals of the species are self-sterile. This self-impotence does not depend on the pollen or ovules being in an unfit state for fertilization, for both have been found effective in union with other plants of the same or of a distinct species. The fact of plants having acquired so peculiar a constitution that they can be fertilized more readily by the pollen of a distinct species than by their own is exactly the reverse of what occurs with all ordinary species, for in the latter, the 2 sexual elements of the same individual plant are of course capable of freely acting on each other, but are so constituted that they are more or less impotent when brought into union with the sexual elements of a distinct species, and produce more or less sterile hybrids. Gartner experimented on 2 plants of Lobelia fulgens brought from separate places, and found 72 that their pollen was good, for he fertilized with it Roman 50 cardinales and syphilitica. Their ovules were likewise good, for they were fertilized by the pollen of these same 2 species. But these 2 plants of Roman 50 fulgens could not be fertilized by their own pollen, as can generally be effected with perfect ease with this species. Again, the pollen of a plant of Verbascum nigrum grown in a pot was found by Gartner 73 capable of fertilizing Roman 5 lichnitis and Roman 5 austriacum. The ovules could be fertilized by the pollen of Roman 5 thapsus, but the flowers could not be fertilized by their own pollen. Kallreuter, also 74, gives the case of 3 garden plants of Verbascum ph niceum, which bore during 2 years many flowers. These he fertilized successfully with the pollen of no less than 4 distinct species, but they produced not a seed with their own apparently good pollen. Subsequently, these same plants and others raised from seed assumed a strangely fluctuating condition, being temporarily sterile on the male or female side, or on both sides, and sometimes fertile on both sides. But 2 of the plants were perfectly fertile throughout the summer. With Reseda odorata, I have found certain individuals quite sterile with their own pollen, and so it is with the indigenous Reseda lutea. The self-sterile plants of both species were perfectly fertile when crossed with pollen from any other individual of the same species. These observations will hereafter be published in another work, in which I shall also show that seeds sent to me by Fritz Müller produced by plants of Eschscholtzia californica, which were quite self-sterile in Brazil, yielded in this country plants which were only slightly self-sterile. It appears 75 that certain flowers on certain plants of Lilium candidum can be fertilized more freely by pollen from a distinct individual than by their own. So again, with the varieties of the potato, Tinsman 76, who made many trials with this plant, says that pollen from another variety sometimes exerts a powerful influence, and I have found sorts of potatoes which would not bear seed from impregnation with the pollen of their own flowers, would bear it when impregnated with other pollen. It does not, however, appear to have been proved that the pollen which failed to act on the flower's own stigma was in itself good. In the genus Passiflora, it has long been known that several species do not produce fruit unless fertilized by pollen taken from distinct species. Thus, Mr. Mowbray 77 found that he could not get fruit from P. alata and racemosa except by reciprocally fertilizing them with each other's pollen, and similar facts have been observed in Germany and France. 78. I have received 2 accounts of P. quadrangularis never producing fruit from its own pollen, but doing so freely when fertilized in one case with the pollen of P. crulea and in another case with that of P. edulis, but in 3 other cases, this species fruited freely when fertilized with its own pollen. And the writer in one case attributed the favorable result to the temperature of the house having been raised from 5 to 10 far above the former temperature after the flowers were fertilized. 79. With respect to P. laurifolia, a cultivator of much experience has recently remarked 80 that the flowers must be fertilized with the pollen of P. crulea, or of some other common kind, as their own pollen will not fertilize them. But the fullest details on this subject have been given by Messrs. Scott and Robertson Munro. 81 plants of Passiflora racemosa crulea and alata flowered profusely during many years in the Botanic Gardens of Edinburgh, and though repeatedly fertilized with their own pollen, never produced any seed, yet this occurred at once with all 3 species, when they were crossed together in various ways. In the case of P. crulea, 3 plants, 2 of which grew in the Botanic Gardens, were all rendered fertile merely by impregnating each with pollen of one of the others. The same result was attained in the same manner with P. alata, but with only 1 plant out of 3. As so many self-sterile species of Passiflora have been mentioned, it should be stated that the flowers of the annual P. gracilis are nearly as fertile with their own pollen as with that from a distinct plant. Thus 16 flowers spontaneously self-fertilized produced fruit each, containing on an average 213 seed, whilst fruit from 14 crossed flowers contained 241 seed. Returning to P. alata, I have received 1866 some interesting details from Mr. Robertson Munro. 3 plants, including 1 in England, have already been mentioned which were inveterately self-sterile, and Mr. Munro informs me of several others which after repeated trials during many years have been found in the same predicament at some other places. However, this species fruits readily when fertilized with its own pollen at Taymouth Castle. There is a plant which was formerly grafted by Mr. Donaldson on a distinct species name unknown, and ever since the operation it has produced fruit in abundance by its own pollen, so that this small and unnatural change in the state of this plant has restored its self-fertility. Some of the seedlings from the Taymouth Castle plant were found to be not only sterile with their own pollen, but with each other's pollen, and with the pollen of distinct species. Pollen from the Taymouth plant failed to fertilize certain plants of the same species, but was successful on one plant. In the Edinburgh Botanic Gardens, seedlings were raised from this latter union, and some of their flowers were fertilized by Mr. Munro with their own pollen, but they were found to be as self-impotent as the mother plant had always proved, except when fertilized by the grafted Taymouth plant, and, except as we shall see when fertilized by her own seedlings. For Mr. Munro fertilized 18 flowers on the self-impotent mother plant with pollen from these her own self-impotent seedlings, and obtained remarkable, as the fact is, 18 fine capsules, full of excellent seed. I have met with no case in regard to plants which shows so well as this of P. alata on what small and mysterious causes complete fertility or complete sterility depends. The facts hitherto given relate to the much lessened or completely destroyed fertility of pure species when impregnated with their own pollen, in comparison with their fertility when impregnated by distinct individuals or distinct species, but closely analogous facts have been observed with hybrids. Herbert states 82 that having in flower at the same time 9 hybrid hippestrums of complicated origin, descended from several species, he found that almost every flower touched with pollen from another cross produced seed abundantly, and those which were touched with their own pollen either failed entirely or formed slowly a pod of inferior size with fewer seeds. In the Horticultural Journal, he adds that the admission of the pollen of another crossbred hippestrum, however complicated the cross to any one flower of the number, is almost sure to check the fructification of the others. In a letter written to me in 1839, Dr. Herbert says that he had already tried these experiments during 5 consecutive years, and he subsequently repeated them with the same invariable result. He was thus led to make an analogous trial on a pure species, namely on the Hippostrum aulicum, which he had lately imported from Brazil. This bulb produced 4 flowers, 3 of which were fertilized by their own pollen, and the 4th by the pollen of a triple cross between H. bulbulosum, regin and vittatum. The result was that the ovaries of the 3 first flowers soon ceased to grow, and after a few days perished entirely, whereas the pod impregnated by the hybrid made vigorous and rapid progress to maturity and bore good seed, which vegetated freely. This is indeed, as Herbert remarks, a strange truth, but not so strange as it then appeared. As a confirmation of these statements, I may add that Mr. Roman 1000, Mays 83, after much experience in crossing the species of Amaryllis hippistrum, says neither the species nor the hybrids will we are well aware produce seed so abundantly from their own pollen as from that of others. So again, Mr. Bidwell in New South Wales, 84 asserts that Amaryllis belladonna bears many more seeds when fertilized by the pollen of Brunswigia amaryllis of some authors Josephine or of B. multiflora than when fertilized by its own pollen. Mr. Beaton dusted 4 flowers of Aceatanthus with their own pollen, and 4 with the pollen of Vallota amaryllis purpurea. On the 7th day, those which received their own pollen slackened their growth, and ultimately perished. Those which were crossed with the Vallota held on 85. These latter cases, however, relate to uncrossed species, like those before given with respect to passiflora orchids etc., and are here referred to only because the plants belong to the same group of Amaryllidae. In the experiments on the hybrid hippistrums, if Herbert had found that the pollen of 2 or 3 kinds alone had been more efficient on certain kinds than their own pollen, it might have been argued that these from their mixed parentage had a closer mutual affinity than the others, but this explanation is inadmissible, for the trials were made reciprocally backwards and forwards on 9 different hybrids, and across whichever way taken always proved highly beneficial. I can add a striking and analogous case from experiments made by the Rev. A. Rawson of Bromley Common with some complex hybrids of gladiolus. This skillful horticulturist possessed a number of French varieties, differing from each other only in the color and size of the flowers, all descended from Gandavensis, a well-known old hybrid said to be descended from G. natalensis by the pollen of G. oppositiflorus 86. Mr. Rawson, after repeated trials, found that none of the varieties would set seed with their own pollen, although taken from distinct plants of the same variety, which had of course been propagated by bulbs, but that they all seeded freely with pollen from any other variety. To give 2 examples, Ophir did not produce a capsule with its own pollen, but when fertilized with that of Janier Brenchlaensis vulcane and Linn, it produced 10 fine capsules, but the pollen of Ophir was good, for when Linn was fertilized by it 7 capsules were produced. This latter variety, on the other hand, was utterly barren with its own pollen, which we have seen was perfectly efficient on Ophir altogether. Mr. Rawson, in the year 1861, fertilized 26 flowers, borne by 4 varieties, with pollen taken from other varieties, and every single flower produced a fine seed capsule, whereas 52 flowers on the same plants fertilized at the same time with their own pollen did not yield a single seed capsule. Mr. Rawson fertilized in some cases the alternate flowers, and in other cases all those down one side of the spike with pollen of other varieties, and the remaining flowers with their own pollen. I saw these plants when the capsules were nearly mature, and their curious arrangement at once brought full conviction to the mind that an immense advantage had been derived from crossing these hybrids. Lastly, I have heard from Dr. E. Bornet of Antibes, who has made numerous experiments in crossing the species of cistus, but has not yet published the results, that when any of these hybrids are fertile, they may be said to be in regard to function dioecious, for the flowers are always sterile when the pistil is fertilized by pollen taken from the same flower or from flowers on the same plant, but they are often fertile if pollen be employed from a distinct individual of the same hybrid nature, or from a hybrid made by a reciprocal cross. Conclusion: that plants should be self-sterile, although both sexual elements are in a fit state for reproduction, appears at first sight opposed to all analogy with respect to the species, all the individuals of which are in this state. Although living under their natural conditions, we may conclude that their self-sterility has been acquired for the sake of effectually preventing self-fertilization. The case is closely analogous with that of dimorphic and trimorphic or heterostyled plants, which can be fully fertilized only by plants belonging to a different form, and not, as in the foregoing cases, indifferently by any other individual of the species. Some of these heterostyled plants are completely sterile with pollen taken from the same plant, or from the same form, with respect to species living under their natural conditions, of which only certain individuals are self-sterile. As with Reseda lutea, it is probable that these have been rendered self-sterile to ensure occasional cross-fertilization, whilst other individuals have remained self-fertile to ensure the propagation of the species. The case seems to be parallel with that of plants, which produce, as Hermann Muller has discovered, 2 formsone bearing more conspicuous flowers, with their structure adapted for cross-fertilization by insects, and the other form with less conspicuous flowers adapted for self-fertilization. The self-sterility, however, of some of the foregoing plants is incidental on the conditions to which they have been subjected, as with the Eschscholtzia, the Verbascum pH Niceum, the sterility of which varied according to the season, and with the Passiflora alata, which recovered its self-fertility when grafted on a different stock. It is interesting to observe in the above several cases the graduated series from plants, which when fertilized by their own pollen yield the full number of seeds, but with the seedlings, a little dwarfed in staturito plants, which when self-fertilized yield few seedsto, those which yield none, but have their ovaria somewhat developed, and lastly to those, in which the plant's own pollen and stigma mutually act on one another like poison. It is also interesting to observe on how slight a difference in the nature of the pollen, or of the ovule's complete self-sterility or complete self-fertility, must depend in some of the above cases. Every individual of the self-sterile species appears to be capable of producing the full complement of seed when fertilized by the pollen of any other individual, though judging from the facts given with respect to Abutilon, the nearest kin must be accepted, but not one individual can be fertilized by its own pollen, as every organism differs in some slight degree from every other individual of the same species. So no doubt it is with their pollen and ovules. And in the above cases, we must believe that complete self-sterility and complete self-fertility depend on such slight differences in the ovules and pollen, and not their having been differentiated in some special manner in relation to one another, for it is impossible that the sexual elements of many thousand individuals should have been specialized in relation to every other individual in some, however, of the above cases. As with certain passifloras, an amount of differentiation between the pollen and ovules sufficient for fertilization is gained only by employing pollen from a distinct species. But this is probably the result of such plants having been rendered somewhat sterile from the unnatural conditions to which they have been exposed. Exotic animals confined in menageries are sometimes in nearly the same state as the above-described self-impotent plants, for as we shall see in the following chapter, certain monkeys, the larger carnivora, several finches, geese, and pheasants cross together quite as freely as or even more freely than the individuals of the same species breed together. Cases will also be given of sexual incompatibility between certain male and female domesticated animals, which nevertheless are fertile when matched with any other individual of the same kind. In the early part of this chapter, it was shown that the crossing of individuals belonging to distinct families of the same race, or to different races or species, gives increased size and constitutional vigor to the offspring, and except in the case of crossed species, increased fertility. The evidence rests on the universal testimony of breeders, for it should be observed that I am not here speaking of the evil results of close interbreeding, and is practically exemplified in the higher value of crossbred animals for immediate consumption. The results of crossing have also been demonstrated with some animals, and with numerous plants by actual weight and measurement. Although animals of pure blood will obviously be deteriorated by crossing, as far as their characteristic qualities are concerned, there seems to be no exception to the rule that advantages of the kind just mentioned are thus gained even when there has not been any previous close interbreeding. And the rule applies to such animals as cattle and sheep, which can long resist breeding inandon between the nearest blood relations. In the case of crossed species, although size, vigor, precocity, and hardiness are with rare exceptions gained, fertility in a greater or less degree is lost. But the gain in the above respects can hardly be attributed to the principle of compensation, for there is no close parallelism between the increased size and vigor of hybrid offspring and their sterility. Moreover, it has been clearly proved that mongrels which are perfectly fertile gain these same advantages, as well as sterile hybrids. With the higher animals, no special adaptations for ensuring occasional crosses between distinct families seem to exist. The eagerness of the males, leading to severe competition between them, is sufficient, for even with gregarious animals, the old and dominant males will be dispossessed after a time, and it would be a mere chance if a closely related member of the same family were to be the victorious successor. The structure of many of the lower animals when they are hermaphrodites is such as to prevent the ovules being fertilized by the male element of the same individual, so that the concourse of two individuals is necessary. In other cases, the access of the male element of a distinct individual is at least possible with plants which are affixed to the ground, and cannot wander from place to place like animals, the numerous adaptations for cross-fertilization are wonderfully perfect, as has been admitted by everyone who has studied the subject. The evil consequences of long-continued close interbreeding are not so easily recognized, as the good effects from crossing for the deterioration is gradual nevertheless. It is the general opinion of those who have had most experience, especially with animals, which propagate quickly, that evil does inevitably follow sooner or later, but at different rates with different animals. No doubt a false belief may, like a superstition, prevail widely. Yet it is difficult to suppose that so many acute observers have all been deceived at the expense of much cost and trouble. A male animal may sometimes be paired with his daughter, granddaughter, and so on, even for 7 generations, without any manifest bad result. But the experiment has never been tried of matching brothers and sisters, which is considered the closest form of interbreeding, for an equal number of generations. There is good reason to believe that by keeping the members of the same family in distinct bodies, especially if exposed to somewhat different conditions of life, and by occasionally crossing these families, the evil results of interbreeding may be much diminished or quite eliminated. These results are loss of constitutional vigor, size, and fertility, but there is no necessary deterioration in the general form of the body or in other good qualities. We have seen that with pigs, first-rate animals have been produced after long-continued close interbreeding. Though they had become extremely infertile, when paired with their near relations, the loss of fertility, when it occurs, seems never to be absolute but only relative to animals of the same blood, so that this sterility is to a certain extent analogous with that of self-impotent plants, which cannot be fertilized by their own pollen, but are perfectly fertile with pollen of any other individual of the same species. The fact of infertility of this peculiar nature being one of the results of long-continued interbreeding shows that interbreeding does not act merely by combining and augmenting various morbid tendencies, common to both parents. For animals with such tendencies, if not at the time actually ill, can generally propagate their kind, although offspring descended from the nearest blood relations are not necessarily deteriorated in structure. Yet some authors believe that they are eminently liable to malformations, and this is not improbable, as everything which lessens the vital powers acts in this manner. Instances of this kind have been recorded in the case of pigs, bloodhounds, and some other animals. Finally, when we consider the various facts now given which plainly show that good follows from crossing, and less plainly, that evil follows from close interbreeding, and when we bear in mind that with very many organisms elaborate provisions have been made for the occasional union of distinct individuals, the existence of a great law of nature is almost proved, namely, that the crossing of animals and plants, which are not closely related to each other, is highly beneficial or even necessary, and that interbreeding prolonged during many generations is injurious. References: Chapter Roman 18, on the advantages and disadvantages of changed conditions of life sterility from various causes. On the good derived from slight changes in the conditions of life sterility, from changed conditions in animals in their native country, and in menageries, mammals, birds, and insects, loss of secondary sexual characters, and of instincts, causes of sterility, sterility of domesticated animals, from changed condition sexual incompatibility, of individual animal sterility of plants, from changed conditions of life contabsence of the anthers monstrosities, as a cause of sterility double flower seedless fruit sterility, from the excessive development of the organs of vegetation from long-continued propagation by buds incipient sterility, the primary cause of double flowers and seedless fruit. On the good derived from slight changes in the conditions of life in, considering whether any facts were known, which might throw light on the conclusion arrived at in the last chapter, namely that benefits ensue from crossing, and that it is a law of nature that all organic beings should occasionally cross. It appeared to me probable that the good derived from slight changes in the conditions of life, from being an analogous phenomenon, might serve this purpose. No two individuals, and still less no two varieties, are absolutely alike in constitution and structure, and when the germ of one is fertilized by the male element of another, we may believe that it is acted on in a somewhat similar manner as an individual when exposed to slightly changed conditions. Now, everyone must have observed the remarkable influence on convalescence of a change of residence, and no medical man doubts the truth of this fact. Small farmers who hold but little land are convinced that their cattle derive great benefit from a change of pasture. In the case of plants, the evidence is strong that a great advantage is derived from exchanging seeds, tubers, bulbs, and cuttings from one soil or place to another as different as possible. The belief that plants are thus benefited, whether or not well-founded, has been firmly maintained from the time of Columella, who wrote shortly after the Christian era to the present day. And it now prevails in England, France, and Germany. A sagacious observer, Bradley, writing in 17,242, says, "When we once become masters of a good sort of seed, we should at least put it into 2 or 3 hands where the soils and situations are as different as possible, and every year the parties should change with one another, by which means I find the goodness of the seed will be maintained for several years. For want of this use, many farmers have failed in their crops, and been great losers." He then gives his own practical experience on this head. A modern writer 3 asserts nothing can be more clearly established in agriculture than that the continual growth of any one variety in the same district makes it liable to deterioration either in quality or quantity. Another writer states that he sowed close together in the same field 2 lots of wheat seed, the product of the same original stock, one of which had been grown on the same land, and the other at a distance, and the difference in favor of the crop from the latter seed was remarkable. A gentleman in Surrey, who has long made it his business to raise wheat to sell for seed, and who has constantly realized in the market higher prices than others, assures me that he finds it indispensable continually to change his seed, and that for this purpose he keeps 2 farms differing much in soil and elevation. With respect to the tubers of the potato, I find that at the present day the practice of exchanging sets is almost everywhere followed. The great growers of potatoes in Lancashire formerly used to get tubers from Scotland, but they found that a change from the mosslands and vice versa was generally sufficient. In former times in France, the crop of potatoes in the Vosges had become reduced in the course of 50 or 60 years, in the proportion from 120,150 to 30-40 bushels, and the famous Oberlin attributed the surprising good which he effected in large part to changing the sets for. A well-known practical gardener, Mr. Robson, 5 positively states that he has himself witnessed decided advantage from obtaining bulbs of the onion tubers of the potato and various seeds, all of the same kind from different soils and distant parts of England. He further states that with plants propagated by cuttings, as with the pelargonium, and especially the dahlia, manifest advantage is derived from getting plants of the same variety which have been cultivated in another place, or where the extent of the place allows to take cuttings from one description of soil to plant on another, so as to afford the change that seems so necessary to the well-being of the plants. He maintains that after a time, an exchange of this nature is forced on the grower whether he be prepared for it or not. Similar remarks have been made by another excellent gardener, Mr. Fish, namely that cuttings of the same variety of calceolaria, which he obtained from a neighbor, showed much greater vigor than some of his own that were treated in exactly the same manner, and he attributed this solely to his own plants having become to a certain extent worn out or tired of their quarters. Something of this kind apparently occurs in grafting and budding fruit trees, for according to Mr. Abbey, grafts or buds generally take with greater facility on a distinct variety or even species, or on a stalk previously grafted than on stalks raised from seeds of the variety which is to be grafted, and he believes this cannot be altogether explained by the stalks in question being better adapted to the soil and climate of the place. It should, however, be added that varieties grafted or budded on very distinct kinds, though they may take more readily and grow at first more vigorously than when grafted on closely allied stalks, afterwards often become unhealthy. I have studied Roman 1000 Tessier's careful and elaborate experiments, 6 made, to disprove the common belief that good is derived from a change of seed, and he certainly shows that the same seed may with care be cultivated on the same farm. It is not stated whether on exactly the same soil for 10 consecutive years, without loss. Another excellent observer, Colonel Le Couture 7, has come to the same conclusion, but then he expressly adds if the same seed be used, that which is grown on land manured from the mixen, 1 year becomes seed for land prepared with lime, and that again becomes seed for land dressed with ashes, then for land dressed with mixed manure, and so on. But this in effect is a systematic exchange of seed within the limits of the same farm. On the whole, the belief which has long been held by many cultivators that good follows from exchanging seed, tubers, etc., seems to be fairly well founded. It seems hardly credible that the advantage thus derived can be due to the seeds, especially if very small ones obtaining in one soil some chemical element deficient in the other, and in sufficient quantity to influence the whole aftergrowth of the plant. As plants, after once germinating, are fixed to the same spot, it might have been anticipated that they would show the good effects of a change more plainly than do animals, which continually wander about. And this apparently is the case. Life, depending on or consisting in an incessant play of the most complex forces, it would appear that their action is in some way stimulated by slight changes in the circumstances to which each organism is exposed. All forces throughout nature, as Mr. Herbert Spencer 8 remarks, tend towards an equilibrium, and for the life of each organism, it is necessary that this tendency should be checked. These views and the foregoing facts probably throw light, on the one hand, on the good effects of crossing the breed, for the germ will be thus slightly modified or acted on by new forces, and on the other hand on the evil effects of close interbreeding, prolonged during many generations, during which the germ will be acted on by a male having almost identically the same constitution. Sterility from changed conditions of life. I will now attempt to show that animals and plants, when removed from their natural conditions, are often rendered in some degree infertile or completely barren, and this occurs even when the conditions have not been greatly changed. This conclusion is not necessarily opposed to that at which we have just arrived, namely, that lesser changes of other kinds are advantageous to organic beings. Our present subject is of some importance from having an intimate connection with the causes of variability. Indirectly, it perhaps bears on the sterility of species, when crossed, for, as on the one hand slight changes in the conditions of life are favorable to plants and animals, and the crossing of varieties adds to the size, vigor, and fertility of their offspring, so on the other hand, certain other changes in the conditions of life cause sterility, and as this likewise ensues from crossing much modified forms or species, we have a parallel and double series of facts, which apparently stand in close relation to each other. It is notorious that many animals, though perfectly tamed, refuse to breed in captivity. Isidore Geoffroy, St. Hilaire 9, consequently, has drawn a broad distinction between tamed animals, which will not breed under captivity, and truly domesticated animals, which breed freely, generally more freely, as shown in the 16th chapter. Then in a state of nature, it is possible and generally easy to tame most animals, but experience has shown that it is difficult to get them to breed regularly or even at all. I shall discuss this subject in detail, but will give only those cases which seem most illustrative. My materials are derived from notices scattered through various works, and especially from a report kindly drawn up for me by the officers of the Zoological Society of London, which has a special value, as it records all the cases during 9 years, from 183,846, in which the animals were seen to couple, but produced no offspring, as well as the cases in which they never, as far as known, coupled. This MS report I have corrected by the annual reports, subsequently published up to the year 186,510. Many facts are given on the breeding of the animals in that magnificent work. Gleanings from the Menageries of Knowsley Hall by Dr. Gray. I made also particular inquiries from the experienced keeper of the birds in the Old Surrey Zoological Gardens. I should premise that a slight change in the treatment of animals sometimes makes a great difference in their fertility, and it is probable that the results observed in different menageries would differ. Indeed, some animals in our zoological gardens have become more productive since the year 1846. It is also manifest from F. Cuvier's account of the Jardin des Plantes, 11, that the animals formerly bred much less freely there than with us. For instance, in the duck tribe, which is highly prolific, only one species had at that period produced young. The most remarkable cases, however, are afforded by animals kept in their native country, which, though perfectly tamed, quite healthy, and allowed some freedom, are absolutely incapable of breeding. Ringer 12, who in Paraguay particularly attended to this subject, specifies 6 quadrupeds in this condition, and he mentions 2 or 3 others, which most rarely breed. Mr. Bates, in his admirable work on the Amazons, strongly insists on similar cases. 13, and he remarks that the fact of thoroughly tamed native mammals and birds not breeding, when kept by the Indians, cannot be wholly accounted for by their negligence or indifference, for the turkey and fowl are kept and bred by various remote tribes in almost every part of the world. For instance, in the interior of Africa and in several of the Polynesian islands, the natives are extremely fond of taming the indigenous quadrupeds and birds, but they rarely or never succeed in getting them to breed. The most notorious case of an animal not breeding in captivity is that of the elephant. Elephants are kept in large numbers in their native Indian home live to old age, and are vigorous enough for the severest labor, yet with a very few exceptions, they have never been known even to couple, though both males and females have their proper periodical seasons. If, however, we proceed a little eastward to Ava, we hear from Mr. Crawford 14 that their breeding in the domestic state, or at least in the half-domestic state, in which the female elephants are generally kept, is of everyday occurrence, and Mr. Crawford informs me that he believes that the difference must be attributed solely to the females being allowed to roam the forest with some degree of freedom. The captive rhinoceros, on the other hand, seems from Bishop Heber's account 15 to breed in India far more readily than the elephant. 4 wild species of the horse genus have bred in Europe, though here exposed to a great change in their natural habits of life. But the species have generally been crossed one with another. Most of the members of the pig family breed readily in our menageries. Even the Red River hog Potamocris penicillatus, from the sweltering plains of West Africa, has bred twice in the zoological gardens. Here also the peccary Dicotyles torquatus has bred several times, but another species, the Roman 500 labiatus, though rendered so tame as to be half domesticated, is said to breed so rarely in its native country of Paraguay that, according to Renger 16, the fact requires confirmation. Mr. Bates remarks that the tapir, though often kept tame in Amazonia by the Indians, never breeds. Ruminants generally breed quite freely in England, though brought from widely different climates, as may be seen in the annual reports of the zoological gardens and in the gleanings from Lord Derby's menagerie. The carnivora, with the exception of the plantigrade division, breed, though with capricious exceptions, about half as freely as ruminants. Many species of Felidae have bred in various menageries, although imported from diverse climates, and closely confined. Mr. Bartlett, the present superintendent of the zoological gardens, 17, remarks that the lion appears to breed more frequently, and to bring forth more young at a birth than any other species of the family. He adds that the tiger has rarely bred, but there are several well-authenticated instances of the female tiger breeding with the lion. Strange as the fact may appear, many animals under confinement unite with distinct species, and produce hybrids quite as freely as, or even more freely than, with their own species. On inquiring from Dr. Falconer and others, it appears that the tiger, when confined in India, does not breed, though it has been known to couple the Cheetah Felis. Jubata has never been known by Mr. Bartlett to breed in England, but it has bred at Frankfurt, nor does it breed in India, where it is kept in large numbers for hunting, but no pains would be taken to make them breed, as only those animals which have hunted for themselves in a state of nature are serviceable and worth training. 18. According to Renger, 2 species of wild cats in Paraguay, though thoroughly tamed, have never bred, although so many of the Felidae breed readily in the zoological gardens. Yet conception by no means always follows union. In the 9-year report, various species are specified which were observed to couple 7 to 3 times, and no doubt this must have passed many times unnoticed. Yet from the 73 unions only 15 births ensued. The carnivora in the zoological gardens were formerly less freely exposed to the air and cold than at present, and this change of treatment, as I was assured by the former superintendent Mr. Miller, greatly increased their fertility. Mr. Bartlett, and there cannot be a more capable judge, says it is remarkable that lions breed more freely in traveling collections than in the zoological gardens. Probably the constant excitement and irritation produced by moving from place to place or change of air may have considerable influence in the matter. Many members of the dog family breed readily when confined. The dhole is one of the most untamable animals in India, yet a pair kept there by Dr. Falconer produced young foxes. On the other hand, rarely breed, and I have never heard of such an occurrence with the European fox. The silver fox of North America, Canis argentatus, however, has bred several times in the zoological gardens. Even the otter has bred there. Every one knows how readily the semi-domesticated ferret breeds, though shut up in miserably small cages, but other species of vivera and Paradoxurus absolutely refuse to breed in the zoological gardens. The Genetta has bred both here and in the Jardin des Plantes, and produced hybrids. The Herpestes fasciatus has likewise bred, but I was formerly assured that the H. Griseus, though many were kept in the gardens, never bred. The plantigrade carnivora breed under confinement, much less freely than other carnivora. Although no reason can be assigned for this fact in the 9-year report, it is stated that the bears had been seen in the zoological gardens to couple freely, but previously to 1848 had most rarely conceived in the reports published. Since this date 3 species have produced young hybrids in one case, and wonderful to relate the white polar bear has produced young. The badger Meles taxus has bred several times in the gardens, but I have not heard of this occurring elsewhere. In England, and the event must be very rare for an instance in Germany, has been thought worth recording. 19 in Paraguay, the native Nasua, though kept in pairs during many years, and perfectly tamed, has never been known according to Renger to breed or show any sexual passion, nor as I hear from Mr. Bates does this animal, or the Cercoleps, breed in Amazonia. 2 other plantigrade genera Procyon and Gulo, though often kept tame in Paraguay, never breed there. In the zoological gardens, species of Nasua and Procyon have been seen to couple, but they did not produce young. As domesticated rabbits, guinea pigs, and white mice breed so abundantly, when closely confined under various climates, it might have been thought that most other members of the rodent order would have bred in captivity, but this is not the case. It deserves notice as showing how the capacity to breed sometimes goes by affinity, that the one native rodent of Paraguay which there breeds freely and has yielded successive generations is the Cavia apirea, and this animal is so closely allied to the guinea pig that it has been erroneously thought to be the parent form. 20 in the zoological gardens, some rodents have coupled, but have never produced young. Some have neither coupled nor bred, but a few have bred, as the porcupine more than once, the Barbary mouse, lemming chinchilla, and Agouti dasyprocta agouti several times. This latter animal has also produced young in Paraguay, though they were born dead and ill-formed. But in Amazonia, according to Mr. Bates, it never breeds, though often kept tame about the houses, nor does the Paca clogenes paca breed there. The common hare, when confined, has, I believe, never bred in Europe, though according to a recent statement, it has crossed with the rabbit. 21. I have never heard of the dormouse breeding in confinement, but squirrels offer a more curious case. With one exception, no species has bred in the zoological gardens, yet as many as 14 individuals of S. pomerum were kept together during several years. The S. cinera has been seen to couple, but it did not produce young, nor has this species, when rendered extremely tame in its native country North America, been ever known to breed. 22. At Lord Derby's menagerie, squirrels of many kinds were kept in numbers, but Mr. Thompson, the superintendent, told me that none had ever bred there or elsewhere as far as he knew. I have never heard of the English squirrel breeding in confinement, but the species which has bred more than once in the zoological gardens is the one which perhaps might have been least expected, namely the flying squirrel Coeopteris volucella. It has also bred several times near Birmingham, but the female never produced more than 2 young at a birth, whereas in its native American home, she bears from 3 to 6 young. 23. Monkeys in the 9-year report from the zoological gardens are stated to unite most freely, but during this period, though many individuals were kept, there were only 7 births. I have heard of only one American monkey, the Uistidi, breeding in Europe. 24. A macacus, according to Flowerens, bred in Paris, and more than one species of this genus has produced young in London, especially the Macacus rhesus, which everywhere shows a special capacity to breed under confinement. Hybrids have been produced both in Paris and London. From this same genus, the Arabian baboon, or Cynocephalus hamadryas, 25, and a Cercopithecus have bred in the zoological gardens, and the latter species at the Duke of Northumberland's. Several members of the family of lemurs have produced hybrids in the zoological gardens. It is much more remarkable that monkeys very rarely breed when confined in their native country. Thus the key Cebus azar is frequently and completely tamed in Paraguay, but Renger 26 says that it breeds so rarely that he never saw more than 2 females which had produced young. A similar observation has been made with respect to the monkeys, which are frequently tamed by the Aborigines in Brazil. 27. In Amazonia, these animals are so often kept in a tame state that Mr. Bates, in walking through the streets of Para, counted 13 species, but as he asserts, they have never been known to breed in captivity. 28. Birds. Birds offer in some respects better evidence than quadrupeds from their breeding more rapidly, and being kept in greater numbers. 29. We have seen that carnivorous animals are more fertile under confinement than most other mammals. The reverse holds good with carnivorous birds. It is said. 30. That as many as 18 species have been used in Europe for hawking, and several others in Persia and India. 30. 1. They have been kept in their native country, finest condition, and have been flown during 6, 8, or 9 years. 32. Yet there is no record of their having ever produced young, as these birds were formerly caught. Whilst young at great expense being imported from Iceland, Norway, and Sweden, there can be little doubt that if possible they would have been propagated in the Jardin des Plantes. No bird of prey has been known to couple. 33. No hawk, vulture, or owl has ever produced fertile eggs in the zoological gardens or in the Old Surrey Gardens, with the exception in the former place on one occasion of a condor and a kite, Milvus niger. Yet several species, namely the Aquila fusca halietus, Leucosphalus falco, Tununculus f. subbuteo, and Buteo vulgaris, have been seen to couple in the zoological gardens. Mr. Morris 34 mentions, as a unique fact, that a kestrel falco tununculus bred in an aviary, the one kind of owl which has been known to couple. The zoological gardens was the eagle owl Bubo maximus, and this species shows a special inclination to breed in captivity for a pair at Arundel Castle, kept more nearly in a state of nature than ever fell to the lot of an animal deprived of its liberty. 35. Actually reared their young. Mr. Gurney has given another instance of this same owl breeding in confinement, and he records the case of a second species of owl, the Strix passerina, breeding in captivity. 36. Of the smaller graminivorous birds, many kinds have been kept tame in their native countries, and have lived long. Yet, as the highest authority on cagebirds, 37, remarks, their propagation is uncommonly difficult. The canary bird shows that there is no inherent difficulty in these birds breeding freely in confinement, and Audubon says 38 that the Fringilla spizacirrus of North America breeds as perfectly as the canary. The difficulty with the many finches which have been kept in confinement is all the more remarkable, as more than a dozen species could be named which have yielded hybrids with the canary, but hardly any of these, with the exception of the siskin Fringilla spinus, have reproduced their own kind. Even the bullfinch Loxia pyrhula has bred as frequently with the canary, though belonging to a distinct genus, as with its own species. 39. With respect to the skylark Alauda arvensis, I have heard of birds living for 7 years in an aviary which never produced young, and a great London bird fancier assured me that he had never known an instance of their breeding. Nevertheless, one case has been recorded. 40. In the 9-year report from the Zoological Society, 24 incessorial species are enumerated which had not bred, and of these only 4 were known to have coupled. Parrots are singularly long-lived birds, and Humboldt mentions the curious fact of a parrot in South America, which spoke the language of an extinct Indian tribe, so that this bird preserved the sole relic of a lost language. Even in this country, there is reason to believe. 41 that parrots have lived to the age of nearly 100 years, yet they breed so rarely, though many have been kept in Europe, that the event has been thought worth recording. In the gravest publications, 42. Nevertheless, when Mr. Buxton turned out a large number of parrots in Norfolk, 3 pairs bred, and reared 10 young birds in the course of 2 seasons, and this success may be attributed to their free life. 43. According to Bechstein, 40, for the African Psittacus erythacus breeds oftener than any other species in Germany. The P. mycoa occasionally lays fertile eggs, but rarely succeeds in hatching them. This bird, however, has the instinct of incubation, sometimes so strongly developed that it will hatch the eggs of fowls or pigeons in the zoological gardens, and in the Old Surrey Gardens, some few species have coupled, but with the exception of 3 species of parakeets, none have bred. It is a much more remarkable fact that in Guiana parrots of 2 kinds, as I am informed by Sir R. Schomburgk, are often taken from the nests by the Indians, and reared in large numbers. They are so tame that they fly freely about the houses, and come when called to be fed like pigeons, yet he has never heard of a single instance of their breeding. 45 In Jamaica, a resident naturalist, Mr. R. Hill, 46, says no birds more readily submit to human dependence than the parrot tribe, but no instance of a parrot breeding in this tame life has been known. Yet Mr. Hill specifies a number of other native birds kept tame in the West Indies, which never breed in this state. The great pigeon family offers a striking contrast with the parrots. In the 9-year report, 13 species are recorded as having bred, and what is more noticeable, only 2 were seen to couple without any result. Since the above date, every annual report gives many cases of various pigeons breeding. The 2 magnificent crown pigeons, Gura coronata and Victoria, produced hybrids. Nevertheless, of the former species, more than a dozen birds were kept, as I am informed by Mr. Crawford, in a park at Penang, under a perfectly well-adapted climate. but never once bred the Columba migratoria in its native country North America, invariably lays 2 eggs, but in Lord Derby's menagerie, never more than one. The same fact has been observed with the Roman 100 Leucosphala 47. Gallinaceous birds of many genera likewise show an eminent capacity for breeding under captivity. This is particularly the case with pheasants, yet our English species seldom lays more than 10 eggs in confinement, whilst from 18 to 20 is the usual number in the wild state, 48 with the gallinus. As with all other orders, there are marked and inexplicable exceptions in regard to the fertility of certain species and genera under confinement. Although many trials have been made with the common partridge, it has rarely bred even when reared in large aviaries, and the hen will never hatch her own eggs. 49. The American tribe of Guans, or Crassid, are tamed with remarkable ease, but are very shy breeders in this country. 50. But with care, various species were formerly made to breed rather freely in Holland. 51 birds of this tribe are often kept in a perfectly tamed condition in their native country by the Indians, but they never breed. 52. It might have been expected that grouse, from their habits of life, would not have bred in captivity, more especially as they are said soon to languish and die. 53. But many cases are recorded of their breeding. The Capercailzie tetrao urigallus has bred in the zoological gardens. It breeds without much difficulty when confined in Norway, and in Russia 5 successive generations have been reared. Tetrao tetrix has likewise bred in Norway, T. scoticus in Ireland, T. umbellus at Lord Derby's, and T. cupido in North America. It is scarcely possible to imagine a greater change in habits than that which the members of the ostrich family must suffer when cooped up in small enclosures under a temperate climate, after freely roaming over desert and tropical plains or entangled forests. Yet almost all the kinds have frequently produced young in the various European menageries, even the Muroc casuarius. Bennetai from New Ireland, the African ostrich, though perfectly healthy and living long in the south of France, never lays more than from 12 to 15 eggs, though in its native country it lays from 25 to 30. 54. Here, we have another instance of fertility impaired, but not lost under confinement, as with the flying squirrel, the hen pheasant, and 2 species of American pigeons. Most waders can be tamed, as the Rev. E. S. Dixon informs me with remarkable facility, but several of them are short-lived under confinement, so that their sterility in this state is not surprising. The cranes breed more readily than other genera. Grus montegresia has bred several times in Paris and in the zoological gardens, as has G. cinerea at the latter place and G. antigone at Calcutta. Of other members of this great order, Tetrapteryx paradisea has bred at Nosli a Porphyrio in Sicily, and the Gallinula chloropus in the zoological gardens. On the other hand, several birds belonging to this order will not breed in their native country Jamaica, and the Sophia, though often kept by the Indians of Guiana about their houses, is seldom or never known to breed. 55. The members of the great duck family breed as readily in confinement as do the column and gallon, and this, considering their aquatic and wandering habits, and the nature of their food, could not have been anticipated even some time ago. Above 24 species had bred in the zoological gardens, and Roman 1000 Selles Longchamps has recorded the production of hybrids from 4 to 4 different members of the family, and to these Professor Newton has added a few more cases. 56. There is not, says Mr. Dixon. 57. In the wide world a goose, which is not in the strict sense of the word domesticable, that is capable of breeding under confinement. But this statement is probably too bold. The capacity to breed sometimes varies in individuals of the same species. Thus Audubon. 58. Kept for more than 8 years some wild geese, Anser canadensis, but they would not mate whilst other individuals of the same species produced young during the 2nd year. I know of but one instance in the whole family of a species which absolutely refuses to breed in captivity, namely the Dendrocygna viduata, although according to Sir R. Schomburgk. 59, it is easily tamed, and is frequently kept by the Indians of Guiana. Lastly, with respect to gulls, though many have been kept in the zoological gardens, and in the old Surrey gardens, no instance was known before the year 1848 of their coupling or breeding, but since that period the herring gull Larus argentatus has bred many times in the zoological gardens, and at Nosli. There is reason to believe that insects are affected by confinement like the higher animals. It is well known that the Sphingidae rarely breed when thus treated. An entomologist 60 in Paris kept 25 specimens of Saturnia piri, but did not succeed in getting a single fertile egg a number of females of Orthosia munda and of Mamstra suesa reared in confinement were unattractive to the males. 61 Mr. Newport kept nearly 100 individuals of 2 species of Vanessa, but not one paired. This, however, might have been due to their habit of coupling on the wing. 62 Mr. Atkinson could never succeed in India in making the Taru silkmoth breed in confinement. 63 It appears that a number of moths, especially the Sphingidae when hatched in the autumn out of their proper season, are completely barren, but this latter case is still involved in some obscurity. 64 Independently of the fact of many animals under confinement not coupling, or if they couple not producing young, there is evidence of another kind, that their sexual functions are disturbed, for many cases have been recorded of the loss by male birds, when confined, of their characteristic plumage. Thus the common linnet Linota canabina, when caged, does not acquire the fine crimson color on its breast, and one of the buntings, Emberiza passerina, loses the black on its head. A pyrhula and an aureolus have been observed to assume the quiet plumage of the henbird, and the falco albitus return to the dress of an earlier age. 65 Mr. Thompson, the superintendent of the Knowsley menagerie, informed me that he had often observed analogous facts. The horns of a male deer Cervus canadensis during the voyage from America were badly developed, but subsequently in Paris, perfect horns were produced. When conception takes place under confinement, the young are often born dead, or die soon, or are ill-formed. This frequently occurs in the zoological gardens, and according to Renger, with native animals confined in Paraguay, the mother's milk often fails. We may also attribute to the disturbance of the sexual functions the frequent occurrence of that monstrous instinct, which leads the mother to devour her own offspring, a mysterious case of perversion, as it at first appears. Sufficient evidence has now been advanced to prove that animals, when first confined, are eminently liable to suffer in their reproductive systems. We feel at first naturally inclined to attribute the result to loss of health, or at least to loss of vigor, but this view can hardly be admitted when we reflect how healthy, long-lived, and vigorous many animals are under captivity, such as parrots and hawks, when used for hawking cheetahs, when used for hunting, and elephants. The reproductive organs themselves are not diseased, and the diseases from which animals in menageries usually perish are not those which in any way affect their fertility. No domestic animal is more subject to disease than the sheep, yet it is remarkably prolific. The failure of animals to breed under confinement has been sometimes attributed exclusively to a failure in their sexual instincts. This may occasionally come into play, but there is no obvious reason why this instinct should be especially liable to be affected with perfectly tamed animals, except indeed indirectly through the reproductive system itself being disturbed. Moreover, numerous cases have been given of various animals which couple freely under confinement, but never conceive, or if they conceive and produce young, these are fewer in number than is natural to the species. In the vegetable kingdom, instinct, of course, can play no part, and we shall presently see that plants, when removed from their natural conditions, are affected in nearly the same manner as animals. Change of climate cannot be the cause of the loss of fertility, for whilst many animals imported into Europe from extremely different climates breed freely, many others, when confined in their native land, are completely sterile. Change of food cannot be the chief cause for ostriches, ducks, and many other animals, which must have undergone a great change. In this respect, breed freely carnivorous birds, when confined, are extremely sterile, whilst most carnivorous mammals, except plantigrades, are moderately fertile. Nor can the amount of food be the cause for a sufficient supply will certainly be given to valuable animals, and there is no reason to suppose that much more food would be given to them than to our choice domestic productions, which retain their full fertility. Lastly, we may infer from the case of the elephant, cheetah, various hawks, and of many animals which are allowed to lead an almost free life in their native land, that want of exercise is not the sole cause. It would appear that any change in the habits of life, whatever these habits may be, if great enough, tends to affect in an inexplicable manner the powers of reproduction. The result depends more on the constitution of the species than on the nature of the change, for certain whole groups are affected more than others. But exceptions always occur, for some species in the most fertile groups refuse to breed, and some in the most sterile groups breed freely. Those animals which usually breed freely under confinement rarely breed, as I was assured in the zoological gardens, within a year or two after their first importation, when an animal which is generally sterile under confinement happens to breed the young, apparently do not inherit this power, for had this been the case, various quadrupeds and birds, which are valuable for exhibition, would have become common. Dr. Broca even affirms 66 that many animals in the Jardin des Plantes, after having produced young for 3 or 4 successive generations, become sterile. But this may be the result of too close interbreeding. It is a remarkable circumstance that many mammals and birds have produced hybrids under confinement, quite as readily, as or even more readily, than they have procreated their own kind. Of this fact, many instances have been given. 67, and we are thus reminded of those plants which when cultivated refuse to be fertilized by their own pollen, but can easily be fertilized by that of a distinct species. Finally, we must conclude limited, as the conclusion is that changed conditions of life have an especial power of acting injuriously on the reproductive system. The whole case is quite peculiar, for these organs, though not diseased, are thus rendered incapable of performing their proper functions, or perform them imperfectly. Sterility of domesticated animals, from changed conditions with respect to domesticated animals, as their domestication mainly depends on the accident of their breeding freely under captivity, we ought not to expect that their reproductive system would be affected by any moderate degree of change. Those orders of quadrupeds and birds, of which the wild species breed most readily in our menageries, have afforded us the greatest number of domesticated productions. Savages in most parts of the world are fond of taming animals. 68, and if any of these regularly produced young, and were at the same time useful, they would be at once domesticated. If when their masters migrated into other countries they were in addition found capable of withstanding various climates, they would be still more valuable, and it appears that the animals which breed readily in captivity can generally withstand different climates. Some few domesticated animals, such as the reindeer and camel, offer an exception to this rule. Many of our domesticated animals can bear with undiminished fertility the most unnatural conditions. For instance, rabbits, guinea pigs, and ferrets breed in miserably confined hutches. Few European dogs of any kind withstand the climate of India without degenerating, but as long as they survive they retain, as I hear from Dr. Falconer, their fertility. So it is according to Dr. Daniel with English dogs taken to Sierra Leone. The fowl, a native of the hot jungles of India, becomes more fertile than its parent stock in every quarter of the world, until we advance as far north as Greenland and northern Siberia, where this bird will not breed. Both fowls and pigeons, which I received during the autumn direct from Sierra Leone, were at once ready to couple. 69. I have also seen pigeons breeding as freely as the common kinds within a year after their importation from the Upper Nile. The guinea fowl, an aboriginal of the hot and dry deserts of Africa, whilst living under our damp and cool climate, produces a large supply of eggs. Nevertheless, our domesticated animals under new conditions occasionally show signs of lessened fertility. Rulin asserts that in the hot valleys of the equatorial Cordillera sheep are not fully fecund. 70, and according to Lord Somerville. 71, the Merino sheep which he imported from Spain were not at first perfectly fertile. It is said. 72, that mares brought up on dry food in the stable and turned out to grass do not at first breed. The peahen, as we have seen, is said not to lay so many eggs in England as in India. It was long before the canary bird was fully fertile, and even now first-rate breeding birds are not common. 73, in the hot and dry province of Delhi, as I hear from Dr. Falconer, the eggs of the turkey, though placed under a hen, are extremely liable to fail. According to Rulin, geese taken to the lofty plateau of Bogota at first laid seldom, and then only a few eggs. Of these scarcely a fourth were hatched, and half the young birds died. In the second generation, they were more fertile, and when Rulin wrote, they were becoming as fertile as our geese in Europe. With respect to the valley of Quito, Mr. Orton says. 74, the only geese in the valley are a few imported from Europe, and these refuse to propagate in the Philippine archipelago. The goose, it is asserted, will not breed, or even lay eggs. 75, a more curious case is that of the fowl, which according to Rulin, when first introduced would not breed at Cusco in Bolivia, but subsequently became quite fertile, and the English game fowl lately introduced had not as yet arrived at its full fertility, for to raise 2 or 3 chickens from a nest of eggs was thought fortunate in Europe. Close confinement has a marked effect on the fertility of the fowl. It has been found in France that with fowls allowed considerable freedom, only 20% of the eggs failed. When allowed less freedom, 40% failed, and in close confinement, 60 out of the 100 were not hatched. 76, so we see that unnatural and changed conditions of life produce some effect on the fertility of our most thoroughly domesticated animals in the same manner, though in a far less degree as with captive wild animals. It is by no means rare to find certain males and females, which will not breed together, though both are known to be perfectly fertile with other males and females. We have no reason to suppose that this is caused by these animals having been subjected to any change in their habits of life. Therefore, such cases are hardly related to our present subject. The cause apparently lies in an innate sexual incompatibility of the pair, which are matched. Several instances have been communicated to me by Mr. W. Roman 100 Spooner, well known for his essay on crossbreeding by Mr. Eiton of Eiton, by Mr. Wickstead, and other breeders, and especially by Mr. Waring of Chelsfield, in relation to horses, cattle, pigs, foxhounds, other dogs, and pigeons, 77 in these cases females which either previously or subsequently were proved to be fertile failed to breed with certain males, with whom it was particularly desired to match them. A change in the constitution of the female may sometimes have occurred before she was put to the second male, but in other cases, this explanation is hardly tenable, for a female known not to be barren has been unsuccessfully paired 7 or 8 times, with the same male likewise known to be perfectly fertile with cartmares, which sometimes will not breed with stallions of pure blood, but subsequently have bred with cart stallions. Mr. Spooner is inclined to attribute the failure to the lesser sexual power of the racehorse, but I have heard from the greatest breeder of racehorses at the present day through Mr. Waring that it frequently occurs with a mare to be put several times during 1 or 2 seasons to a particular stallion of acknowledged power, and yet prove barren, the mare afterwards breeding at once with some other horse. These facts are worth recording, as they show, like so many previous facts, on what slight constitutional differences the fertility of an animal often depends. Sterility of plants from changed conditions of life, and from other causes. In the vegetable kingdom, cases of sterility frequently occur analogous with those previously given in the animal kingdom, but the subject is obscured by several circumstances presently to be discussed, namely, the contabsence of the anthers, as Gartner has named a certain affection monstrositas doubleness of the flower, much enlarged fruit, and long continued, or excessive propagation by buds. It is notorious that many plants in our gardens and hothouses, though preserved in the most perfect health, rarely or never produce seed. I do not allude to plants which run to leaves from being kept too damp, or too warm, or too much manured, for these do not flower, and the case may be wholly different, nor do I allude to fruit not ripening from want of heat, or rotting from too much moisture, but many exotic plants with their ovules and pollen appearing perfectly sound will not set any seed. The sterility in many cases, as I know from my own observation, is simply due to the absence of the proper insects for carrying the pollen to the stigma. But after excluding the several cases just specified, there are many plants in which the reproductive system has been seriously affected by the altered conditions of life to which they have been subjected. It would be tedious to enter on many details. Linus long ago observed 78 that alpine plants, although naturally loaded with seed, produce either few or none when cultivated in gardens. But exceptions often occur. The Draba sylvestris, one of our most thoroughly alpine plants, multiplies itself by seed in Mr. H. Roman 100 Watson's garden, London, and Kerner, who has particularly attended to the cultivation of alpine plants, found that various kinds, when cultivated spontaneously, sowed themselves. 79 Many plants, which naturally grow in peat earth, are entirely sterile in our gardens. I have noticed the same fact with several liliaceous plants, which nevertheless grew vigorously. Too much manure renders some kinds utterly sterile, as I have myself observed. The tendency to sterility from this cause runs in families. Thus, according to Gartner 80, it is hardly possible to give too much manure to most grama and crucifer and leguminos, whilst succulent and bulbous-rooted plants are easily affected. Extreme poverty of soil is less apt to induce sterility, but dwarfed plants of Trifolium minus and repens growing on a lawn, often mown and never manured, were found by me not to produce any seed. The temperature of the soil and the season at which plants are watered often have a marked effect on their fertility, as was observed by Kallreuter in the case of Mirabilis. 81 Mr. Scott in the Botanic Gardens of Edinburgh observed that Oncidium divricatum would not set seed when grown in a basket in which it throve, but was capable of fertilization in a pot where it was a little damper. Pelargonium fulgidum, for many years after its introduction, seeded freely. It then became sterile. Now it is fertile. 82 if kept in a dry stove during the winter. Other varieties of pelargonium are sterile, and others fertile, without our being able to assign any cause. Very slight changes in the position of a plant, whether planted on a bank or at its base, sometimes make all the difference in its producing seed. Temperature, apparently, has a much more powerful influence on the fertility of plants than on that of animals. Nevertheless, it is wonderful what changes some few plants will withstand with undiminished fertility. Thus the Zephyranthes candida, a native of the moderately warm banks of the Plata, sows itself in the hot dry country near Lima, and in Yorkshire resists the severest frosts. And I have seen seeds gathered from pods, which had been covered with snow, during 3 weeks. 83 Berberis wallacea from the hot Kaja range in India is uninjured by our sharpest frosts, and ripens its fruit under our cool summers. Nevertheless, I presume we must attribute to change of climate the sterility of many foreign plants. Thus the Persian and Chinese lilacs, Syringa persica and chinensis, though perfectly hardy here, never produce a seed. The common lilac S. vulgaris seeds with us moderately well, but in parts of Germany, the capsules never contain seed. 80, for some few of the cases given in the last chapter of self-impotent plants might have been here introduced, as their state seems due to the conditions to which they have been subjected. The liability of plants to be affected in their fertility by slightly changed conditions is the more remarkable as the pollen, when once in process of formation, is not easily injured. A plant may be transplanted, or a branch with flower buds be cut off and placed in water, and the pollen will be matured. Pollen also, when once mature, may be kept for weeks or even months. 85. The female organs are more sensitive. For Gartner 86 found that dicotyledonous plants, when carefully removed, so that they did not in the least flag, could seldom be fertilized. This occurred even with potted plants, if the roots had grown out of the hole at the bottom. In some few cases, however, as with digitalis transplantation, did not prevent fertilization, and according to the testimony of Moz brassica rapa, when pulled up by its roots and placed in water, ripened its seed. Flower stems of several monocotyledonous plants, when cut off and placed in water, likewise produce seed, but in these cases, I presume that the flowers had been already fertilized. For Herbert 87, found, with the crocus, that the plants might be removed or mutilated after the act of fertilization, and would still perfect their seeds, but that if transplanted before being fertilized, the application of pollen was powerless. Plants which have been long cultivated can generally endure with undiminished fertility various and great changes, but not in most cases so great a change of climate as domesticated animals. It is remarkable that many plants under these circumstances are so much affected that the proportion and the nature of their chemical ingredients are modified, yet their fertility is unimpaired. Thus, as Dr. Falconer informs me, there is a great difference in the character of the fiber in hemp, in the quantity of oil in the seed of the linum, in the proportion of narcotin to morphine in the poppy, in gluten to starch in wheat, when these plants are cultivated on the plains and on the mountains of India. Nevertheless, they all remain fully fertile. Contabscence Gartner has designated by this term a peculiar condition of the anthers in certain plants, in which they are shriveled or become brown and tough, and contain no good pollen. When in this state, they exactly resemble the anthers of the most sterile hybrids. Gartner 88, in his discussion on this subject, has shown that plants of many orders are occasionally thus affected, but the Caryophyllaceae and Liliaceae suffer most, and to these orders, I think the Ericaceae may be added. Contabscence varies in degree, but on the same plant, all the flowers are generally affected to nearly the same extent. The anthers are affected at a very early period in the flower bud, and remain in the same state, with one recorded exception, during the life of the plant. The affection cannot be cured by any change of treatment, and is propagated by layers, cuttings, etc., and perhaps even by seed. In contabscent plants, the female organs are seldom affected or merely become precocious in their development. The cause of this affection is doubtful, and is different in different cases. Until I read Gartner's discussion, I attributed it, as apparently did Herbert, to the unnatural treatment of the plants, but its permanence under changed conditions, and the female organs not being affected, seem incompatible with this view. The fact of several endemic plants becoming contabscent in our gardens seems at first sight equally incompatible with this view. But Kallreuter believes that this is the result of their transplantation. The contabscent plants of Dianthus and Verbascum, found wild by Wiegmann, grew on a dry and sterile bank. The fact that exotic plants are eminently liable to this affection also seems to show that it is in some manner caused by their unnatural treatment in some instances, as with Silene Gartner's view, seems the most probable, namely, that it is caused by an inherent tendency in the species to become dioecious. I can add another cause, namely the illegitimate unions of heterostyled plants, for I have observed seedlings of 3 species of primula and of Lythrum salicaria, which had been raised from plants illegitimately fertilized by their own form pollen, with some or all their anthers in a contabscent state. There is perhaps an additional cause, namely self-fertilization, for many plants of dianthus and lobelia, which had been raised from self-fertilized seeds, had their anthers in this state. But these instances are not conclusive, as both genera are liable from other causes to this affection. Cases of an opposite nature likewise occur, namely plants with the female organs struck with sterility, whilst the male organs remain perfect. Dianthus japonicus, a passiflora and nicotiana have been described by Gartner 89 as being in this unusual condition. Monstrosities as a cause of sterility. Great deviations of structure, even when the reproductive organs themselves are not seriously affected, sometimes cause plants to become sterile, but in other cases, plants may become monstrous to an extreme degree, and yet retain their full fertility. Galizio, who certainly had great experience, 90 often attributes sterility to this cause, but it may be suspected that in some of his cases sterility was the cause, and not the result of the monstrous growths. The curious St. Valery apple, although it bears fruit, rarely produces seed. The wonderfully anomalous flowers of Begonia frigida, formerly described, though they appear fit for fructification, are sterile. 91 species of primula in which the calyx is brightly colored are said 92 to be often sterile, though I have known them to be fertile. On the other hand, Verlat gives several cases of proliferous flowers, which can be propagated by seed. This was the case with a poppy which had become monopetalous by the union of its petals. 93. Another extraordinary poppy with the stamens replaced by numerous small supplementary capsules likewise reproduces itself by seed. This has also occurred with a plant of Saxifraga geum, in which a series of adventitious carpels bearing ovules on their margins had been developed between the stamens and the normal carpels. 94. Lastly, with respect to peloric flowers, which depart wonderfully from the natural structurethos of Linaria vulgaris, seem generally to be more or less sterile, whilst those before described of Antirrhinum majus, when artificially fertilized with their own pollen, are perfectly fertile though sterile when left to themselves, for bees are unable to crawl into the narrow tubular flower. The peloric flowers of Corydalus solida, according to Godrin 95, are sometimes barren and sometimes fertile, whilst those of Gloxinia are well known to yield plenty of seed in our greenhouse pelargoniums. The central flower of the truss is often peloric, and Mr. Masters informs me that he tried in vain during several years to get seed from these flowers. I likewise made many vain attempts, but sometimes succeeded in fertilizing them with pollen from a normal flower of another variety. And conversely, I several times fertilized ordinary flowers with peloric pollen. Only once I succeeded in raising a plant from a peloric flower, fertilized by pollen from a peloric flower borne by another variety, but the plant, it may be added, presented nothing particular in its structure. Hence, we may conclude that no general rule can be laid down, but any great deviation from the normal structure, even when the reproductive organs themselves are not seriously affected, certainly, often leads to sexual impotence. Double flowers. When the stamens are converted into petals, the plant becomes on the male side sterile. When both stamens and pistils are thus changed, the plant becomes completely barren. Symmetrical flowers, having numerous stamens and petals, are the most liable to become double, as perhaps follows from all multiple organs being the most subject to variability. But flowers furnished with only a few stamens and others which are asymmetrical in structure sometimes become double, as we see with the double gorse or ulex, and Antirrhinum. The composite bear what are called double flowers, by the abnormal development of the corolla of their central florets. Doubleness is sometimes connected with prolification. 96, or the continued growth of the axis of the flower. Doubleness is strongly inherited. No one has produced, as Lindley remarks, 97 double flowers by promoting the perfect health of the plant. On the contrary, unnatural conditions of life favor their production. There is some reason to believe that seeds kept during many years, and seeds believed to be imperfectly fertilized, yield double flowers more freely than fresh and perfectly fertilized seed. 98. Long continued cultivation in rich soil seems to be the commonest exciting cause. A double narcissus and a double Anthemis nobilis transplanted into very poor soil has been observed to become single 99, and I have seen a completely double white primrose rendered permanently single by being divided and transplanted. Whilst in full flower, it has been observed by Professor E. Morin that doubleness of the flowers and variegation of the leaves are antagonistic states, but so many exceptions to the rule have lately been recorded 100, that though general it cannot be looked at as invariable variegation, seems generally to result from a feeble or atrophied condition of the plant, and a large proportion of the seedlings raised from parents, if both are variegated, usually perish at an early age. Hence, we may perhaps infer that doubleness, which is the antagonistic state, commonly arises from a plethoric condition. On the other hand, extremely poor soil sometimes, though rarely, appears to cause doubleness. I formerly described one some completely double bud-like flowers, produced in large numbers by stunted wild plants of Gentiana amarella, growing on a poor chalky bank. I have also noticed a distinct tendency to doubleness in the flowers of a ranunculus, horsechestnut and bladdernut ranunculus, repens aesculus pavia and staphylia, growing under very unfavorable conditions. Professor Lehmann 102 found several wild plants growing near a hot spring with double flowers. With respect to the cause of doubleness, which arises, as we see, under widely different circumstances, I shall presently attempt to show that the most probable view is that unnatural conditions first give a tendency to sterility, and that then, on the principle of compensation, as the reproductive organs do not perform their proper functions, they either become developed into petals or additional petals are formed. This view has lately been supported by Mr. Laxton, who advances the case of some common peas, which after long continued heavy rain flowered a second time and produced double flowers. Seedless fruit. Many of our most valuable fruits, although consisting in a homological sense of widely different organs, are either quite sterile or produce extremely few seeds. This is notoriously the case with our best pears, grapes, and figs, with the pineapple, banana, breadfruit, pomegranate, azarole, date palms, and some members of the orange tribe. Poorer varieties of these same fruits either habitually or occasionally yield seed. 4. Most horticulturists look at the great size and anomalous development of the fruit as the cause and sterility as the result, but the opposite view, as we shall presently see, is more probable. Sterility from the excessive development of the organs of growth or vegetation plants, which from any cause grow too luxuriantly and produce leaves, stems, runners, suckers, tubers, bulbs, etc. in excess, sometimes do not flower, or if they flower do not yield seed. To make European vegetables under the hot climate of India yield seed, it is necessary to check their growth, and when 1/3 grown they are taken up, and their stems and taproots are cut or mutilated. 105. So it is with hybrids. For instance, Prof. Lecoq 106 had 3 plants of mirabilis, which though they grew luxuriantly and flowered were quite sterile, but after beating one with a stick, until a few branches alone were left, these at once yielded good seed. The sugar cane, which grows vigorously and produces a large supply of succulent stems, never, according to various observers, bears seed. In the West Indies, Malaga, India, Cochin, China, Mauritius, or the Malay archipelago, 107 plants, which produce a large number of tubers, are apt to be sterile, as occurs to a certain extent with the common potato, and Mr. Fortune informs me that the sweet potato convolvulus batatas in China never, as far as he has seen, yields seed. Dr. Royal remarks 108 that in India, the agave vivipara, when grown in rich soil, invariably produces bulbs, but no seeds, whilst a poor soil and dry climate lead to an opposite result. In China, according to Mr. Fortune, an extraordinary number of little bulbs are developed in the axils of the leaves of the yam, and this plant does not bear seed, whether in these cases as in those of double flowers and seedless fruit. Sexual sterility from changed conditions of life is the primary cause, which leads to the excessive development of the organs of vegetation. Is doubtful, though some evidence might be advanced in favor of this view. It is perhaps a more probable view that plants which propagate themselves largely by one method, namely by buds, have not sufficient vital power or organized matter for the other method of sexual generation. Several distinguished botanists and good practical judges believe that long-continued propagation by cuttings, runners, tubers, bulbs, etc., independently of any excessive development of these parts, is the cause of many plants failing to produce flowers or producing only barren flowerset. is as if they had lost the habit of sexual generation 109, that many plants, when thus propagated, are sterile there can be no doubt. But as to whether the long continuance of this form of propagation is the actual cause of their sterility, I will not venture from the want of sufficient evidence to express an opinion. That plants may be propagated for long periods by buds without the aid of sexual generation, we may safely infer from this being the case with many plants, which must have long survived in a state of nature, as I have had occasion before to allude to this subject. I will here give such cases, as I have collected many alpine plants ascend mountains beyond the height at which they can produce seed. 110 Certain species of Poa and Festuca, when growing on mountain pastures, propagate themselves, as I hear from Mr. Bentham, almost exclusively by bulblets. Calm gives a more curious instance. 111 of several American trees, which grow so plentifully in marshes, or in thick woods, that they are certainly well adapted for these stations, yet scarcely ever produce seeds, but when accidentally growing on the outside of the marsh or wood are loaded with seed. The common ivy is found in northern Sweden and Russia, but flowers and fruits only in the southern provinces. The Acorus calamus extends over a large portion of the globe, but so rarely perfects fruit that this has been seen only by a few botanists. According to Caspary, all its pollen grains are in a worthless condition. 112 The Hypericum calicinum, which propagates itself so freely in our shrubberies by rhizomes, and is naturalized in Ireland, blossoms profusely, but rarely sets any seed, and this only during certain years, nor did it set any when fertilized in my garden by pollen from plants growing at a distance. The Lysimachia nummularia, which is furnished with long runners, so seldom, produces seed capsules that Prof. Decisny 113, who has especially attended to this plant, has never seen it in fruit. The Carex rigida often fails to perfect its seed in Scotland, Lapland, Greenland, Germany, and New Hampshire in the United States. 114 The Periwinkle vinca minor, which spreads largely by runners, is said scarcely ever to produce fruit in England. 115 But this plant requires insectade for its fertilization, and the proper insects may be absent or rare. The Jussia grandiflora has become naturalized in southern France and has spread by its rhizomes so extensively as to impede the navigation of the waters, but never produces fertile seed. 116 The horseradish Cattleya armoracea spreads pertinaciously and is naturalized in various parts of Europe. Though it bears flowers, these rarely produce capsules. Professor Caspary informs me that he has watched this plant since 1851, but has never seen its fruit. 65% of its pollen grains are bad. The common Ranunculus ficaria rarely bears seed in England, France, or Switzerland, but in 1863, I observed seeds on several plants growing near my house. 117 Other cases analogous with the foregoing could be given. For instance, some kinds of mosses and lichens have never been seen to fructify in France. Some of these endemic and naturalized plants are probably rendered sterile from excessive multiplication by buds and their consequent incapacity to produce and nourish seed. But the sterility of others more probably depends on the peculiar conditions under which they live, as in the case of the ivy in the northern part of Europe and of the trees in the swamps of the United States. Yet these plants must be in some respects eminently well adapted for the stations which they occupy, for they hold their places against a host of competitors. Finally, the high degree of sterility which often accompanies the doubling of flowers, or an excessive development of fruit, seldom supervenes. At once an incipient tendency is observed, and continued selection completes the result. The view which seems the most probable, and which connects together all the foregoing facts, and brings them within our present subject, is that changed and unnatural conditions of life first give a tendency to sterility, and in consequence of this, the organs of reproduction being no longer able fully to perform their proper functions, a supply of organized matter not required for the development of the seed flows either into these organs and renders them foliaceous, or into the fruit stems, tubers, etc., increasing their size and succulency. But it is probable that there exists, independently of any incipient sterility, an antagonism between the two forms of reproduction, namely by seed and buds. When either is carried to an extreme degree, that incipient sterility plays an important part in the doubling of flowers, and in the other cases just specified, I infer chiefly from the following facts. When fertility is lost from a wholly different cause, namely from hybridism, there is a strong tendency, as Gartner affirms, for flowers to become double, And this tendency is inherited. Moreover, it is notorious that with hybrids, the male organs become sterile before the female organs, and with double flowers the stamens first become foliaceous. This latter fact is well shown by the male flowers of dioecious plants, which according to Galesio 119, first become double again. Gartner often insists that the flowers of even utterly sterile hybrids, which do not produce any seed, generally yield perfect capsules or fruit, a fact which has likewise been repeatedly observed by Naudin with the cucurbitaceae, so that the production of fruit by plants rendered sterile through any cause is intelligible. Kallreuter has also expressed his unbounded astonishment at the size and development of the tubers in certain hybrids, and all experimentalists 121 have remarked on the strong tendency in hybrids to increase by roots, runners, and suckers, seeing that hybrid plants which from their nature are more or less sterile thus tend to produce double flowers, that they have the parts including the seed, that is, the fruit, perfectly developed, even when containing no seed, that they sometimes yield gigantic roots, that they almost invariably tend to increase largely by suckers, and other such means. Seeing this, and knowing from the many facts given in the earlier parts of this chapter, that almost all organic beings, when exposed to unnatural conditions, tend to become more or less sterile, it seems much the most probable view that with cultivated plant sterility is the exciting cause, and double flowers, rich seedless fruit, and in some cases largely developed organs of vegetation, etc., are the indirect results, these results having been in most cases largely increased through continued selection by man. References: Chapter Roman 19 Summary of the 4 last chapters, with remarks on hybridism. On the good derived on the effects of crossing, the influence of domestication on fertility, interbreeding, good and evil results from changed conditions of life. Varieties, when crossed, not invariably fertilian, the difference in fertility between crossed species and varietious inclusions, with respect to hybridism, light thrown on hybridism by the illegitimate progeny of heterostyled plant sterility of cross species, due to differences confined to the reproductive system, not accumulated through natural selection. Reasons why domestic varieties are not mutually sterile. Too much stress has been laid on the difference in fertility between cross species and crossed varietious inclusion. It was shown in the 15th chapter that when individuals of the same variety or even of a distinct variety are allowed freely to intercross, uniformity of character is ultimately acquired. Some few characters, however, are incapable of fusion, but these are unimportant as they are often of a semi-monstrous nature and have suddenly appeared. Hence, to preserve our domesticated breeds true, or to improve them by methodical selection, it is obviously necessary that they should be kept separate. Nevertheless, a whole body of individuals may be slowly modified through unconscious selection, as we shall see in a future chapter, without separating them into distinct lots. Domestic races have often been intentionally modified by 1 or 2 crosses made with some allied race, and occasionally even by repeated crosses with very distinct races, but in almost all such cases, long continued and careful selection has been absolutely necessary, owing to the excessive variability of the crossed offspring, due to the principle of reversion in a few instances. However, mongrels have retained a uniform character from their first production.